Okay, so thanks everyone for joining this bootcamp lecture number 1. Let's get started with today's lecture. I'll initially start with the instructor introduction, and I'll also clarify some administrative questions which all of you have asked in the chat with respect to recordings, then with respect to lecture notes, duration of the lecture, etc. Each lecture will be roughly around 60 to 90 minutes duration. However, as we go deeper and deeper into the course, some lectures may take long, depending on how well you are understanding the concept. Okay, so I thank all of you for being here in the first place. And on the first lecture, everyone shows up. But right now, I want all of you to make a commitment that you will attend as many lectures as possible in this bootcamp. So I have planned 10 lectures, and the excitement is always high on day one. But you need to show up every single day, even if concepts get slightly more challenging. Okay, so let's get started. First, I'll tell all of you a bit about myself so that you get to know me as an instructor and how I decided to launch this bootcamp in the first place. So actually, if you see in this photo, this year is me. I graduated from IIT Madras with a bachelor's in mechanical engineering. This was 2017. And after that, I joined MIT to do a PhD. At this time, my only goal was to become a professor in mechanical engineering. So the first research which I started was in fluid mechanics. That was for a duration of 2 years from 2017 to 2019. 2019 was a very critical time in my PhD journey because I completely lost interest in mechanical engineering. And at that time, I switched to machine learning. So this was the time at which my machine learning journey truly started. I was lucky enough to join this Julia group at MIT. So if you search about the Julia lab, I don't know how many of you are familiar about the Julia programming language, but this was my research group at MIT. And once I transitioned to this research group, I started reading machine learning books, attending machine learning courses, ML research, ML teaching, and that consumed my entire life, and that became my passion. 3 years later, I published my first ML research paper, which was featured on news articles in several different countries. And I also collaborated with government, startups, global research groups, etc. Remember, this was COVID time in 2022. So the research which I did was using artificial intelligence and machine learning to model COVID-19 infections. Now, so here's a photo of me defending my PhD thesis at MIT. This was 2022. This was another critical moment in my life because I had received several job offers from Meta, Amazon, Julia Computing, etc. But I decided to leave all of those job offers, come back to India, and then along with my partners in crime, Dr. Rajat and Dr. Shridath, we started Vijwara AI Labs. And that has been the main purpose of my life ever since. The goal of our company is to make AI accessible to all, and this bootcamp is a part of that mission. We also started a YouTube channel. So how many of you have gone through these video lectures on YouTube? You can let us know in the chat. So basically, this is the machine learning teach by doing. That's the first playlist which I taught on YouTube. Then this is the neural networks from scratch. This again has 34 videos and this got a great response on YouTube. But the playlist which actually transformed the life of so many people around the world is this build large language models from scratch. We still receive messages from people every single day that this playlist helped them to get job offers. This playlist helped them to get into machine learning, artificial intelligence research, and this playlist just transformed their whole journey of learning ML and AI. So first of all, if there are some of you in this call who have watched this playlist, it's great. But those of you who are not aware of this playlist, I'm just putting the link in the chat. So you can complement your learning from this bootcamp with this playlist. The bootcamp is predominantly going to be a mix of theory plus practical, but this playlist will teach you how to build a large language model completely from scratch. There are 43 videos in this playlist, and I really encourage all of you to watch all of these videos to strengthen your foundational concepts. All right, so this is the instructor introduction in brief. And the reason I thought about doing this agents bootcamp was there is so much hype about this field. And earlier I thought that it's just noise. And I don't like to make playlists or teach about things which I don't believe in. So I thought that it's just noise and it will die down. But now I see a stage where agents are truly making an impact in lives of organizations. My friends who are startup founders, even enterprises who want to integrate agents in their organization. So the technology has reached a stage where I think it's a good time to have this bootcamp so that all of you know exactly what agents are. The philosophy which I want to follow throughout this bootcamp is the philosophy of Vijwara for teaching all of our courses. So if you look at this pie chart, this is how I think about the field of AI agents at this moment, right? There are 90% of people who have heard of agents as something cool or flashy. Maybe they have built some quick projects and added it to their resume. I don't want all of you to be part of this 90%, but rather we are going to be focusing on the foundations. We are going to learn about agents from first principles, the theoretical foundations, and then we are also going to build real life agent applications. That's the 8% over here. And the final 2% are those people who can start earning revenue through agents. I believe that agents are at a stage where we can start earning revenue also if we learn how to use agents correctly. So I want all of you to somehow be in this 10% where, let's say, if you are a startup founder, or if you have just started a new company, or if you are a middle level manager in an industry who wants to integrate agents, you should be knowing the best practices to integrate agents in your enterprise. And doing quick projects, something cool and flashy is not going to make a difference, because if you are part of a company who deploys AI agents, you need those agents to work, right? Because they will affect the life of your customers. So my goal is to teach you the bottom 90%. So if you think of agents as this kind of an iceberg, right? If foundations are strong, if fundamentals are strong, then you will be able to achieve all of these things which come on the top of the iceberg. Research papers, industry transition, job offers, grad school admits, if you want to integrate agents in your startup company, etc. But to do all this which comes on the top of the iceberg, you have to invest time. You need to build your foundations and they need to be very strong. So from my side, I am going to give my best in every lecture of this bootcamp, and there will be 10 such lectures, but all of you need to contribute. So here are the expectations which I have from all of the people who are attending this call. You have to be proactive. That's number one, which means I'll be asking questions during the session. And some of these questions would be a bit open-ended. But whatever comes to your mind, you should at least make an effort to answer what's your thinking or what are your thoughts. That will make sure that learning is maximized. The second thing is try to attend as many lectures as possible. If you just attend two lectures and then drop off, the benefits will not be visible. And the third thing which I want to tell all of you is that this class currently has peers which may become your co-authors or co-founders in the future. Especially for participants who have registered in the Pro plan, we have started a Discord group for all of you. And in this call right now, we have undergraduate students, graduate students, working professionals. There are people from different countries as well. Wide range of people from wide range of countries have registered. So if you are on the Pro plan, you must have received a Discord link where you can go ahead and you can introduce yourself. Okay, now regarding administrative stuff, there is a course dashboard. So if all of you, if you have enrolled either in the pro plan or if you have enrolled in the free plan, there is a dashboard for all of you now, and the Zoom links, then the recordings will be uploaded on the dashboard itself. So please make sure to check out this dashboard, and there is also an announcement section on this dashboard where I'll be making regular announcements. People who are registered in the pro plan, I will be sharing lecture notes on the Discord group, and I'll also be sharing lecture notes on the dashboard. So after every lecture, you will see the lecture recording, you will see the lecture notes, and for those of you on the pro plan, I'll also be sharing assignments at the end of every lecture so that you can test your understanding. Okay, so this is about administrative stuff. Then let's come to course content and curriculum and what all we'll be covering throughout this bootcamp. So let's see this. So 10 days are planned, right? On day one, today we are going to have an introductory lecture on what agents are. We are going to understand the intuition behind agents. Then we are going to, in tomorrow's or in Monday's lecture rather, we'll learn about large language models. So there are two lectures I want to devote on agents and LLMs. And then we'll start learning about frameworks. So broadly speaking, there are two types of agentic frameworks: no code frameworks and code-based frameworks. No code frameworks which have become very popular are n8n. So using n8n, you can build automated workflows, and we'll learn how to do that. Then coding-based frameworks which have become highly popular are LangGraph. Now, if you want to truly understand agents and build applications using AI agents, you should not only have an understanding of no code. You should definitely master coding frameworks as well. So my goal in this bootcamp is that I want to equip you with code-based frameworks as well as no-code frameworks. Okay. So initially we'll get started with code-based frameworks, which are basically, we'll cover three types of code-based frameworks: small agents, LangChain, LangGraph, and also LlamaIndex. And these will be covered on Google Colab. So I expect all of you to have Google Colab installed and ready to go on your machine. Then we will also cover no code frameworks which don't need Google Colab, but we'll create accounts on these websites and we'll build agents over here. Now, one more aspect of agents which is frequently neglected is evaluations. So let me just write this down so that it's it's visible to all of you. So what evaluation means is that it's not just enough to build agents. We should develop frameworks to evaluate these agents also. And I'm going to teach you two frameworks for evaluating agents. One is called as LangFuse. Through these frameworks, we'll actually understand whether the agents we have built are actually useful to us or not. So when I teach you all this, it will look something like this, where we are going to look at, so this is a sample agent which we'll be building and we'll be inspecting it. It's kind of like dissecting an agent to see whether it's working or not. That's one evaluation framework which we'll be learning about. The second evaluation framework which we'll be learning about is something called Arise. How many of you have heard about Arise or LangFuse? You can just mention in the chat if you have. If you have not, it's fine. I am going to cover all of this in detail. So yeah, so this is Arise, and we'll also be inspecting AI agents through this Arise framework. So for example, this is how the inspection platform looks like. Don't worry about these details right now. My plan is to cover all of this in as much detail as I can. So this is the course content and curriculum which we'll be doing. So initially, the first two lectures on agents and LLMs. Then we will build agents using code-based frameworks: small agents, LangChain, LangGraph, LlamaIndex. We'll build multi-agent systems using CrewAI. We'll understand n8n. And in the last lectures, I will also teach you how to monetize using agents and start earning revenue. And as I mentioned, evaluating AI agents will be one of my primary focus through many of the lectures. Because one thing which I've seen is that people are randomly deploying agents without asking the question, is this actually useful or not? So agentic evaluation is going to be very important throughout our live lectures. All right. So goals of the bootcamp are again build a very strong foundations, understand theory very well, implement practical projects, and cultivate a research mindset. If you are watching these lectures, it will be good to also make notes alongside. For the pro plan people, I'll be sharing these notes, so don't worry if something is missed out. So let's get started. In today's lecture, I want to cover what are agents, and I've heard or I've seen so many different courses and material on agents, which directly start with the definition. But before going to that, let's discuss a bit about the AI agents hype in the first place and why this bootcamp exists right now. So the hype which I want to discuss about is with respect to two things. First is also with respect to the job market. So if you see, this is the global AI agents market from 2023 and projected till 2033. And it's definitely going to rise. So, and every single indicator which you see tells us that AI agents are going to play an increasingly important role in the future. So we need to be prepared with this skill set. That's number one. Number two is that funding, right? So if funding is a very good indicator of what's going to happen in the future. So AI agents are hugely funded at the moment. If you take a look at this, if you take a look at this graph, you'll see that the funding for the investor funding for AI agents is on the rise, and it will continue to do so, I believe, because funding goes to projects which investors believe are the future. So if you are or if you're thinking about a startup, or if you already have a startup, I think this is a good place to be in right now. So these are the positive side, but there are also a huge number of Reddit threads and Reddit forums where people are debating about these things, that AI agents are overhyped. Are they actually useful or just fancy demos? So let's say this thread, which became really popular on Reddit, which says that AI agents are hyped as the future, but are they really that useful? Most seem like flashy demos, cool in theory, but impractical in real life. That's one aspect. Then you have the other side where someone just makes this post that I just hit $25,000 monthly recurring revenue in 4 months with n8n. n8n, by the way, is this framework which I just mentioned, which we are going to learn. And this person says here that I just secured my 10th contract for $2,500 per month to build and manage workflows for businesses. Then again, AI agents, hype or real, I see it everywhere, news talking about the next big thing, etc. Then someone else has written that ever since LangGraph came into the picture, the limitations of agents have largely been addressed. So if you are browsing the internet, you come across all these type of articles, right? And it's really difficult to know what is the fluff and what exactly can agents do. So my goal through this bootcamp is to cut through this noise, so that all of you, when you read these type of articles, you know for yourself what is possible with agents and what is not possible. And one way to cut through the noise is look at research articles. So this bootcamp is also going to be grounded on the research articles and not just hype, right? So there are four papers which actually I believe led to this agentic transformation. And I'm going to share those four research papers with you right now so that all of you can go through it. And also take a look at the timeline where these papers came out. The first paper is chain of thought prompting. Don't worry if you don't know these terminologies right now. So this is the first paper, chain of thought prompting, which came out in Jan 2023. The second paper, which is one of the biggest revolution in the agentic space, it's called React, synergizing reasoning and acting in language models. So this is the second paper. The third paper is this tool former, which showed that language models can teach themselves to use tools. And the fourth paper is this generative agents, interactive simulation of human behavior. And if you see very closely, these four papers came out in very short intervals of time. This came in January 2023. Then we have March 2023. Then we have February 2023. And then we have August 2023. Within a span of 6 to 7 months, there were 4 papers which came out that completely transformed agents as we know it. So all the applications which we are going to learn, the code-based and the no-code applications, such as let's say n8n or CrewAI or LangGraph, these applications are built on top of this research. That's very important for all of you to know. These 4 papers, which were published in a span of 6 months, were so crucial that people built on top of these papers and made applications. And these applications are the one which we are learning right now. So agents definitely is not all hype. There is a very strong signals behind it because these papers actually work. So all of what I'm going to teach you right in this bootcamp will be based on these research papers. So 4 papers which I've shared right now in the chat. After let's say this lecture is done, before the next lecture, it would be great if you can at least read this second paper, which is React. We'll be covering this in the bootcamp, so don't worry if this seems a bit complex right now. Okay, so this is about the agentic hype which we see. Now let's get to the main content of today's lecture, which is agents and what are agents in the first place. And as I mentioned before, I've seen many courses, videos, etc., which define agents. But today we are going to do something new. Today, what we are going to do is that we are going to construct a definition of agents ourselves, right? So let's forget about all of this. These are all definitions which come in textbooks or lectures. But let's come up with a definition ourselves and let's start with a simple example. The first example I want to take is this. And let me come to this part of the board. So let's say you want to plan a trip to Spain, okay, with 3 friends, and you are one of them. So forget about agents and everything right now. Let's just discuss what will you need to do. So let's say we are planning a trip in December of 2025, and it's a 7-day trip from 14 December to 21st December. Okay, imagine you have a group of 3 people. How will you plan this trip? What all will you need to think about? Can you mention it in the chat? I'll write all of those points over here. Okay, book tickets, flights, hotel, travel. Let me write all of this, right? So first, let's see flights. We need to book flights. Second, we need to book tickets, or rather, let's say hotels. Let me write hotels. We need to search for hotels during that time. Third thing also we need to figure out is the visa situation. Let's see what else do we have in the chat. Payment schedule, visa, safe place or not, correct. Then we have to write, then we have to think about places to visit over there. Then there is also the actual booking, right? So we have to search about this and then we have to also book it. So this is one thing. Then there is also the actions which need to be performed. The actions which need to be performed are, I need to book my flights, I need to book my hotels, I need to book my visa appointment, and I need to maybe plan for places to visit. Okay, these are broad level things, right? And in each of these, there are several further decisions. For booking the flight, I need to see the price. For booking the hotels, I need to see, again, of course, price, then whether it's safe or not, how many reviews does it have. When we see places to visit, if it's a 7-day trip, right? And on day one, you are visiting a particular place. On day two, the place which you visit should not be much farther from the day one place. Otherwise, it will lead to losing one entire day. So you need to make an entire plan for how you visit day one, day two, day three, four, five, six, seven. Which places are you going to stay in Spain? Let's say Seville, Barcelona, Madrid. It can be anything, right? But several of these things need to be decided. And on top of that, you also need to take actions. You need to book these things. One more thing which someone has pointed in the chat, and actually it's very important. You need to send an email to your manager um, asking for the leave and whether the leave is possible or not. So out of these 3 people, you need to make sure that if all 3 are working professionals, whether their leave is approved or not. That is a decision which you need to take. Another decision, of course, is if some friend is giving you too much of a hard time, then you need to decide who to kick out of this trip, in the worst case scenario. Then there are many things like this, right? Loan, applying for loan, etc. So many things need to be decided and so many things need to be planned. So currently you are right now at point A. Point A is right now in this call. We have no clue how we are going to plan this trip. We are throwing ideas around. Point B, point B is where your flights are booked, your hotels are booked, your visa appointment is booked, you have sent an email to your manager. All three have sent an email to your manager, and it's been approved, and the travel plan is fixed. Travel plan is fixed. Now, to get from point A to point B, to get from point A to point B, it's a lot of time for us, right? It's a huge amount of time to search through all of these different things. Probably sometimes such plans never happen. But what if I could tell you that you can directly go from point A to point B using something, in which you don't have to do too much. It will automatically take you from point A to point B. And then you ask me what that something is. So that something is our first notion of understanding what an agent is. An agent really is something at its most fundamental level. It takes you from point A to point B in your life. That can be any point A to point B. So agent takes you from point A to point B in your life, takes you from point A to point B and adds value while doing so. What is the value which the agent has added here? Can you put in the chat what's the value which the agent has added here? Time, right? Time, and adds value to your life. Agent is something which takes you from point A to point B and adds value to your life. And if you ask me what is value, well, that's time in one case, or it could be money. Okay, so all of us are at this stage where agent takes you from point A to point B and adds value. And while doing that, it saves time and money. But this seems too generic. There are many things which can take you from point A to point B and add value while saving time and money, right? A car can also do this. A flight can also do this. There are several things which take you from point A to point B and add value to your lives. So we need to dig deeper. Now let us try to dig deeper, right? Going from point A to point B automatically, how will an agent be able to do this? There are some things which an agent needs to be capable of, right? As we discussed, it's not just easy to go from point A to point B. There are several decisions which you have to make. There are several decisions, right? So this definition is our first attempt at defining agents. And it's good enough, but I gave you some counter examples that a car can also take me from point A to point B. Flight can also do that. So this is not a good definition. We need to extend it further. For that, we dive deeper. Now, okay, this is my first attempt. In my second attempt, I am going to think of the capabilities which the agent has. And as we saw, we need to make a number of decisions based on our decision making points, such as price, is it safe, what are the reviews, is my leave approved or not, which friend do I need to kick out from the trip, then what's the daily schedule for my trip, which place I have to visit every single day. So an agent is also something which is capable of making decisions on its own, and not just decisions, it can also plan. And these are incredibly difficult things to do. As humans, how do we plan? We talk with each other, we talk on the phone, we understand each other's priorities, right? But planning a 7-day trip is not easy. An agent is something which can automatically take decisions for us, and the agent can plan. So these are two things which are now added, which a car or flight cannot do. So the counter example which I gave here is that of a car and that of a flight, right? But now if I say that an agent is also something which can take own decisions and can plan on its own, well then what about a self-driving car? So this is still not a fully comprehensive definition. There is some things which are still missing. Planning and decision making is fine. Adding value to your life is also fine. But what is that thing which is still missing? One thing which is missing is that an agent also has access to tools. And this term will come up so many times that it's very important to take a diversion here. Uh, okay, so if someone is annotating here, I would request you to not do that because the annotation is staying here on the screen. So, yeah. Anyway, so tools, right? Now, can you all tell me what all tools will the agent need to do this planning? What do I mean by tools? Is it something which is first let's understand from everyone that what tools, what do I mean by tools here? If an agent has to actually do all these things for you, or if this something which we are defining has to take you from point A to point B, it has to make decisions and it has to plan. What are the tools which it needs? Okay, so let's write some of these tools down. Of course, it needs to do an internet search, correct? Because how else will you find flights? As a human, what will I do? As a human, I will first go to Google Flights. So let's go to Google Flights. I will go to Google Flights. I'll go to Google Flights and then I'll go from, let's say, Pune to Madrid, and I'll try to find the best flights, right? So, of course, the agent needs access to Google search. If I want to book hotels, I'll go to sites like Make My Trip and choose hotels. So, in any case, we need to do internet search. Not just that, we also need to be able to scrape a website. We also need to be able to scrape a website. What scraping a website means is I need to go to a website and I need to find out what information is written on the website so that I understand it. So I need to do internet search. I need to scrape a website. If I want to send an email to the manager automatically, I need to be able to draft an email. I need to be able to draft an email. What else? What other tools have I not covered here? Notification booking, right? So booking, an agent should also be capable of going to a website, completing the booking, doing a two-factor authentication, all of those things which are needed to actually book flights, hotel, visa, etc. So now I modify my definition of agents to say that an agent is something which takes you from point A to point B. It adds value to your life. While doing so, it can make decisions, it can plan, and the way it can make decisions and it can plan is by having access to tools. We are going to learn formally what these tools are. So as you can see, an agent, while doing all of these things, it's interacting with the external environment, right? An agent is interacting with the external environment. And what do I mean external environment? An agent goes to websites, it clicks over there, it takes decisions, it makes up a plan or a travel itinerary, it sends an email to the manager, it receives the email response. So it's like out there in the world and it's interacting with the world on your behalf. And all of these things actually come together to make up the actual definition of an agent. So now let me write the agent definition, which we have all thought about from the first principles, right? So what is an agent again? So if someone asks you what is an agent, think of this example and go step by step. First, an agent takes you from point A to point B and adds value to your life. Okay. Second, the agent has access to tools. Through these tools, it can make decisions, and the agent can also plan. Third thing is the agent interacts with the external environment while doing so. So all of these things put together, then you can start realizing what exactly an agent might really be. And now you can see why this is so important, right? Because uh, it saves you so much time, it saves you so much mental energy of doing these things in an automated manner. And this example which we have taken right now is an example of consumers, of people, right? Let's take an example of an industry. Let's take an example of an industry. So let me stop sharing and share my screen again. Yeah. Okay. So let's take an example of industry and let's try to drive home this definition which all of us have learned. So I'm going to look at an industry and I'm going to look at the sales team of that industry. Okay. And I'll tell you the workflow of the sales team, and you are going to tell me using the definition which you have learned what agents can do. So workflow of the sales team is that uh, if a person is on the sales team, what they'll do is that they'll initially go to LinkedIn, identify potential prospects, they'll identify potential clients, they'll send a cold email to these clients. They'll send a cold email to these clients. If the client does not respond, then nothing happens after this point. But if the client does respond, then they will set up a calendar meeting, or let me say they'll set up a Zoom meeting for a discovery call with the client. The person will then have the discovery call, and after that they'll send a follow-up email. After all of these things, the company will maintain a sheet. A company will maintain a sheet of clients where they will have the client name, number, and ultimately they will classify whether the lead is a hot lead or a cold lead. By hot lead, I mean, is it a prospect which can be converted into sales, or is it someone who has not replied? Now, this is the entire workflow of the company, and company cares about the bottom line, right? Company cares about revenue. The more people employed here, the more time they take, the more it costs for the company. Now let's think about the definition which we have learned about agents, point A to point B. So first, let's identify what's point A and what's point B. Point A is this. Point A is, so let me mark with a different color. This is point number A, where you just have the salesperson and they're discovering people on LinkedIn. And point number B is this sheet. Point number B is this sheet where you have to mark the person as a hot lead or a cold lead. Okay, so point A and point B have been defined, and our agent is going to take us from point A to point B, and it's going to add value for us. Let's see how. Let's now think about tools. So can you all tell me what tools will this agent need? What tools will the agent need to complete this entire workflow in an automated manner? Okay, so people are mentioning Google search, email, access to LinkedIn, LinkedIn search, LinkedIn API. Okay, so the first thing, the tool, I'm going to mark the tools in purple. So the first tool which the agent needs is that they need LinkedIn access, which means they have to go to LinkedIn and they have to search for people, and then they have to find the potential clients. So LinkedIn access is needed as a tool. Then email, the agent should be capable of drafting an email on its own. Then if the person has not replied, the agent should be capable of executing this action. Then what about this? The agent should automatically book calendar meeting. The agent should automatically book calendar meeting. Then after the meeting, the agent should automatically send email. And then the agent should also transcribe the discovery call. The agent should transcribe the discovery call and understand the sentiment of this discovery call. Through the transcript, the agent should understand how did this discovery call go. Based on the follow-up email also, the agent can understand is the customer really interested or they are not interested. So the agent should be able to transcribe, the agent should be able to understand the sentiment of emails and transcripts, and then the agent should have access to this Excel or this whatever sheet. The agent should have access to this Excel sheet, and then based on the sentiment, the agent should classify this as a hot lead or the cold lead, right? So all of these tools will be needed by the agent. And as people who are working in industry, they are familiar with this. What I'm calling it as Excel is also called as CRM. Uh, but that's an official terminology, right? So now let's see whether this fits in our definition. Here is an agent which takes me from point A to point B. It has all of these tools. What's the decision which the agent is making here? The decision the agent makes is whether it's a hot lead or a cold lead. So the agent is able to make decisions on its own. The agent provides value because now if everything is automated, you probably don't need humans everywhere. In this entire workflow, maybe you just need human over here. You need a human to be present in the Zoom link, right? But if you think about it, everything else can be automated. And a human can go to LinkedIn and maybe make 50 emails in a day. But an agent has no restrictions. An agent can send 5,000 emails in a day. So for a company, this entire workflow, if it's automated, it can not only boost your revenue, but save costs as well, because you don't need to probably hire so many people in this pipeline. You will be able to send more cold emails every day, which might lead to more chances of conversion. This is an industry example of why agents are being increasingly used. The example which I showed you right now is an actual use case. There have been many industries which have reached out to us to implement this exact same workflow. So this is not a toy example which I'm showing you right now. Industries across the world are actually interested to make something like this. And that's why we are having this bootcamp, so that I can teach you the tools where you can go from point A to point B. Right now, we all are at point number A. We need to reach to point number B, and we need to understand how an agent can do all of these things. So an agent definition is now understood. One more aspect which I did not tell you here is something called memory. An agent needs to have memory of what has happened in the past, because let's say an agent wrongly classified a lead as hot and a cold, right? And then a manager reviewed it. So this is called human in the loop. So this is called human in the loop evaluation. If an agent classified this incorrectly, and a manager evaluated this and provided feedback that this is an incorrect classification, agent needs to have this memory as it's going forward so that it does not make this same mistake again. So memory is an important thing, and another important thing is human in the loop. The agent should be capable of receiving feedback from humans. So this is called human in the loop feedback. We are going to see some examples of this in this bootcamp as well. You cannot just leave out an agent in the wild and uh, have it go in the external environment. At least currently in the AI progress life cycle, we are in the stage where a human in the loop feedback definitely has to be there. So I hope this example clarifies all of these 5 points for you. Point A to point B: value, tools, decision, planning, external environment, memory, and human in the loop feedback. So whenever someone tells about agents, and you think that they are just using the term vaguely, ask yourself that, is this thing taking me from point A to point B? What's the value which it is adding? Is it capable of planning, reasoning, and decision making? Does it have memory? And can it listen to human feedback and improve? If all of the things are satisfied, then it is an agent. That is the definition of an agent, which now all of us have learned about ourselves. So I could have just showed you this definition over here, right? Instead of doing this example exercise, I could have just shown you this definition, which is normally shown everywhere. but that is not true learning. You might think you have understood this, but if there are examples which are presented which you can relate to, you will never forget this definition now. But this is still not enough. This is still not enough because you all must be thinking, right? All of this, all of what I'm explaining right now, why are we having this bootcamp in 2025? Why this bootcamp was not there in 2015? There is one key aspect which I have not covered here until now. Uh, why 2025? So year of agentic AI, but why is it the year of agentic AI? What happened in 2020? What happened in 2022, 2023? What's the biggest revolution which we are currently living in right now? ChatGPT, right? But let's wind back few years and then comes 2017. 2017 is when the Attention is All You Need paper was published. So Attention is All You Need. This paper is probably the most important paper of this generation. It has more than 150,000 citations right now. Within this paper, figure number one is why we are here right now. If figure number one was not present in this paper, we would not have this lecture at all. In fact, this bootcamp itself will not exist. This one figure has led us to this place. And why? Why has this one figure, what has this one figure done? What has this figure done for us? And why are all of these things possible because of this one figure? All of these things have become much better because of this one figure. Why? And the answer is actually pretty simple. Um, the answer is language. Language, right? Everything boils down to language. And if you think about language, we have now gotten to a stage where computer models have become extremely good at understanding human language. So why has this happened? And so if you think about the history of language evolution and models understanding language, we had neural networks, then we had recurrent neural networks. 2017 was the year when the transformer architecture was proposed, and there was an attention mechanism in this architecture. Due to this attention mechanism, language models became extremely good at understanding human language. So now you can think of large language models as models which can completely understand the form and meaning of human language. I'm going to have a next lecture completely on large language models. So if you don't know this, don't worry. But just think of these models as models understanding language. Now, what's the connection between language and all of these five things which I'm explaining to you right now? So we learned about agents, right? And suddenly I'm talking about language and transformer. So again, go back to your example of the Spain trip. How do you, if you think about it, how do you actually plan? What does planning mean? You have a call with your friend, right? Your friend talks to you. How do they talk to you? How can you communicate? You use language. If both of you speak separate languages, planning will never happen. Planning depends on understanding of language. Decision making also depends on understanding of language. Going further, if you want to go to Google flights and you want to understand what's the cheapest flight, everything which I see on the screen right now is text and images, right? Everything right now is text. So the main takeaway is that if you have a model which can understand language, if it can understand text, you can literally do planning. You can make decisions. So right now as a human, why am I able to decide the cheapest flights? Because I can go to this page and I can read what's written here. If it's in some different language, I won't be able to read this. So the reason I am able to make decision is because I can understand the language which is written here. And when this transformer architecture came out, models became extremely good at understanding language. And the moment models became good at understanding language, people figured out that these models can also be good at planning, decision making, and taking actions. Because language is the cornerstone of everything, right? If you think of a pyramid, language is the bottom of the pyramid. On top of that comes planning. On top of that comes decision making. So the reason we are having this agentic bootcamp in 2025 is because large language models have reached a stage where they can understand every single thing about human language. Consider here, how can you draft an email? Right now it seems very easy to me, right? I can go to chat GPT and I can say draft an email to my manager asking for a leave, and an email comes in front of my screen. How is this possible? This is a language model in action which has become so good that it can exactly understand what's going on. So the reason we are having this bootcamp right now is, again, language underpins all of this. So let's say if I take all of this and bring it to some other aspect of the screen right now. Yeah. Let's say this is what we had written, right? And if I rub all of this, the base of all of this, the base of all of this is language, or language models rather. So I will now augment the definition of an agent, saying that agents do all of these things using a large language model. Agents do all of these things using a large language models. Agents take you from point A to point B. They make decisions, they plan, they use tools, they have memory, they listen to human feedback, and they do all of this by using a language model. Uh, so, okay, now you might be thinking, what is a language model really? I'm not aware of it. Don't worry, I'm going to explain that to you in tomorrow's lecture. But first, there is one last thing which is missing from this definition. So we saw point A to point B. The reason I'm saying this again and again is because I want you to take this away from today's lecture. Tools, decide, plan, what else? Environment, memory, human in the loop, and LLM. There is one thing which is a slight detail which we have not yet discussed, and that is how much level of agency does an agent have? That's called level of agency. Now let's see what this means, right? Let's take an example, and I'm again going to chat GPT, and I'm saying, um, so all of you have to tell me whether this is an agent. What is Visuara AI Labs? So if I type this right now, what is happening here? See, it's searching the web and there is a response which is provided. Is this an example of an agent? So I can see that it's a mix of yes and no, right? Yes, no, yes, no, yes, no. Okay, so which means that the definition is still not clear. So there are some non-negotiables. The non-negotiables are that LLM, if an LLM is used and if there are tools, it's the base requirement for it to be an agent. Right now, if you see the example which I just showed all of you, I went to chat GPT, I asked this, right? Did you see what happened when I asked this? When I asked this, there is this thing of searching the web. This is a tool. Web search is a tool, right? So web search is a tool which is being used in this case. So it's an LLM which is using this tool. Of course, we are not taking any decision. We are not doing any planning over here. So the level of agency in that particular example is quite minimal. So let me take you to a table now which explains the different agency level. What I described to you right now, it's a very simple agent where we just call a tool, where the large language model just interacts with a tool. That's a simple agent. So I can call this agency level 2, let's say. But it did not do any planning, it did not do any decision making. The Spain trip, which we discussed about, right? Personal travel planner that gathers flight options, hotel, local activities. Now that's an agent which has a higher level of agency because it can do multiple different things and it can plan, it can take decisions, it can execute actions. So both of these are agents, but it's just that their agency level differs. And what is agency? Agency is basically the amount of control which an agent has. Um, so if I see many people getting confused here, there is so this definition which I just showed you, that has to be taken into context with what is the level of agency which your agent has. The example which I just showed you is an example of an agent with not too much agency. But these examples which we discussed, the sales example and the travel example, these are examples of agents which have a lot of agency. Now, the highest level of agency is when one agentic workflow calls another agentic workflow, which means that if you have a travel planning agent, then you that calls a booking agent, that calls an email agent, etc. That's multi-agent, and that's also a very high level of agency. We are going to learn about and we are going to create multi-agent in this lecture, so don't worry about this right now. But the main point is that after this lecture, let's say if you have understood this definition, if you have understood this definition which we constructed, that's fine. But always also think about the level of agency or the how much control an agent has. In this case, when we asked this question, the agent just used one tool. There was no other decision to make. Whereas when the agent makes decisions on its own, the agent performs actions on its own. Um, that becomes an agent which has a higher level of agency. And usually, when enterprises and companies want to integrate agents in their workflow, they want agents which have a higher level of agency. That's where true value really lies. The lower the amount of agency an agent has, the lower the value it generates. So higher, so if you have an agent with very low agency, so it just makes a function call. So just remember this low agency is low value creation and high agency is high value creation. And when I say value creation, I specifically mean time and money. There are only two things which ultimately matter really, especially in enterprises. Either you save time, you increase revenue, or you reduce costs. So that is what I mean by value in this particular case. Okay, so this is the definition of an agent and the amount of agency. So one way to think about it in a very simple manner is that an agent consists of two main parts if you think about it, the brain and the body. The brain is the large language model, which we are going to see tomorrow. And the body is basically the tools which enable the agent to perform tasks and to perform actions. So this is a very crude form of describing um, what I already explained to you, the definition. But if that definition was a bit hard for you to comprehend, then just remember that if you think of agent as brain and body, and always think of an example which you find easy, right? This train trip, I took an easy example deliberately because all of you can refer to that if you get confused at any point regarding what exactly is an agent. So don't confuse large language models with agents. Large language models predominantly by themselves don't make decisions and don't take actions really. They also cannot interact with the external environment. They cannot browse web pages on their own. But an agent can do all of these things. So very simply, a large language model equipped with tools gives you an agent with minimum agency. That agent of minimum agency, if you add planning, if you add reasoning, then it truly becomes a smarter agent. And of course, the final stage of this is artificial general intelligence and artificial super intelligence, which is, I don't think this is very realistic at the moment. So I'm not going to spend too much time on that. Yeah, but if the LLM part for all of you was a bit too fast today, don't worry about that. Tomorrow's lecture, or Monday's lecture rather, is fully on language models. I believe it is important for all of you to understand or have an intuition of language models before we proceed to building agents in the first place. So we will be building agents which take you from point A to point B. We will be taking all of these examples and actually build these agents. And for that, we will use code-based frameworks as well as no-code frameworks. So I hope this definition puts into context very clearly what an agent is. And this, I think you should do with all concepts, right? If you come across a concept, instead of just reading the definition, try to think about your own definition and try to come up with it yourself using examples. Now, one final thing which I want to do in today's lecture is um, I want to take an example. So this is an in-class activity, which is an actual project we are going to build. We are going to build in this bootcamp. And I'll tell you, this is an actual problem which we faced as a company. The problem which we faced as a company is that, and I'm sure many other companies also face this problem. Let's say if you have created a new job post, if you have created a new job post and there are 500 applicants, or rather, let me come back a step. So earlier, what we did is we created a job post and we had textual problems to solve. But then everyone started using ChatGPT. So then we came up with this idea of video interviews, where what we do is we ask a candidate to record videos as assignments, and then we judge those videos. The problem is that if there are 500 candidates, then there are 500 videos, and we cannot spend the time to go through every single video in detail, right? This is a problem. As an enterprise, I'm telling you my problem and I want you to build an agent. So if you are a student of this class, you look at this problem. uh, I'll explain the problem further. We use a platform called Hireflix. This is a platform where candidates can record videos and share with us. Okay, so all our videos are stored on this platform. That's the problem. Now, if you are a student and if you have attended this first lecture, you want to build an agent. How will you go about building this agent? As always, what's your point A and what's your point B? Can someone write in the chat what is your point A and what is your point B? Uh, Point A is where we currently are as the company. The company has video interviews which are stored. The company has video interviews which are stored. That's point number B, point number A. Point number B is I want list of good candidates. I want list of good candidates from these video interviews which are stored. Okay. So this problem definitely makes sense. And what's the value which the agent is adding? Again, either time or money, right? The agent is saving me a huge amount of time as an enterprise. So I'm willing to pay for this as an enterprise to solve this problem for me. Okay, so let me bring this thing also down so that, yeah. So we have understood point A, we have understood point B. Let's look at some other things now. What about the tools? What are the tools which this agent will need? So you want to go from point number A and you want to go to point number B. Let's see. What are the tools? Let's see the responses. So speech to text transcription. Okay, but let's start very simply, right? First, I should be able to visit a website. That's the simplest thing. So I should be able to search. I should be able to visit a website, which is Hireflix, because the videos are stored on the website. Then I should be able to interact with the website and I should be able to download the videos. Then after downloading the videos, I need to convert the videos into transcripts. Then I need to analyze the sentiment of those transcripts. Then I need to rank the candidates based on whether they are a good candidate or not. So these are the 6 things which I need to perform. So I need access to Google search. I need access to visiting a website. I need to download videos. So transcript is basically speech to text, right? I need a speech to text tool essentially. Then what else? I need to find the sentiment of the video and I need to analyze it. So here probably I'll need a language model. A language model which looks at transcripts and which understands that whether this is a good candidate or not. And finally, I'll rank candidates. So these are the tools which my agent will actually need. So until now, we saw point A, point B, we saw tools. What is the decision making which this agent is doing? At what point is a decision being made? Sentiment and ranking, right? So this is the point at which a decision is being made. This is a point at which a decision is being made. And since a decision is made, this is definitely a very high agency agent. This is very high agency because it's making decisions on its own. So this is the point at which decision is made. So this also we understood. What about human in the loop? Is there any place where the agent might benefit from human feedback? So think about this deeply. There are places at which agent always benefits from human feedback. Let's say what we can do is that the agent ranks certain candidates, right? Ranks the videos, and in one case it has ranked poorly, which means as a manager, I want to evaluate this agent, right? So as a manager, I randomly watch, as a manager, I randomly watch 10 to 15 videos. And I realize that in some videos, the agent is not ranking it correctly. So then as a manager, I'll provide feedback. I'll provide feedback to this agent. And this feedback needs to be stored in the agentic memory. And it needs to make sure that it does not repeat that same mistake again. Um, so human feedback is very important. And definitely we are interacting with the external environment because we are going to websites, we are scraping the information, we are listening to human feedback. So this application is a very high agency agent because it actually does all of these things together. In this bootcamp, in the lecture 9 or lecture 10, we'll actually build this entire system. We'll build this system where we will take these videos um, using n8n, where we will build this video, we'll take these videos, we'll analyze these videos, and then we will make sure the agent gives a description of whether the candidate should be hired or not. So as you can see, this is the place where agents are truly useful. And when I actually saw that agents can do such type of examples, I also decided to take this bootcamp and to conduct this bootcamp so that I can pass on this knowledge to all of you. If a company like our company has this problem and if an agent can solve this problem, it's truly useful for me, right? That means that agents are actually valuable in the workplace. And the reason they are valuable is that it's because of these steps. How can sentiment be detected? How can speech be converted to text? It's because of language models. So don't take these points lightly. It's one of the biggest innovations which have happened in the last 2 decades. That's transformers. The reason we are able to look at transcripts and we are able to rate candidates is because language models enable us to do that. Without language models, this entire exercise would be useless. Because even before language models, we can do all these things. The first 3 points are not difficult. We can scrape a website, download videos, all of that is fine. But the remaining 3 points are where language models come into the picture. And that's why I'm suggesting that all of you who have not watched this playlist, watch it alongside agents, because as we already saw, agents, language models are the brain of agents, right? And without really understanding the brain, you will not be able to truly understand what an agent is doing. Uh, One more thing which I want to mention towards the end of the class is that on the Discord, what I'll be doing is that I'll be uploading these lecture notes. I'll be uploading lecture recordings as well. So you can all take a look at it. So just to recap what we saw in today's class, we initially started by looking at the hype around AI agents really. And then we saw that if we look behind the hype, there are research papers which have strengthened this field of AI agents a lot. So this whole what all coding frameworks, no code frameworks I'm going to teach you are all built on top of this. For example, React, right? LangChain, LangGraph, all modern packages have a React framework integrated into them. Then we actually constructed the definition of an agent ourselves. We initially started by saying that agent just takes you from point A to point B and adds value, saves time and money. But even cars and flights can do that. Then we say that agents can make decisions and plan. So even self-driving cars can do that. Then we say that that's not the only thing. Agents also have access to tools. They can book hotels, they can draft emails, they can do internet search, they can scrape websites. But that's not all. Agents also have memory. They listen to the external environment, and the foundation of agents are language models. Again, this does not exist in autonomous cars or other types of technologies, but agents are predominantly existing or agentic AI rather, and the foundation is on LLMs. Agents are very different from LLMs. When you give tools to language models, they become a very simple agent. So if you take language model and if you equip it with tools, then it becomes a very simple agent. A simple agent has low agency. Low agency is low value. Now, on top of that, if the agent can plan, the agent can reason, and the agent can take action, it becomes an advanced agent which has high agency. And high agency leads to high value. So in this bootcamp, I've planned it such that we'll start with low agency agents and I'll gradually take it to high agency agents. Okay, so this brings us to the end of today's lecture. People on the pro plan, please make sure that you see the lecture notes. The lecture notes won't be available for people on the free plan. Lecture notes are only available for people on the pro plan. So make sure you watch the lecture notes, and our next lecture will be on Monday. I'll also make an announcement on the dashboard. Our next lecture will be on Monday and it's at the same time, 2 p.m. IST. In case you or some of your friends missed this lecture, or if you are not able to attend, please at least catch up with the recordings. In the next lecture, we are going to look at language models. We are going to look at large language models in particular, and I'm going to explain large language models in a very different way. Similar to this lecture, I'm going to explain it from the very basics. So once we understand agents and LLMs, then we are going to build stuff. So in the third lecture is when we'll actually build our first agents. But before that, the foundation is very crucial. I'll also be uploading the recording of this on YouTube for anyone who misses it. And for people on the pro plan, I'll also upload assignments on the Discord. So make the Discord group lively. Make sure you interact with each other, get to know each other on the Discord. Zoom link will be same for all the sessions. So you can use the same Zoom link. Thanks everyone. I hope you learned a lot from this lecture. We will continue discussing on Discord and I'll see you on Monday. Please make sure to attend all lectures. Show up. Showing up is one of the most difficult things. It sounds easy, but it's actually quite hard. All right, everyone. Thank you. And I look forward to seeing you in the next lecture. See you. Bye. All right. So let's get started with today's lecture. Today is day 2 of this 10-day agent bootcamp. And the main topic which we are going to cover today is what exactly is a large language model. The reason we are covering this topic is, if you remember from last lecture, we saw that LLMs or large language models are the brain of how agents actually operate. And without understanding LLMs, understanding agents is impossible. So that's the main goal of today's lecture. After today's lecture, I hope all of you have an intuitive understanding of what large language models are. Similar to what we did for agents, we are going to look at large language models from the first principles. And I'll encourage all of you to come up with your own definition and understanding of LLMs so that you feel as though things are intuitive. So one of my goals of these lectures is to also make sure that these terminologies are not just something new to you, but you find them intuitive and easy to explain to anyone else. Before we actually get started, let's first do a quick recap of the previous lecture. For those of you who are enrolled in the Pro plan, I've shared this Substack article with all of you now. We'll be making it private for our Discord community, but I've opened it up here so that I can recap the previous lecture. So we started by defining agents, right? And our first definition was an agent is something which takes you from point A to point B and adds value to your life. That value can be time as well as money. But then we saw that cars, planes, and so many other machines can also do this. So we needed to augment the definition of agents. Then we saw that agents not only take you from point number A to point number B, but they can also help you plan and take decisions. But even self-driving cars can plan and make decisions, right? So we needed to further augment our definition. Then we said that agents also have access to tools. What are these tools? These tools can be Google search engine, the ability to access websites and read what's written on the website, the ability to go to payment gateways and make the payment, the ability to draft emails. All of these are tools. So agents have access to tools. And then finally, we saw that the reason we are having this bootcamp in 2025 is because 2017 was the year where the transformer architecture came into existence that completely changed the field of language modeling. And language models became massively better at understanding and responding to human language. So agents use LLMs for planning, reasoning, and decision making. That's why I call LLMs as the brain of agents. So then we had to finally modify our definition by saying that agents also interact with the external environment and they have memory. So in this one figure, I have encapsulated our entire understanding of the previous lecture. And let me define agents finally once and for all. So agents take you from point A to point B and they add value to your life. They do this because they have access to tools. Using those tools, agents can plan and take decisions. They can also interact with the environment and they have memory. And the foundation of all of this, the foundation of planning, decision making, reasoning is a large language model. So I hope that sets up the stage for today's lecture, because if LLMs are indeed the foundations of agents, then we need to understand what exactly LLMs are. And I plan to take you beyond the usual way of understanding LLMs, right? All of us interact with ChatGPT now. But I plan to kind of take a look behind the curtains and really understand LLMs from the first principles. So let's take an example, and I want all of you to be wearing your thinking hat at the moment and try to answer this question, which I'm going to ask all of you. So imagine that you are an alien, okay, but you are a very smart alien, and you have access to all the material which has been published. You have access to books, blog, literally everything, and you also know mathematics, you can think, etc. But you don't know anything about language. And here's your task. I will give you an incomplete sentence And your task is to take the incomplete sentence and you have to predict the next word. That's it. You have to take an incomplete sentence and predict the next word. So forget everything you know about LLMs at the moment, or everything you might have learned about LLMs. Just try to answer this question. You are an alien who is super smart and who has access to books, blogs, and I give you this sentence. Let's say your effort will take you, and as this smart alien, I want you to complete this sentence. In fact, I want you to answer what would be the next word after this sentence. How will you do this? Again, think from first principles, right? How will you do this? So I can see some answers in the chat based on previous occurrences in textbooks. What about others? Word which have the highest probability in articles and blogs. There is some answer that without language we can't. I will look into my context that I have from the material, right? So one very popular answer or one very intuitive way to think about this is what many people have caught on to the correct idea, that we will go through all of our textbooks and we'll try to see where all these sentences or these word actually comes. And then let's say this same occurrence, your effort will take you, comes 500 times. We'll see out of these 500 times, what's the word which has the highest probability of coming next. So what's the word with the highest probability? So if I was the alien, I would have done this. I would have looked at all the data which I have, and let's say this sentence comes 500 times. I would look at those 500 sentences and I would have seen what comes next. And I would have chosen the word which comes the most number of times, or I would have chosen the word which comes the most frequently. Okay, that's how you predict the next word. But what about the word after that, and the word after that, and the word after that? What if you want to predict an entire sentence? This is where the problem comes, because if you look at the English language, and let's say we say that the vocabulary has 40,000 words, right? If you want to predict one word into the future, there are 40,000 options. If you want to predict two words into the future with such a probabilistic approach, there are 40,000 multiplied by 40,000 options. If you want to predict three words into the future, there are 40,000 multiplied by 40,000 multiplied by 40,000 options. That's around 1.6 trillion options. And the funny thing is that if you want to predict 20 words in the future, then it will be 40,000 multiplied by 40,000 multiplied by dot 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 20 times. And that's more options than the number of particles in the universe. So this just becomes an impossible problem to solve, right? Through just a probabilistic approach, that I cannot look at my past data and predict a full sentence. It's just impossible to do. Another issue is that what if the given sentence does not come anywhere in your past data? Then what are you going to do? Then it would be impossible to predict the next word. So what do humans do in situations like this? Humans do a very simple thing, right? Let's say, I'm sure all of you are aware of this Leaning Tower experiment, right? Leaning Tower of Pisa experiment. So let's say you are the scientist and you drop some material from the top of the tower and you want to find the time which it takes for the material to reach the ground. And you do it for 10, 15, 20 number of trials and you note down the readings. What do you do after this point? Once you have some data, there is one particular thing which all physicists have done. Once you have data, what's that thing? What do you do after you get data? Even Newton, let's say, you have the data of how an object moves, right? What do you do with all of this data? So already we can see some answers in the chat that you try to find patterns in the data, right? And what does it mean trying to find patterns in the data? It means creating a model. We create a model for how much time it takes for a ball which is dropped here to reach the ground. So let's say that time of descent is square root of 2 into height divided by the gravity, something like that. That's a model, right? Um, so models can be very powerful because what's essentially a model? You have an input, the input goes to the model and you get an output. So what if we do something similar in this case also? In this case, what if I take my given set of words, I have my given set of words, I'll pass it into a model, and what I want as the prediction is my next token. So what if we could create a model which accepts a given set of words as an input? So this set of words, let's say this set of words or any set of words, these set of words will be given as an input to the model, and the model's job would be to predict the next token. That is exactly what people tried to do. Since we could not predict the next token by normal thinking, by statistical reasoning, then we turn towards models. And such a model, this model which takes an input sequence of words and predicts the next token, that's called as a large language model. Okay, forget the word large for a moment. That's called as a language model. Now let's understand why it's called a large language model. If you take y equal to ax plus b, how many parameters are there in this model? Can you answer in the chat? A simple straight line. Simple straight line has two parameters, correct? If you go to quadratic, there are three parameters. Now I'm going to make a statement which should be extremely shocking. Large language models have billions of parameters. People who have been in this field would now think that this is quite normal. But again, go back to what we have studied in school, right? We studied two parameters, three parameters, 10 parameters, that's fine. But what if I suddenly tell you that language models have billions of parameters? This is impossible to understand. And I just want all of you to appreciate the scale of this. It's already quite hard to deal with, like all of us can visualize a two-dimensional surface, right? But we cannot visualize a four-dimensional surface. It's impossible. Now I'm telling you to look at models which have billions of parameters. That's that's something which cannot even fit in our minds. Because let's say, to give an analogy, let's say this is India's map, right? And these are all the people, more than a billion people, right? So each of these persons, if these are a parameter, if each person is a parameter, even still there would be 100 such countries which need to be created to have as many parameters as language models have. And every parameter will have certain value which is optimized so that we can predict the next token. So when we say large, when we attach a word large, the reason this word is attached is because large does not mean 10 or 100 or 1000. It means millions and billions of parameter. That's what large language models are. Large language models help you predict the next token. Large language models help you predict the next token given a set of words, and they have millions or billions of parameters. The advantage of models again is that, let's say if you had this data, if you have this data and you make a straight line through it, the advantage of models is that if I give you any other input which is not present in my data, I can still predict an output for it. So similarly, even if I give you a set of words which are not in my data set, my language model will still predict the next token. That's another advantage of using models. So that's the first principles approach of language modeling. And still, the question which all of you should be asking is that if we are predicting the next token, why is it called a language model? It should be called a next token prediction model, right? Why is it called a language model? We'll come to that in a moment. But for now, just keep this definition in mind that language models predict the next token. And when we say large, they are really large in terms of the number of parameters which they contain. All right. So now one thing which I want to ask all of you is, let's say when I ask, uh, get me the code or get me, let's say, recommendations for books to read this year. If I go to ChatGPT, And if I ask something like this, there are next tokens which are predicted, right? As I told you, language model predicts the next token. So given a set of input tokens, we have this as the next token, then we have the token after that, then we have the token after that, then we have the token after that. Let me ask you the question, is ChatGPT or does ChatGPT, is it fully confident in making these predictions? So put in another way, is this a deterministic prediction or is this a probabilistic prediction? So we can see in the chat that people have answered it's a probabilistic prediction, right? So indeed, we see these tokens which are predicted, but what a language model actually does is that as it predicts the next token, it has, it predicts the probability actually, or it chooses the token which it thinks has the maximum chance of being the next token. So we are now just going to do a small activity in Google Colab. Um, Before we move to Google Colab, I want to ask how many of you have access to their own OpenAI API key? We would need an API key for the rest of this duration of the bootcamp. So I'm just going to show you the process of creating your own API key. I'm sure many of you already know this, but you have to go to openai.com, then you have to log in. So here I'm logging in with Google right now. So you have to log in here and then you have to go to settings. When you go to settings, you have to go to API keys section over here. And then you have to click on create new secret key. And when you click on, let's say, so I type a name Agents Bootcamp and then I create my secret key. So don't share this with anyone. This will be, you'll get some free credits, I believe, but after that it will be charged. So in this bootcamp, we won't be needing a huge amount of API key usage, but it will be needed. So can you all mention how many of you does have API, OpenAI API key right now, or how many of you can immediately create one? So make sure that don't share your keys with anyone. So I'm also going to delete my key over here once I share this notebook with all of you. So if you don't have a key, you can go to OpenAI like I went right now, and you can create this key. Um, so if you go to platform.openai.com, you can go to the API keys section, go to settings, go to API keys. You can create new secret key and you can copy it. In any case, if you don't have a key, I'll share this Google Colab notebook with all of you. So then you can experiment with this later. But so what I'm going to demonstrate here right now is that you just install this OpenAI package. Um, and then what we are going to do is that we are going to see the probabilities of the next tokens which are predicted. So the input sentence which we are going to have is after years of hard work, your effort will take you, and then we are going to predict the next token. Um, let me just share this code file with all of you right now. Okay, before I do that, let me show you. So see, this is what's actually happening in the backend. When you type this on the ChatGPT front end, when you type this sentence, you will see deterministic answers of the next tokens, right? But actually, what's going on internally is that GPT thinks that, okay, all of these can be the next tokens. And here I've printed out the probabilities. So the probability that next token is going to be 2 is 80%, which is the highest. So then it will print out the next token to be equal to TO2. But there are all of these other tokens which might as well have been the next tokens, right? So I'm going to delete my API keys from here, and I'm going to share this now with all of you. Let me delete the API keys everywhere. So you can replace your actual API key over here. And for the purposes of this class, we will need API keys later also. So I encourage all of you to have API keys with you right now itself, so that later it won't be an issue. Okay, so I'm copying this link and I'm sharing it with all of you on the chat. You can run this file even after this lecture is over. But what I wanted to demonstrate here right now is that until now we saw that LLMs predict the next token, and this token is predicted in a probabilistic manner. The LLMs, when they predict the next token, they assign a set of probabilities and they choose that token which has the highest probability to become the next token. Okay, so this is the definition of what large language models are. Now let us peek a bit into how LLMs have become useful to us today, and we'll also see why they are called language models and not just next token prediction models. There is a question, do I have to buy their subscription from OpenAI? Yeah, if I believe you'll have to buy a subscription to, or at least add some balance to have API key access from the OpenAI dashboard. So key is still there in the collab notebook which I shared. Let me remove that. Anyways, this key which I have has only like $0.5 or something balance. So yeah, so this is the first section of what I plan to cover today, that large language models. So let me write down the takeaway. LLMs are next token prediction engines. So LLMs, you can think of them as an engine which takes into account the input set of tokens, and then we predict the next token. Okay, now let's come a bit to the history of large language models and why they are called language models in the first place. Why do they need so many parameters? So here is the history of how it all started. The first paper which came out was 2017. This is attention is all you need. That's when they implemented the transformer architecture. Does anyone know the year in which the first GPT came out? What was the first GPT model which came out? So all of us know about GPT 3.5 Chat GPT, right? But that's the product. When was the first GPT paper which came out? That's actually GPT-2. So GPT-2 paper, I believe, was submitted at the end of 2017 and it was made available in 2018. That's the GPT-2 paper. And it was titled Language Models are Unsupervised Multitask Learners. So GPT-2 had 1.5 billion parameters. Let me share this paper with all of you right now. This was the paper which introduced GPT-2 and it had 1.5 billion parameters. And this model could do a wide range of tasks, but it was still pretty small, right? So check this out. This was the parameter size in GPT-2. They had 4 parameters. They started with a 117 million parameter model and their largest parameter size was 1.5 billion. Then in 2020 came GPT-3. That's another huge advancement. And the reason I call this an advancement is because GPT-3, if you see the size graph which they have in this paper, GPT-3 came in a huge range of sizes, but their largest model was 175 billion parameter. And this was one of the first studies, I believe, which had this one figure, which was extremely important. It's this figure. What's actually shown in this figure is that the accuracy of the language model, which is on the y-axis, tremendously improves as you increase the number of parameters in the models. So if the parameters are small, so if you see the green graph, that's 1.3 billion parameters, that has the lowest accuracy. As we go from green to orange to blue, the accuracy of the language model goes on increasing. So this figure showed people that it makes sense to go on increasing the number of parameters in a language model because the accuracy is increasing. Its performance on several language tasks just keep getting better. And then people were curious, right? Okay, if 175 billion parameters achieves a good accuracy, what if I keep on pushing higher and higher and higher? So 2020, 175 billion parameter, and here people figured out that the size of the language model is actually proportional to the amount of tasks language model can do. So the higher the size, we can get better language models. Then 2022, GPT 3.5 came out, and that is what we know as ChatGPT, the product. But people in this field knew the powers of GPT from 2018 itself. It just got into the commercial space 4 years later when OpenAI converted their research into a product. That's when the whole world knew about this. Now people believe that GPT-4, their largest models, have more than 1 trillion parameters because they have just gotten so much better at reasoning. So if you look at the sizes itself, here is the GPT-2 size chart. They had 1.5 billion, right? That's the maximum. But there is this size scaling law in language models, which says that the amount of or the more the parameters you have, the better performance you get. So people just try to increase the number of parameters. So if you see, this figure was published in Nature. And if you look at year 2000, the largest model we had was 1 million. But as we go into the last decade, so if we look at 2020, at the start of 2020, we had models of about 100 million. And now we have reached around 1 trillion within a span of 5 years. So you see, this looks like linear, right? This looks like linear, but the y-axis is actually logarithmic. So this is actually an exponential increase in the computational or in the parameter size of large language models in the last decade. And they still continue to get bigger and bigger and bigger. Now, can someone tell me that why do we need so many parameters in a large language model? What's the reason? Why do we keep increasing the number of parameters? So I'm going to give you two explanations for this. One is an intuitive explanation and one is a technical explanation. So why do we need so many parameters? So let's see some answers in the chat. Accuracy and the performance improvement. But yeah, but why? Why do you think increasing parameters increases the performance? And when you say performance, what do you mean? Better contextualization, right? Takes into account all aspects, it can understand well. So, okay, more parameters leads to more performance. And when we say performance, we are saying that maybe language understanding or performance on language related tasks. Right? So I told you I'll give two explanations for this question. One is technical and one is the intuitive explanation. So let me start with the technical explanation first. There is something which is magical about language models, and that is the fact that language models have emergent properties. I believe this is one of the single most important traits or qualities of language models. And what emergent properties mean is that an ability is emergent if it is not present in smaller models, but it is present in larger models. And this is a beautiful result because let's take one of these arithmetic performance on arithmetic tasks. On the x-axis, it's the compute power. So you can equate this to the size of the model. And you see, if the size of the model is small, its accuracy on arithmetic is not that great, but suddenly it shoots up. So there is a tip-off point or there is a tipping point over here. After this tipping point, the language model has suddenly become better at arithmetic. And such tipping point is usually seen for translation tasks, for word unscrambling tasks, for question answer tasks. For a huge range of tasks, language models show emergent properties or tipping points, which are directly related to their size. So this means that the reason we increase size is because suddenly the language model starts doing certain tasks which it did not do before. And this is absolutely incredible if you think about it. I don't think anyone still knows why these magical properties arise at certain tipping points, but they do. And this is one reason why people started pushing for size of large language models, because we don't know what's the next emergent property, right? Right now, I told you we are at 1 trillion. We are at 1 trillion parameters, but researchers at Anthropic, OpenAI, DeepSeek, they might be thinking, what if some new emergent property unlocks at 10 trillion parameters? What if another emergent property unlocks at 100 trillion parameters? So big companies are still pushing along or across the size dimension, although it has significantly plateaued a bit. This push for size of language models has significantly decreased now because of small language models and several other things which we won't get into in this lecture, such as test time scaling and some other concepts. But for now, just keep in mind that this uh, emergent emergent properties is one magical thing which LLMs have. And as their size increases, they just get better at doing things. The second thing which I want to tell you about is a lot more intuitive, and I wish someone in the chat would have pointed this out, right? Let me ask once more. What we are doing when we are building an LLM is that, as I told you before, they predict the next token, right? Then how is it that they get so much better at all of the tasks such as translation task, let's say summarization tasks? There are so many other things which an LLM can do. It can understand the sentiment of the language. So if we are just constructing this model to predict the next token, how can a large language model do all of these other tasks? Yeah, how can it understand the language? So someone is saying you have to fine tune. I'll come to that later, but I'm just training the model to predict the next token. So let's think about this again from first principles, right? There is another thing which is so interesting here, and this was recently covered by an OpenAI researcher at a talk which they gave at MIT. And the intuitive explanation for why LLMs need to be so large is because we train them to predict the next token. That's fine. But what language models discover on their own is that the simplest way to learn how to predict the next token, the simplest way to learn how to predict the next token is to learn the language itself. So what's very incredible about language models is that we don't teach language to these models. They learn about it on their own. So for example, let's say there is a sentence, Mary kicked the ball. There is a certain ordering to the sentence, right? There is subject, verb, and object. There are certain rules which languages have. Subject needs to come before verb, before object. This also differs across languages. We don't teach this to the LLM at all, but the LLM learns it. The LLM will never give you a sentence which is opposite of this. And I believe the reason they are learning language is because we train the LLMs to predict the next token, but LLMs themselves figure out that for me to predict the next token, the fastest way for me to do this is if I learn the language itself. So LLMs need to be very large because they are learning a language, and learning a language is not easy at all. It involves two things. It involves understanding the form of the language, and it involves understanding meaning of the language. So by form, I mean grammatical construction. As we train them on the next token, they realize that they have their own patterns which are forming in their mind. Or when I say mind, I mean some parameters, and they understand the grammatical form. And when I say meaning, LLMs also probably have certain knowledge about the world. So for example, let's say this sentence, blue electrons eat fish. This sentence is grammatically correct. Blue electrons eat fish is grammatically correct, but it has no meaning. So large language models will never give you this sentence because they know this sentence does not make sense any sense at all. So in a sense, large language models understand the form as a consequence or as a byproduct really of trying to predict the next token, and they also seem to have some notion of what's the world in which they are living in. Now, this second thing is highly debated because some researchers believe that language models don't have a worldview. But learning a language is not an easy thing to do, and that's why LLMs need to have so many parameters. So look at humans, right? How do we learn language? Let's say there are also two theories for this. One theory is that when we are born, we already have a cortex, which further improves as we listen to our parents, etc. Whereas the second theory is that we have no cortex and everything is learned from scratch. So if a large language model is to learn a language, that's the reason it needs to have maybe billions of parameters. Otherwise, it's very difficult for them to learn a language itself. So through large amount of data, we have a huge amount of data initially, and we train the language model to predict the next token. And while doing so, language models understand the form and the meaning of language itself. Now, there is another aspect to this called fine tuning, which we'll come to a bit later. But I hope all of you have some understanding of why do we need so many parameters. The first reason for this is, of course, we can unlock emergent behaviors in language models. And the second reason is because learning a language is not easy. And in this case, a model learns all the languages in the world, right, based on the data which are fed into it. So this is the intuitive explanation. For those of you who like to have intuitive explanations, this second explanation might work well. But for those of you who prefer more technical explanations, the first explanation works well. In any case, my task is to give you all kind of explanations so that you can decide which one resonates with you the best. So these are emergent properties of language models. And one more thing which I want to mention over here is that language models, right, are a bit different than earlier natural language processing models. So earlier, before language model came into picture or the transformer architecture really, we had natural language processing, right? Here also using an NLP model, we could do translation tasks, summarization tasks, grammar checking, etc. But we needed a separate model to do each of these. We needed a separate model for translation, a separate model for summarization, a separate model for grammar checking. The cool thing about language models is that just one model, which is trained to predict the next token, suddenly becomes good at translation, summarization, sentiment analysis, all of these things. Even without fine tuning, we can take the language model to a stage where just predicting the next token makes it better at these tasks. Fine tuning pushes it to the next level, of course. Uh, okay. So there is a secret sauce which I keep talking about, right? And that's transformers. We are not going to cover transformers in this bootcamp because that gets into theory of how to construct a language model from scratch. So we are not going to get into the transformer architecture right now, but this figure here and the whole, if you dissect this figure, there is something called attention here. So the simplest way to explain attention is different words in a sentence, know what other words mean. And that helps us understand the context of sequences better, context of data better. That helps in predicting next tokens or next words. So all of this must be seeming a bit magical to you right now if you don't know transformers. But in this course, I'm not going to teach you transformers because as long as you have an understanding of large language models, that is good enough for understanding agents. What I want you to appreciate after this lecture is that language models can do wide range of tasks. What are language models and how to construct language models, which is going to be the next section. But before that, I just want to have a small Q&A kind of a section where so I've made four buckets here, right? One, two, three, four. And I know many people are confused between these four terminologies, language models, generative AI, deep learning, and machine learning. So can you tell me what is number one, number two, number three, and number four? So four is the broadest terminology. Three is a subset of four. Two is a subset of three, and one is the subset of two. So let's start with four. What is four among these? So four is actually machine learning. That's the broadest space. Within that comes deep learning, which involves gradient descent and neural networks. Within that comes generative AI, where we have multiple modalities such as vision, text, etc. And within generative AI, the further subset of generative AI are language models. That's the uh, narrowest criteria here. So what we are studying right now is a subset of generative AI, which is a subset of deep learning, which is a subset of ML. And the superset of all of this is artificial intelligence, or AI rather. So I just wanted to clarify this right at the start so that there are no confusions with respect to terminology. Now let's get to how to build language models in the first place, the entire pipeline or the process of building the language model. So let's just throw around some ideas here. Imagine that you are the first team of GPT. So let's say you're building GPT from scratch. What all things would you need? What would you do? So I just tell you that until now we have seen that LLM is a model which takes in a sequence of words, and it predicts the next token, right? This is what we have seen until now. And we have also seen that they have something called emergent properties, um, and they learn the form and meaning as a byproduct of trying to predict the next token. But now we'll look into how is this built in the first place? How is this constructed? What all will we need as toolkits? Uh, so it's fine if you just throw around some ideas over here. So the first thing which we'll need, of course, is data, right? That's the first thing which we definitely have to start with. And if you look at, let me see if there are so many other answers. So tokenizing encoder. So if you try to keep it a bit broad right now, we first need to start with data, right? And then we need to think about the model itself. So first, let's look at the data. So the process of assembling any language model is first you aggregate a huge amount of data from the internet. So for example, here is the data sets which were used by GPT-2 for their training. And when I say GPT-2, it's this paper. Language models are unsupervised multitask learners. For this paper, they use this data. So Common Crawl, Web Text 2, books, Wikipedia articles, etc. And if you don't know what Common Crawl is, or if you're not aware of Common Crawl, it's this open repository of web crawl data, which consists of huge amount of aggregated data from Reddit threads, etc. There is another open web text. So open web text corpus is one more such corpus which is extremely famous where you can get data from. Essentially, you just source data from a huge variety of different links and websites, and that makes up your data set. So that's the first stage. You collect data, and this data can be internet text, books, media, research articles, etc. Wide range of data, and entire books are used. So the whole whatever books are available can directly be used as raw unlabeled data. So this can actually be trillions of words. The scale which we are talking about is huge amounts of data, right? So if you think of one token as one word, look at the amount of words in these data sets. It's huge. So we cannot comprehend the scale at which this is done. Then the next step is that we have to construct a model. So once we have the data is then pass to a model. And for now, when you think of the model, just think of some architecture like this. It's fine if you don't know every building block of this architecture. But for now, just think of when I say a foundational model is essentially a model which is built on the transformer architecture. So you train this model on such a huge amount of data, and the trained model which comes out of this is called as foundational model. This is a very important terminology because a foundational model is a model which has not undergone any additional fine tuning. It's a model which is pre-trained on underlying data. And then on top of that, so this is step number two. Step number one is accumulating the data. Step number 2 is pre-training the LLM. And step number 3 is fine-tuning the LLM on labeled data. So it turns out that if you just pre-train the LLM, it's not very good at following instructions. So you need to give a certain set of instructions. Let's say if you want it to be better at translation, if you want the LLM to be better at summarization or classification, you can give certain sentences as or certain input output pairs as labeled data to the LLM, and you can fine tune the language model. So the first data set for the pre-training part, that's unlabeled data, whereas the second data set is labeled. So in the second data, you also provide what should be the correct answer. Here's the input, what should be the translated output. So this is the general, very high level workflow of how LLMs are built. And here I've just put that on text. You train on a large corpus of data. That's the first thing. The first training stage of an LLM is also called as a pre-training. And after the pre-trained or after obtaining the pre-trained LLM, we can further train the language model on labeled data, and that's called fine-tuning. So when GPT 3.5 actually came out into the market, they do all of these three stages. It's not just a pre-trained model, it's a pre-trained model as well as a fine-tuned model. Only then it's released as a product. So all of us interacted with GPT 3.5, I believe in 2022 and 2023. That's a model which is pre-trained as well as it's fine-tuned. So both of these steps need to be done. And the pre-training cost is huge. It's upwards of multiple, or just for GPT-3 pre-training, it costs around $4.6 million. For GPT-4 and for models which have more number of parameters, it will cost even more. So pre-training foundational models is currently done by labs and startups which have that level of funding and that level of vision. So this is the workflow of how an LLM is built from scratch in the first place. And if you see, nowhere in this entire workflow do we teach the language model about grammar. Nowhere in this entire workflow we teach the language model about meaning. It just gets it from the amount of data on which it is trained on. So this LLM, which is pre-trained and fine-tuned, that LLM then serves as the brain for an agent. And why does it serve as the brain for the agents? It's because this LLM, which is pre-trained and fine-tuned, is now extremely good at all kinds of text-related tasks. It's great at summarization. It's great at classification, let's say classifying the text, sentiment analysis, then translation, all various sorts of things, right? So in the previous class, when we took a look at the different types of agents, right, and the tasks which they need to perform, all these type of tasks involve dealing with language. So we need some sort of a model which is good at understanding language, processing language, and that model is a large language model. So let me just pause here for a while and ask here if anyone has any doubts or any questions. So let me take some questions in the chat. Uh, you can keep asking questions if you feel it's important enough. If web scraping is the source to knowledge, and nowadays everyone uses Chat GPT. Yeah, so one more thing is that as we are interacting with the LLMs, right, that itself can serve as the data for further training. And I think some of you are also interested in what actually happens in the training procedure, right? So in the training procedure, let me break it down a bit. What really happens? And those of you who are not interested in this or who think it's a bit complex, don't worry about this, but I'm just showing the whole workflow. Let's say if you have huge amounts of data, right? For the sake of simplicity, let's assume we have to build a Harry Potter specific LLM. We have to build a Harry Potter specific LLM which understands and can answer all questions related to Harry Potter, right? So what we'll do first is that we'll source Harry Potter data. let's say I take this PDF just as a reference, and I use this data and I collect it, right? Once we have all of this data, then what we are going to do is that this data which we have, that's tokenized. By tokenization, I mean it's broken down into smaller and smaller parts. And then each of these tokens pass through the entire LLM architecture. And the LLM architecture consists of the attention layer. There are many layers which are stacked together, the normalization layer, and then there is an output layer, let's say. So you can think of this block as the LLM architecture block. And then what comes out of this is the next token prediction. So this is the predicted next token. And then we compare with the actual next token. So we have the predicted next token and the actual next token. There is a loss term which is calculated between these. That's the categorical cross entropy loss. And then we do back propagation. So then we do back propagation to minimize this loss. And what this means is that, let's say there are 175 billion parameters in this model. All of these parameters are optimized during back propagation so that the next tokens are predicted correctly. That is the entire, so when I say pre-training, it's this entire workflow which happens. So if any of you are actually interested in this, right, then this build LLM from scratch playlist which I have, it's this one. This playlist has 43 videos which teach you exactly this workflow which I right now showed. So my main purpose in today's lecture was to give you a high level overview of what large language models are, so that when we use the term LLMs in future lectures, you know exactly what I mean. But if any one of you want to dive deeper into this and actually know how LLMs are pre-trained, then you will need to spend a significantly more amount of time understanding this. Uh, so there is a question, 175 billion parameters. What are these parameters? These parameters are actually all kind of neural network layers. Then if you have queries, keys, values, matrices, there are several places at which these parameters are present. The simplest way to think about it is y equal to ax plus b, right? Here a and b are parameters. So here the input data, let's say, is your x, and the next token is y. All of these parameters which come in between x and y, those are your 175 billion trainable parameters. Um, there is a question that are agents built on top of generative AI or ML layers? That's an interesting question. So see, now the reason we covered this is because if you see, uh, yeah. So let's say the same example of trip planning, right? And what we want to do is that, let's say on day number 1, we are going to Barcelona. And I want to decide where we are going to on day number 2. We need a model which can understand what is mentioned on websites. We need a model which can calculate distances. So it needs to have access to certain tools, and it should essentially understand what's written on web pages. So there has to be a language layer. So you asked about machine learning, right? The reason why agents use a language modeling layer is because all these other, so if you consider deep learning, right? Deep learning is a very vast field which also has many things that have nothing to do with language. But agents are specifically built on top of large language models because language is the thing which helps you to reason and to plan. So if we look at this definition of agents, right? This definition of agents can plan and take decisions. How is this possible? How will they be able to plan and take decisions if they don't understand what's written on web pages, if they don't understand what's written on booking websites, if they don't understand human feedback? So as a human, let's say if you're given feedback through voice or text, the agent needs to understand what's your feedback, right? Uh, they cannot do all of these things unless they have a language layer underneath. So that's why we say that the brain or foundation of an agent is a large language model. And now when you say large language model, don't just think of Chat GPT. People who have not understood LLMs just associate LLMs with Chat GPT. But when I show you this figure and when I say uh, brain or foundation of an agent is a large language model, right? I specifically mean language models which are pre-trained and fine-tuned. And when I say pre-trained, it means that whole workflow of tokenization, predicting the next token, etc., and then fine-tune. And when you think of LLMs, you should know that they are trained to predict the next token, but as a byproduct, they have become very good at understanding form of the language. They have also understood meaning of the language. And as a result, they are able to draft emails, they are able to understand the sentiment of a given piece of paragraph or a given piece of text, etc. So this lecture is kind of like peeking behind the curtain and really trying to understand what LLMs are. In fact, in our live course, Build Large Language Models from Scratch, this is our first lecture, or rather the first two lectures. That's a 25 lecture course. But in this lecture, I always like to give this because here we teach things from first principles. Actually, one more book which I would like to share with all of you is by Wolfram, and it's called How ChatGPT Works. It's one of the best books I've read on how GPT works. And in fact, um, so let me share this book. This is that book. It's freely available, and I really encourage all of you to read this book because it's absolutely incredible. So some of the ideas which I've got at the start of this lecture, right? Like more options than the number of particles in the universe, etc. It's been inspired from this book. It's just 79 pages and it's a 2 hour read, but it really breaks down what ChatGPT is from first principles. I think that if all of you have this knowledge, you will just get better at building agents and understanding agents. Okay, let's see. So I can take a few more questions now from the chat. Parameters are basically weights and biases. Yeah, that's correct. But they show up at various places. How come DeepSeek with 13 billion parameters perform as good as 175 billion GPT model? What other factors are involved in the performance? That's actually a very complicated question because the answer to that would require. Uh, so essentially, the reason DeepSeek is so good is because they have several things. So first, they have KV cache optimizations. They have something called multi-head latent attention. They have rotary positional encodings integrated with latent attention. All of these things are there. So I won't get into this right now, but the short answer is that they have implemented a lot of architectural innovations, actually. That's what makes DeepSeek so much better. Um, so there is a question on small language models, right? That's actually an interesting question because let me try to explain my thinking about the way the LLM space has evolved, right? So there was a scaling law at the start. There was a scaling law, and everyone was interested in this. That the more you parameters you have, the more better you get. Slowly started reaching a plateau. Then what happened is that businesses started figuring out that if I have a specific use case, I don't need the all the data in the world to train my language model. I will start with a small amount of data. I will start with a small amount of data and I will use a language model which has only 10 to 50 million parameters. And then they figured out that even such a small model leads to great results if you have specific small amount of data. These language models, which are much smaller than their larger counterparts, are called as small language models. And small language models are extremely effective in enterprises. The reason is because enterprises generally want their own corporate brain. So they cannot use ChatGPT. They want to train a language model which has knowledge about their company, about their data, and they have specific operations which need to be performed. So small language models are the future in that space, I believe. If any one of you is further interested, uh, you can watch this 3 hour workshop. Yeah, so this is how to build a small language model from scratch. So I've recorded this.
That's it, everyone. Good job.
I recorded this 3-hour workshop 3 weeks back. But before doing that, I really encourage you to watch this playlist because this starts at slightly higher level, but it teaches you how to build an SLM from scratch actually. Um, okay, let's see what other questions are there. Moore's law, yeah, you can think of scaling law as slightly similar to Moore's law, just in the reverse direction. How much math is required? So for this agents bootcamp in particular, I'll try to cover everything from first principles. So I'll tell you the plan going forward. Until now, we have covered the introductory lectures, right, which are LLMs and LLM agent. In the next lecture, what we are going to do is that we are going to see how an agent works. And we are going to write our first code in the next lecture for building an agent. And there, what we'll do is that we'll peek into the inner workings of an AI agent actually. Because when I say that agents have large language model as their brain, you might be thinking, what does this exactly mean, right? You might have understood what LLMs are, but you would not currently see the integration of an LLM into an agent. For that, we'll need to understand something called as the React framework. So React framework, I shared this paper actually in the previous lecture, if you saw. But yeah, this is that paper. We'll need to understand this. In this paper, we'll actually learn how language models are integrated with agents, or how language models can be equipped to plan and reason. So there is something called reasoning and acting, which is React, which we'll be looking at in the next lecture. Okay, so next lecture, now this lecture has come to an end. What I'm going to do is that next lecture will be held tomorrow, which is Tuesday. And in the next lecture, we are going to cover how an AI agent works. We are going to cover this React framework. We are actually going to see our first agent in code. Now, for the rest of this lecture series, it's very important that all of you are regularly going to be attending lectures. You should have an OpenAI. You should have an OpenAI API key. So that is the purpose of this. And mostly what I'll be trying to do is that many of the lectures I've constructed with open source LLMs, but a huge number of participants in this call are industry professionals. At least those participants who are from enterprises, you need API keys. For students, I would say go ahead with free API keys. But people who are joining from enterprises or people who are industry professionals, you definitely need to have your OpenAI API key. So that's going to be extremely important moving forward. All other API keys which we'll create will be free. So we need API keys for several other platforms like Hugging Face. We'll need API keys for LLM and agent monitoring platforms. Those are free. But please have them ready so that you can follow along the different coding lectures which we are going to conduct. Tomorrow's lecture will also have coding in Google Colab. So make sure that you have Colab. We don't need any pro plan subscription, but don't join tomorrow's lecture from mobile phone. And let me iterate this once more. Tomorrow's lecture will deal with some code. So many of you who might be joining through mobile phones, please don't do that, because then it's not the best effective medium for understanding. It's very difficult to run code files on phone. Um, so just make sure to avoid that. Tomorrow's lecture, you need Google Colab. OpenAI API key might not be needed in tomorrow's lecture, but it will be needed in one of the subsequent lectures. But just have it ready tomorrow also. Um, Also, people who are on the pro plan, you will receive three things after every lecture. You will receive the Substack, you will receive the notes, and assignments. So I've shared the first assignment with all of you on Discord, right? So it's important that you do that assignment and submit the solution on the Discord group itself. And plus, after each lecture, you may have certain doubts, right? So those doubts you can ask on Discord and I'll clarify them. To summarize the key takeaways from today's lecture, here is what you should take away from today's lecture. First, language models are next token prediction engines. Language models are next token prediction engines, and they are not deterministic prediction engines, but they are probabilistic. So they have a certain confidence score of what the next token should be, and they choose the next token with the highest confidence or the highest probability of being the next token. Now, while we pre-train a language model for predicting the next token, they learn the language itself as a byproduct, which is the form and the meaning of the language. And language models are called large language models because they have huge number of parameters. And why do they have huge number of parameters? First is because they get emergent properties. As we increase the parameter size, language models magically start becoming better at new tasks. Second reason is that as kids, uh, certain neuronal connections are formed in our minds as we learn a language. Similarly, for a language model, learning a language is not easy. That's why they need so many parameters which are flexible, which can be tweaked so that they can effectively learn a language. Then we saw that the core of language models is, of course, this transformer architecture. And we saw the difference between LLMs, generative AI, deep learning, and machine learning. And finally, we saw that when we look at LLMs or any large language model which we are going to use, it has two stages. It has pre-training and fine-tuning. Fine-tuning comes after pre-training. The reason it's called pre-trained LLMs, it's a bit misleading because we already trained it before. The reason it's called pre-trained is because there is also one more stage, which is the fine-tuning stage, which is going to come afterwards. So it's in the anticipation of the next stage, which is going to come. That's why it's called pre-training. I also shared this Google Colab notebook with all of you. Those of you who are students, just replace the models with Gemini models and use the free API keys. But industry professionals and people joining from enterprises, please have your API key ready so that we can do tomorrow's lecture efficiently. We'll need to create accounts on many different things, and I'll do that on the go. So you'll need an account on Hugging Face. So just make sure that you have an account which is created on Hugging Face. If you don't have it right now, it's fine. I'll take you through it as we are going through the lecture. Then what else? I might be forgetting some things, but I'll cover it as and when we go through that particular lecture. And then finally, I hope many of you will now start making the link between lecture number 1 and lecture number 2. In lecture number 1, I talked about this foundational layer of agents, right, which is a language model. And in lecture number 2, we have seen what that foundational layer is. And I hope you think beyond ChatGPT when you think of a language model. Try to think from first principles. Like, here is how I relate it to physics, right? Because physics is what comes naturally to me. So I look at physical models and then I try to relate to language models. I think that's always a better way to learn rather than learning just directly from applications. Okay, so now that we know agents and LLMs independently, I will look forward to seeing all of you in the next lecture, in which we will learn how agents actually work and the React framework in particular. And again, let me repeat one more thing. If any of you is actually interested in going deep, make notes along as you are learning. Because one thing which I have learned myself is that as I make notes, I get better at the material. Second thing which I've learned is what I also covered in the Discord group assignments is teaching, the benefit of teaching. So when I say teaching, what I mean is that if you really have understood something, you should be able to teach it to someone who has no clue about that topic. And if you're not able to teach it, it means you have not understood it. That's why I started explaining LLMs from very simple terms. So if you want to teach, let's say, language models to a 10-year-old, how will you teach? You cannot use difficult words, right? So that's one of the best ways to teach. or best ways to learn rather. So I call this learn by teaching. And I don't know why this method is not implemented in universities, right? In all of our college, during undergraduate, graduate, I gave exams and they judged me for my marks. But instead, if there were teaching assignments, so if there was an exam where you teach your students and we check how well the students have understood it, I think that's a better indicator of whether you have actually learned the concept or not. So as an exercise, try explaining language models to someone who has no clue about this field. And if if you are able to explain it successfully, then maybe you have understood it well. Thanks everyone. I will look forward to seeing you in the next lecture, which will be at the same time, 2 p.m. tomorrow, same Zoom link. So I look forward to seeing you then. Thanks everyone. Bye. All right. So let's get started with today's lecture. Today is day number 3 of the Vijwara AI Agents Bootcamp. And today is going to be an extremely important lecture because today we are actually going to look at the theory behind agents. And we'll also be seeing our first AI agent on Google Colab, like I mentioned to all of you yesterday. So before we get started, actually, let me do a quick recap of what all we have covered on day number 1 and day number 2. So let's go to day number 1. The main takeaway from day number 1 was that agents take you from point A to point B and they add value to your life, value being time and money. Agents can also plan and take decisions, and they do that through the usage of tools. Furthermore, agents can interact with their environment and they have memory. And in the previous lecture, we saw that the foundation of agents is something which is called as a large language model. So for the people who have registered for the pro plan, I've summarized all of the lecture content in of the previous lecture in this Substack article. So we started the lecture by assuming that if an alien enters town and if they want to predict the next token, how will the alien go about doing this? Statistical or probabilistic methods are quite difficult here. So that's why we turn towards models. So large language models essentially take sequences of words as input and they predict the next token. That's the main idea. And as they're trained to predict the next token, they also learn about the form and the meaning of the language itself. LLMs have this magical property that after a certain number of parameters, they start developing emergent properties. And that's why people continuously chased increasing the number of parameters in a language model. And then finally, we saw that there are actually two stages of building a large language model. The first is pre-training and the second is fine-tuning. And once both of these stages are completed, we have a language model which can completely understand human language, which can do translation tasks, summarization tasks, essentially all kind of language related tasks which we want. But if you are following along closely, all of you might be thinking that what is the exact link between LLMs and agents, right? So I'm bringing this screenshot over here right now. All of you might be thinking that what does it mean that the brain or foundation of an agent is a large language model? How do we assemble an agent with the help of large language models? Today we are going to see exactly this. We are going to see how you start with a large language model and then how you can augment the large language model so that it can plan, take decisions, and it has access to tools. We'll also see how you can augment large language models so that they interact with their environment and have memory. So you can think of this lecture number 3 as lecture number 1 plus lecture number 2. And here is where everything will come together. So for now, you might be thinking of this aspect and this aspect a bit separately. In this lecture, we'll merge it together and I'll actually show you how LLMs can be augmented to give them all the functionalities of an agent. But before we understand how agents are actually constructed from the ground up and how LLMs can be augmented to give agents, I first want to show you an AI agent in action, which means we are going to code an AI agent ourselves right now. And I'm going to share this Google Colab code file with all of you right now. I've mentioned this as Visuara Agents course code number 1. We'll eventually have 8 to 9 code files like this. And so in today's lecture, our aim will not be to understand the code itself. I'll do that in the later lectures. Our goal will be to run the different code cells, and I'll give you a brief overview of what these code cells mean and see the output. In the later lectures, we are going to dive into code-based frameworks and no-code frameworks, where I'll actually explain how the code really works. But in today's lecture, all of you should be able to run this Google Colab code file with me. So I'm going to share this right now with all of you on the chat. And if some people are joining late, you can share this link with those people who are joining late. So Google Colab link is this one. All of you can click on this link and open it. There is one thing which all of you will need, which I mentioned in the previous lecture as well, and that's the OpenAI API key. So those of you who have their OpenAI API key handy, you can paste it over here in between the inverted commas. And let's get started with executing the code step by step. So let's run the first code cell right now. So I've already run it. So I'm just going to wait for a couple of minutes because this first cell takes some time to run. So so if anyone finishes running this first code block, can you just let me know in the chat if you have finished running this first code cell? And when I say finish, you should see a green tick which is appearing over here. In the first code cell, we are just installing some packages such as LangChain, OpenAI, etc. Don't worry if you don't know what these packages mean. I'll cover that in one of the later lectures. As I mentioned, today's aim is to just run this code file and see an agent in action so that you get a feel of what's really going on over here. Um, so there is a question in the chat, do we need to change the imports for Google Gemini API? So we are going to use this package called Chat OpenAI, which is specifically for ChatGPT. For Gemini, the code needs to be changed slightly. So I'll mention those details after the class is done. But for now, we have to stick with ChatGPT. And you have to install these required modules before we get started. So just to clarify, LangChain is the main framework in which we are going to develop our first agent today. And if you can, how many of you are aware about LangChain in the first place? If you have heard of LangChain or if you have used LangChain before, you can just type yes or no in the chat. So yeah, so it's one of the most famous platforms for not just building agents, but essentially building applications on top of large language models. I'm going to cover this in detail in lecture number 5. Uh, all right, so how many of you have finished running the first code cell? Can you type in the chat if you see a green tick over here? I can see that 4 to 5 people have finished running it. That's very good. So this part of the code will take the longest time. Rest, everything will be a bit straightforward. Now, as we move next, we will need to put in the API key over here. So if you directly, I have already put in here, so it does not show an error. But for others, you will need to put your OpenAI API key here and then just run this code cell. Um, has anyone successfully run this second code cell by inputting their API key? Yes? Okay, good. I can see that many have run this. For those who are joining late, I'm just sharing this Google Colab code file link once more. So you can follow along with the rest of us. Great. So then we are going to move forward. There is something which is called as React template and something called as prompt template. Again, don't worry about this right now. Just run this currently. Here we are essentially defining the prompt which needs to be given to the large language model. And in this code cell, what we are essentially doing is that we are giving tools. We are giving two tools to the large language model. The first tool is called DuckDuckGo Search. How many of you are aware of DuckDuckGo? So if you search DuckDuckGo, right, it's a privacy first company, but you can think of it as Google search, but with your privacy protected. So the first tool which we are giving to this agent is that it can go to any website and search what's mentioned on that website. That's the DuckDuckGo search tool. And the second tool which we are going to give this agent is LLM math, which essentially means that we are equipping this large language model with a calculator and other mathematical operations. And the large language model which we are using here is GPT 3.5 Turbo. You can change this to whichever one you want, but we can stick with this for now. And then what we are doing is that we have to, we are essentially loading these tools. So we are collecting the tools together. So essentially we have the search tool and we have the mathematics tool. We have two tools which have been given to the language model. And then we have to just create an agent. So here we have to mention that this is the agent. It has access to these tools, etc. And then finally, the question which we'll ask to the agent is, what is the current price of a MacBook Pro in USD? How much would it cost? So this is the question which we are asking to the agent. So let me actually take a screenshot of this and bring it over here. So if this is the question, what is the current price of MacBook Pro in USD and how much would it cost in euros if the exchange rate is 0.85? So let me ask this question to all of you. What tools would you need to solve this question? Let's say you have the large language model, which is ChatGPT or any language model. What are the tools you will need to answer this question? What will you need to do? If I ask you that what is the current price of a MacBook Pro and how much would it cost in euro if the exchange rate is this much? As we can see already, right, we definitely need a web search. We essentially need a web search because we have to go online and we have to type what is the current price of MacBook Pro. This is what a human would do, right? If this is the question asked to me, I would go and search on the web MacBook price in USD. So that's the first tool which is needed. And then what's the second tool which is needed? Let's say I get the price as $1,000. The second tool which will be needed is a calculator. Why would a calculator be needed? Because I have to convert this $1,000 into euros. And for that, I will be multiplying it with 0.85. So to convert this large language model to an agent, I essentially I need two tools. I need a web search and I need a calculator. So that's exactly what we are doing here, right? The tools which we have defined are the mathematics operations and a DuckDuckGo web search engine. These are the tools passed to the LLM. And if you click on this agent executor.invoke, oh, I think I did not put my OpenAI API key over here. So that's why I got this error. So let me just go ahead and um, so now I have put my API key And you can see here, now let me go and invoke this once more. So now you see what's going on over here. Here we can see that the agent, let's see what the agent is doing. The agent first figures out that I should use a web search engine to find the current price of a MacBook Pro in USD, and then I should use a calculator to convert it into euros. The agent then takes an action. The first tool which it uses is DuckDuckGo. It uses this tool and it goes online to find the current price of a MacBook Pro. And then it understands that the prices of a MacBook Pro start at 1999 $1999. And then the second tool is a calculator, which the agent figures out that's the second tool which we should use. And then you multiply this 1999 with 0.85 to get the price in euros, right? So this is now the price of the MacBook Pro in euros. So let me again hide this once more. So one simple thing which we can do actually is create something called secret keys in Google Colab. The reason I'm not doing this here is because it's sometimes confusing to some people. So here you can go and create secret keys like this. So your API key will be stored as a secret key. But first, how many of you were able to run until here and see the output which I'm seeing on the screen right now? Yes. So you can mention how many of you. Okay, so I can see that many were able to run it, but just got a different answer, right? And that's totally fine. Uh, it's fine if you got a different answer as long as you are able to run this code. All right, so just see what's going on here right now. Just like how humans are thinking, here we have an agent who is thinking along very similar lines. Um, the agent first uses the web search engine to search about the current price of a MacBook Pro. It gets that price and then it realizes that I need to convert this into euros. Um, and then it uses the calculator tool and converts the pricing into euros. And then it says that I now know the final answer. The current price of a MacBook Pro is $1999, and it would cost approximately 1699 euros with an exchange rate of 0.85. So I deliberately went a bit fast through the code. I just wanted you to get a feel of how agents are working. But now we'll again jump back to our Miro whiteboard and we'll try to see what exactly did we see currently in code. What really happened right now? Currently, all of you would see that we had a large language model in the code, and that language model was ChatGPT. So now all of you who have run the code, it's great. All of you who have not, it's fine. You can do it after the lecture is over. Now it's time to focus on the main theory part. Okay, so pay a lot of attention to what's going on right now because I'm slowly going to explain what we just saw in the code. All of you saw that we used a large language model and that was actually GPT 3.5. Okay. Then we also saw that there were tools which were used. The first tool which was used was a web search, and the second tool which was used was mathematical operations, like let's say calculator. This is what we saw, right? But this is the output which was produced, and it seems like there is really a lot of thought which is going on. The agent thinks like a human. The agent formulates its thoughts and then it takes actions. So what exactly is going on here? And why do we get descriptive answers like this? Where exactly is a large language model used in this process? Um, did we see something magical? Let's deconstruct it now. Once we understand it, it will no longer be magical. We'll now take a step back and we'll understand two things which have led to this answer. The first concept which we need to understand is tools and what exactly are tools. And the second concept we need to understand is something which is called as a React framework. So until now in this bootcamp, I've used the term tools very vaguely, but it's actually one of the most important things which convert a large language model into an agent. Okay, so let us understand what tools are and how we can supply tools to a large language model so that it becomes an agent. Okay, so the simplest way I like to think about it is tools essentially are just weapons which a large language model receives so that it can interact with its environment. And tools can come in various forms. There can be a web search tool. There can be a tool for image generation. There can even be a tool for, let's say, code generation, code evaluation. There can be a tool which retrieves documents. There can be a tool which interacts with an external API such as GitHub, YouTube, Spotify, etc. So essentially, tool is any such thing which allows an LLM to interact with its external environment. Okay. Uh, Tools. So we have only seen web search and the calculator tool, but subsequently in this bootcamp, we'll see all of these tools which will be utilized. But then let me ask you the question that, okay, these are the tools and we need to pass a tool to the LLM. How do we let the large language model know that it has to use the tool? Uh, how do we tell the large language model that this is a tool uh, which you have to use? So LangChain, so someone has answered LangChain. That's not, so always think from first principles, right? LangChain is a package which is developed, but the question which I'm asking is, the answer is not React framework also. I have not taught these things yet. So try to think from first principles. Uh, let's say you have a large language model. How do you tell the large language model that it has to use the tool? And the answer is actually very simple. I hope someone answers that in the chat. Yeah, exactly. Now I think we are getting to the correct answer, right? The answer is only one word and it's as simple as the prompt. So agents, the more you learn about agents, the more you will understand that um, LLMs and prompt engineering are extremely important to really understand agents. And here is why. So if you have a language model right now, let's say ChatGPT, right? What is a prompt? A prompt is anything which I type. So if I type, hey LLM, here are the tools which you have access to. I want you to use these tools. And then we provide the list of tools to the language model. And this is the simplest way I can explain how large language models can acquire tools and then they can execute actions based on these tools. And I'm going to show you now how such a prompt is actually augmented. But please keep in mind that a good tool complements the power of a language model. If an LLM struggles with math, you give it the calculator tool. If the language model cannot find latest information, you can provide it with a web search tool. If a large language model is struggling, so let me ask you a question. If the language model is struggling with finding the correct weather, what's the tool which you will give? If you have a language model and when you ask the weather of a place, and that weather is answered incorrectly by the language model, what's the tool which you will give to the language model in such a case? You will probably give a weather API, right? What I mean by weather API is that you will give access to some API which the LLM can request the answer from and then get the answer from that API. If you don't know what an API means, just think of it as websites like, let's say, AccuWeather. So websites such as AccuWeather essentially have APIs which you can use. So the LLM can ask this website that, hey, can you help me to get the answer which is requested by the user because I am not able to answer on my own. So that's how tools complement the power of a large language model. But now I want to show you how do tools actually work. So as we saw yesterday, large language models can receive input texts and generate output, right? These input texts which a large language model receives, it's called a prompt. These input text which a large language model receives, it's called a prompt. And unless we mention some things in the prompt, large language models cannot call tools on their own. So we need to tell the language models that, hey, LLM, this particular tool exists, and here's how you have to use this particular tool. So the way agents or any package like LangChain or any agentic framework is actually written is there is a lot of prompt engineering which goes on in the background. So let's say if you want to make an agent which answers this question about weather, right? What is the weather in Paris? So you first have a language model, and then the language model has access to the weather tool. Now in the prompt, it will be written that you have access to these tools. Then what the language model will do is that the language model will make a tool call. What tool call means is that it just calls this particular weather tool, or writes this text that this weather tool needs to be called. The language model, it has now become an agent because it's equipped with a tool call. So the agent reads this response and the agent executes the tool call on the language model's behalf. And then we get the weather data, and then the language model uses the weather data for further for getting further responses. So essentially, if you see, it's the whole process is actually quite simple. You have a language model at the initial stage. Then the language model, if the question is about weather, right, then there is some text which is generated, uh, which calls that particular tool. Let's say that text is something like call a weather tool. Now it has become an agent because it has access to this tool. And then that API call will be made. And then we receive the response. That response is again uh, received by the language model, and then the language model prints the answer. So tools, the way tools are integrated into language models is through prompt engineering. We mention it in the prompt itself that this is a tool which has to be used. And the way it's done is that, so here I've taken a screenshot of how LangChain or other packages actually work. In the prompt, we have to mention that you are an AI assistant. So let me mark this with the yellow color. In the prompt, it's mentioned that you are an AI assistant designed to help users efficiently and accurately. Your primary goal is to provide helpful, precise, and clear responses. And it's also mentioned that you have access to the following tools. And then you mention a description about the tool. That's very important. You have to mention that what the tool really does and what are the inputs which the particular tool expects. So this is how language models actually use tools. And even when you think about tools, there can be two types of tools. If a certain tool does not exist, so I mentioned a list of tools over here, right? If a certain tool does not exist, you can create a custom tool. And by custom tool, I mean you can create a simple functionality, which is a tool which you can provide the language model in the prompt itself. So tools are actually one of the simplest concepts of AI agents because it's nothing but prompt engineering. So if you go back to the start of the lecture now and see what we started thinking about how are large language models augmented to achieve all these other things, right? So until now, we have seen that we start with an LLM, and through the prompt itself, we give the language model access to tools. So the first part we have now understood how do language models have access to tools? We mention it in the prompt itself. That's step number one. So my takeaway so now I've built and deployed so many AI agents that the simple takeaway after understanding how tool works is that prompt engineering is extremely important because it's how you convey in the prompt that, hey, LLM, here are the tools which you have to use. And if you go back to your code right now, if you scroll up, just look at the start of the prompt template which we have. To the language model which we have defined here, we have mentioned that answer the following questions as best as you can, and you have access to the following tools. And then we have provided tools to the language model. This is the first aspect of how language models became or have or use tools to become an agent. That's part number one. So let me pause here for a while and ask, does anyone have any doubts or questions in the first part? So remember, I mentioned that we need to understand two things to answer the code. The first, to understand the code. The first is tools. And if there are no doubts in this section, then I'm going to move to the second section, which is React framework. But I'm waiting here for a while to see if there are any questions. There is a question here. Can we make our own tools? Yeah, we can define custom tools. Um, is LLM able to handle all formats in which data comes from the API? So in this case, we have to mention that in the prompt itself, that what's the response, which is the format in which the response is going to come. Or if your LLM can only handle a specific format, we have to ensure that the response is in that format before augmenting the prompt. Can the large language model handle tools without us including it in the prompt? So it has to be mentioned somewhere. Otherwise, the language model does not know really what to do. It's only what we mention in the prompt. When we mention in the prompt, the language model knows that, okay, these are the tools which I have to use. Okay, let's see. Are there scenarios where we need, do we have to specify system prompt for the agent? Yeah, we have to specify system prompt to the agent. Then how does ChatGPT know how to use the weather tool then? Because probably it's internally configured that if the user asks questions about weather, make a call to the API. But here we are actually looking how that internal thing works, right? So if ChatGPT should not be your basis for understanding agents, we should look beneath that. Okay, if ChatGPT is making a weather API call, how would they have coded it internally? So what I'm mentioning right now is we don't have to write this for every single agent. That's why we use frameworks such as LangChain. So in LangChain, LangChain already has defined some tools for us. So we don't have to write too many custom tools. And LangChain already comes with predefined templates like React agent, etc. So that makes our job easy. Is NLP a part of it? So NLP is the broader umbrella, right, under which we have large language models. So definitely this this all these lectures come under natural language processing by default. Okay, now let's move to the second part, which is understanding the React framework. Um, and why do we need a framework like React? Because if you see very carefully, we started with this screenshot, right? And until now, I've told you that agents have access to tools and how agents use tools, but we have not learned about two things. How can agents plan and take decisions? And how can agents interact with their environment and have memory? How do we go about doing this? Because until now, I just explained to you how an LLM can receive tools in its prompt um, and use those tools. But I did not explain how can agents plan and take decisions and how they can interact with their environment and have memory. So the underlying framework to help agents do this is called React framework. And I mentioned this paper at the start of the first lecture itself, but let me share this paper in the chat. This is one of the pioneering papers from, I think it came out in 2022 or something. Yeah, React. So this is the paper. I would encourage all of you to just take a look at it. So if you see, it's called REACT because it's reasoning and action. So RE stands for reasoning and ACT stands for action. And let me deconstruct this framework to you step by step. This framework will eventually help agents interact with the external environment and help them to plan and reason. So here is how the React framework was actually born. We initially started with something called chain of thought prompting. And chain of thought prompting essentially helps language models to answer as if they are thinking and as if they are planning. So let's say if you have a question that Roger has 5 tennis balls, he buys 2 more cans of tennis balls, and each can have 3 tennis balls. How many tennis balls does Roger have? So actually to do this calculation, we all know that it's 5 plus 2 multiplied by 3, right? That's our reasoning. So the answer is 11. But in the first case, we only say that the answer is 11. And then we ask a new question. The cafeteria had 23 apples. If they use 20 to make lunch and bring 6 more, how many apples do they have? So in the first case, which is standard prompting, the LLM answers incorrectly. But then people figured out a method which is chain of thought prompting, which means that in your prompt itself, if you tell the LLM how reasoning is done, the language model mimics that in its responses. So for example, if the same question which we have, Roger has 5 tennis balls, he buys 2 more cans of tennis balls, each can has 3 balls. How many tennis balls does he have now? And we actually show the calculation that Roger started with 5 and then 2 cans of 3, each is 6. So 5 plus 6 equal to 11. The answer is 11. We include this in the prompt itself. And then we ask the new question. And you will see that when the LLM answers now, the cafeteria had 23 apples. You'll see the answer is first of all much more detailed. And it's as if the LLM is planning. The language model is planning as it answers. So this clearly shows that if we actually include some thought process in our prompt itself, the language model will answer as if it's planning. And we want planning capabilities in our agent. We want planning capabilities in our agent. That's one of the most important things which we have seen in an agentic definition, right? We want agents which can plan and take decisions. So chain of thought, this paper, chain of thought prompting was a huge success. And this technique actually proved that language models are capable of generating reasoning traces or thoughts. Uh, the answer here, which you are seeing here, these are also called reasoning traces because it looks like the language model has its own thoughts and it's reasoning through those thoughts and coming to an actual answer. But chain of thought prompting had some issues. It does not have access to any external world, so it cannot act, which means it cannot take actions. We have reasoning traces, that's good, but we also want a language model to take actions on top of this. There are some questions, few shot prompting, so basically single shot prompt. So this is, you can call this as a few shot prompting because we just give one single prompt, and in this case, even a single prompt is sufficient. A single additional example is sufficient in this particular case. But the disadvantage of chain of thought is that it lacks access to the external world and it cannot act. That's where the act of React comes into the picture. It builds on top of chain of thought. React builds on top of chain of thought, but on top of that, it adds this acting capability. And the way React framework does that is through something called the TAO principle. What the TAO principle means is it's thought, action, and observation. And actually, it's a loop. So I should actually draw it as follows: T, thought, action, and observation. It's in a full loop like this. So you may be confused that what does this exactly mean, right? Let me show you with the same example which we saw. Let's say the question is the same question which we start with, right? This question that what is the current price of a MacBook Pro? How much would it cost? Let's say if that's the question given to an agent, the thought action observation framework goes like this. The first thought which the agent will have is I have to check the MacBook prices. Based on that, the agent will take an action. That action is let me do a web search. And then it receives an observation, which is the price seems to be in dollars. Now, here is the most important thing about agents. Agents don't stop here after one loop. They keep on repeating this loop until they get the correct answer. So price seems to be in dollars. That's the current observation. On top of that, I will have my second thought, which is the price now needs to be converted into euro. My second action is let me use the calculator tool. And my final observation is the price is in euro. I am now satisfied. So you see this loop keeps on happening until the agent is satisfied. And this is one of the biggest differences between language models and agents. A language model will just generate an answer and stop over there. But in this thought, action, and observation framework, the agent keeps repeating this loop until it has an answer which it thinks is right. If it's not, it will go to the loop again. So for example, the things which I've shown in the red here right now, on or let me mark it with the first circle in red. So the first circle which I'm marking right now, this first circle, that's the first loop of the agent. Thought, action, and observation. I have to check MacBook prices, that's the thought. Let me do web search, that's the action. Price seems to be in dollars, that's the observation. It does not stop here. We go to the second loop. Thought. So the second loop is essentially the outside loop, which is this loop. So the thought is the price needs to be converted into euro. Let me use the calculator tool, that's the action. And then the final observation is price in euro. The agent is satisfied here and then it stops. So this is the main difference between chain of thought prompting and the React framework. Because if you see in chain of thought prompting, there is no thought action observation framework loop like this. There is only thinking and the answer. React essentially builds on top of this because it adds reasoning and acting. Where does the acting come into the picture? It's the action part. And these actions are actually performed through the usage of tools. So now see, this is where everything actually comes together. The actions are performed using tools. And we already looked at tools before, right? The tools are actually used in this thought action observation framework. That's the reasoning plus acting. And here you see the whole framework is such that the agent continuously interacts with the external environment. So this observation which it has, it's through its interaction with the external environment. In this observation, the agent can also receive human feedback. Remember in the first lecture, we talked about human feedback. We can even give feedback in the in the observation. So then the agent again goes into this loop. So essentially agents are LLM equipped with tool, that's fine. But using the React framework, agents can interact with external environment to add additional information into their reasoning. So there is reasoning here, there is action here, and there is observation and this entire loop. And this diagram which you are seeing right now, that's the main difference between LLM and agents. So it's a simple addition that these people actually thought of this loop, right? That the thought action observation framework needs to be set into a loop. And they got huge benefits through this simple framework. You can call this a React framework, you can call this agentic framework, you can call this agentic AI, etc. But broken down into its simplest form, agents just have this thought process in their minds. So they have this framework which guides them and they have access to tools. Now, the simplest analogy which I can think of is, let's say that there is a kid, right, which is left out into the environment. And there are 5 chairs here, and the kid needs to find that chair which has the candy. So here you will see the thought action observation framework, right? The kid first goes to chair number one. It sees that there is nothing over here. That's the observation. So the thought is now there is nothing in chair number one. So the action is let me go to chair number two. Again, the observation is there is nothing here. So then again, the thought is that there is nothing in chair two. Let me go to chair three. So similarly, when kids are in their external environment, when they receive feedback from the external environment, we are also in this thought action observation cycle continuously. In fact, if you think about all of the decisions we humans make, it can be boiled down to this simple framework where we are in an external environment where nothing is fixed. We are continuously receiving feedback, and through that feedback, we are improving, we are learning. And if you observe very closely, for this to work, agents need to have memory. Why am I saying that? Because let's say the kid here, right, after going to chair number three, if the kid suddenly forgets what has come before, it might go back, right? So you need to have memory for this to proceed. So the thought action observation framework definitely needs the agent to have memory of the interactions which it has had in the past. So for example, here, right, we need to have memory of what happened in my first loop. I saw that the price is in USD, because if this memory does not come to the next loop, then this framework is useless. That's why now if you go ahead and if you go to the top of the lecture, and now if we try to deconstruct how can agents plan and take decisions and how can they interact with their environment and have memory, that is because of the React framework. And where is this React framework actually implemented? The React framework is also implemented in the prompt itself. So right in the prompt, we give the agents access to tools, and the React is also there in the prompt. So if you see here, if you closely see the prompt, there is the thought, there is a thought, there is the action, and there is the observation which is mentioned in the prompt itself. And LangChain by default has something called create React agent. And this is a package, but it will use this thought, action, and observation which we have defined over here to go into that loop. So see here, the thought is you should always think about what to do. Action is the action to take should be one of the tool names. See, here is where I mentioned that when you want to um, take an action here, here is where you have to use the tools. So the action to take should be one of the tool names. The action input is the input to the action. So if it's, let's say, weather API, the input is maybe the city where you want the weather. The observation is the result of the action. And see what's mentioned here. This thought action observation framework is repeated n times. So this thought action observation is repeated n times. And finally, when the LLM thinks that, okay, now I know the final answer, that's when we come out of this loop. That's when we come out of the thought loop. So it's all in the prompt. So if you might be thinking, okay, I understood the React template and I understood the tools, where is the place where we give that to the LLM? Everything is given to the language model in the prompt itself. So in the prompt itself, we tell the LLM to go through this thought action observation loop and only stop when you think you know the final answer. So see, we are relying so much on the power of an LLM to understand language, because if your model did not understand language, this entire framework is useless. This framework is based on the premise that your language model is amazing and it can understand everything about human language, which is probably true with the latest GPT models. So now when you look back at this code, you should look at it in a completely different light. You should now think that, oh, okay, the reason I have this React template here is because I have to give a much more detailed prompt to the language model. I want the language model to follow this thought action observation framework. If I don't have any framework, my language model won't plan. And not just planning, we want the language model to continuously question itself, right? That's why we have this loop. We want the language model to question itself and we want it to repeat n times until you know the final answer. So all the important learning of agents actually lies in how you make the prompts which are passed to the LLM. Once you have the prompt, so you actually need two things. You need the prompt, and in the prompt, you need tools. So first we define the prompt template, then we actually define the tools which we need, and then we created an agent. So the agent needs these three things. It needs the language model. The language model needs a prompt, and the prompt needs tools. So that's why this create react agent has three main arguments. You need a language model. The language model needs prompts, and the prompts need access to tools. Why do you need access to tools? Because you cannot perform any action in the thought action observation framework without tools. That's it. And then you just do agent executor.invoke. So at its very basic, what we are doing here is just calling a large language model, right? We are actually just asking some question to a large language model. The reason it's been called as an agent is because now the framework is such that it has access to the external environment and it can reason and plan, and it has access to tools. But all what we are doing is just making changes in the prompt really. So one way to think of agents is glorified language models who have access to tools, who have access to environment, who can reason and plan with memory. But I hope that you are not intimidated by codes like these now. The way to start understanding this code is from the bottom up. So first look at this thing that, okay, I have these three things, right? LLM, tools, and prompt. What's the LLM which I'm using? It's GPT 3.5. What are the tools which I'm using? DuckDuckGo for web search and math. And what's the prompt which I'm using? It's the thought action observation framework. Okay, that's the React template. Uh, all right, so this is the core of today's lecture, which I wanted to, that's the first takeaway from today's lecture. It's the React framework and this loop, which I've shown over here, which is the main highlight of how LLMs are converted into agents. We are going to take a look at one last code today, but before that, let me pause and take some questions in the chat. Uh, can someone share the links? So the links which have been shared are this Google Colab notebook. And let me share this link once more. Yeah, so this is the Google Colab notebook, which you can open. Let me see if there are any other questions. Are we going to have a class on prompts? No, we will not have a separate class on prompts, but as we develop agents in subsequent lectures, I'll show you how you write effective prompts. There's a good question that what if the agent goes in an endless loop? So usually when we'll define agents, there is a max iterations which we set. So that's the maximum number of times it can go in that loop. What's the difference between reasoning models and agents? Reasoning models again are not equipped to take actions with tools, right? Um, Agents are equipped with tools. So the prompt specifically mentions usage of tools. The main thing of agents you can think of, it's reasoning models in a loop. Uh, and also reasoning models reason and stop. They don't self-evaluate themselves many times. You can define an agent to enter a loop countless number of times and then take action. Can agents end up overthinking and give wrong answer? Yeah, probably. We are already seeing that with some reasoning models, right? But we need good amount of thinking for planning. So if you take a look at the first lecture and the example which we took in the first lecture regarding the Spain trip, right? That needs a lot of planning. So we would want our agent to think. Um, does the React agent created in the notebook have memory? That's actually quite a good question. So by default, React agents have memory, but they don't have infinite memory. So for example, there is something called conversation window buffer or window memory buffer, which we can set, which defines the amount of memory which a React agent has. How does agent know its last end loop? That's another very good question. So how does agent know its last end loop, right? Take a close look at what we have mentioned in the prompt. We have mentioned in the prompt that whenever you think you know the final answer, you have to stop. So we are relying on the language model judgment that, okay, now I've got the final answer, I'm going to stop over here. And if it still keeps on going, then we can put a limit on the number of maximum loops which we can have. Can the agent eval itself? Actually, it is evaluating itself, right? Because the moment it enters into a loop, we know that some kind of self-evaluation is going on. We can even put human feedback. So to give additional evaluation points. Okay, now let's go to the last point in today's lecture, which is essentially one more code which we are going to explicitly do with agents. Now, this is the second React demo code number 2. So what I'm going to do over here now is that you can first refresh your notebook entirely. And we'll need one more API key. That's essentially the Serper API key. So what I'm going to do is that I'm going to refresh here once more. And meanwhile, let me show you the Serper. How many of you know what Serper is? There is a question about can we create AI agents with Ollama locally? That, yeah, I think it's possible. So for example, if you download a local Ollama model and you do the prompt engineering yourself, then you can deploy an agent locally. So what I just mentioned, the thought action observation, you have to create a prompt template and you have to feed that prompt template to the language model and use tools. The reason normally we use packages like LangChain or LangGraph is because they have functions out of the box. So for example, they have functions such as this agent executor, then create React agent. These functions are given out of the box by LlamaIndex. You can even do it locally. So you can use these packages locally, and the LLM, you can use the one which you have locally downloaded from Ollama. But in that case, it needs to be a small language model, I think, because otherwise it will be very slow. Or you can check DeepSeek, trying to download it locally. Yeah, so what I was talking about was this Serper. So Serper is essentially the reason why we need search APIs is because we'll frequently need to go to Google and we'll need to do some sort of a search, right? That's why we need search API, and there are multiple search APIs. I want to expose you to as many search APIs as possible. So you can think of it as a essentially Google search API. There are many competitors in this space, but these are some of the widely used competitors. So just go here, click on sign in. Uh, um, and I think these API keys you will get for free. So you can just create an account over here at Serper, and you can get their API keys for free. You can create an account login using Google, and then it will directly prompt you towards creating an API key. So I have already got my API key here on the free tier. So you can now start running the rest. There is a question that tried to make this code work with perplexity, but failing due to a weird error. Yeah, so perplexity, I have not actually tested it out with this code. So I need to see how that actually works. Okay, so let me run these packages once more. Meanwhile, let me explain what's going on in this code. So what we are going to do in this code right now is that it's a simple thing. We are just going to ask a question, that some random question, and then we are going to use the Google search or the Serper API, and we are going to use it along with another tool, which is the calculator tool. So let's see. Meanwhile, let me take some questions in the chat. The API key for OpenAI has a rate limit. Yeah, so that's you'll have to update your balance to move past the rate limit on OpenAI right now. But in the second code, let me quickly explain what's happening. So we have the OpenAI API key, and we have the Serper API key. And see, again, what we are doing here is that we are initializing an agent and we are using tools. The tools are the Serper API tool and the LLM math, which is essentially calculator, right? And then the agent which we have mentioned is zero shot react description. So now all of you should intuitively understand what this really means. What does it mean agent equal to zero shot react description? It means that we are using a React framework and it's a zero shot React framework, which means we are not passing any examples in the prompt. Um, and then finally, what I'm going to ask over here is that, let's say, who are Dr. Raj Dandekar's co-founders and what is their current age raised to the power of 1? So here again, what are the tools which will be needed? Can you type it in the chat that who are the if you want to find the co-founders of a person, what tools will be needed? And let's say we want to take the current age raised to number 1 power, whatever. Yeah, we need Serper for web search, right? And we need to use the math tool. So here again, I'm using the Serper API, but the answers which we get is not very good because there is not too much information about this online. I think you can replace this with anything which you want. You can put your name over here. But the point here is that take a look at this thought action observation framework over here. The first thought is that I can use a search engine to find information. That's the first thought. The action is that I'm going to use the Google Serper tool. The action input is Dr. Raj Dandekar, co-founders. And the observation is whatever that the current age is this. So the thought action observation framework, which we learnt about on the Miro, that's the exact same thought action observation framework which is now happening on the screen. Let's see. I tried using LangChain with Gemini models, however, I was unable to use that React agent. Yeah, so with LangChain, OpenAI libraries are very much compatible. So if you see, there is the import chat OpenAI package that's extremely compatible with LangChain. All right. So now let's see how many of you were able to run this second demo code. Can you mention in the chat if you are able to run this and what are the answers which you are getting? So I think Manish is able to run this code. Um, good. I ran into errors where the output is tuple. Yes. So Madhavan is also able to run this code. That's quite good. So as you can see, the answer might be a bit hallucinating a bit, right? And we are going to look at some examples later to reduce hallucinations and to ground the LLM output in reality. So the reason I took this example is to mention that we should not blindly trust the answers given by an agent because an agent at the heart of it is ultimately a large language model, right? And large language models can hallucinate. So that means that agents can also hallucinate. Um, but some takeaways which I want all of you to remember after this lecture is that agents essentially are large language models which have access to tools. They are built on top of this framework, which is called as the React framework. The React framework is a thought action observation loop. So we have a thought, we go into the action and we see the observation. That's the thought action observation loop. In the action, we have access to tools. And I've already exposed you to some tools and I'm deliberately exposing you to more and more tools which are used in industry. So for example, the Serper API, which I just showed you right now, right? The Serper API is a very widely used search API in industry settings because it's extremely fast and it's also cheaper. So I'll introduce you to many such API calls like these. Um, Okay, can someone share the Google Colab code file? So let me share the Colab code file once more. Meanwhile, are there any doubts or questions in this lecture? I'll be happy to take any of those questions. How do we find out the different tools which are available like Surfer API? So one of my main goals in this bootcamp is that I'll eventually introduce you to all of the type of tools which I've mentioned here. I'll introduce all of you to these categories of tools. I'll introduce you to the web search tool which we already saw. There is Surfer. Then I'll introduce you to image generation, retrieval, and different API tools. So in those lectures, I'll try to cover as many as you can. Um, are all packages for agents prompt types configured in LangChain? So let me actually now explain one more thing. Now what we saw is we saw the React framework, right? In the next lecture, we are going to actually start looking at frameworks for building agents. So the next lecture is about frameworks, and there we are going to see code-based frameworks and no-code frameworks. And the reason I explained the React framework to you is that almost all of these frameworks are built on top of the React logic, which is the reasoning and acting. So it's very important for you to know what's going on. When we take a look at these codes, most of the underlying thing will be abstracted away. At that time, we'll just use a package. So it will be difficult for you then to understand what's going on. That's why this lecture was very important. So when you see something like, let's say, if you see something like this create React agent, you should know what this means instead of blindly using this in the packages. We are going to have a separate lecture on LangGraph, LlamaIndex, and Smolagents, where all of them have possibilities of creating React agents like this. They all use different um, code, different code, but the underlying thing is the same thing. Uh, let's see, there are many questions. Is there any way to make the agents choose the LLM model? We can, there are some agents which choose the model automatically. For example, we have a routing layer and the layer chooses the model on its own based on if you want to prioritize on cost, etc. But mostly it's given to the LLM. So it's given to the agent. Three things need to be given to an agent mostly. The language model needs to be given, the tools need to be given, and the prompt needs to be given. If the agent evaluates itself during TAO loop, how is it trained to do so? So the training lies in the prompt itself, because in the prompt itself, we have mentioned that, okay, here is how you should think about this question. Here is how you should go into the loop. If the answer is not correct, go into the loop once more. So all the details have been mentioned in the prompt. Um, it seems like the real magic is the emergent properties of LLM. And now we use LLM in different ways to get the answer. Yeah. So again, if you think about it, the reason agents have become so popular is because they rely completely on LLMs. And if LLMs did not have emergent properties, the LLMs were not so good at many tasks, agents will naturally be performing worse. Um, so can I say that the whole code is an agent which solves the particular problem with LLM as its brain? Yeah, that's probably a simplest way to think about it, that the LLM is the brain of an agent. The tools you can think of as arms and limbs of the agent, but don't forget about the thought action observation loop. That's probably the most important. Are multiple iterations always necessary for accurate predictions, right? Mostly, because if you want to plan something, planning never happens in a single shot. So if you want to plan and make decisions, you always need to go in a loop. Otherwise, planning is not good. And if you think about, humans, right, when we plan, we also go into multiple loops. We don't immediately get to the correct answer. That's why I think this thought action observation framework is so intuitive, because even humans think and plan like this. As I gave an example of this kid who is looking for this candy, right? As the kid navigates the external environment, we automatically are in the thought action observation kind of a bubble. Would we need to include any guardrails? Yeah, uh, we do need to include guardrails if the project is sensitive. So, for example, if usually when we build agents for enterprises, there is a guardrail step and evaluation step, which are the final steps, because you cannot have responses which are which contain sensitive information, etc. So enterprises have some rules about the kind of responses they want and the kind of responses they need to be filtered out. So for that, we have to add a guardrail layer on top of the output of the agent. So I hope that after this lecture, all of you realize that agents are not something quite extremely complex. At the heart of it, it's just an LLM with prompt engineering, but it's just that the prompt engineering is done so wisely. It's based on this research paper, the thought action observation framework. The prompt engineering is done through this TAO framework, and the actions need access to tools, and that's how tools are provided. And actually, to provide tools, there are two ways to provide tools. One is you directly give API or access to tools. The other way is something called code. So you can also provide a tool as a code. So let's say if you want to create a custom tool, it can be a custom code function which you have written. I deliberately did not go into those details because it might have made the lecture a bit more complex. Can we get a link to the research paper? So I already shared the research paper link, but I'm sharing it once more. How do we apply the human feedback loop, right? That's one of the most important pieces of the puzzle, which is ultimately not covered quite well. So there has to be an evaluation framework, a manual evaluation framework where a human is in the loop. And there are multiple dashboards where even human feedback can be collected along with the agent's own feedback. So then that feedback is added to the observation and the agent continues in its loop. I will be showing some evaluation frameworks like these in subsequent lectures. How does it know it's not the right answer? So right answer is one thing, right? But some questions itself are multi-step. So if I ask an agent to give me a travel itinerary, first it has to go through web search. That's the first thought action observation. Then it has to do something else. That is the second thought action observation. So the TAO frameworks are also needed in multi-step planning. Uh, so it's not just about whether the answer is correct or wrong. Wrong. If the LLM feels that its answer is not good, it will again go in a loop. But even if the answer is good, there may be multiple planning steps involved in the question. That also might require the LLM to enter this TAO loop. So there are some questions like, will the bootcamp cover production grade agents in further lectures? Yeah. So we will have special projects for production grade agents for the pro registered candidates. All other lectures which we'll be covering, we'll be building 5 to 6 agentic projects in these 10 lectures. But there are 5 industrial projects which I'll be sharing with people on the Discord group essentially. Um, how do we apply? Okay, this question I already covered. Where does RAG help in agents? Actually, this is a very good question. We have a separate lecture called Agentic RAG. So Agentic RAG essentially, I'll cover that in the lecture, but there is this thing called Agentic RAG, which basically augments the traditional RAG framework. In traditional RAG, you don't have this TAO loop, right? In Agentic RAG, you have this loop. So Agentic RAG is better for some things than traditional RAG. When we learn about LlamaIndex, we will learn about Agentic RAG. I think that's in lecture number 6. All right, everyone. So this brings us to the end of this lecture. In the next lecture, we'll look at frameworks for agents. So we'll look at we'll look at the introduction to the frameworks, and then the day after the next, we'll actually start building through frameworks. So next lecture will be on introduction to coding frameworks and no code frameworks. But now that you understand the theory, all the frameworks which come after this will be based on the theory. Next lecture will be held tomorrow at the same time. So 2 p.m. IST on Wednesday, 25th June. That will be the next lecture, and I'll also upload the recordings. The recording of all previous lectures are on the dashboard. And those of you on the pro plan, the recording lecture notes are also on the dashboard. And on Discord, I'll be uploading some new assignments. Thanks everyone for attending, and I look forward to seeing you in the next lecture. Please make sure that you don't drop off after 3 lectures, because it's good that all of you have stayed for 3. Now only 7 more are remaining. Thanks everyone. I'll see you in the next lecture. Bye. So let's get started with today's lecture. Before that, I want to mention a couple of things. For the pro registered people, I've added the next assignment on the Discord channel. So you can check that assignment and submit your solution. It's a theoretical assignment designed to test your understanding of the thought action observation framework, which we learned about in the previous lecture. In today's lecture, what we'll be doing is that we will have a quick overview of the different type of tools or the different type of agentic frameworks rather, which the entire world is moving towards slowly. So I've given the name of today's lecture as Agentic Frameworks, what the world is doing. So I'll list down all the current frameworks which are there, all the frameworks which have been popular, the useful frameworks which I use, and the frameworks which make a lot of sense for industry as well. So that's the main purpose of today's lecture. So I'll mainly cover 3 types of frameworks, and I'll explain to you what those means: coding frameworks, low code frameworks, and no code frameworks. And in the next lecture onwards, we'll start diving into each of these frameworks separately and build a project in these frameworks. One hands-on element in today's lecture is we are going to use an application called LangFlow today, and I'll show you the downloading process live. But to save time for all of us, if you guys can head over to this link and download the application onto your desktop, then that will save us time when we move to this part of the lecture today. So just go here and download it. This application is free for initial use, so it won't cost you anything. Let's recap what we have learned so far in the previous 3 lectures. The 3 Substack articles for the 3 lectures are now available. In day 1, we covered the definition of agents. In day 2, we learned about the underlying framework of agents, which is language models. We saw that language models have 2 stages: pre-training and fine-tuning. And in day 3, which is yesterday, we covered the thought action observation framework. So the Substack notes which I have written for this are extremely detailed. If you go through the Substack, you will see we covered about tools, which you can think of as weapons which an LLM receives to perform a certain action. Then we covered prompt engineering, which is essentially an extremely important ingredient for agents. We pass the tools to a large language model through the prompt. So here you see in the system prompt itself, we pass the tool's description. And that's how the language model knows that it has to use a tool. So language models only take text input and produce text output. They have no built-in button to call a function. So we have to describe the available tools in the system prompt or the context and instruct the model on the format to use them. That's the second major insight which we learned from previous lecture. So prompt engineering plays a very, very crucial role. And in subsequent lectures, when we are going to build the projects, I am going to show you how I usually write prompts. Um, So now the third part which we learned about is chain of thought. And I hope all of you now know the difference between chain of thought prompting and the React framework. Chain of thought prompting showed that models can generate reasoning traces, but they don't interact with the external environment and hence they cannot take actions. On the other hand, React goes a step further by introducing something which is called as the thought action observation loop. So the thought action observation loop is the heartbeat of the React agent. And through this loop, the agent interacts with the external environment and the agent also learns how to plan, how to take decisions, and it needs memory for this purpose. That's the main part which we covered in yesterday's lecture. And now we are all set to essentially learn about how to build applications using agents, which are also called as agentic applications. So now that we know how agents operate, we are ready to build agentic workflows. So these are also called as um, agentic workflows, or these are called agentic applications. Okay, so to learn about agentic workflows or agentic approach, first we have to understand why do agentic frameworks exist in the first place. Agentic frameworks exist because we saw that agents have value. Now, how can people in the real world extract agents or use agents so that agents can add value to their life? So let's say a person wants to use agents and they want to add value to their lives or they want to add value to their organization or enterprise. Um, that's the reason why agentic workflows or agentic applications exist. And broadly speaking, there are three types. Broadly speaking, there are three types of agentic workflows. First is code-based agentic workflows. Second is something which is called as low-code agentic workflows. And the third, which is called as no-code, which is absolutely no coding involved based agentic workflows. And all of these have become extremely popular now. Based on the use case and based on the person who is deploying the agents, you can choose which type of agentic framework to essentially go ahead with. So, as I mentioned in today's lecture, we are going to learn an overview of these three types of agentic frameworks, and we are going to essentially dive into LangFlow. So if you cannot use LangFlow or if you are not able to access it right now, it's fine. Just try to pay attention to what I'm doing in this lecture so that you can work on it after the lecture is over. So first, let's get started with code-based agentic workflows. Code-based agentic workflows essentially are meant for developers in enterprises who want to build agents in their workplace or students who want to code agents from scratch. Um, so yesterday itself, we have looked at a code-based agent workflow, which is LangChain. So formally speaking, right now there are 5 code-based agentic workflows which are extremely popular. The first is LangGraph, and there is a reason why I've kept it first over here. I'll explain that. The second is LangChain. The third is LlamaIndex. The fourth is Smolagents, and the fifth is AutoGen. These are 5 code-based agentic workflows which have become extremely popular. And let me show you in an essence what these agentic workflows do. By far the most popular code-based agentic workflow at the moment is LangGraph. So I'll share a link with you. You can head over to this. So actually LangChain came first and then LangGraph was introduced, but it's much better than LangChain for several different reasons. Now, why do we use frameworks such as LangChain? Or LangGraph rather, because they have a functionality which is called as create react agent, which is a functionality in the application itself. So then you don't have to code every single thing from scratch. You can just use this function, which automatically creates a React agent for you. So that saves time for you as a developer. Now, what I'm showing right now is the documentation of LangChain, and see what they have written here. This implementation is based on the foundational React paper, but is older and not well suited for production applications. For a more robust and feature-rich implementation, we recommend using create React agent from the LangGraph library. So again, here the one of the most important points to understand is that both LangChain and LangGraph provide you functionalities to implement agents, but LangGraph is better. So even LangGraph has this functionality of creating a React agent. And what it does under the hood is essentially exactly what we saw, right? We looked about the thought, or we learned about the thought, action, and observation framework. This is exactly what packages like LangGraph and LangChain actually do. So create React agent, they also have a documentation for this. And within the documentation, you will again see this loop. So this loop, the words look different, but it's very similar to the thought action observation framework, which we learned about. So essentially, these code-based frameworks are a way to implement the thought action observation framework using a function which is already created by these frameworks. And that's one way to explain why code-based frameworks are so popular. So these are two which are extremely famous, LangGraph and LangChain, but there is a third framework which is LlamaIndex. How many of you have heard about LlamaIndex before? You can mention in the chat if you have heard about it. So essentially, LlamaIndex is good for RAG-based applications which involve indexing of documents, etc. But now they also provide agentic workflows. And that's why even LlamaIndex has become extremely popular for creating agents. And we are going to create agentic RAG systems using LlamaIndex in this course. So just to give you a sneak peek, this is the first code which I already showed you, right? That used LangChain. Then in lecture number 6, we are going to code using LangGraph. So you'll see when we come to this lecture, we are going to build a graph like this uh, and execute the thought action observation loop. And then in one more lecture, which I believe is lecture number 5, we are going to code agentic RAG systems in LlamaIndex. So the reason I'm showing this to you right now is because when we learn about these tools, all the coding we will do will be in Google Colab. Because if you see here, these are full code based frameworks, which means you will need to understand the code to run these agents. And depending on the type of audience, essentially, this might be, if it's slightly intimidating to you to look at this Google Colab, don't worry about this. When I go to that lecture, I'll explain each and every code cell individually. But I particularly think that it's extremely important for everyone to understand code-based frameworks before you jump to low code or no code. You can already understand why low code and no code are so popular, right? Because it's easy to use. It's way easier to use than code-based frameworks. But code-based frameworks offer you one thing which overpowers the low code or no code, and that's essentially control. So if you are attending this bootcamp and if you're from an industry or enterprise, no code or low code frameworks will take you to a certain level. But if you want to integrate agentic workflows within your organization, which are deeply embedded with your current systems, then you have to rely on code-based frameworks because they offer you a lot of control. So we don't need to be intimidated by code-based frameworks. And in this bootcamp, I'm going to cover LangGraph, I'm going to cover LlamaIndex, I'm going to cover Smolagents, I'm going to cover 3 code-based frameworks. There is one more which I've mentioned here, which is called as Autogen. And Autogen is Microsoft's agentic framework. And the reason I'm showing this right now is because this is also quite popular. But the thing about these code-based frameworks is that if you learn 2 or 3 of them, you will find others very easy to implement. So my task is to implement 3 projects using these 3 frameworks, LangGraph, LlamaIndex, and Smolagents. And I want to mention a quick note about Smolagents. How many of you have used Hugging Face or are aware of what Hugging Face is? Right? Hugging Face has become the gold standard for open source artificial intelligence or open source machine learning, whenever you have implemented a project, you can open source it, upload it on Hugging Face. Many open source models are available on Hugging Face. So the team at Hugging Face has created their own package, which is Smolagents. And I think this is the simplest code-based framework to learn. So first we are going to start learning about this framework in the next lecture. Then we will move to LlamaIndex. Then we will move to LangGraph. That's the order in which we'll cover these three. So we'll build a project using Smolagents because it's a very simple library, and that will be a good introduction for all of you to code-based agentic frameworks. But I'll make sure that the code which I give you will be generic enough so that you can use it and repurpose it for your own applications later. So this part of the bootcamp might be a bit challenging for people who have never dealt with code-based artificial intelligence or ML, but don't worry, it's my job to explain it to you in as simple a manner as possible. And in fact, for those of you who ran this code yesterday, you already got a taste of code-based frameworks, right? So that's part number one. The second part is low code. Can someone tell me how many of these terminologies you have heard of before? You can just mention the number if you have heard of all these four. So there are four applications which I've listed here. CrewAI, CrewAI, LangFlow, n8n, and Agno. How many of you have heard about these before? Or how many of these have you heard about before? So I can see 0, 2, 3. The most common answer seems to be 2 to 3, right? Essentially, all of these are frameworks which have become extremely popular because they are low code. That means that if someone has no coding initiation or if someone has no code background, they can still use these frameworks. So these frameworks actually provide a hybrid option. For example, if you see n8n, you can start off by assembling different blocks in a no code fashion, but it also provides coding. It also provides an option to build custom code. So let's go through these step by step and understand each of them. The first is CrewAI. CrewAI can be called as a low code because, so for example, we have a whole tutorial on CrewAI and we will write code here. So the reason I'm calling it low code is because it's extremely simple code. Everything is abstracted away. It does not even feel like a code. That's why I'm calling it low code for CrewAI. And CrewAI is extremely good for organizing multiple agents together. That's their specialty, and almost everyone uses CrewAI now if they want to attach different agents or chain different agents to each other. But I call it a low code framework because the code involved in CrewAI is not as complex as LangGraph or LangChain. They abstract away so many things that the code essentially reads like English text. Like, take a look at this. This almost looks like English text, right? We are mentioning the role, the goal, the backstory, whatever. So that's CrewAI. The second is LangFlow, and we are going to actually build an agent using LangFlow today. I'm on Mac right now, so I have an application. For Windows, I don't know if an application exists or not. If it does not exist, you need to pip install. I'll share instructions with you after this lecture is over. But those of you on Windows who are not able to build this, right now, just follow along as closely as you can, but do build it later. Then comes n8n, and I'll show you all a quick demo of n8n. But this is how the n8n actually looks like, where you see different things are assembled as uh, building blocks, right? See, here there is no code. It's all building blocks which are assembled. It's a visual interface which is there. And that's why this is, so you might be saying that then why is this called a low code? It should just be no code. The reason it's called low code is because n8n gives you the ability to add custom code as well. So you can use it as a no code interface, and that's why it has become so popular. But you can even include custom tools, for example, in n8n. Links, right? Yeah. So let me paste the links in the chat so that all of you can access. So this is the link of CrewAI. Let me post the link of n8n also. So this is the link of n8n. So you can just go to n8n.io. And LangFlow, I already pasted the link at the beginning of this lecture, but essentially it's this. Someone asked about make.com, right? So make is also considered a low code. It's actually much more easier to build in make compared to n8n, but n8n also has a lot of coding customization. So make is almost fully no code. So n8n is a bit better for developers because it also gives you ability to add custom code. Then Agno. How many of you have heard about Agno? So this is probably the least popular among all these other ones, but I think it's an amazing agentic workflow. See, no one has heard about this, right? I'll tell you about this when we come to this, but it's the full stack framework for building multi-agent systems. We are not going to cover Agno in this bootcamp because it's not quite popular as of now, but I want to introduce you all to this because I think it might become popular in the future. It already has about 30,000 stars on GitHub right now. As you can see, it's fully open source, right? One more thing to mention is open source versus closed source, right? So LangChain and LangGraph, they are based on open source frameworks. Whereas when we deal with n8n, n8n is also open source. If you check the GitHub repo of n8n, it has around 100,000 stars now. Take a look at the number of stars on this GitHub repo. So there is this open source movement which is happening, and it's amazing, right? Because then people can learn from each other, etc. Let me share the link for Agno with all of you. And then the last type of framework which is there, it's no code. And I'll come to this towards the end. No code means absolutely no code. And there are some key players here, such as Microsoft Copilot Studio. Google Vertex is not exactly no code, but I've included it here because you can do some no code things using Google Vertex AI agent. Then we have Manus, which is an absolutely incredible no code platform. And I'll show you about Manus. But before actually going into no code, now I want to show you a demonstration where all of you will be building, all of us will actually be building a agent through LangFlow. And the reason I'm doing this is because so that you will get a feel of low code environments. You already have a feel of coding environments from the previous lecture. Now to give you a feel of low code environment, let us learn about LangFlow. So I'm going to LangFlow right now and I'll show you my installation process fully. So you click on get started for free and then I will click on download LangFlow at the moment. So I'll mention my email address, my company over here, and then I'll click on download. Okay, so before actually I go ahead, I think I'll need to share my entire screen over here. So I'll stop sharing and share my full screen so that, yeah, then now I'll click. If you don't see any part of the screen, just let me know. So I click on download LangFlow at the moment and you see the download has started. And then I open this DMG file and then I bring this into my applications folder. I already have an existing LangFlow, so I'm going to click on replace over here. It's in use, so I need to quit my existing LangFlow, I think, for me to, now let me try this once more. So let me click replace and now it's installed. So now I can just open LangFlow. Yeah, and this booting up, I hope you see on the screen that LangFlow is booting up right now. This will take some time to boot up. So while this is booting up, so I hope, how many of you are following this process right now? Can you just mention yes if you are using LangFlow right now as we are speaking? Okay, it's good. At least 5 to 10 people are following, right? So if Windows is not there, it might lead to some issues, but if not, just follow along what I'm doing right now. LangFlow can be set up for Windows as well, but for Mac, the setup is extremely easy. Uh, it is there for Windows. You just need to install it through pip install. Okay, so now you can see here that the LangFlow, you'll see some kind of a interface like this, right? So I'm just going to maximize my screen. Before going further, those of you who are following along, Please make sure to have your OpenAI API key ready because we are going to need it. So click, just have that handy. And now I'm going to maximize. So first let me copy my OpenAI API key actually because I'll be needing this. Okay, so now let me maximize my screen and let me show you my framework for building a simple agent. If you are not able to follow along for some reason, or if you are not able to install this or get it running, try to pay close attention to the exact workflow and see how intuitive this is. So I'm going to click on new flow over here, new flow, and we are going to build a simple agent right now. So I'm going to click on simple agent. Okay, so that opens a template which you see right now on the screen. And this might look a bit complicated right now, but it exactly fits into the framework which we have learned. So let's zoom in here and see step by step what's happening. This is an agent which essentially uses two tools. The agent uses the URL tool, so which means we can give it any URL on the internet, and the tool is that it can understand what's written on that particular URL. That's tool number one, which is this. This is the URL tool. And tool number two is the calculator tool for performing basic operations. So that is tool number two. So URL is one and calculator is two. So that's two tools. And what we are going to do is that, you remember, agent has access to tools, right? So the tools are defined over here. The tools are defined over here. Tool number one is the URL tool. It's called tool set over here. And here it loads and retrieves data from the specific URL. You can see what's mentioned over here. You can even move this around here and there. But that's tool number one. Now, if you scroll below, you'll see that there is tool number two here, which is calculator, that essentially performs basic operations or basic arithmetic operation on a given expression, right? So that's two tools we are using. And then what do we do with these tools? We pass these tools to the agent. So see, these tools are passed to the agent. This line which you see over here, this line which passes from the tool to the agent. And as I mentioned earlier, or as we have now seen in detail earlier, agents are based on language models as their foundation. So here we have to provide a model here. So now we need OpenAI API key only if you are choosing OpenAI as the model. For those who are using Gemini, you can use Google Generative AI also and provide that particular API key over here. But if you are using OpenAI API key like me, just copy paste it here. But they also have provision for other models. So there are three things which this agent receives as an input: the two tools and the chat input, which we will ask to the language model. But now this should not be a black box for all of you, because we have seen what an agent means, right? What an agent is just a language model which has access to tools through the prompt. So the reason LangFlow is a low code is that it also gives you access to code. So if you click on this code over here, if you click on this code, you will see that the entire code opens up and you can see what they have done over here. See what they have done. You are a helpful assistant that can use tools to answer questions and perform tasks. This is where we pass tools through the prompt to the language model. So these are the agent instructions, right? And we also pass, the language model is already decided by us, but the main instruction is over here. You are a helpful assistant that can use tools to answer question and perform tasks. Everything else is just for adding memory, etc. But don't be intimidated by this code. The reason I'm showing this to you right now is when we say an agent, it just means an LLM which is augmented with this prompt. And this prompt is not the React based framework which we saw. This is a very simple prompt because we are creating a very, very simple agent right now. If you want to make a React framework, you also need to mention thought, action, observation in the prompt itself. And the reason it's called low code is because you can technically modify this code with whatever you want. So that's why it's not fully no code. So I'm going to close this right now by clicking on the close. And now our agent is fully defined, right? So then what we can do is that once this is fully defined, you can click on playground. And so playground is on the top right. If you see on the top right, here is where you will see the playground. You click on the playground button. So those of you who are not being able to install, no problem, just follow along right now with what's going on. Otherwise, if you keep on trying to do both things, you will lose track. So here what I want to give is I want to mention a URL. So let me actually use the URL of our company itself. You can use any URL which you want. And so now let me mention that go to this URL, go to this, go to this website and summarize what you see on the first page. Also mention the tools which you need for this operation, right? And then what I'll do is that I'll click on send. So you see this is passed now and the agent is thinking to summarize the first page, I need to access the website and I need to retrieve its content. I need to analyze the text and main elements which are visible on the page. And you will also see that if you close this, you will see this whole thing being executed. So when a green tick comes over here, it means we have used this tool, and the green tick comes over here, which means the agent has now run successfully. And we can see the output in the playground itself. So you can see that this is finished right now. And the summary, Visual AI Labs is focused on making AI accessible to all. The homepage highlights their mission, etc., etc. And then I also asked for mention the tools which you needed for this operation, right? And here you can clearly see that the tools used for this operation are fetch context text. This essentially is going to a particular URL and fetching the text mentioned in that URL. So here you can clearly see this agentic workflow. You take a language model, you augment its prompt. Where did we augment its prompt? We augmented its prompt over here in the code. And then we give tools to the language model. And then we can test out those tools. Then we can also do, can you do this? Can you do this operation 1, 2, 3, 4, 5 into 5, 6, 7, 8, 9? Mention the tools you need for this. Okay, so now I've mentioned a mathematical question, right? So it does not need to use the URL tool. So we can see that this is also finished right now and the calculator tool is now used, which means that based on the input text which is provided in the chat input, based on the input text which is provided in the chat input, the agent can actually select which tool it needs to use. And you can already see the beauty of this low code framework, right? Because now let's compare and contrast. Let's compare and contrast this with our first code in Google Colab. So when we executed the first code in Google Colab, there is no visual modules for me to drag and drop. There is nothing for me to move around. It's code in linear fashion. So for many people, this is actually hard to get used to. But for mid-level, senior level managers in industries or companies who are just transitioning to AI, using a low code is much more easier, because if you see here, we are doing the same thing. Here is the place where we pass the tools um, to the agent. So here is where we have the tools, the prompt, and the language model. Three things, right? Language model, tools, and the prompt. And in the low code, what we saw is that the language model is defined over here. Language model is defined over here. Tools are defined over here. And the prompt, actually the prompt also you can modify over here. The prompt can be modified over here. Always let me know which tool you use. And always make sure to check your answer before responding. Yeah, whatever. So we can modify the prompt here. So the prompt is over here. The tools are over here. The tools are over here and the LLM is over here. But this visual interface is so much more easier for me to control, right? If you think the tools should be here, I can even move the tools to random pages of the UI. And that's the reason low code frameworks are becoming extremely popular. If you see on GitHub now, Langflow has around 78,000 stars. It's a very widely used repository, right? So this is very simple. Can we do something complex with LangFlow? And that's what we are going to see right now. And when I say complex, I mean, you remember the first example which we took. The first example which we took in day number one was travel agent, right? Essentially, what we saw in day number one was, can we make an agent which can make a travel itinerary for me? And at that time, we had discussed about Pune to Spain. So essentially, traveling to Spain, and can we have multiple agents linked together who can make this itinerary for us? I hope you remember this example. Now, this is a much more complex example, and this example requires planning, and it probably requires access to multiple tools. We are going to see this, how easy it's going to be to implement this in LangFlow. So again, if you are on LangFlow and if you have, so by the way, can you mention how many of you were able to implement this on LangFlow? You can just mention, yes, the first model. Okay, it's good. If 10 to 15 people are implementing it right now, it's great. So let's follow along and move to the next. So what you can do now is that you can click on this LangFlow button on the top left. There is a LangFlow button on the top left. You can click over here and it will bring you again to the main page. And now we are going to build an agent, which is essentially a travel itinerary agent, which will make a travel plan for us. And this is going to be interesting. So those of you who are following along, you can see the prompt which I'm giving in, and you can modify or tailor the prompt accordingly. So click on new flow. And here, if you see the templates which they have, you can click on scroll below and click on travel planning agents over here. So click on travel planning agent and you will be greeted with this screen. Again, it looks like something pretty big, but I'll walk you through every single thing over here. Essentially, what we want to do is that, remember I mentioned to you about point number A and point number B. If you have forgotten about this, let me recap that. So here we saw that we have to go from point number A to point number B, right? An agent adds value to your life. So here, try to identify what's point number A and point number B when you see a workflow like this. So point number A is where we ask something like this: create create a travel itinerary for me. That's point number A. I'll mention this in detail, but I just want to show the point A and point B graphically. So point A is we are here, and point B is when we get the entire travel itinerary for us. So here right now what we have is that we have three agents which will take us from point A to point number B. The first agent is a city selection agent. The first agent is a city selection agent. What it does is that it evaluates potential travel destinations based on the user input. So we are going to put some user input over here about the place we want to visit. So the city selection agent will evaluate the best travel destinations for us. That's the agent number one. Then what's the role of the other agents? Move to the right hand side, there is a local expert agent. So this agent actually is focused on gathering and providing an in-depth guide to the selected city. So it compiles insights into attractions, local customs, and unique experiences. That's the second agent. And the third agent is which gives us the final answer. So the third agent is a travel concierge agent, which basically crafts a very detailed itinerary for us. Like on day one, you should visit this, on day two, you should visit this. And not just that, our travel concierge agent is also going to give us the budget. Our travel concierge agent is also going to give us the budget. So if you see over here, accurate budget, it will give us all these three things. Okay, so we have three agents which have been planned. Now let us discuss the tools which are needed for each agent, right? So for the city selection agent, what are the tools which you will need? If you are an agent which has to evaluate potential travel destinations based on user input, what tools will you need access to? uh, web search web search, right? So as we can see, web search is probably the most important tool which you will need. So we are going to give the city selection agent an access to the search API. So if you see the city, so every agent is associated with an agent dialog and the tools. So the city selection agent has the city selection agent box, and it also has the tool which is associated with it. So the tool which we are giving to the city selection agent is the search API over here. What about the local expert agent? So local expert agent will be focused on gathering and providing an in-depth guide on the selected city. So along with web search, it also needs something else. What is that something else? Along with web search, the local expert agent needs something else. Only search is not enough. Apart from search, the apart from search, the local expert agent needs to scrape that particular website, right? And actually need to collect data in detail. So that's why the local expert agent needs this load and retrieve data from specified URL, this tool. What this tool essentially does is that it goes to a specific URL and not just looks at the URL, but actually scrapes the entire data from that URL. So here you see we have fetch context text. So the entire data is fetched from that URL and converted into a data frame. So imagine this tool is the one which goes to sites such as Make My Trip or travel blogs, the best travel blog for that city, and it collects that information together. And the final agent, which is the travel concierge agent, has also has access to calculator tool because it has to perform arithmetic calculations for the budget. So now I hope you understood the tools, right? So the tools have been mentioned in the bottom part here. This is tool number 1 for the first agent. This is tool number 2 for the second agent, and this is tool number 3 for the third agent. By the way, this entire thing is completely customizable, which means you can select your own model over here. You can literally drag and drop tools from here. So you can select a particular tool from the left hand side and drag and drop over here if you want that tool to be used. It's as simple. So adding tools is extremely simple over here. You just need to drag and drop the particular box and create these sort of connections. So see, there is a connection here between every single input tool and the agent. Okay. So now I mentioned about the tools, but let me explain about the agent itself. So every agent, if you see, it has a model provider. So here the city selection agent has the model provider as OpenAI. In local expert agent, the model provider is again OpenAI, and in travel concierge agent, the model provider is again OpenAI. Again, here you can change this to whatever you want. The second thing which is customizable here is that the agent instruction. So for example, in local expert agent, you will see that we have added this instruction. You are a knowledgeable local expert with extensive information about the selected city. Your goal is to provide the best insights about the city. Compile an in-depth guide for travelers. So um, that's the agent instructions here. In the travel concierge, the agent instruction is you are an amazing travel concierge, a specialist in travel planning and logistics with decades of experience. Your goal is to create the most amazing travel itineraries. So see the detail in which this has been written. If you don't write the detail here, the answers which you will get will not be very good. And this is something very counterintuitive to people, right? People would think that why would a simple thing like a detailed prompt actually contribute to my LLM output? But it's one of the most important things. Uh, Having a detailed prompt is extremely important. So you have to write as many details as you can over here. So someone has asked, can you paste the prompt over here, right? Yeah, take a look at this prompt and the detail with which it has been written. The more details you write, the better you extract from the language model. So now in all of these different blocks, you will see that you can actually access the code file. So if there are some developers in this call right now, here you will see that you can access the code file and you can change whatever you want over here. If you think something needs to be added or augmented over here, you can change in the code. I'm not going to tamper with the code right now, but I'm showing you where different things are so that you can yourself play around with it a bit. Uh, And as I said, this is highly customizable. If you want to add some other APIs, you can add an API as a tool. So there are questions about Make My Trip, right? You can add Make My Trip API as a tool over here. And then the entire workflow will remain the same. And now let's actually construct the input, right? We have assembled the agents. There are these three agents: city selection agent, local expert agent, and travel concierge agent. There is a question in the chat how to apply React framework. That's a great question. And I think Langflow by default does not provide their own React components, but we can customize it. Essentially, what you will need to do to make it into a React framework is that you will need to go into this code and you will need to change it a bit. The previous version of Langflow actually did have React as a component, but they have changed in the current version. I did not see it. These agents are again quite simple agents. If you see the code, you will see that these are not React based agents, but just agents where the prompt has been modified. This is not following React framework. So do we still call these agents? So this is a good question, right? And this question again brings us back to what we covered at the ending of the first lecture. So remember, in the ending of the first lecture, we looked at this table about agency and agents, right? So currently, our agents are tool callers. They are still agents and they are multi-step agents. So they are still agents. React agents make it better. They can do more things. They can plan better. They can make more decisions. So they just have more agency. Currently, we are building agents whose agency level is not that high. So now all of your vocabulary should also increase. People who are not taking this bootcamp will just have it binary, right? Agents versus no agent. But now you should think about the level of agency. You can say that, yeah, these are also agents, but their agency level is probably lower than a React based agents. So there is a question that do multi-agents need coding? So the frameworks, so there are coding frameworks for multi-agents also. When we are going to learn about small agents, we are going to code a multi-agent framework in Google Colab. But here what we are doing is that we are not coding this multi-agent framework. We are using a low-code environment over here. Between a React-based prompting approach and a reasoning-based model, which is likely to deliver superior performance. So again, this is a question which is the goals of these models are different, right? The reasoning-based model is meant for answering questions by reasoning. It's not really meant to take actions in an external world. Um, so again, the React-based framework is different. It's interacting with the external environment. There is a question how to create a task to enter the captcha in a website. So that's a custom task. And you can even build an agent for this, but I think here you will need to create a custom tool. So this question is asked by Rajesh. Uh, that's the main issue with LangFlow and other no code or low code frameworks. The ability to create custom tools is a bit lower. So for example, if the question is that you want to create a task to enter the captcha in a website, right? You need a custom tool for this because I don't think uh, you need to first go to the website. That's fine, that can be done. But to create the captcha, you need a new tool, and then you just need to link them together. For that, we'll need a code-based framework, maybe LangGraph. I'll teach that in one of the lectures. Actually, in CrewAI also we can do custom tools. So when we learn about CrewAI, we'll see how to create custom tools as well. Now let's actually go and execute this workflow. Since all of you uh, have learned about the three agents, the tools and these agent boxes, let's now define our chat input. So here all of you can vary what you write. So I'm going to write create a trip from Pune to Spain. And I'm going to mention on December 15, 2025. And you can write anything which you want here. So I'm mentioning the traveler enjoys visiting old museums and historical attractions. And you can then click on finish editing. So that's your input text which passes to the LLM right now. Then what you can do is that once you have written the input text, you will also need to enter your OpenAI API key. Um, so first let me, yeah, I'll need to copy paste my OpenAI API key, which I've saved over here. And okay, so yeah, so what I'll do now is that there are three places where I'll enter this OpenAI API key. I'll enter it over here. I'll enter it over here, and I'll enter it over here. In this particular example, the search API and all is taken care for you because it's already passed in, so you don't need to create a separate search API. Okay, now that the OpenAI key is passed in, you are fully ready now. So you can click on the playground. You can click on the playground. So again, playground is on the top right. Um, so just click on the playground over here, and you will see that this text appears, right? Create a travel itinerary, and then you can click on send. So now it's sent, and you can close this and again come back over here. So once you send it, you can actually observe the workflow. So here we are at this step right now. See, so this arrow is still kind of flowing, which means currently the city selection agent is active. Now it's completed. And then we are at the local expert agent. So when it's completed, it will show that 13 seconds with a green tick. And now we have moved forward, and now the local agent is active. So again, it's completed over here right now. And now the last agent is active, which is essentially the travel concierge agent. The travel concierge agent takes a bit more time, but if you see that, because it's probably doing the most work, right? It's aggregating the entire information. It's also making a detailed travel plan, and it also has to give us the budget, by the way. Um, so let's go to playground and check. Yeah, see, now we are printing out the exact plan. So here you see the seven day Spain history and museum. Why is it showing history and museum? Because I mentioned that the traveler is interested in old historical attractions. And here you see the result which has appeared. Weather forecast has appeared. Then a day uh, summary table. Then if you scroll up, you'll see the entire itinerary. So if you see, first we have day 1, December 15, then day 2, what to do, then day 7, day 6, day 5, day 4. So this is done by the last agent, and there is also a budget, by the way. If you see this budget breakdown, that's where the budget has been mentioned, that for the flights, what would it cost? For the food, what would it cost? Now see, these are simple agents, right? So they might be making mistakes. And the thought action observation framework is one way to avoid these mistakes, because the agent continuously keeps correcting itself in that case. In this case, actually, everything is, we are not going into that TAO loop. So there might be some sort of hallucinations over here. Um, but it's fine. It's still pretty amazing to see that we got this entire itinerary by three agents who are working one after the other. If you change the city, let's say, to something else, you will now get the response according to that. And the reason this is much better than using a language model is, again, because now every agent is thinking for its own before we go to the next agent. In language model, the entire text is passed to the model. So the entire context is one big context, right? Here, every agent is accountable. Every agent does its own thinking, and then the next agent is called. So at every step of the way, it's like we are improving the accuracy at every step of the way by having multiple agents working together. Uh, okay, so I hope all of you, how many of you were able to execute this, by the way? How many of you were able to run this on Langflow right now and see such kind of a travel itinerary for you? Because if you see this for yourself, you truly start believing in the power of agents. That's one more reason why I specially showed Langflow, because it's the easiest tool to demonstrate, through which you can start appreciating the kind of tools or kind of things which we can do with agents. By the way, there are multiple other things which we can do. I'll not go through all of them right now, but I have also implemented this YouTube analysis workflow. So you can go to, you can take any YouTube video which you want, you can essentially, yeah, you can take any YouTube video which you want. So here I have put the URL video link, and you can gather the YouTube comments for that particular video. So these are new tools, right? So this is a YouTube comments tool. And then one more tool is YouTube transcripts. So you get the YouTube transcripts, you get the YouTube comment, you combine the transcripts and the comment, and finally you have this YT Insight agent, which basically gives you insights regarding that video. So if you go to the playground of this, and you can just click on the particular playlist and you can type send. Um, yeah, I think I'll need to re-enter my credentials over here. But anyways, once you execute this, all you will need is you'll need a YouTube account API key. And once this API key is executed, or once this API key is added, that's the only thing. And the OpenAI API key, that's the key which you will of course need. But here you see how different tools can be easily added. Until now, we are only seeing web tools, right? But you can also add default tools which are there for YouTube comments. So this is a tool. Um, this is a tool which is a YouTube transcripts tool essentially. If you see over here, YouTube transcript. What this tool does is that it extracts the content from YouTube videos and then it converts it into transcripts. And actually, I can go to the playground right now and I can maybe try to run this once more. Okay, so it takes some time to run, but if you click on the chat output, you should be able to execute this code and get the insights for your YouTube video as well. So now my chat output is also run. Yeah, this was the sentiment analysis which I had got. So content summary, the majority of the comments analyzed show positive sentiment with viewers expressing gratitude. Some comments express regret for not discovering the content sooner, etc. So see, like this, you can set up an entire automated workflow for analyzing how your YouTube videos are actually doing. But in principle, the summary or the workflow of this project is exactly same as the workflow of the travel planning project. It's just that the tools used are different. So if you want to implement any such project simply, you can use LangFlow and just assemble different type of tools. Now let me go to the notes once more and let me cover the rest of the lecture. All right, so until now, what we have seen is that we have seen code frameworks, we have seen low code, and here we have seen LangFlow. One more framework which we'll have an entire lecture devoted to is n8n. So no need to follow along with me right now or here, but the n8n workflow actually looks something like this. Um, the n8n workflow is where you can see here the way I've assembled an agent is that you have building blocks. So I have an agent over here. I've connected it to the language model. The tools which I've used is a SERP API, which is a web search tool. No need to follow along with me right now over here. I'm just showing this so that you get a feel of what n8n is all about. So I've added a tool over here. I've added the OpenAI chat model and I can also add memory over here. So then the agent has memory. Then what I can do is that I can simply go to the chat interface. I can restart the chat session and I can say that NVIDIA, let's say NVIDIA stock price 2025, and I can press enter over here. So here you see this agent workflow is executing right now. And in the bottom, so here is where you can see the different tools which are being used. The LLM is being used, the SERP API is used, and then you'll see the final response on the left hand side that here are some recent analysis and predictions regarding NVIDIA stock price, etc. So this is how you can use n8n to equip your agent with tools. We are going to have one entire lecture devoted to n8n and how essentially we can start creating workflows in n8n and monetizing using n8n as well. But this is quite incredible, right? This is another low code framework. So already you should start seeing some sort of similarities between, let's say, this and what we saw, which is LangFlow, right? There are many things which are common. LangFlow also has these elements which can be moved around. Um, and n8n also has these elements which can be moved around essentially. So there are many competitors existing in this space, but n8n is also very user friendly, and it's actually agnostic to operating system as well. So it can be run directly in the browser as well. LangFlow also used to have that functionality, but for some reason they have switched to application based now fully. Yeah, but here you can see again the same thing happens. We can see that the agent has memory, and the agent has an LLM associated with it and certain tools. It just the way we represent it now differs in this interface compared to coding interface versus no code interface. Okay, so this is about low code. So we covered coding. We covered so this thing we covered low code, and then the last thing left for us to cover is no code. And has anyone actually experimented with OpenAI deep research feature or deep search? Um, so if you go to ChatGPT, if you ask anything like create a document for me, let's say, and if you go to tools, you'll see here that there is this run deep research. Create a document for me for uh, historical museums, let's say. What this deep research tool actually does is that focused on global countries. So what this deep research tool actually does is that it's actually an agent. Multiple agents work together to collect information for the deep research tool, but it's fully no code. There is no way we can write any code here, right? It's different agents which are orchestrating together. So one agent will do some research that will give it to another agent. The other agent will make graphs. There will be one more agent which looks at the graph and gives you the entire analysis. So deep research is actually absolutely incredible, and no one knows how OpenAI has integrated it because obviously it's closed source. Uh, Claude also has deep research now, and Gemini also has deep research now. All of these are fantastic tools. I've used it for many sort of research-based analysis, and it's incredible how they work. These are actually multi-agent systems which are acting in the background. So we will learn about multi-agent systems in small agents coding lecture. Then, so this is about the deep research, right? One more no code framework which I really, really like is Manus. How many of you have heard about Manus? So Manus is something extremely incredible, right? Because it's a fully no code interface, but they can do a great thing. So for example, here what I did is, and you can also experiment with Manus right now. I'll just share the link with all of you. Uh, I mentioned here that I need your assistance in selecting a suitable database, compare Postgres, SQL, and MongoDB, etc. And what this Manus tool does here is that, see, all of these are actually different agents. There is a creating file agent, there is a searching agent, there is a browsing agent, there is update to-do list, there is again a searching agent, an editing agent. All of these agents are working together. And there are finally writing agents which make the PDF for me. And after all of these agents orchestrate together and they work, you can see the response on the right hand side of the screen. This is the documents which have been generated, and these are extremely detailed documents which actually compare Postgres SQL versus MongoDB. This is actually a peek behind how deep research actually works, because here also multiple agents coordinate together, and you can ask any task for Manus. So let's say I click on research, and I can say market analysis web page, and you click on, so here you will see that Manus is thinking right now and understood I will analyze the outdoor activity market in Singapore and present it as an interactive web page. So see, this is a thinking. So mostly it's a language model which is thinking right now, but soon the language model will have access to tools. So the beauty of Manus is that they actually create a server for you. They create an instance for you, and you can actually see what that server is doing. So you see on the right hand side, it's that agent which is searching things. I am not searching this thing on the right hand side. So what you see live over here is actually an agent which is acquiring information through web. So this thing is updating live. It's a Manus agent which is thinking, it's going through different web pages right now as we are speaking. So separate server has been allocated for this, and the agent goes through different files. So see, it's searching right now. And then it's maintaining this todo.md file which the agent itself has created. And it has finished the first task, which is research Singapore's outdoor activity. And now it's going to the next task, which is select and apply appropriate business activity framework. So Manus is also a tool which I have used a lot in my day-to-day work for developing research reports, etc. And it's more like it OpenAI's deep research tool, although they show what's going on the right-hand side, I find it more of a black box than Manus, because in Manus I can exactly see what's really going on. Okay, so this is the last no-code tool which I wanted to cover. One special mention about Google Vertex AI agent. So Google also has this thing called Google AI Studio, and they have something called ADK, which is an agent development kit. So this is a code-based framework, but Google also gives a full no-code framework on their interface. I'm not going to cover this because once you understand the other code-based frameworks, understanding the agent development kit will be very easy. But I just wanted to give an overview of this so that you are aware of what all exists in the market currently. So I've shared the link of the agent development kit, and I know many students actually use it in college. Google Agent Development Kit. It's very popular. So this is the whole overview of the different coding, low code and no code frameworks. And as we come to the end of the lecture, I just have my recommendations for which type of frameworks are good for you as an industry professional. So here is my overall feedback on these tools after I've used many of them, right? So if you want to use code-based frameworks, then LangGraph, LlamaIndex, and Smolagents are the best ones. Smolagents, if you want to get started with easy code, but then you definitely have to move to LangGraph. It's probably one of the best coding-based agentic tools at the moment. Then we have low code, right? So low code frameworks, the ones which I like a lot are n8n and CrewAI. These are the ones which I use the most. There is also LangFlow, which is equally good, and you can use LangFlow, but I've just found n8n to be better because it's easy to create custom code in n8n. And it's a bit harder to do that in LangFlow, although it's possible to do that in LangFlow, but it's just a bit more easier in n8n. Gemini, so for no code, I prefer OpenAI Deep Research and Manus. Actually, Gemini Deep Research is also very good. Then Gemini, so Google AI Studio, I myself don't use that much, but I've heard people say good things about it. I mostly use these frameworks. And these all, so 1, 2, 3, 4, 5, these are the main frameworks we are going to cover in this bootcamp, because I think these are the ones which will be extremely relevant to all of you. So now in the next lectures, what we'll be doing is that my next lecture will be on small agents, and we'll build AI agents in code using small agents. So we'll build two types of agents. First, we'll build a single agent, and then we'll build a multi-agent. We'll build a multi-agent system in small agent, and we'll also build a browser agent. Does anyone know what a browser agent is? So actually we'll build four types of agent. We'll build a single agent, we'll build multi-agents, browser agents, and vision agents. So browser agents are the types of agents which can directly have access to your browser, and they can automatically scroll through websites and give you results. It's actually incredible to see them in action. We are going to cover browser agents, and yeah, exactly like operator. So if you're aware of operator, yeah, this can be called as a browser agent. which can essentially browse through websites automatically. We are going to see a simple demonstration of that. All right, so this brings us to the end of today's lecture, where I wanted to comprehensively cover three types of frameworks: the coding, low code, and no code. In coding frameworks, we saw LangGraph, LangChain, LlamaIndex, Smolagents, and AutoGen. And in low code, we saw CrewAI, LangFlow, n8n, and Agno. Actually, Agno I'll just cover in a moment. But we actually made deep dive, or we learned about LangFlow in depth, because we can build a lot of agents in a simple manner using this. And the reason it's a low code framework is because you can actually directly get access to the code and you can modify the code. So it cannot be called fully no code. And when you look at an agent over here in LangFlow, the agent actually consists of a language model, and the agent consists of tools and prompts, which is very similar to code-based frameworks also. In code-based frameworks, we have a language model, we have tools and prompt. So it's trying to achieve the same things, but we get at it through different ways. Code-based frameworks are great if you want control. But if you want to explore quick prototypes, then CrewAI, LangFlow, and n8n all are very good. The reason I'm calling CrewAI as low code is because although we'll do it in Google Colab, the coding is almost as if you're writing English language. So it's as simple as that. And then for no code, the best are Manus, then OpenAI Deep Research, Google Deep Research. And now we are out of time. So let me now show one last thing, which is actually Agno. So not many people have heard of Agno, but it can again be called as a low code interface, where if you see the Agno repository, they don't have a desktop version or any app, anything like that. You have to run it through the terminal. But once you run it through the terminal, you will see a browser like this, and you can actually very quickly select an agent. So if I select a web search agent over here, and I click on which tools do you have access to, then it says that I have access to these tools, etc. We are not going to cover Agno just because it's not used that much currently in industry, but I'm deliberately showing it to you so that if you come across this later, you should not be intimidated by this tool. It's actually exactly the same as other low code frameworks, but Agno just needs Python coding. So see here you have to define an agent simply over here, and then you have to click on or you have to run python demo.py, and then that playground which I'm showing you right now will open for you. Yeah, so that's essentially Agno. Okay, so does no code, and let me take a few questions on chat, and then we can end this lecture. Does no code and low code have future? So yeah, I think both of them have their own place, because everyone is using n8n for quick demonstrations. But in enterprises, if you want to integrate agents, you cannot use these type of tools. You have to, I mean, when you want to build application using agents for enterprises, for either their clients or for internal facing value addition, we need to use code-based frameworks for more control. There is a question on Zapier I thought I saw on chat, right? So Zapier is actually incredible, and it became popular much before any of these tools came in. They also have an agentic framework which they have added now. But I still prefer n8n a lot more than Zapier, just because it's very intuitive to me now. And as I said, it's easy to customize code on n8n as well. There is a question about MCP, right? So we will cover MCP in this class. We'll cover it when we learn about n8n and the materials needed for the next class, right? So next class, what we'll be doing is that running our first, we'll be running our code in small agents. So you'll need access to Google Colab, and you'll need access to OpenAI API key. Actually, you don't need access to OpenAI API key in next class. You just need access to Google Colab. And if you can create an API key on Hugging Face, that will be good. I'll show this to you in next class as well. You just have to go here and click on access tokens. So next class we won't need to install any application like we did in today's class. How can we improve the performance of an agent? I'll cover that as we build the application slowly. So as I mentioned, in the next two classes, we are going to build these four agents. We are going to build a single agent, a multi-agent, a vision agent, and browser agent. And we'll also see methods to improve these agents. Now the next class for us will be on Thursday, so tomorrow. So next class will be Thursday, 26 June, and this will be held again at 2 p.m. IST. If there are any changes to the timings, I'll let you know. But please keep checking the course announcements for the timings. Tentatively, the class is scheduled tomorrow at 2 p.m. IST itself. Um, how do we test agents to make sure they're production ready? That's a great question, actually. So we will use evaluation frameworks such as I'm going to teach you two types of frameworks. First is LangFuse, that's one, and second is Arise. So actually, if all of you are on this call before next lecture, if you can create an account on LangFuse and generate API keys, that will be useful. It won't cost anything, but we'll use two evaluation platforms for agents. One is LangFuse and one is Arise. So Arise is actually this. All right, everyone. This brings us to the end of today's lecture. If you have any more questions, please ask them on the Discord group. And for pro participants, the assignment is uploaded. So it's important you submit that to test your understanding. So as we are moving through the lectures, it's important you submit assignments. And I'll upload the lecture notes also on the Discord. All right, everyone. So thanks a lot for attending this lecture. And as I mentioned earlier, make notes if possible, because things are now getting a bit deeper. The first three lectures were a bit high level, but now we are getting into lower level stuff slowly. So make notes to improve your understanding. In these 10 days, I want you to learn as much as you can. I hope this session was enlightening for you and you have now a broad level idea of different frameworks and where they fit in your workflow. So whether you are an industry professional or researcher, after this lecture, just revise these different frameworks and try to think about which ones will be the most relevant for you based on the pros and cons which we have discussed today. Thanks everyone, and I look forward to seeing you in the next lecture. Bye. All right, so let's get started with today's lecture. So today, our main goal is that we are going to start exploring the first code-based framework, which is Smolagents. The reason we are starting with this is because I believe it's the simplest code-based agentic framework available right now. So today we are going to start with simple agentic applications. We are going to learn about code agents today, and we are also going to learn about tool calling agents and what's the difference between these two types of agents. And as we learn about code agents and tool calling agents, we'll also be implementing and evaluating agents using Smolagents. So it will be good if all of you are attending through laptop, because then that way you can open the Google Colab and you can follow along with me. Before we get started, let me first provide a quick recap of what all we have covered in the previous lecture. So in the last lecture, we looked at the code, low code and no code agentic frameworks. In particular, we took a very detailed overview regarding LangGraph, LlamaIndex, Smolagents, n8n, CrewAI, Agno, LangFlow, Manus, etc. I have mentioned all of these details in the newsletter, which have been added to the Discord. And towards the end, I have also added recommendations for industry professionals, what type of agentic frameworks you should be looking at. And the reasons for these recommendations have been covered in the previous lecture. So this is the main summary of the last lecture. And in the lectures before that, we looked at essentially the thought action observation framework. This is the main concept which you have to keep in mind when you learn about AI agents. And today we are going to see this loop again, but we are going to examine it through code today. And in the first lecture, what we had done is we had seen the definition of AI agents. So I'll keep reiterating this many times. Agents essentially can plan, take decisions, they have access to tools. Their brain or foundation is a large language model, and they can also interact with the environment and have memory. With that, let's get started with today's lecture. I'll plan to finish today's lecture within a period of 1 hour so that all of you can later go ahead and revise this lecture. So, what is exactly Small Agents? Small Agents is a code-based agentic framework which has been developed by Hugging Face. And today we are going to build some very simple agents using Small Agent. So as you can see here, it's an open source Python library designed to make it extremely easy to build and run agents using just a few lines of code. But through this, it will be a good introduction for all of you to code-based frameworks without intimidating or scaring you in the first place. One more thing I am going to focus a lot on in this bootcamp is agentic evaluation. And I've mentioned this earlier also. And today is going to be the first lecture where we are going to actually evaluate our agents. In particular, we are going to not just look at the output given by the agents, but we are going to kind of open the black box and see how the code works. And for that, we are going to be using an evaluation platform which is called as LangFuse. So we are going to use this evaluation platform today, and I'm going to teach you how to use it. So the main takeaways of today's lecture are two takeaways. You will be able to learn to code using small agents. And after today's lecture, you will be able to build an agent on your own in this code-based platform. And the second takeaway is that you will understand what this LangFuse is all about and how we can open the black box behind agents. So let's get started. First, what I want to discuss is when agents take actions and when they use tools, they can use tools in two types of ways. So essentially, there are something called coding agents and there are something called tool calling agents. So at the beginning of this lecture, let me theoretically explain the difference between these two types. So let's say we have an agent, right, which wants to perform an action. In the first case, the agent uses text or JSON to perform this action. I'll explain what this means. And the second type of agent is which performs actions through code blocks. Now, what this means is that let's take a very simple example for now. Let's say the example is this. The agent's task is to determine the most, let me reduce the thickness of the pen. Yeah. The task of the agent is to determine the most cost-effective country to purchase the smartphone, certain smartphone, and the countries to consider are USA, Japan, Germany, and India. The task of the agent is to find the most cost-effective country to purchase the phone. And as we have seen before, agents need tools, right? So to the agent, we are going to give all of these tools. We are going to give a tool called lookup rates, which will basically look up the rate of the phone in the given country. We are also going to use convert and tax, then estimate final price, look up phone price, etc. Essentially, the agent has access to all of these APIs, which are tools. Now, although an agent has the prompt and it has access to tools, there are two ways the agent can use the tool. First is that, okay, so the thought, action, and observation framework will remain the same across this thought, action, and observation. But if you take a closer look at the action itself, in this first case, the action is mentioned as text. So the agent first thinks that I should calculate the phone price in USD for each country, and then I should find the most effective country. So essentially, the agent will find the prices for each of these phones, convert them into US dollars, compare the prices, and then choose the phone which costs the least. But here, it's basically the action. To perform the action, the agent receives textual information or JSON rather, where the tool is given and the country is given. So the first country it looks at is Germany. It finds the price. The second country it looks at is, let's say, Japan. It finds the price, etc. So similarly, the agent performs this action for every single country individually, and then it finds the most effective country. But the main thing which I want to draw your attention to is that the agent receives the information that it has to perform an action in this JSON format. So JSON is nothing but JavaScript object notation, which you can think of as a textual format like this. So this text is passed to the agent, and then the agent performs the action. So the tool is passed as a text. Tool is passed as a text. That's the first type of agent. The LLM agent uses text to perform the action. The second type of agent is the tool is passed as a code itself. So what happens in the second type of agents, which are also called coding agents, is that the thinking process remains the same. If you see, the thinking process is I should calculate the price in US dollars and then find the most cost effective country. So that's the same thinking process year and year. But now to perform the action, first a code is generated. And the code is such that you go through all the countries, you get the local price from each country, you get the converted price, and then you find the minimum of all the prices. So here you see what's happening. This is much more concise because we don't have to essentially go through every single country individually. What if there are 50 countries? This on the left hand side, we will need to do 50 actions. But if you go to the right hand side, we just need to write one code and execute that code and then retrieve the minimum phone price. The advantage of coding agent also is that you can reuse Python's coding libraries. Essentially, that gives you a lot of flexibility in constructing the agent itself. Since most of the actions will be written as code calls or coding functions, you can technically use any Python defined library or a function like this. So Smolagents is the framework provided by Hugging Face, which supports coding agents primarily, which means that whenever a certain action is to be taken, it's converted into code. And there are trade-offs between, so these first type of agents are called as tool agents, and the second type of agents are called as code agents. Both of them perform exactly the same type of functionality, but and please keep in mind that we do not write the code over here. See, that's the main thing. The human has not written the code in the prompt, and I'm going to, when we open the black box of the Smolagents code today, I'm going to see what's exactly written in the prompt, or I'm going to show you rather. But in the prompt to the LLM, we say that whenever you want to perform an action, convert it into code and then perform the action. So the code itself is generated by the large language model, but the format is very different. Whereas here we don't generate a code. In the prompt, it's written that just use the tools which are passed to you and perform the action. Whereas in this case, in the prompt to the language model, we explicitly write that you have to convert. Uh, so if you want to use a tool, first write a code and only then you will use the tool. So there are these two types of agent which we'll constantly see. And in today's, when we go to the code, we are going to compare both of these type of agents. So the first, let me write this down over here. This is called as a tool calling agent, or very simply, you can call it as a tool agent. And this is called as a coding agent. The terminology can be a bit confusing because both of these actually use tools, but it's just that when you deal with coding agents, every single action is converted into a code. And you can already see the advantages of this for a developer, right? You can literally plug and play any different Python packages into this code. You can also mention which Python packages to use. So let's say if you want to make an agent which visualizes or plots, since the agent is anyway going to convert the action into code, you can also mention the packages which it can use, such as Matplotlib, Plotly, etc. So agents, coding agents actually give you a lot more control in your hands. And we are going to see what exactly happens in coding agents. But before that, let's actually go to Google Colab and let's try to execute our first code using small agents. So I'm going to share this with all of you right now, and let's all execute this together. So people might be joining late, but you can share this Google Colab file with them. So I'm sharing this over here right now. Yeah. So this is the Google Colab code file. I hope all of you have access to it right now. And let's start running it sequentially. What we are going to do is we are going to make a very simple agent which has access to web search. We are going to make a simple agent which has access to web search. So I'm going to write it over here. We are going to make a simple agent that has access to web search. And the job of this agent is that it's going to give us, the job of this agent is that it's going to give us AI ML book recommendations for industry professionals. For industry professionals, that's going to be the job of the agent. And I'm going to do three things today in the code with this task. I'm going to first show you this same thing we are going to do with a tool agent and a coding agent. So the same thing we are going to do through two different ways, so that you can compare and contrast the differences for yourself. And third thing which we are going to do is that we are going to evaluate the output. We are going to evaluate the output of this agent, which means we are going to actually open the black box and see what's happening within. And for that, we are going to use LangFuse. That's the plan of today's lecture. As we are proceeding through this, I'll also take a moment to actually explain what is really going on. But before that, let's finish the first part actually. Let's actually implement a coding agent using small agents, which does this functionality. Okay, so let's do the first step, which is essentially installing the small agents package. And I hope now all of you are familiar with DuckDuckGo search. It's the search engine which we are going to use predominantly throughout this bootcamp. If you have finished running this first code cell, you can just let me know in the chat if you have finished this. Otherwise, this does take, I think, a couple of minutes to run. Done, right? So I've also finished running this right now. So next what we have to do is that we have to create a login through Hugging Face. This is not strictly needed, but it will be useful nonetheless. So let me show you how to do this. Essentially, you have to go to Hugging Face. You have to create an account. You have to create an account at Hugging Face. So if you don't have the account, just create it. You can sign in through Google. You can sign in through Gmail. And then what you can do is that on the top right, if you see, you can click on the top right and you can go to access tokens. Just go to access tokens over here. I need to enter my password here, I think so. Yeah, so see what you have to do next is that you have to click on create a new token. You have to click on create a new token, go to right and just give any name to the token. So here, the name for this token which I'm going to give is small agents Visual Bootcamp, and then I'm going to click create token. So this will give you the Hugging Face API key. Then what you will need to do is that when you click this, you will just need to enter your API key over here, and then you will need to click on login. It's a pretty simple procedure, and actually it's not technically needed for us to do this today. So if you don't manage to do it right now as you're following along, that's totally fine. You can just skip this and move to the next code cell. The reason I showed this to all of you is because if we have developed our own agent and if we want to push it to Hugging Face, if we want to create a repository on Hugging Face, we need to log in first and then we need to upload the repository on Hugging Face. But anyways, we can move forward now and let me show you how easy it is to use the small agents workflow to create an agent. So once the small agents package is downloaded, you have to import three things basically. And I'm going to explain to you all these three things mean. First is code agent. So this lets you define whether it's actually going to be a code agent or a tool agent. And now we have already seen the difference between code agent and tool agent, right? So here we are defining that we want the agent to be a code agent. So I've imported a code agent over here. The second thing is the DuckDuckGo search tool. So in the agent, we have to pass the tools. And here I am passing the DuckDuckGo search tool. And the third is the inference client model. What this actually is that you remember here we saw that the brain of an agent is a large language model. So we have to actually specify which large language model we are going to use. And by default, if you don't specify anything over here, so here I have not specified a model, I have just mentioned inference client model and I've mentioned the provider. I have not specified which language model, right? So by default, Hugging Face uses this language model. How many of you are aware of Quen models? Or you have heard of this or you have used it before in practice? Yeah, these are one of the best and most efficient small language models in the market right now. They are fully open source, and they give an incredible performance and they don't take up too much space also. So the model which Hugging Face is using over here, it's an open source Quen 2.5 model over here. And that's where the flexibility comes into the picture, right? If you want to use any other sort of model, you can just mention it in the model name. You can use closed source models, you can use open source models. In fact, Hugging Face is the best place to find open source models. So just go to models over here and you will see the new models which have been published. Most of the open source model you will see on Hugging Face. So see, DeepSeek has recently released this DeepSeek R10528. It has about 100,000 downloads every month. So all the models which have been uploaded on Hugging Face can be used as the foundational layer of our agent over here. But we are using this Quen one because it does not take too much space and it's actually quite fast but accurate at the same time. After this lecture is done, I highly encourage you to play around with different models. Okay, so if you see, we are doing three things here. We are defining a code agent, we are passing the tools, and we are passing the model. So you might be wondering, what is this provider? So providers are those companies which have hosted open source models. So even when you have to run Quen 2.5, right? This is an open source model. It needs to be hosted somewhere. It needs to be hosted by some company. So Together AI is a very famous company. Hugging Face has partnered with many such companies who provide their models. But Together is one of the most reliable one. So you define the code agent like this. And then what we are going to do is that we are going to do agent.run. And here is where we type in what we are looking for. So I'm looking for searching for the best book recommendations for implementing AI in the workplace. That's my question, right? So it's as easy as this to define a code agent. So here you might be thinking, where is the thought action observation loop? Where are all the things which we have discussed before? All of those are in this statement because that functionality of the thought action observation, remember we saw this thought action observation over here, that functionality is taken care internally through small agents. And when I say open the black box, I'm going to show you how code agent actually does this in practice. But for now, just assume that everything is set up in the backend by this library and then just click on run. And here is where you should be able to see some very interesting things which are happening, right? You will actually be able to see how the agent is thinking. So just take a closer look here. Here's the first thought: search for the best book recommendations for implementing AI in the workplace. That's a thought. Then see executing parsed code, which means the web search is a tool, but tools cannot be directly used by code agents, right? Tools have to be converted into a code first, as we have already seen over here. Tools have to be converted into codes. So here's the code web search and the input which is taken by this code. So this is the action which is performed And then when we want to print something, again, this is mentioned in the format of a code. So we first generate the book recommendations and we print the book recommendations. And you'll see the execution logs over here, 6 books on AI in the workplace, etc. But this is just the step number one. And when I say step, it's actually the thought, action, observation loop. So see, thought, action, observation. Going through this loop once is one step. Going through this loop again is the second step. So here you see step number one is completed right now. And then you move below and you go to step number two. And step number two is again, it's going through the same loop because books have been retrieved in the first step, but the agent figures out that I need to do it in a lot more detail. So again, it goes through the book titles over here, and then it prints out the book titles. And so then these are the execution logs of step number two. Then you move to step number three. So when the code agent reaches the when it reaches its final output, it executes something which is called as final answer. So in the previous lecture, someone was asking when does the agent know that it has to stop, right? So whenever final answer is executed by the agent, that's an indication that the agent believes that the answer is good enough. And so this answer is just printed. So now these are the books which have been recommended by the agent: The Business Case for AI, A Leader's Guide to AI Strategies, AI Superpowers, China, Silicon Valley and New World Order, Life 3.0, Being Human in the Age of Artificial Intelligence. Let's actually check whether this exists or not. So you can go and check, and this book actually exists, and I've actually read this book. It's a book which is really quite good. So until now, what we have seen is that the agent goes through this thought, action, observation loop. And as someone has mentioned in the chat, sometimes you might get an error, right? Just run it again. Because sometimes the error gets stuck in its thought process. And then you need to run the loop once more so that the agent can go through that barrier and execute it. So here, at least in my screen right now, I have run 3 steps. Can you all mention in the chat how many steps did your agent take? Because it won't be the same across all. So see, someone has mentioned the agent took 6 steps, 2 steps, 3 steps, right? It's not fixed. But no matter how many steps your agent took, all of you should have seen this final answer over here, because that's the last indication that we have finished the entire thought action observation loop, and now we have to stop. So two things you should notice over here. The first thing is that all actions are completed as code blocks because we are doing a code agent over here. The second thing which I want all of you to notice is that it's incredibly difficult to actually read what's written on the screen right now. It's not easy to parse this, right? I have to go through this individually. The formatting is not very good, and I cannot actually see the agent's thinking um, in detail. This is still good. These different colors which they have provided in the interface, the black and the yellow, provide some contrast, but still it's not very good to understand the agent's thought process. So just pin that thought in your mind right now, because we are going to revisit this thought later when we learn about LangFuse. LangFuse is a tool which solves exactly the same problem which we are facing right now. So for a while, let's just go to the Miro board and really try to understand code agents. As I mentioned, my main goal in this bootcamp is not only to show you codes, but also to make sure you have really understood. So when we see this output here right now, what is exactly happening is this. And all of you should be able to construct this loop in your mind after this lecture is over, because now we have seen this many times. See, the user input is received first. That's the step number one. And in my case, the user input is search for AI ML books, right? That's the user input, which is search for AI ML, etc. Then there is a loop which begins. That is the thought action observation loop. So this prompt is sent to the language model. Language model then returns a response instructing the agent to perform an action based on the tools which are there. So the tools are selected. In this case, the DuckDuckGo search tool is selected, and then the action step is performed. In this case, it's a code. It's a code which is generated. The action is then executed by the tool, and the result of this action is appended to the main prompt. Whatever question has been asked, the result is appended to the main prompt, and then we go back to the beginning of the loop once more if we are not satisfied with the answer. And now the language model actually has the previous result also along with the prompt. So the language model has the previous result generated in the previous step. So when we keep on looping, the language model actually accumulates history. It has knowledge of the history because it has memory. It knows what has happened in the previous steps. So just look at this loop. The loop begins. The LLM is the LLM has a prompt. The LLM then returns a response instructing agent to perform an action. The agent then performs the action. If it's a code agent, the agent generates the code and then the code is executed. The result of that code, if it's some books which are given or some websites in step number 1, that's appended to the main prompt, and that whole appended prompt is again sent back to the language model. This entire loop continues until if the model thinks that it has sufficient information, it calls a tool called final answer. So final answer is actually one more tool which indicates that we have to stop right now. And since this is a code agent, the final answer is also called as a code itself. So here all of you will see that there is this final answer over here, right? So whenever final answer is called, we stop the execution. So that is the entire loop. And there is a one very nice animation which I want to show all of you, which actually explains this loop. So it's a 30-second animation, but watch it closely. We'll start out with a system prompt. So this is a system prompt. The system prompt can be solved. This task is in an iterative way with a thought action observation loop. And you can use these tools. And the question is how much is 2 raised to 0.27? Let's say this is the system prompt. Then what happens is that the prompt is the system prompt plus memory. So initially when the language model starts out, its memory will be empty, but memory will sequentially go on updating as we go through more loops. So then the LLM runs and see this LLM output is thought is I should use the calculator, and action is making a code call to the calculator tool. And then what you do is the tool we call the calculator tool, and then the observation is actually appended back. See this is the main step. The observation after the tool call is appended back to the system prompt. So the memory is again updated. See, the memory is now the previous output as well. And then this whole loop actually proceeds. So if I play this once more from the start, now all of you will be able to relate to it. So we get the system prompt first, the memory is empty. Then the language model makes the tool call. The output of the tool call now, at this moment, the output of the tool call is passed as an observation, and that updates the memory of the agent. So this is how the agent stores memory. The previous steps output is added to the memory, and then the LLM makes subsequent calls until we get the final answer, and then it stops. So this is the thought action observation loop in action. So until now, what I've not shown you is where is this system prompt actually? Because we have just looked at the user prompt, and the user prompt is give me movie recommendations. I have not shown you the system prompt. The system prompt is what Smolagents does in the backend. I'll show that to you when we look at LangFuse. But I hope this is what agents actually do, and that's what makes them so different from language models, right? Because you can just ask that, why don't I do this using language models? Language models don't go into this loop, which I just showed you right now. Language models don't have a this thought action observation loop. This is what makes agents special. So if you forget about thought action observation, I've already mentioned about it in this notebook in a lot of detail. But if you forget about this, and if you are a visual learner, I hope this video, at least you can remember this video to differentiate between what an LLM is and what an agent is. So again, this is a great video to answer that question, right? What's the difference between an LLM and an agent? So take a look at this figure on the screen right now. LLM is just one small aspect of this entire loop. That whole loop is an agent, because here we are also interacting with the external environment because the observation is passed back. We are making decisions through the thought action observation loop. We are also planning. All of these things are done, and the LLM, which is shown in the orange color, that's just a part of this loop right now. Reasoning models don't go through the thought action observation framework loop. They don't have the ability to perform actions by interacting with the environment unless we explicitly specify that you have to perform an action. So this is what coding agent actually does. And I hope all of you have now understood what it means to make tool calls in code. It just means that the action which needs to be performed, that's written as a code. There are some questions about how do you determine the amount of memory required. That's a very good question. And in fact, in all of these frameworks, we can decide how much memory we want. So there is something called conversation window buffer. So this variable determines how much of the past memory we want to retain. And that depends on your applications. Typically in chat applications, you need to retain memory of what all comes in the past. And if there are a huge number of messages, what you can do is that instead of retaining every single thing, you can even use a language model to make a summary of your history. So it's like an abridged version of the history which is retained, which is exactly what happens when human speaks, right? When you speak with another person, and let's say the other person is speaking for 5 minutes. At the end of 5 minutes, you have a summary of what that other person has spoken. You don't remember each and every single thing they have said. So the second way to reduce the amount of memory is using summary. So instead of storing every single piece of history separately, make a summary of the history and give it to the agent. Of course, this leads to slight loss in accuracy as opposed to maintaining um, every single historical conversation as it is. Okay, so this is about code agents, right? So I want to show you one more thing. I want to show you the same thing using tool agent. So let's go to code right now, and that's the next thing which we are going to do. Here, what we are doing is that everything remains the same. It's just that instead of using a code agent, now we are going to use a tool calling agent. And we are going to see what changes. But first, you should see how flexible this package is, right? This small agent package is completely flexible. So if you see, I had a coding agent written over here. I have just replaced that with something which is called tool calling agent right now. Everything else remains exactly the same. Even my prompt remains the same. But now let's see what's the difference over here, right? The step number one is calling a tool web search, but nowhere will you see code here because the action is not implemented as a code. It just calls the tool, which is text. So this is just textual. The format is text, right? There is no code which is generated. But the thought action observation loop is the same. You have certain observations which you have seen over here. And then I go to step number two. There is some invalid call to tool final answer. And then I get my final answer after step three. So here you can see that three steps have been executed. But as I've written over here, when you examine the agent's trace, instead of seeing executing parsed code, in the previous coding agent, you will see executing parsed code, right? Instead of this, we don't see this at the moment. Instead of executing parsed code, what we instead see is that calling tool. So this agent generates a structured tool call rather than directly executing a code like coding agent. But if you see, even here we get answers. So here I've got the top recommendations for anyone who, let's say, wants to implement AI in the workplace. And the 10 answers have been given to me, but it's just that they have been presented in, or they have been generated in a different manner than using coding agents. And the workflow remains exactly the same, right? This video which we saw, the way tool agents work and code agents work is exactly the same. But in the action step, they don't tool agents don't make a code call. They just write the actions in text or JavaScript object notation, JSON format. So one of the main takeaways from today's lecture is that there is a difference between tool agent and coding agent, and it's very important to call out that difference because if you are designing an agentic application in your workplace, you will need to make the decision of whether I want to make a tool agent or whether I want to make a coding agent, right? So here I have just made a quick summary of what exactly is the difference between coding agent and tool agents, and how can we select between the two, right? So there are multiple features. So first, if you think about complexity, code agent is definitely more complex because you have to make sure the code is written. So it's more work for the language model, and you have to also make sure other existing packages from Python can be integrated. So it's a bit more complex, but the main advantages of, or really the main advantage of a coding agent is that it offers you a lot more flexibility. And for developers in the workplace who want to make their own agents, such kind of a control is highly advantageous. It's very flexible and it's very dynamic. That is not offered in tool calling agents. It's quite structured and predictable. But one more major advantage is that you can randomly tag on other packages in the whole Python community. So here, if you see, when this code call was made, we used a function, minimum function, right? Because everything is in the format of a code already. So we can plug and play other coding packages from the Python ecosystem. That makes this a very advantageous proposition if you want to build your own agents in the workplace. And if the task is complex, then I definitely suggest going forward with coding agents, because tool calling agents are good for simple structured tasks. For complex tasks, usually all modern production workflows have coding agents. Then another thing is the safety, right? The thing is the code agents execute Python. So there might be security implications if the code is leaked, etc. And the error risk is also a bit higher if there are runtime errors. But all of these, I believe, can be taken care of if you're implementing agents in enterprise. First of all, you should know the difference between code agent and tool calling agent. And when you know the difference, if the application which you're building for is complex, we should definitely go ahead with the coding agent because it gives you more control, which is not given usually in tool calling agents. So many people who learn about agents, they have no clue about the differences between these two types of agents. But it's highly important to note that the same output can be achieved through two different ways. And it's usually the developer's choice to decide which aspect they want to go ahead with. So the first part of today's lecture, which was one of the major agenda, was to actually compare the tool agent and the or to run the tool agent and the coding agent, and then to compare and contrast between the two. But if you notice already that there are two drawbacks, right? The first drawback is the output is not formatted very well. So I'm not able to evaluate whether the output generated is good enough or not. That's the first major drawback. The second major drawback again is that it's like a black box for me right now. I want to show all of you what happens behind the scenes. So we are not able to do this at the moment. And both of these problems are solved when we use agent evaluation frameworks such as LangFuse. But before going there, let me just take a small pause and clarify any questions which are there in the chat. Let's see, will code agent be faster in executing? Yeah, so code agent uses Python, so it's always a bit faster than tool calling agent, but we won't see the difference right now for the use cases which we have. So the difference between code agent and tool calling agent, to explain once more, if you see the major difference is where is how the action is performed. Code agents, to perform the actions, they convert the action itself into code. Whereas tool calling agent, the action is just as textual or JSON format. That's the main difference, but this difference leads to a whole lot of bigger differences downstream. If the application is complex, you ideally want a code which can integrate with other code files, etc. Yeah, the code is not running locally. The code is also running on the server. which we are using through Together AI at the moment. What if the agent fails? Will it still give appropriate results? So if the agent fails and if the final answer is not converged, we'll get an error in Google Colab. Then we don't usually see any answer. So when you say memory, is it a database? We can store the memory in databases also, but for now it's not a database. It's simply stored on the fly and it's added to the prompt. But we can integrate an agent with a database to store memory as well. Okay, can we control if one message goes to which session? Yeah, the only way I think to do that is to have agents, multiple agents interacting with each other. So one agent takes a certain sort of messages and other agent takes another sort. But within the same agent, it's a bit difficult usually to um, separate out messages which are incoming. Can we tell the code agents which tools to use? Yeah, that's one of the main advantages of code agents, right? You can actually tell the code agent which packages to use in Python. And that's why it's so popular, because you can just tell that you can use the plotly package or you can use the matplotlib package, and the code agent will now directly integrate it when it generates the code. Can agents cache the response so as to respond from history rather than make LLMs? Yeah, that is possible. So agent caching is completely possible. So the LLM does not have to make the same call each time. Okay, so now let's move ahead to the last section of today's lecture, which is, in this section, what we are going to do is we are going to inspect our agent. So there are two things I want to show you first. The first is something called open telemetry. So open telemetry is essentially a standard to observe and evaluate several different things, to observe and evaluate different tools, different APIs, essentially to add traces or metrics to whatever software or tool which we are using. So agents by nature are quite unpredictable, right? And difficult to inspect. So that's why we need to merge two things. We need to merge open telemetry, which is essentially, you can think of it as a standard for monitoring different frameworks. And second major thing is LangFuse. And this is what I want to show to all of you right now. So you can follow along with me. I'll create an account on LangFuse as if I don't have one. And for that, I want to open a different screen. So let me share my screen right now. Yeah. So all of you can head over to LangFuse. So you can head over to langfuse.com. Yeah. So then what you have to do here is that you have to click on sign up on the top right. And when you click on sign up, just choose the data region as US, and you can sign in with Google like I'm doing right now. I'm signing in with Google right now. And then you can just choose your Google account and you can sign in over here. I hope all of you are following along with me until this stage. You can skip all of these sections. Then you can click on new organization, and then you can just say, you can give whatever name you want over here, and you can click on create. So now this organization has been created. Just click on next, give a name to your project, click on create over here. How many of you have reached this stage? Can you mention in the chat if you have reached this stage along with me right now? Okay, you have, right? Great. Then what you have to do is that once you reach this stage, just click on create API key. Click on create API key and just copy whatever you see here. This is a secret key and this is a public key. Just copy these two keys. We'll need to paste them into our code. Okay. So I'm going to move away from this window now, and I hope that all of you have access to your keys right now. Uh, okay, let me open my Yeah. So how many of you have your secret keys and public keys? Can you just mention in the chat? So we will need that. And before proceeding any further, what you can do is just scroll down below. And here is the place where I've mentioned LangFuse public key and LangFuse secret key. Just add these keys over here right now. Just add these keys over here. And once you have added these keys, what you can do is that let's move to the rest of the code. So once you've added these keys, we are at this stage right now, right? But make sure you first add in your keys and then run these packages. Otherwise, we'll need to restart. So just create pip install. So here what we are installing is that Smolagents embraces the open telemetry standard. So through this, we can easily connect LangFuse and we can monitor our agent. So this is going to be very interesting. So all of you definitely need to be able to follow along here because evaluation is one aspect which not too many people really focus on. They just run agents and that's it. But it's equally important for all of us to know whether our agents are working or not, right? Great. So I have my public key and my secret key over here, and you need it for your own account so that you can inspect on your own. Then just click over here. Here we are just establishing the connection to LangFuse. Run this. Okay, so how many of you have reached this stage where you have run this Smolagents instrumenter, this code block? Because that's the last stage for connecting LangFuse. If you have done this successfully, then we are ready. So what we are going to do now is that we are going to do the exact same code. We are going to run the exact same code, but we should hopefully be able to see traces on LangFuse. So see, this is the same code as what we ran before, right? We are creating a code agent over here. We are using the DuckDuckGo search tool and we are using the inference client model with Together AI. And the question is also the same, search for the best book recommendations for implementing AI in the workplace. And I'm going to click on, oh, I think that I'll need to load some of the packages. But those of you who are following along, it should work for you because you have already loaded the required packages. Uh, I'll just need to, yeah, I think the DuckDuckGo search tool is not defined. Okay, now it should work for me. So now you can see that this thing will stay the same. Nothing will change on your Google Colab. But once this is run, what I'm interested to check is what do we see on the LangFuse? So here you can see I've got some error right now. Let me run this once more. Step number 1, step number 2, step number 3. Yeah. So the final answer is generated now. Now what I will do is that I will go to my LangFuse now. So let's see. Let me share my screen. So what you will have to do is that there will be something called traces. There will be something called traces on the left hand side. So you have to go to those traces. Let me see where it is. Yeah, traces. You have to go to traces, and here is where you will see the trace for your particular question. Are you able to see this? Okay, yes, right. So I think Madhavan is able to see this. What about others? Are you able to see the trace on LangFuse? Good. So I think all of you should be able to see a trace on LangFuse if you have created the API key successfully. Now let me tell you how to evaluate this trace. If those of you have not yet created the trace, don't worry, because later you can follow along and try to do it once more after this lecture is over. So first of all, what you have to do is that you have to click on this, and it opens this kind of a dialog box. Here is where you can inspect things in a much better manner. So the question we asked was search for the best book recommendations, and the output is this. These are the book recommendations. But now we can go one more step and inspect this. So if you click on this inference client model.generate, you will actually see the system prompt which these people Hugging Face have actually given. So let's actually look at the system prompt. So this is the system prompt. You are an expert assistant who can solve any task using code blobs. See, that's the most important thing. In the system prompt itself, it's already mentioned that you have to solve the task using code blobs. You will be given a task to solve as best as you can. To do so, you have been given access to a list of tools. These tools are basically Python functions which you can call with code. To solve the task, you must plan to proceed in a series of steps in thought, code, and observation. So this is the thought action observation framework which we have seen before. See, if you just run small agents, you will never understand what's going on in the backend. But if you use LangFuse along with small agents, you can actually see the system prompt which they have given. So every time you make a code agent call with small agents, this is the system prompt which is by default passed to the agent. So then to solve the task, you must proceed in a thought action observation sequences. At each step in the thought, you should first explain your reasoning towards solving the task and the tools you want to use. Then in the uh, then in the code, you should write the code in simple Python because it's a code agent. During each intermediate step, you can use print to save whatever important information you will then need. And then what they do very interestingly when they create an agent is that they provide some examples. So this is few shot prompting. They provide some examples. So here are a few examples. So if the task is to generate an image of the oldest person in the document, Hugging Face has actually constructed it so that they give what the thought action observation should look like so that the LLM can learn better through few shot prompting. So for this question, the thought should be I will proceed step by step and use the following tools to find the oldest person. Then I will use the image generation tool, etc., etc. So they have actually given multiple examples here. If you scroll to the bottom, they have given 10 to 15 different examples of how the coding agent should actually be used. So see, these are the different examples um, of their prompt. So this is the system prompt which is by default added. So if any one of you want to make your own agent in enterprise or workplace, you should be copying this, whatever you see on LangFuse, and you should construct your system prompt in a very similar manner. Not all other frameworks like LangGraph and all provide this much level of openness, because now I'm able to open this black box and we can literally see how they have coded small agents, right? So then what our agent is doing is that, see, first it's thinking that we can even inspect the thought action observation loops of our agent. First, it's thinking that I will use the web search tool. I'll start by searching and then it generates this code. See, this is that code because it's a coding agent. Book recommendations equal to web search, and then query equal to best books for implementing AI in the workplace, and then print book recommendations. Here you also see the amount of input and output tokens which are utilized by your model. In this case, it's Gwen. And then you can actually look at this for all the different thought action observation steps which have happened. You can inspect the thought process of the agent in using LangFuse in a lot of detail. This would not have been possible without using LangFuse, because here you can already see the how many token prompts are there, how many tokens are there for completion, then the total LLM count is this much. These metrics are usually very important if you are building industrial projects, right? Because you want to keep a track of you can keep a track of whether you are exceeding the costs or not. So there is a question about observability versus evaluation, right? So evaluation comes as the next step. The first thing to do is for us to observe in the first place and then evaluate it. So both of the things we are going to see, but first it's observability. In LangFuse, mostly we are going to use it for observability and to see where we are going wrong. And then comes evaluation. So evaluation is not just to inspect whether your answer is correct or not, but you should even be able to, first of all, understand or how to debug whether your thought process is correct or not. That is very important. So someone is asking about when using something like small agents or other code agents, for enterprise, we need to control the system prompt. I think the best way to do this then would be to clone. So if you go to Smolagents, right, they have a GitHub repository. The best way to do this would be to clone this GitHub repository and to create your own repository. And here is where you can change your system prompt. And that will be quite easy to do because it's just, I think, 500 to 1000 lines of code. So if you see src/small agents, um, all of this code combined is not too much. So you just have to go to the place where system prompt is written and you have to change that thing. Okay, anyway, so now this is how the code agents actually work, right? And this is the first step towards evaluation, observability. There is no evaluation without observability. It's extremely important to make sure that you are able to observe the output of your model and actually track the output. And that's one of the main purposes of using LangFuse. The second thing what we are going to do right now is that we are going to run the tool calling agent. Okay, so I hope you can see my screen. What we are going to do now is that the last piece of code which we'll be running today is the same thing, but a tool calling agent, and then we'll also inspect this. So I am getting the error tool calling agent not defined. I'll need to borrow it from where I've defined at the top. Yeah, here. So I think all of you won't get this error because we have already defined it. Yeah, see now we have a tool calling agent and I'm going to inspect this using LangFuse as well. So then you can compare and contrast between both. I think I've hit some DuckDuckGo rate limit, so I'm getting some error here. Let me show you the trace which I had generated before. So this is the code agent, right? Now here is where the tool calling agent is. So if you inspect the tool calling agent, you can see the prompt which Hugging Face have mentioned over here. And let me zoom in a bit. Yeah. So here it's mentioned that you are an expert assistant who can solve any task using tool calls. You will be given a task to solve as best as you can. To do so, you have been given access to some tools. So here see there is no mention of code blobs or converting the action into a coding block. What they mention is just that you have been given access to tools. And then the tool call you write is an action. After the tool is executed, you will get the result of the tool call as an observation, etc. So it's exactly the same thing, but without using the coding blobs. So I hope from here now you really understand the difference between the coding agent and the tool agent. If you want to monitor costs using LangFuse, you can do it similarly. If you scroll down below in this message, you will see the input tokens, the output tokens, and the total tokens which are used. And then you can even inspect the output. So the output now is formatted in a much better manner. And in one place, you can see the time to response, the number of tokens utilized, all of these things. So LangFuse is one of the my go-to observability tools for agents and for inspecting agent quality. Does anyone have any doubts or any questions in this part? There is one more final thing which I want to do before we actually end this lecture, but at this moment, I'll just pause to ask if there are any doubts or any questions. Where do we check the traces in LangFuse? Okay, so traces actually are, if you go to any project, right, you will see the tracing on the left hand side. It's with this symbol. So there is home, dashboards, tracing. So you go to traces and here is where you'll see the different traces. Um, yeah, this is where you see the traces. You see the timestamp, the input, output, the observation levels. Yeah, this is also quite important. Actually, observation, as we So in the future lectures, this is from one of the next lectures, we are going to code an agent with multiple observation levels. Right now, we just coded an agent with 2 to 3 observation levels, right? Which are how many loops are there. So LangFuse also tracks how many loops your agent entered. Um, and these are the number of loops as we go into more complex agentic projects. Here you will see that there are 66 loops, and it also mentioned the places where there were errors. So very easily you can identify the loops, the places where errors were there, etc. And by the way, once you set up a tracing, right, you can easily create a human annotation or an LLM as a judge. So you can link your traces to evaluators. You can create your evaluator over here. You can define the metrics. So once observability is there, then comes evaluation, right? And this is where you define, uh, let's say if you want hallucination as a metric, if you want conciseness as a metric, etc. This can also be done using LangFuse. Okay, how do we judge what is the ideal number of loops? So that is something which needs to be um, figured out. It's like a hyperparameter, I would say, in machine learning terminology. We never know at the start, but usually more loops means more planning, but at the same time, more computational expense, more token expense, etc. So there is like a trade-off. Um, there are some questions about resources on prompt engineering, open source. So I'll be sharing these resources on the Discord group. There are multiple good resources for prompt engineering books, for observatory tools. Both of these I'll share in the resources channel of our Discord group. Now let's move to the and Discord group access is only for pro registered candidates. So one final thing which I want to showcase before we actually end today's lecture is that we'll quickly build one more agent, which is essentially a vision agent. And this is a very simple agent which all of you will be able to build. What are the top metrics used by people? That's a very good question. So let me quickly answer that. Out of these evaluation metrics, right? The top metrics used by people are hallucination is the one hallucination, relevance, and faithfulness and context recall. So four actually: hallucination, relevance, faithfulness, and context recall. If you are actually in an enterprise, you need to do one more thing of adding guardrails. So then this toxicity also becomes a very important metric for you. One good open source library for observability is something called Ragas. Has anyone heard of this before? Ragas is a fully open source library for LLM evaluation and observability. It's quite good. So here also you can check the different evaluation metrics which they have. Anyways, let's now come to the final module of this, in which we'll actually build vision agents very simply. For executing this, you will need access to again OpenAI API key. So I'll share this Google Colab code file with all of you right now. And I'll go over this a bit quickly because we are almost at the end of time, but I'll explain to you enough so that we can actually, so that you can run this on your own at the end. So what we are going to do is that we are going to build a very simple vision agent through small agent, and the code will stay the same exactly, but we'll take input images. So here there are images of the Joker. Uh, so if you see the image which we are using, you can choose any image, but this is one image which we are using. The second image is also of a Joker. So this is the second image. So two images of the Joker have been downloaded. You can change this to whatever you want. And here we are again setting the same thing, the LangFuse observability. So this part is the same. The only change which you'll see over here is that the agent now does not have any tools. The agent only has access to a model, which is a vision model. The task of this agent is to look at images and to tell us what's present in the given image. So the reason I'm sharing this is because I want to show one text-based simple example using small agents and one vision-based simple example using small agent. So what this agent will do is that it will describe the costume and makeup that the comic character in this photos is wearing and return the description. Tell me if the guest is the Joker or the Wonder Woman. In this case, the agent needs no tools because just the multimodal language model itself is enough for the agent to look at images and tell which character is present in that given image. So if you see, the code requires three API keys actually. Two API keys you have already generated right now. These are the LangFuse public key and the LangFuse secret key. Those are two API keys which we generated right now. The second API key which it will need is the OpenAI API key, which you will need to put over here. So let me now run this. You first again. I'll need to terminate some other session here. Yeah, so I've terminated all other sessions. So let me again install Smolagents right now. I'll download these images, these two images. Um, I've already loaded my OpenAI key over here, so I won't need to copy it again. And then I'll need to load these same telemetry packages so that we can connect LangFuse. And I've inserted my public key, my secret key, etc. Yeah, this is the main code which we are going to run. We are going to again define a code agent, but which has no tools. And the task of this agent is to describe, as I discussed, to what's present in the image. So now I have run this and this agent is running at the moment. So again, you see the same thought action observation loop and you will see that actions are again made as code calls. So the reason I'm repeating this point is to again drive home this thing that code calls are always made. So then we are moving from step 1 to step 2, etc. Yeah, and then finally the output is given, right? So the final answer is that the character is wearing a costume and makeup resembling the Joker. The face is painted white with bright red lips, exaggerated into large menacing grin, etc., etc. The guest in these images is the Joker. And then if you print out the response, you can see the response over here. But one more thing you can do is that you can simply go to the traces. You can go to the traces and you can see what's there. So describe the costume and makeup, right? And then you get the output. And then you can see the code agent run and see the task, output, and the metadata. So this is one pre-stored result which I'm showing right now. Let me go to one live result as well. Yeah, I think, this is the live describe the costume and makeup. And here you can again see the same thing that the message, the small agent system prompt message is the same thing, solve any task using code blobs, etc. And then we can see the thinking. Um, the thinking you'll see over here that what's the, where is the tool call being made, then how many tokens are involved in the prompt, how many tokens in the completion, what's the model which we are using, etc. So it's the same thing essentially, but just transition from a text-based to a vision-based. So using LangFuse, actually, we can monitor all sorts of agents. I'll also share a tutorial on Discord regarding evaluation. How can we integrate LLM evaluators using LangFuse? So now that you're comfortable with the platform itself, to all those who were able to see these traces, what we'll do next is that I'll provide a tutorial on Discord about how to integrate evaluation frameworks with these traces. So then it will be a mix of observability plus evaluation. So one final thing is related to the next class. Next class, so we'll be having the next class again on Monday now. in the next class, what we'll be doing is that we are going to create multi-agents and browser agents using small agents. So the multi-agent will be a complex agent problem which will have 50 to 60 thought action observation loops. And the browser agent, as I explained to you yesterday, it will be mimicking this operator which we saw, OpenAI's operator. So in the next lecture, we are going to build these two types of agents using small agent. In the multi-agent framework, you will also see how one agent can hand off its responsibility to another agent. So 66 thought action observation loops are too much for one agent to handle. So it can pass on some of those loops to another agent so that task workflow becomes efficient. Yeah, so the next lecture will be on Monday, and the timing is so 27, 20, 29. So that will be 30 of June, and it will be at 2 p.m. IST. So we have one lecture on Monday on multi-agents and browser agents, and then we'll move to more types of agents. So then we'll move to LangGraph, Agentic RAG, and then projects using CrewAI, and then after that we will move towards n8n, and then final projects using n8n. So 5 lectures are now done. So we are halfway through this boot camp, and as I mentioned at the end of every lecture, it's very relevant that, or it's very important that you make notes. One more assignment I'll be adding to the Discord server as we go towards more practical concepts. So thanks a lot, everyone. If you have any more doubts or questions, please feel free to ask on Discord. We'll continue our discussions over there. And I'll upload the lecture notes and the video recording today as soon as the lecture is over. If you felt some portions of the lecture were a bit fast, you can go through the recording once more, especially the LangFuse part. All right, so thanks everyone. Again, looking forward to the remaining 5. So if you've attended these 5, it's already great. So please stay consistent and attain the next 5 because so I planned the story of this bootcamp such that when you finish watching all 10, you will get a good cohesive thing in your mind that, okay, these are what agents are about. But if you leave halfway, then that link will be lost. All right. So thanks everyone. I look forward to seeing you on Monday. Bye. Okay, with that, let's actually get started with today's lecture. Some people might join late because they are facing some issues with entering the Zoom room, but we can get started. So today, the main topic which we are going to cover is a slightly advanced concept which is called multi-agents. And we are also going to look at browser agents. Before going into the details of today's lecture, as always, let's do a quick recap of what all we have seen so far. So on day 3 of the bootcamp, we learned about the most important framework which governs agents, and that's the thought action observation framework. That's the underlying theory behind every agentic framework, which we are going to learn in this bootcamp. This was the main content of lecture number 3. In lecture number 4, we looked at an overview of coding, low code, and no code frameworks. And lecture number 5, which was the last lecture, we started coding AI agents using the small agents library. And the reason we have started with this is that it's the simplest agent coding library out there currently. And we saw the difference between code tools or tool agents and coding agents. And we saw that code agents draft the action in format of a code like this. And we also saw this GIF, which is extremely important to remember how the thought action observation framework actually works and how the memory of the agent gets updated with consecutive responses. And finally, we took a look at the difference between tool calling agents and code agents. And we saw one example using vision agents. And finally, we covered LangFuse. LangFuse is where you can see these traces and you can observe how well your agent is doing. As we discussed in the last lecture, there are two components, right? Observability is one component. And the second thing is, once we observe how our agents is doing, we should also evaluate the agent. So today I'm actually going to show you how to evaluate the agentic response using LangFuse. So today we are going to look at observability, and today we are going to look at evaluation simultaneously for this multi-agent approach, which we are going to consider. So let's get started with today's lecture. Before we start, at some point in today's lecture, we need the OpenAI API key. So just keep that handy. It will be needed at different stages during the coding process today. So have it ready. And if you don't have it, just follow the lecture as I'm teaching it. But after the lecture, get the API key and revise your knowledge once more. So what do we mean by multi-agents? We have already seen that in the first lecture, there is a level of agency, right, to AI agents. All of us now know about a much more sophisticated definition of AI agents, which means that even a simple agent such as going to a language model and then doing a web search, that's also an agent. Whereas if you have much complicated sequence of agents chained together, that's also an agent. Both are agents. It's just that the level of agency depends between the two. So there is a comment on the chat that we are asked to enter passcode and haven't received. So actually this meeting should not require a passcode. So I'm not sure why it's asking a passcode. So Surya, Daksh, how did you guys join this meeting? Because it should not require a passcode. 1 2 3 4 5 6, is it? Okay. Um, so if any one of you is in the Discord, please mention the new link does not require a passcode. And if it's the old link, then 1 2 3 4 5 6 is the passcode. So I can see now that many more people are joining. So it's fine now. Yeah, so what I was discussing was the definition of an agent remains the same. It's an LLM equipped with tool calls, deals with external environment, has memory, etc. But the amount of actions, the amount of decisions which agents make, that affects the level of agency. So at the smallest level of agency, an agent just does a simple tool call maybe. But as the level of agency increases, then we get from single agents to multi-agents. So what multi-agent essentially means is that we are just going to arrange agents together. We are going to couple agents, and we are going to share the tasks between different agents. This is one major advantage of having multiple agents. We share the tasks, and I'm going to explain why we need multiple agents as we do our practical example today. And the second type of agent which we are going to look at briefly is browser agents, which means how can you allow an agent to automatically take control of your browser and interact with the different web pages, etc. Right. So we are going to take a very interesting problem today, and we are going to construct multi-agents and browser agents using this problem. And we are all going to think about this together. So we are going to approach this now based on whatever we have learned so far. So the problem is that Harry Potter, right? We are going to take a look at this. And after this lecture, you can replace our current example with whatever you want. It's a general purpose coding file which I'm going to provide to you today. So you can replace the current example with whichever example you want. So the task is this, that let's say we want to visit all the places in the world where Harry Potter was filmed. That's our number one task. And number two task is that while we are visiting these places, we also want to visit if there are any nearby cricket stadiums. So it sounds like a task which is two tasks, right? The first task is I want to visit all the places where Harry Potter was filmed, but I also like watching cricket matches. So while I'm visiting these locations, I also want to visit any nearby cricket stadiums. And then the third task is that I want to plot all these locations on a map. So you can already see that as we are entering deeper and deeper into the bootcamp, the tasks are getting complex. Here we want to do three tasks together. We want to list the places where Harry Potter was filmed. We want to visit nearby cricket stadium to those filming locations. And third, we also want to plot these locations on a map. And I want an agent to do all of these things for me. I don't want to do anything manually. As a so now let's start thinking from first principles, right? What tools will this agent need? If this agent wants to if this agent wants to do all of these tasks, what are the tools which the agent needs access to? And we have seen this multiple times in this class so far. So I hope many of you will be able to answer this. Map. So map is not which type of map. We need to explain this in a lot of detail. Like what do you mean by map? So of course, some things which are definitely clear is that we need search. We need search API so that we can visit the different websites and um, we can collect information of what's mentioned on that website. The second thing which we'll also need is that we will search API is one thing. The second thing is we will need to scrape information from web pages. So we'll need to scrape information from web pages. That's the second tool which is needed. And as I can see on the chat, the third thing which we might need is some tool for plotting, right? And many of you have mentioned map. So I'll just mention plotting tool here. But there is one more thing which someone has already mentioned this correctly in the chat. We need one more tool which lets us calculate the distance and which lets us calculate the time. And I can see that some folks have already mentioned this in the chat, and that is something called the travel time calculator. So we need all of these tools which we need to equip our agent with. And you will see that when we write the code, we are going to equip our agent with all these tools. Second thing which you will see today is that we are again going to use LangFuse. So today, the number of thought action observation loops which the agent is going to enter is going to be a lot more than what we have seen earlier, because this is not a simple thing to do at all. Even for a human to do this, it will take time. We have to go to websites first. We have to list down the places where Harry Potter was filmed. Then we have to write a script in Python to find the distance from our place to that place. Then we have to find the places which are closest. Then on top of that, we need to search if there are any nearby cricket stadiums. These are complex tasks which are chained together. So now let's go to the code, and I'm going to share this Google Colab code file with all of you. So let me just share the link. Yeah, so this is the Google Colab code file. So for the participants who are joining late, it's you can share the participants currently in the call, you can share this file with them so that everyone has access to this code file. And if you scroll down, you'll see that the code is slightly longer. So I'm going to explain every single thing in detail. Let's do a couple of things before we actually start. LangFuse. We are going to need the LangFuse public key and secret key, which needs to be put over here. So how many of you have this? Because if you have done the LangFuse project in the previous lecture, you should already have these keys ready, because we created these in the last lecture. It's the same keys which you need to input over here. You don't need to recreate new keys. You just can input the same public key and the secret key over here. So this is the copy file I've shared with all of you where these details are not yet entered. but this is my actual file where I have entered these details, and this is where I have my LangFuse public key and secret key. So let me just show you, for those who don't have access to this, the way you can get access is that you go to LangFuse, you'll first need to create an account. Then you need to go to the project where you are. You can go to settings on the left hand side. You can click on API keys over here, and here you can create new API keys. When you create a new API key, you will get a public key and you will get a secret key. You can copy these public key and the secret key, and you will need to paste them over here. So if you scroll down in the code, you will see the first place where there is LangFuse public key and LangFuse secret key. You'll need to paste them over here. We have already seen this in the previous lecture, so I'm not going to go through the LangFuse login and the sign up process. And if you have not stored your public and secret key from previous lecture, it's a good practice to keep on reusing the keys if the project is similar. Otherwise, you need to, if you're working on new projects, you need different keys. But for the purposes of this bootcamp, you can now use the same public and the secret key which we created last time. Then when we go below, we'll also need SERP. Let me see what all we need. We need SERP API key. So let's go to SERP API, and this let's create together. So if you go to SERP API, this is Google Search API, and we actually saw this also in one of the lectures. But what you can do is that you can sign in with Google, and you can copy your private key over here. So you can see that I've already exhausted 83 of my 100 searches, but all of you should have many more searches remaining over here. So um, just copy this SERP API key, and then you can paste this over here. That's the second thing which we'll need. Third thing which we'll need is we'll also need the API key for Serper. So this might be confusing, but one of my intentions in this bootcamp is to expose you to as many search APIs as possible. So SERP API is one search API, and there is also Serper. So these are actually two different API. Even here, what you can do is you can click on sign up. You can click on sign up. You can create an account over here. So if I go right now and if I create my account over here, you can follow along similarly right now and create your own account so that all of us have these keys, and these can be created for free. So it does not take too much time. So I'll just go to my email using my phone and let me verify this. Okay, so now once this thing is verified, you should all see. Let me do resend email. So now I'm going to my Gmail to verify this. Yeah. Yeah, so this thing I verified right now, and you can then go to settings. Actually, you can directly go to the API keys on the left hand side. You can create new key. You can give a name called agents, let's say bootcamp, and you can create your key. So then you will get your API key, and you can click on this copy symbol over here to copy this key that is for Serper. And if you scroll down below, if you scroll down below here is where you will need the Serper API key. And then the last thing, fourth API key which you'll need is the OpenAI API key. So as we go towards more complicated projects, all tools will need API keys. So later, once you do this for one project, it will become easier utilization of multiple API keys. But here is where you need your OpenAI API key. So to summarize, you need let's go from the start. The first thing which you need is LangFuse. You need LangFuse public key. You need LangFuse secret key. Then you need SERP API key, and you need Serper API key as well. Okay, you need these 4 API keys, and then you will also need OpenAI API key. 5 things will be needed. And then one last thing is that we have to go to Hugging Face. And as we saw last time, you have to click on access tokens on the right hand side. And then you need to have your create new token, write token, and HF agents. This is not strictly needed, but I always think it's good practice if you want to upload your model to Hugging Face. So I will keep on showing this in subsequent lectures as well. So let me pause here for a moment and ask if anyone has any doubts here, or are you comfortable setting up these multiple API keys? Can you just type yes in the chat if you have filled the code with the different API keys which are needed? Okay, yes, I can see that 3 to 4 people have mentioned that. So Rahul is asking, can you please repeat the 5 things? Yeah. So let me repeat the things again. First thing is this Hugging Face login. So when you click on this, you'll be asked to enter your Hugging Face access token. This is not strictly needed. That's the first thing. The second thing is if you scroll down below, there will be LangFuse public key and there will be LangFuse secret key. So these 2 keys will be needed. Then once you scroll down below, there will be SERP API key that will be needed over here. And then we are also going to use Serper. This is very confusing because SERP and Serper sound the same, but they are actually different. So Serper API key is needed here. Technically, you can use either of SERP or Serper, but I want to expose you to all the different tools. So that's why I've used both here interchangeably. And then you need finally the OpenAI API key. So that's the 5 keys which you need. And once you have this, you are all set to run this and monitor whatever you want in the LangFuse. Okay. So that's another important thing. If you have actually put your LangFuse keys, you will definitely be able to monitor your results on LangFuse. As I mentioned before, observability and evaluation is one of the most important things which I want to cover through this bootcamp. So in every lecture, I'll be focusing on LangFuse. And last lecture, we covered observability. This lecture, we are going to look at evaluation also. So let's start. You can first execute the first line of code. Here is where we are installing the packages. These packages, GeoPandas, Shapely, and Kaleido, these are the packages which we will need later for plotting these locations on a map. But other than that, the only package which you really need to install is Smolagents. And this Light LLM is a service provider where through one platform, you can access multiple different LLMs actually. Okay, so that's the first thing. Second, you can run this code cell and you will be asked to enter your Hugging Face token over here. So let me just go to my Hugging Face. I'll copy this. And then I'll enter this over here and click on login. Okay, so now I'm logged in. And then, so this is also the class where I'll teach you about custom tools. Until now, all the tools we have done are predefined libraries, right? But this travel time calculator is one such tool which is not predefined anywhere. So we need to define it as a function. And the way we are going to define it is that we are going to consider the latitude and longitude. And you can change this based on where you are located right now. So I'm located in Pune. So I have mentioned the latitude and longitude of this city in the code. And then what we'll be doing is that Pune's latitude and longitude is, let's say, something X and Y. And then whichever location which we scout for where Harry Potter was filmed, let's say that location is X1 and Y1. We are going to find the distance between these two places by a simple x minus x1 square plus y minus y1 square root, etc. And then based on this distance, we are going to find the time taken, considering the average flight speed. And this thing which we are doing right now, all of you will need to do when you are working on industrial projects, because it very frequently happens that the tools which we want are not given to us by default. So we need to write functions for these tools. So here is the function. The way you define your own custom tool is using this @tool. And we have mentioned define calculate travel time and then origin coordinates and destination coordinates and cruising speed. You can actually change all of this. So if you see, the way I have done it here is that you get the latitude and longitude of both the places, and then you have some sort of a grid circle distance which calculates the distance based on latitude and longitude, and then finally you have the actual distance divided by the cruising speed. That gives you the time, that gives you the time taken to go from one location to another location. So some people in the chat have asked for a quick recap, right? So essentially what we are doing in this lecture is that we are we are we want to visit the places in the world where Harry Potter was filmed, and then while we visit these places, we also want to visit nearby cricket stadiums, and then finally we want to plot all of these locations on a map. So we are assembling an agent which will be able to do all these three things. This agent will have access to search API, scraping information, plotting tools. All of these are by default tools which are available to us from the package itself, but we also need a travel time calculator. For that, we are defining a custom tool which lets us find the travel time between any two places on the globe essentially. And the way we are doing that is there is something called the great circle. There is something called great circle distance. And what it does is that it's essentially this. You have a latitude and longitude of a particular point and another point. It just measures the distance between these. So it's like an arc, if you can imagine it like that. That's this function which actually gets the flight time. And now this is my custom tool. So you can run this. You can either think of this as a function, but since we have a @tool decorator over here, it has become a custom tool for us, which lets us find the travel time between any two locations as long as you give the coordinates. And then what we are going to do is that the second tool is the Serper API, which I'll come to in a moment. But remember, you all created um, on SERP and Serper. Both of this will be required for us today. Once we have defined this tool for calculating the distance based on latitude and longitude, the next thing which is extremely important is connecting to LangFuse. So we already saw this in the last class where we install the Open Telemetry standard and we connect to LangFuse using the LangFuse public key and LangFuse secret key. This is where the LangFuse key will be needed for all of you. Once this is connected, we have to make the agent itself, right? So if you see, we are going to define a coding agent like this, but for the agent to work, as we have seen earlier many times, we need a language model foundation. We need tools. And the tools which we are using is, see, this is where we added our custom function which we defined. The custom function which lets us find distance between any two locations. Then we are using visit web page tool and Google search tool. Now, one thing to note is that you should understand the difference between Google search tool and visit web page. These are fundamentally different tools. Google search tool allows you to search for a particular query which you input. Visit web page will actually go to that web page and collect information of what all is present on that web page. And calculate cargo time is our custom function. These two functions are by default functions which have been provided using the Smolagents package itself. The model which we are defining here is an inference is Quen. We have already seen this same model which we used in the previous lecture. So run this to load the model. And then we are also going to use so here is where you define the SERP API key. And before that, here is the task. So ultimately we have to run agent.run task, right? So the task is this: find all Harry Potter filming locations in the world, calculate the time to transfer via passenger plane to here. We are in Pune. So this is where you can change to your location, wherever you are, wherever in the world you are right now. Just type in that place and type in the coordinates of that place, the latitude and longitude, wherever you are in the world. Just change this over here. So what I've written here is that find all Harry Potter filming locations, calculate the time to transfer via passenger plane, and return them to me as a pandas data frame. Also give me some cricket stadiums if there are any nearby to the filming locations. This is exactly what we want. We'll look at the plotting functionality later, but this is what we want. So just run this task and so Arun is asking, what if I put Pune, India? Is it not enough? So Arun, one thing to note is that take a look at our calculate cargo travel time function. Our agent will ultimately use this function. But if you scroll up and see how we have defined the function, this function expects origin coordinates and destination coordinates. So this function expects us to give the coordinates in latitude and longitude. If we do not give it, the agent will have a hard time to actually retrieve those coordinates and then run the function. Instead, we just make it a bit simpler for the agent to directly give the coordinates on our own, so that it knows it has to use that function. Okay, so this is my task, and all of you should now be familiar with this model, these tools, additional authorized imports. So the reason I've added this is because I want to return my answer as a pandas data frame. And this is again where you see the advantage of using coding agents. Since our entire actions are going to be formulated as code anyways, it becomes much easier for the agent to directly use the pandas plotting library from Python. That is what I explained to you in the previous lecture, that code agents, if you take a look at the Substack article for the previous lecture, code agents formulate action in format of a code. So if you want to use a pandas library over here, it's easily integrable. That's what we have written over here, that return them to me as a pandas data frame. So the additional authorized imports which I have is pandas. This is where we say that you can feel free to use the pandas Python package. And finally, what you are going to do is that once you have defined the agent, you can just do agent.run and mention the task. So now you see this is a new run, and our agent is already started to work. Find all Harry Potter filming locations in the world, return them to me as a pandas data frame. So this is step number 1, where everything is being formulated as a code right now. So Satish is asking, finding cricket stadiums is also part of the same task. Are we not creating a different agent? We will create a different agent, Satish, but for the plotting functionality. Actually, this also you can separate it out. I'll show you how to create a new agent after this is done. Okay, so see, now this is running, and I really encourage all of you to go through these execution logs, because step number 1, now it's a code agent, right? So web search, this is formulated as a code. So first we are looking for Harry Potter locations, and you see this is what the agent has answered, right? And then what the agent kind of figures out is that, okay, these are my origin coordinates and these are the locations which I've retrieved. The agent automatically converts these locations into latitude and longitude. And the reason it does that is because to find the distance, we need everything in latitude and longitude. So these locations have been identified where Harry Potter is filmed, and those are converted into latitude and longitude. Uh, and then if you scroll down below, you'll see that this is the function which actually our agent is using. And it integrates the pandas.data frame directly with this function. Again, since it's a coding agent, everything is a code. So it becomes much easier to integrate the pandas.data frame here itself. And finally, the output is where it gives the locations along with the coordinates, travel time to Pune, etc. You can actually print the result over here. So you can see the locations where Harry Potter was filmed over here. Then you can here itself see the coordinates of that particular location. You can see the travel time to Pune. It ranges from 11.88 hours to 12.18 hours, let's say. And you can also see the nearby cricket stadiums here itself. Now, clearly, as you can see, there are some hallucinations over here, right? This points to the fact that we can decouple it into a different agent. But anyways, if you see this right now, our agent has kind of given us what we want, but each of us might have different responses. For some of you, it might return an error. For some of you, it might return it quickly. So right now, for me, I got a response within 1 minute. But as a preparation to this class, I've run this multiple times, and sometimes it even takes 7 to 8 minutes for me. So for every person, the time the agent might take will be different, because sometimes the agent might get stuck somewhere and it does not know what to do after that point, right? Yeah, so this, as you can see, this is something which is printed, which Jay has put. This is definitely not a good answer. So Jay, you can again run it once more to see whether the output improves or not. The second thing what we can do is, now all of us can go to LangFuse. Let's go to LangFuse and let's actually see what is going on. So I'm going to share my screen again. So that's why I really encourage all of you to have those LangFuse keys ready, because otherwise you won't be able to inspect. So now if you have actually run this on LangFuse, you will see a trace which is appearing over here. So look at this, the timing is 14:33, which is 2:33 p.m., which is right now my time here. And you can click here. Actually, before clicking, just scroll to the right and see the number of observation levels. Can you all mention the number of observation levels which you have seen? So I have 29 observation levels over here. For each of you, this might be different. So in the chat, we can see 16 observation levels, two observation levels is definitely low for this. Tejas has 26, Pritham has 65. Yeah, I think 65 to 70 observation levels are what is actually needed to solve this. Otherwise, the answers won't be good. So now let us actually inspect. Just click on this output over here. And if you can just see you can see on the left hand side, the different tools which it has used. We have used the Google search tool multiple times. We have also used this simple tool. Um, so I believe this simple tool is our custom tool. Google search tool is going to the search engine and actually scraping through the website, but the simple tool is where we actually find the distances. So every time you go to the simple tool, you'll find the distance between two coordinates. And then you have the final answer tool. This is where the agent actually stops, and you can inspect the final answer over here. This is the final answer which I have obtained, and I can see some hallucinations here because there are only 26 or 27 different observation levels in my code. So you can again scroll up and try to see some different things over here. Now, if you go to the right hand side, you will see the amount of tokens which are used, the input tokens, the output tokens, and the total tokens. What exactly simple tool? So simple tool is the distance, like is the custom tool which we have defined. And for each of us, it might be different. In some of, like, I can see a screenshot where visit web page has resulted in an error, right? And that happens many times when once an agent goes to the web page and it tries to figure out what is present on the web page, but is not able to pass the information, it results in an error. But the cool thing about agents is that it goes into that thought action observation loop again. It does not stop there. It gets an error, it goes into the loop again, and usually it will try to resolve that error on its own. So this is what we are seeing right now. And here you can also see in each call how many tokens are generated total, right? So 3206 plus 676, that's 3882 input plus output tokens. So tracing, I can see some people are unable to set up tracing. So this we have already covered in the previous lecture. If it's still not working, you can restart the two things: restart the Google Colab notebook and make sure your keys are correct. Then ideally it should work. Okay, so next what we are going to do is that I'm going to look at evaluation a bit later. First, we are going to again go to the code. Yeah, so let me take you all to the code file right now. Okay, so now we are here, but we can, if those of you who are not seeing good answers, please remember that we can give some more custom instructions over here. So we can give a planning interval. That means there are some dedicated extra number of planning steps which we want our agent to go through to get to a good answer. So if you click on this right now, it will keep on running for a long period of time. So I'm not going to click on this right now, but this you can vary from 5, 3, 4, anything which you want. And then this will definitely go through those many different planning steps if you have not got good answers. So here is where you can customize the number of planning steps. Do this maybe after the class is done, because other than the code keeps on running for more number of time. And here I've added more things, right? I can also print out a report. So for example, you are an expert analyst, you make comprehensive reports after visiting many websites. Don't hesitate to search for many queries at once in a loop, etc. We can give custom instructions like that also to the agent. Okay, so here we have got some good responses over here. But again, plotting is not implemented, right? Plotting is not implemented and multiple agents are also not implemented. So I'm going to now slowly explain that to all of you. So let me see if there are any questions in the chat meanwhile. Can we parallelize agents like a pre-processing stage where you fetch all the necessary information and then finally create a data frame instead of serialized manner? Yeah, we can do that. So when we do CrewAI, I'm going to I'm going to show you how you can parallelize agent functionalities. You can even, so currently we are doing serial agents, right? We can also have functionalities done in parallel and then merge those results. So someone has asked, can you please repeat what planning interval means? So agent planning interval actually means that the number of planning steps which it definitely has to perform. So for example, after going through one complete thought action observation framework, you can think of it as one loop. So I want the agent to go into 4 such loops through the entire process, which means it goes through the thought action observation, gets some result, but it does not stop there. It goes through that planning process 4 times so that it can keep correcting itself. Then let's see, can we talk about few packages which are imported and use of them? Yeah, so basically the main packages which we have imported, if you see, are small agents, of course. Then uh, these are telemetry packages which are for evaluation and observability purposes. So if you see, there is a long package. Yeah, this again is integrating LangFuse with small agents. And here we have imported the tools from small agents itself. So if you see, the only real package which we have is small agents. Everything else are modular packages which are meant to integrate with small agents really. Okay, now let's actually go to the next portion of today's lecture, where we are going to create one more agent which is linked to the current agent. So right now what we have done is that we only have one agent. Right now we only have one agent, and that one agent has access to, yeah, it takes some time to get the detailed report. That's why I did not run that part of the code. But as I'm explaining this, actually, maybe you guys can, maybe I can also run this because it does take some time, but let's see. So I can run this right now. So let it run. And while it's running, I can explain the concept of multiple agents. So currently we have only one agent, right? And that one agent actually is doing two things: web search tool and travel time tool. Now we also want to plot. We also want to plot the different locations which we have obtained on a map, on a globe. Now there are two ways to do this thing. The first thing is that you can simply stick with your current agent and you can just give it one more tool, which is a plotting tool. So that way you will have one agent and that agent will have access to three tools. That's one way you can go about this. The second way you can go about this is that let's call this agent as our web agent, but without the plotting tool. So whatever we have so far, let's call it the web agent, which has access to the search tool and the travel time tool. I can have a manager agent. What the manager agent does is that the manager agent will have access to this web agent and it will have a special access to the plotting tool. Both of this will achieve the same functionality, but can you tell me what do you think would be the advantage of using multiple agents in this case? Why would people want to go with something like on the right hand side versus just having one agent? Why do we even have this manager agent in the first place? How does it make sense? Specialized agenda, parallel execution. Yeah, actually, all of these reasons are correct. So the main thing is that currently, if you have just one agent doing all of these tasks, the context of the agent has all of these things mentioned in one single big prompt. So the amount of attention one agent can give to each of these tasks is kind of divided. And so sometimes the agent might not perform as well in some of these tasks as it does in other tasks. So it's like one person doing all the work. Instead, what you can do is that you can separate the work among agents, right? So then we have specialized agent. We have this agent which only specializes at using the search tool and the travel time tool. And the manager agent oversees this agent and it also oversees the plotting. So that way we are creating compartments. We are creating compartments between agents and the tasks which they can perform. Another reason why this compartmentalization is useful is because it separates the memories of agents. Now, if memories are not separated, what happens is that if you go to LangFuse again, let's say, and if you go to traces, you will see here the amount of input and the output tokens which are consumed. On the right hand side, if you scroll, you will see the input and the output tokens, and sometimes this token count can become very large, and that affects the memory of the agent. Why does it affect the memory of the agent? Because as we have seen in the previous lecture, whatever output which is produced from one thought action observation loop, it is appended to the memory of the agent again and again. So the more tasks an agent has to perform, the more amount of tokens it has in its memory. The more amount of tokens will be there in the memory of the agent, which is not good. Why is it not good if there are more amount of tokens? Because an agent is ultimately a language model, right? And language model have something called context windows. If the memory of a language model keeps on increasing, it will slowly start losing out information. Think of it as a human with limited memory. If more things are stuffed into your memory, you will slowly start losing information which you had before, right? So what happens is that if only one agent is performing all the tasks, its memory will go on increasing a lot because now the token count will be from the output of all those tasks. And this token count, if it goes on increasing, it might lead to memory overload for an agent. Then it might start losing context. And then once an agent starts losing context, it starts to hallucinate. So this memory overload problem is directly related with hallucination. If you have all of these tasks which are performed by a single agent, then it leads to its memory being overloaded. So the context window, whatever is fit in the context window of an agent is limited. So if memory becomes larger than that, the agent starts losing information. It starts to hallucinate and provide and produce random information. So what this does is that this web agent's memory will be its own memory. This manager agent's memory will be its own memory. These two are separate memories. They don't interfere with each other. And that's why you can keep these memories separate. So in a sense, you are kind of also reducing the hallucination problem. Separating memories also reduces cost and latency because if memory starts to increase, the language model takes more time to respond. So when I asked you why do we prefer multiple agents, one answer is with respect to computations. The second answer is what all of you mentioned, that each agent is now focused on its core task, and hence it's more performant on that particular task which it is doing. So there are two reasons actually. Uh, Having multiple agents will eventually help us to separate memories. It reduces the overall token cost. It reduces the latency, and every agent can now focus on its own core task and hence be more performant. right? That's why tools like CrewAI, which we are going to learn, that's why tools like this have become so popular. The reason is because having multiple agents really makes a lot of sense, from improving the performance, also reducing the latency, reducing the cost, etc. Jay is saying, will the cumulative memory of all the agents not create hallucinations? So the cumulative memory will not create hallucinations, right? Because every agent will have a separate LLM for it now. So manager agent has a separate LLM, which has its own memory, which it's responding from its own memory. Web agent has a separate LLM, which is responding on based on the memory of the web agent, really. So that is the reason there are separate LLMs which are allocated to different agents in the multi-agent framework which we have. It's not a single LLM which takes care of all the problems. Manager agent will take input from all the other agents, so that could create problem. But manager agent will take the output of the web agent as the input. And the output tokens are usually, the output is pretty structured. The entire thought process, all the tokens, those are not passed to the memory agent. The output of the web agent is passed to the memory agent, and those are not usually enough tokens because it's a final answer which is produced. We don't pass the entire thinking. And each of these agents has a thought action observation framework, right? So the web agent has a thought action observation framework within this. The web agent has this thought action observation framework within this. So web agent goes through this entire framework, returns some answer, but manager agent also has its own thought action observation framework. So essentially, it's like you are checking the answer multiple times, right? Two agents are checking the same thing through their thought action observation framework. So that's another check which prevents hallucinations. So web agent, if it returns the answer and if it thinks it's correct, manager agent can still go into its own thought action observation framework. So that way the TAO framework will keep on repeating. There is a question that even though it will be memory overload for the particular LLM, the original memory requirement from the prompt will increase or remain the same. So the thing with agents is that agents are thinking, right? And as they think, they go through this thought action observation loop. The memory will continuously go on increasing. After this point, the system prompt is fixed. So if you take a look at an LLM, right, it's system prompt plus the memory. System prompt is fixed, but this memory component will keep on increasing based on the past answers which are given to the LLM. So you would want to reduce the memory requirements as much as possible eventually. So multi-agents have significant advantages, not only in terms of computational performance, but actual agent output itself. So it really makes sense to divide tasks and split it across agents. Okay, now what we can do is that let's move forward and let's actually code this. We can code this right now in Python. We are now fully ready. Oh, by the way, I finished this report, I think. So I can print this detailed report. Yeah, see, this is my detailed report over here, and I already got much better answers than the previous one. My previous answers, if you saw, um, without these planning steps, my previous answers in the nearby cricket stadiums were some hallucinated answer like this. This does not make any sense, right? But now if you scroll below, and if here the change which I've made is that I've added a planning interval. So if you scroll down below over here, yeah, once I add my planning interval, the answers which I've got. So if there is no cricket stadium, it says not available. But wherever it says like Lord's Cricket Ground, London, Edgbaston Stadium, I'm aware that these are actual cricket grounds. So it means that we have returned to a better answer. That is the advantage of planning steps. Okay, now let's actually split the tasks between two agents. So first thing what we have to do is that we have to define this web agent initially, right? So I'm going to define this web agent now. If you see, I'm going to say that the web agent is a code agent, and the tools which it is going to use is Google search tool. Provider is Serper. So here we are using the Serper API key. Remember, this is the one which we have downloaded from here. This is the Serper API key. This is my web agent which only goes to web pages, it extracts information and it finds the distance and the time between two places. This is exactly what we saw in the earlier agent, right? And here the maximum number of thought, action, observation steps which the agent can go through, I've limited that to 4 right now. And the description is browses the web to find information. So what we can do here is that this is the web agent which is defined, and here I have mentioned inference client model as Quen, provider is together, and maximum tokens is 8096. So someone has asked in the chat about any other providers, right? So actually, Hugging Face provides multiple providers, so you can just check the documentation once. But there are providers like Sambanova is one provider. Then I think Black Forest Labs is another provider. I think so. But just check this once. I use Together because I have not faced too many issues with it in the past. So this is where you define the web agent. And now what you have to do is that we have to also define the manager agent over here. So this is my manager agent right now. If you see, the manager agent has tools such as cargo travel time. We give it access to this tool, and it has a managed agent, which is the web agent. So the web agent which we have defined previously, that is a managed agent of this manager agent. So I have defined this manager agent as a code agent, and its managed agent is web agent. And remember that this manager agent will also need to plot. It will need to plot on a map. So since it's a code agent, I can directly give it Python packages to use. Again, this is where code agent really shines through, because we can very simply integrate different coding packages together. So here I have mentioned that you can use GeoPandas, Plotly, Plotly.express, Shapely, all of these Python packages you can use. Okay, and what I've done is that I've also told it this check reasoning and plot, which is basically the point at which you have to stop. So here I've basically mentioned, please check that the reasoning process and the plot are correct. Do they correctly answer the given task? Don't be harsh. If the plot mostly solves the task, it should pass. To pass, a plot should be made using px.scattermap and not any other method. So this is kind of a final check which makes sure that my plot generated is actually correct or not. And I am saving it as savedmap.png. Before we run this, can everyone tell me that how many of you actually got this detailed report correctly, like I have done on the screen right now? I saw some comments that in the detailed report you were not able to see the cricket stadium, right? Um, but ideally it should work. If it did not work on the first attempt, I encourage you to do it once more, because sometimes the agent might be stuck. But it really feels good to see this report. So all of this report is now the work of an AI agent in an autonomous fashion. I did not spend any time to generate this report. Okay, so let's move forward now. This OpenAI API key, by the way, it's going to be very important because we are going to use for the web agent, or rather for the manager agent, we are going to use the OpenAI LLM. So see, I mentioned there are different LLMs for the different agents, right? For this agent, we are going to use a Quen for the web agent. And for the manager agent, we are going to use OpenAI's GPT-4o. That's why you need the OpenAI API key. So this is done. And then you can actually visualize the manager agent. So pay close attention to manager agent right now. So the way to understand this visualization is the manager agent is a code agent, and it's managing another agent, which is the web agent. That's a sub agent which it's managing. This web agent is run by Quen 2.5. The manager agent is a code agent which is run by GPT-4o. And manager agent has access to two tools, the calculate cargo travel time and the final answer tool, which is the moment when it stops. And the web agent, which is a managed agent, that has access to the web search tool, the visit web page tool, the calculate cargo time tool, and the final answer tool. Why are we using different LLMs? The reason we are using different LLMs is the second task is slightly more complex actually, because what we want the manager agent to do is that the manager agent has to manage the web agent, plus it has to do the plotting. So you can use actually the Hugging Face agent as well. You can use Quen, but and that also leads to results. But I've seen that GPT leads to better results if you uh, if you use that as the LLM for the manager agent. Instead of using OpenAI, if we had to use an open source LLM, which one would be preferred for these kind of multi-agent tasks? That's actually a very good question. So, in terms of open LLMs, so my go-to is Llama for complex tasks, Llama 70 billion model, and Quen. So right now we are using, uh, I think we are using a smaller Quen model. We are using a Quen 2.5 coder 32 billion instruct, right? If you only want to stick with open source models, I would suggest to go with Llama 70 billion or Quen larger models. Those might lead to better answers if the problem is difficult. If the problem is challenging, you cannot always stick with this simpler Quen model, right? You have to use bigger LLMs for that with larger number of parameters. Okay, so this is where we have visualized the manager agent. And now let's see. I'm going to do manager agent dot run, but the task which I'm giving the manager agent is as follows. I'm asking it to find all Harry Potter filming locations in the world, calculate time to transfer. We are in Pune. This we already saw. Also give me some cricket stadium. This also we saw. You need at least 6 points in total. Represent this as a spatial map of the world with the locations represented as scatter points with a color that depends on the travel time, and save it to savedmap.png. And then I also give some instructions with respect to how plotting needs to be done. So if you see, plotting is done through these following commands, right? Where we have px using plotly. So here it's plotly.express. You can use matplotlib, pyplot, anything. But I've here given an example to the agent how to plot. So you can think of this as few shot prompting. Okay, so let's run this together. All of us might get different answers over here. For some of us, the code will not work in the first attempt because here it's quite complex. Huge number of things need to be done together. It's not simple at all. This framework, which is now tied in together, there are multiple agents which are doing different things. We are going to Google search, we are scraping web pages, we are ranking this according to travel time. Then we are doing plotting. Many things need to be done. So let's run this now. So I'm going to run manager agent right now, and let's see how this is actually functioning. Okay, so it might usually take many steps also. This is not a quick run by any means. So let's see actually the different steps. So I'm right now. So this is the plan which the agent has proposed on its own. Here are the facts I know and the plan of actions I will follow. Facts given in the task are this. Facts to look up specific coordinates of all Harry Potter locations. So the agent has kind of made a plan. This is very difficult to do, right? This is exactly how humans generally plan. First, I will find film databases. I will find the locations and coordinates. Then I will find the travel time. Then I will use the web agents to look up and gather a list of filming locations, compile the filming locations, and then finally I'll create a map. This is the plan of the agent right now, and it's executing the different steps. And here itself, the agent itself will realize the mistakes which it is making in the code and will try to correct it eventually. Error in generating model output. Um, yeah, so I've seen that this also fails if the Hugging Face, let's say API limit is exceeded, but still the agent is able to follow through and give some answers eventually. There is a question related to production. When we deploy this to production, won't the LLMs be trained on client data? Won't that be a problem? How to solve this? As we want to monetize this by the end of the bootcamp. Yeah, so all the techniques which I'm teaching you right now, eventually when we are going to work on the techniques for the client, we have to make private API calls, which means the LLM will be hosted on the client server. And then you will need, so usually big companies have access to Azure, AWS, GCP, etc., right? So what we can do is that instead of making API calls to OpenAI right now, the way we are doing, the API calls will be made to their private LLMs. The rest of the things will entirely stay the same. You will have a LangFuse dashboard, which you can share with your client to show the different evaluations. The code will remain the same. It's just that the calls which you are making will be made to private LLMs, which is hosted on the enterprise server. So the data will stay within the enterprise. But all the logic which I'm showing right now, that usually stays the same. So here you see I'm at step number 7, step number 8, step number 9, and finally I'm at step number 10. But let me see whether the map is actually generated or not towards the end. Step 12. I think I've finished 15 steps over here. And I can then run the final thing, which is manager agent. Yeah, so my map has been generated over here. If you scroll in, if you zoom into this, these are the 6 places which the LLM has actually identified. So let me try to zoom in over here. So the 6 places seem to be Alnwick Castle, Emirates Riverside, Edgbaston Cricket Ground, Bristol County, etc. So these are what are plotted on the map. But I still want to see what happened during my execution run. So let me go to my LangFuse now and let me see what's going on. So I go to my LangFuse. Um, and again I refresh this to see my new traces. So this is my latest trace which is obtained at this. So it has 52. Yeah, it has 52 observation level. So if I click on this, uh, yeah, so here is the plot final code which the agent executed. It got these locations, it got the coordinates, and then it tried to use the px.scatter map box. That's why we got the ultimate the plot which I showed you on the Google Colab interface. But if you see on the left hand side, there are places where we encountered errors, right? And there are places where we did not encounter errors. So what you can do through LangFuse is that you can actually see what happened over here. So here, wherever there is an error, you can actually inspect the error, right? There is an error, that error in generating model output 422 client error. So together.ai is giving me an error over here because maximum number of new tokens is probably not specified, or it's specified but it's exceeding maximum number of tokens. So then what we can do is that this error, we can try to fix this error iteratively. And now fixing errors is easy because of access to LLM tools. But without using LangFuse, it's very difficult to know where exactly the errors are. So I know one error which is here. I will try to then fix it by going to code. Then I see the second error which is here. And I currently don't know why this error is there, but I can try to understand, right? Again, this error comes to is probably because of Together again, because of Together's API. So I might again try to switch my API to some other provider, maybe any other inference client provider which Hugging Face provides. And actually, if I go to all errors, I'll eventually see that they are the same errors. They are usually the Together API errors which we see over here. Then simply you can change the inference client provider. And if this starts to happen again and again, Hugging Face also has the Pro plan, which is I think $5 a month or something, where such errors might not be there. But then what I'll do, so if you're building such a product for your client eventually, right, these errors are likely to come all the time. You should know framework about how to fix these errors. So now these errors are there, right? You should have a evaluation platform like LangFuse, get these errors, make a note of it, and try solving them one by one. In this case, it will be quite easy to solve this because it's just an inference provider. So I'll just change the inference provider and solve it. I'll also see any other places where there is an error. So the simple tool seems to be working fine. Towards the end, there might be a plotting tool which is used. So OpenAI server model.generate. Here is where, yeah, here is where the plotly.express is used by our agent. So here you see we have significantly more number of loops, the thought action observation framework compared to the agents which we have seen in the previous lecture. How many of you have actually got this plot towards the end? Can you, if you have got it, can you paste the screenshot in the chat? I just want to see the different results which all of us have obtained. Because in some cases you might get an error. In that case, you will need to run it once more. But if you have got the final plot, please paste it in the chat so that we can see how many of you have actually reached the end and got that plot. And while you have got that plot, please also check LangFuse where you will see, yeah. So Amit, if you actually zoom in to that plot, you will see the different locations. So currently it looks like there are multiple text-based entries, right? If you zoom into there, you will see the multiple locations which have been plotted by the agent. So in today's 1 hour lecture, we did a task which is very hard even for humans to do. Going to different web pages, scouting for filming locations, then scouting for cricket stadiums, and on top of that, plotting it all on a map. It's a set of actions which need planning. So yeah, now I can see Amit's plot clearly. Pratik is saying I run multiple times but still get an error. Uh, yeah, so error, students who are getting an error, I think it might be because of either if one of the API keys is getting exhausted, or you might just need to restart once more. And if you are getting an error, it's a good time for you to explore LangFuse and see why you are getting an error. So we are on the free plan, right? That's why these issues are there. But if you upgrade to the Hugging Face Pro plan, I think, let's see, someone mentioned in the chat that it's $9 or something. If you're doing this for an enterprise, you should by default have this Pro subscription. Yeah, I think Pro is $9 per month, where we have 20 times more credit across all the inference providers, which is missing right now for us. So then things will be much faster for all of you, believe me, because otherwise there will be an error. So now Pratik has got it. So Pratik, did you just rerun this once more? Yeah, I think the error is because of the inference client provider itself, for those who are getting the error. Okay. And we can also see the cost here, by the way. Since I'm using OpenAI here, right? So the cost is $0.8, $0.79, etc. Now what I want to do is I want to actually show you how evaluation can be set up in LangFuse so that all of you can do that. Until now, we have observed how the agent is working through LangFuse. We have not yet looked at evaluation. So let's see how to do that. To do that, you will go to the left-hand side, click on evaluation and click on LLM as a judge. So I here already have an evaluation. So let me just remove that. So I've removed this right now. What you can do is that you need to set up. So first, if all of you have not set up a default model, you will need to set up a default model over here. And what it means setting up a default model is just that you will need to provide your OpenAI credentials and you can set up your default model. The reason we need OpenAI credentials is because we are using LLM as a judge, right? Which means we are using a bigger language model to evaluate the output of our responses. So that naturally needs access to OpenAI API key. So you can set up the default model over here. You will just need to enter the API key. That's it. And then you will be able to set this up. So here I have set it up. You can call it anything. I have called it LangFuse OpenAI and the model I have used is GPT 4.1. Okay, then what you can do once you have set up the default model, you can click on Setup Evaluator. And when you click on Setup Evaluator, you can select which metrics do you want to set up. So for now, I'm just going to maybe click on helpfulness. So all of these metrics, so some metrics are given by LangFuse themselves. Then there is another set of metrics. Does anyone recall this symbol, by the way? Are you aware what this symbol means? It's actually a package which is called as Ragas. It's a very famous GitHub repository for evaluating language models. And LangFuse has actually partnered with them. So they provide their evaluation metrics also over here. You can select whichever evaluation metric you want based on the problem which you are solving. So what I'm going to do is that I'm just going to select on helpfulness for now. I'm going to select helpfulness, so it will show tick over here. And I will also, let's say, I will, I think you can only select one in this free plan over here. So let me click on helpfulness here. And then I am going to click on use selected evaluator. So this is good, use selected evaluator. I am going to run it on new traces and on existing traces also. So there are 25 traces, right? So it will take some time to run. Um, then what we can do, so here you can see what helpfulness actually means. Evaluate the helpfulness of a generation. A generation can be considered helpful if it not only effectively answers the user's query, but also does so in a friendly and engaging manner. So this prompt will be given to our language model now, which we have chosen as our default model here in evaluation. And this language model will then evaluate the answers which have been given to us through LangFuse itself. And this thing by step is again to introduce chain of thought prompting, right? So here, for example, my input can be this find all Harry Potter examples in the world, and generation is this again showing this task. So in this case, actually, it's not a very helpful metric, but let's just go with it because later you can choose any metric and change what you have in the query, right? So here you can actually change which object you have in the generation. So if the generation has span, or if the generation has just generation over here, or if the generation has event, it's different things. Uh, all right. So then this metric is created. So what I will do now is that I'll click on execute on the bottom right. So this metric is created, and now what it will do is that if I click on view, it will actually it will start to evaluate all of my 25 queries. So I'm evaluating on new traces and existing traces, right? Similarly, last time I had this hallucination metric, which I deactivated just before running our current metric. And here, see, this is how it should ultimately look like when you start your evaluation. So when the evaluation is finished, you will get some comment about your uh, um, the evaluation comment, and then you can click on the trace and you can see the evaluation over here and the reason why that particular score is given. So in LangFuse, it's pretty simple to set up an evaluation framework. So what we do at our company is that if an enterprise gives us any project to be performed, and if it's an agentic project, we subscribe to LangFuse, which you should definitely do if you're in an enterprise, and we share the dashboard with them. So in that same dashboard, they can see the tests which we are running, and we can also see the tests which we are running. And we have evaluation metrics such as what I just showed you. First, we discuss the evaluation metrics with the client. Um, we finalize on these evaluation metrics, and then everything is automated after that point. Once you finalize the evaluation metrics, they all appear in the logs. So right now, everything is being evaluated for this helpfulness metric which we have set up. So whenever every new test is done, an automatic evaluation appears here. Why is it automatic? Because we have set up this thing on new traces as well as existing traces. So whenever a new trace comes in, automatic evaluation is performed on that trace. So this is how observability and evaluation can be integrated with every agentic framework which you deploy. Right now, we deployed a multi-agent framework, right? And I showed you how to debug errors, how to see errors, and then also how to evaluate different things. Now, when you actually start evaluation, you will need a thorough knowledge of the different metrics, right? All of these metrics mean different things. And you can see here what they actually mean. And you should only use those metrics which make sense for your particular question. How many of you were able to set up this evaluation? Can you type yes in the chat if you were able to set up this evaluation? Because there were actually a couple of things which are involved, especially setting up a default model. That was a process which I did not show, but you just need to enter your API key over here. Okay, it's good to see that at least 4 to 5 people in this call are able to set up the evaluation framework right now itself. For those who are unable to set it up right now, anyway, the recording will be available to all of you. So you can set it up later as well. The last thing which I want to cover today is browser agents. And we are going to cover this a bit quickly because we are out of time. I'll first explain what do browser agents actually mean. So we saw one type of agent today, which is multi-agent framework, right? Browser agent is something like operator, which OpenAI introduced, that automatically goes through websites, automatically scrapes through whatever is present on different websites and gives us answers, right? So Hugging Face actually has a very good um, code for this. So I'm going to share this code in the chat, which all of you can execute after the class. What you need to do is that you just need to uh, copy this code in VS Code and run this through Python. So this is webbrowser.py, right? I'll first explain what is going on in this code. In this code, we are defining an agent. So that's the same thing. So I'll take it from here. We are defining a code agent. It's just that the agent does some very cool things. The agent can open websites on its own. The agent can go back to web pages. The agent can close pop-ups. The agent can go to a web page, control F, search for a specified item, etc. So if I tell the agent to go through different web pages, look at how Harry Potter looks like, and tell me how Harry Potter looks like, what you will see is that the agent itself goes to different web pages, clicks on close window if it retrieves information from there. The agent can also take a screenshot. So these are the tools, right? And what are the tools here? Go back, close, pop-up, search, item, etc. So you can see that the rest of the code is essentially the different tools which we are passing to the agent. So search control F is essentially going to a web page, doing control F. So this is not a search tool actually. This is something different. This is a bit more autonomous. It actually opens websites. It can click on different websites. It can move back to a different website all in front of us. So it will open the browser in front of us as we are speaking, and it will do all that search. So let me show you actually this. That's probably the best way to make you realize this. So I'm going to share my entire screen right now. Can all of you see my VS Code right now? Uh, you are able to see, right? Okay, so what I've done is that the code which I just showed you, I have just downloaded this in my VS Code. And what I have asked is that please search for images of Harry Potter and generate a detailed visual description based on those images. Additionally, navigate to Wikipedia to gather key details. So now let me run this code. So here what I'm doing is that I'm just doing Python browser agent.py. Um, and now you'll see here that automatically a web page has been opened. I hope you can see this web page right now. And now I'm not doing anything on this web page. The agent will automatically go through. Yeah, see the search now. I did not go to Pixabay right now. The agent went to Pixabay on its own to search images, and then the agent automatically went to Wikipedia because I had mentioned to go to Wikipedia. And the agent is now scrolling through this Wikipedia article as we are having this lecture, and the agent is forming its own opinions right now. It can take screenshots also. So for example, if you um, yeah, here, so agent went through these different websites and it got all the information it needed, and ultimately the answer which we see here is that this is the final answer, right? Harry Potter is depicted as a young wizard with round glasses, unkempt black hair, bright green eyes. He has a distinct lightning-shaped scar on his forehead. So essentially, what we did right now is an autonomous browser agent. A browser agent is an agent which can access live. It can go through different web pages. It can search through different web pages. It can take screenshots. The way we did that is using something called Helium. So I don't want to go into too many details of this. And another thing is also Selenium. How many of you have heard of Selenium WebDriver? So many of you might have heard of Selenium WebDriver, right? It essentially helps you automate. It's a web framework basically which helps you automate going through different browser windows, etc. That's the main framework which we have used, and rest of the functions have been written in a custom manner. So if you see, we are using Selenium, and using Selenium, the other things we are doing is what to do when you go for on a particular web page. You can do Control F search for. So when the agent goes to a website, it can Control F search for Harry Potter, get that information, add it into its memory, and move forward. So now, if you think about it, the operator which was introduced by OpenAI, when all of us look at this demo, it seems like this looks like rocket science. So what have they really introduced? But this is nothing but a browser agent. What they introduced here is the browser agent which can automatically go through different web pages on its own. So what I showed you right now is a simple version of the browser agent, but ultimately it's the same thing but with more number of features what OpenAI introduced. Essentially, once you have an agent, it's very easy to introduce browser tools to that agent. So it can go through different web pages, scrape information, close tabs, click Control F, etc. And here I only showed two to three different functionalities, right? Close pop-ups is one, then search Control F. You can add 5 to 10 different functionalities like this. You can even take help of any LLM like ChatGPT to help you add more functionalities. So this link, I will share it once more in the chat. All you can do after this class is that you can just download this link and then type Python 3 or whatever. Let me type it in the chat, Python or your code name.py. And you will need to just define the OpenAI API key in your VS Code interface. So in your VS Code, you will just need to also write export OpenAI API key equal to this thing. Now there are multiple ways you can take this to the next level. So as someone has asked, how can browser handle bot detection prevention like Cloudflare? It's very difficult to pass that. It's very, very difficult to pass through websites like which have been protected through Cloudflare and other sophisticated detection systems. But at least for now, there are many websites through which, like Wikipedia, many are there through which you can build sophisticated browser agents. All right, so this brings us to the end of today's lecture where we looked at a bit more complicated things. We looked at multi-agentic framework and we also looked at browser agents, which are both different things, but both can be done through the small agents library. In multi-agent frameworks, we started by looking at how to make a custom tool. That's one of the major learnings from today's class. We made a custom tool like this and we added it to the agent. We added this custom tool to our agent, and then we saw how the agent gives us responses for the nearest Harry Potter locations, nearest cricket stadiums. And then we also use LangFuse to inspect our agent. This was fine, but then we realized that, okay, why don't we have multiple agents instead of a single agent? So now if I also want to plot, if I add all tools within one agent, the memory of that agent will get overloaded. That's not good. The answers, then the agent will start to hallucinate. I'll expect latency, my cost, my tokens will increase. So it's actually better to compartmentalize and have different agents where each agent handles a specific task separately. So I have a manager agent now who has a web agent which the manager is managing, and their memories are separated. So every agent has a specific task to do with separate memories. So memory overloading does not happen. Hallucination reduces. That's two major reasons why multi-agents frameworks are used. They help reduce cost and latency because they help reduce token count by separating memories. And each agent is also more focused on its core task. And as a result, it's more performant. This is multi-agent. And then we actually implemented a multi-agent framework in Python, where we split the task between two agents and we ask the manager agent to also plot the locations for us on a map. Now, this took us a huge number of steps. For me, it was 15 steps. And we saw that on LangFuse as well. And we saw the map over here. We saw the locations on a map. On top of that, today we learned a very important concept of evaluation. This is extremely important, especially if you are working on solving industry level problems. If you're working on industry, um, okay, understanding fundamentals and running the code is one thing, but ultimately evaluation is the most important thing. And not many people talk about evaluation. Everyone talks about new cool frameworks, etc. But the reason I wanted to teach you today what evaluation is just for the same purpose that it's very easy to set up evaluation metrics and probably also one of the most important things. You just need to create a default model over here. Once you create a default model, you can set up an evaluation metric over here based on your problem. This is probably the most important thing. You need to understand what each of these metrics mean. They are very easy English terms, but you need to relate it to your specific problem. Uh, and then finally, we saw browser agents towards the end. So I covered this a bit quickly, but I have put a Python code in chat, which you can run and then you'll be able to simulate what I showed you today. So this is essentially like taking a look behind the scenes of what ChatGPT did with their operator. In next lecture, which will be happening tomorrow, so the next lecture will be tomorrow and that will be held at 2 p.m. IST. So that will be our seventh lecture. And in next lecture, we are going to look at Agentic RAG. So we are going to look at Agentic RAG in the next lecture using LlamaIndex. So we are going to move our focus from small agents to LlamaIndex. We are going to understand what is RAG, what's the difference between RAG and Agentic RAG. And then we are going to implement an Agentic RAG project in Google Colab. And I'll share it with you in tomorrow's lecture. So thanks a lot everyone for attending. We went overtime today. But I could see that many of you stayed towards the end. I was unable to finish today's lecture in 1 hour, but it was very difficult to cover everything in 60 minutes. So it took time. Later lectures also might go on for a bit longer because we are going to cover LlamaIndex, then we are going to cover LangGraph. Those are extremely important tools and I don't want to rush it. So tomorrow's lecture also might be a bit longer. Um, so I'll look forward to seeing you in tomorrow's lecture. Today, I don't know what issue happened with the passcode because I usually create the meeting with no passcode. I'll check it out because I did not have a passcode. But if passcode is asked, you can type 123456 as some people entered today by typing this passcode. Okay, thanks everyone. I look forward to seeing you tomorrow. Bye. Okay, so let's get started with today's lecture. Welcome everyone. Today is day 7 of the AI Agents Bootcamp. And today we are going to cover the very important topic of what is known as Agentic RAG. Now, these two look like terms which might not make sense when they are merged together. So my main aim today is to explain this concept of Agentic RAG and also explain first of all what is this RAG, if in case any one of you are not aware. We'll see the difference of RAG versus Agentic RAG, and we'll do this through hands-on coding examples. The framework which we are going to be using to understand the difference between RAG and Agentic RAG is a framework which is known as LlamaIndex. So I'll just highlight this over here. This is the main framework which we are going to be utilizing today, LlamaIndex. Before we get started with with the current lecture, as always, let me do a revision of what we have seen in the previous two lectures. So in the previous two lectures, we have looked at small agents, which is a minimalistic AI agent coding library. In day 5 of the bootcamp, we looked at the difference between tool calling agent versus code agent, and we looked at two examples. We made a simple agent using small agents, using both code, code coding agents as well as tool calling agents. We explored the similarities and differences between both of them. And I will keep returning to this figure at multiple points in this bootcamp because this is the main schematic which helps us to understand how the memory of an agent goes on accumulating with time, how the agent interacts with the external environment, and how it uses the thought action observation loop for making plans and to take decisions. And this was the lecture when I introduced LangFuse for observability mostly. We did not look at evaluations in this lecture. However, in the previous lecture, which is day 6 of the bootcamp, we looked at evaluation using LangFuse, and the topic which we covered was multi-agent systems. So this is when we looked at essentially 7 different things. Why do we use a multi-agent system? We did a case study where we wanted to know all the locations where Harry Potter was filmed. And we first started with a single agent with many tools, and we got decent results. But soon we explored that single agents have issues such as long context, high token usage, and complex reasoning is not really reasoning over multiple tasks is not really handled well by one agent. That's why we thought of a better plan that instead of having just one agent, why not we divide the tasks among two agents? So then we had this manager agent, and the manager agent managed our web agent. And the manager agent also has access to tools. So we saw that if we construct a multi-agent framework this way, memory is divided between agents. So we not only get good answers, but token usage is also reduced, and we also end up saving costs. That's why multi-agentic frameworks have become so popular. This is how we constructed our multi-agent framework in the previous lecture. And this was the final result which we got, plotting all the locations on a map. In the last lecture, I also showed you different evaluation metrics using LangFuse. We built an evaluation dashboard and we looked at different metrics such as hallucinations, trustworthiness, etc. And at the end of the last lecture, I encouraged you to really be familiar with all of these evaluation metrics. They are simple English metrics, but sometimes it can get confusing about what's the difference between these two. If you are integrating a multi-agent system into an industrial project, you will need to maintain an evaluation dashboard and share it with your client. So that's going to be one of the most important steps. And together with the client, you need to decide what are the metrics which make the most sense in our project. Is it how much hallucinations do we have? So for example, if it's a chatbot, which is which is going to be deployed in critical situations, hallucinations is an important metric which you need to trust, which you need to incorporate. If it's, for example, a system which you are implementing in the healthcare domain, trustworthiness is also quite important. And then finally, we looked at browser agent. Simple way to think about browser agent is just AI which has internet superpowers, which means it can automatically go to different web pages, go back, take screenshots, expand or minimize or close pop-up windows. It can do all of these things. So this is similar to the OpenAI operator tool. All of this we covered in the previous lecture and I have uploaded the recording on the dashboard. So we have actually covered a lot of material in yesterday's class. So I really encourage all of you to revise this in case you have not. And the coding files which I'm providing to all of you, you can use those as templates to actually build projects of your own. Essentially, I showed you multi-agent frameworks for one particular example, right? You can take the similar code and actually adapt it to any example or um, any task which you need. These Substack articles are shared with people who are enrolled in the pro registration plan. Now we are done with small agents, and today we are going to start with a new tool which is called as LlamaIndex. So first, let me try to understand how many of you have used LlamaIndex before. Can you mention in the chat if you have or have not? Both are fine. But if you have experimented with LlamaIndex before, If you have not, it's fine. Today can be the first day where you learn about it. If you have explored with it, it can be a good revision for you. So let me just share this link with all of you. So the evolution of LlamaIndex is quite interesting because initially LlamaIndex was specifically used for building RAG-based applications, which we are going to discuss today. RAG essentially stands for Retrieval Augmented Generation. And then now LlamaIndex has adopted or advanced, augmented itself to even deal with AI agents. The functionalities which these different packages provide are very similar to each other. So Smolagents also has functionalities which LlamaIndex provides. But my main aim in this workshop is to get all of you equipped with all of these major packages which have been released currently. We are going to cover RAG in today's lecture, so don't worry about that. Our main application is going to be RAG itself. But before that, I want to do a quick introduction on LlamaIndex itself. So LlamaIndex is an awesome tool for something which is known as creating a vector index, and we are going to see even this today. And using Llama agents, we can even build, using LlamaIndex, we can even build agents. We are going to build agents today using this framework. And in my understanding, what makes LlamaIndex special is that it's simple, similar to small index. It provides a simple workflow system. Document parsing is easy using something called as llama parse, and document parsing will be needed when we are using or when we learn about retrieval augmented generation. But some of the most important things which make LlamaIndex special is that they have something which is called as Llama Hub. And I'll share the link of Llama Hub also with all of you. So I've shared this with you. It is that one place where you can find, let's say if you're building an agent, you can very easily find the different tools which are provided. All of these are tools which are uploaded to Llama Hub by users. So in that sense, it's an open source system where you can get all the tools in one place. And the number of these tools are much more than the tools offered by small agent. That's one of the huge advantages of LlamaIndex. It's this Llama Hub. Today we are going to use tools from Llama Hub. So I'm going to show you how to use tools from this place. So whatever I show you right now, later you can use it to take or use any of the tools which you see over here. By the way, today we are going to use a tool which is called as Brave Search. And we are also going to use the archive, essentially the archive tool. I'll come to that when I want to explain, yeah, this, not this, but the archive tool spec. So yeah, this one over here. We are going to use this one also. Uh, okay, so with that brief introduction, let's get started. The best way for you to actually understand how LlamaIndex work is to directly start coding with it. So as I said, today, the main example which we are going to take is we are going to build an agentic RAG system in LlamaIndex. But before jumping to RAG, before jumping to agentic RAG, first we are going to cover what is RAG itself. Because unless you understand RAG, it is impossible to understand agentic RAG. How many of you have heard this terminology RAG before, or have implemented some application related to RAG? Yeah, as you can see in the chat, almost everyone has heard of this terminology. And the reason is because this is one technique which is extremely useful for building chatbots. And not just chatbots, this is a technique which is extremely useful for reducing hallucinations uh, when we use large language models. So the main idea of a retrieval augmented generation system is this. Let's say you have a document like this. By the way, this is the main document which we are going to be using today. So what I'm going to do now is that I'm going to download this document, and I am going to share a link with all of you. Or what I can do rather is I'll just upload this document onto our chat. Yeah, I have uploaded, it's around a 6 MB document, and I've uploaded this on the chat. All of you can take a look at this document and actually download it and open it on your laptop right now. And the examples, all the examples which we are building is with respect to this document today. So it's a document called State of AI, and it's about how organizations are rewiring to capture value. It involves a lot of text. It involves different charts about risk, data governance. Then, for example, they have some description of how generative AI is used in organizations, etc., etc. There's lots of information in this document, and it's a report regarding the state of artificial intelligence, which is prepared by McKinsey. I hope all of you have downloaded this document and opened this on your device. And again, I highly encourage you to watch these or attend these lectures using a laptop. Now, let's say I have this document, right, which is state of AI. And what I do is I ask a question to the LLM. I ask a question, who is this person called Yarina Lee? Now I know that within this document there is a reference to this person. This is the spelling should be I know that within this document there is a reference to this person, right? Who is Yarina Lee? It's clearly mentioned in the document. So if you um, control F on this document, you'll see that Yarina Lee is mentioned 3 times in the document, and this is a senior partner and McKinsey Global Institute director. Now, uh, let's say I've asked, oh, actually, yeah, so let me change this again. Okay, so let's say I've asked this question to the language model now. There are 2 ways for the language model to answer. The first way is this: when the language model receives this question, it loads this entire document within the context window. It loads this entire document in the context window, and then it tries to answer based on the document which is loaded within the context window. Now, this kind of a system works very well for, let's say, if you have only one document or two document, right? But if you have 50 or 60 documents, if you have 50 or 60 documents, and if I ask this similar question, it becomes very difficult to load all the documents within the context window model. Why does it become difficult? Because as we have seen, the context window is limited. And although new models do have larger and larger and larger context windows, for example, Gemini Flash models recently have context windows of about a million tokens. But still, as you feed and load more and more documents within the context of a language model, it really gets difficult for the model to fit in all this information at once. Similar to humans, right? If we are bombarded with too much information at once, and then if I want to answer this question, it's basically like finding a needle in a haystack. It becomes very difficult to really pinpoint where that actual information is. And to solve this question, that's when the technique of retrieval That's when the technique of retrieval augmented generation was introduced. The main idea of RAG is actually pretty simple. So you have an LLM, right? And the LLM receives a prompt. The prompt is this. That's fine. But now what we are going to do is that, let's say, uh, let's say this is my document, right? Yeah. And that document consists of 26 pages. So I'm dividing all the pages over here. Page number 1, page number 2, page number 3, dot 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 up to page number 26. Then what I'm going to do is that I'm going to take the text on each page and convert it into a high dimensional vector. Let's say I convert each document into a 300 dimensional vector. So now I have 26 documents and I have 300 dimensional vectors for each of these 26 documents. So what do you mean converting documents into vectors? There is this technique called word embedding, where essentially we can represent information contained within text as high dimensional vectors. So you can think of it as follows. This vector now contains compressed information of whatever was present on this particular page. This, this vector contains information of whatever was present on this particular page. etc. So these vectors are not random vectors. They carry meaning of what is present in the document itself. The way these vectors are constructed, that's another topic on its own, because there are some amazing techniques like word2vec, etc., which demonstrated that meaning can be captured within vectors. And I believe that's one of the fundamental advancements which led to language model, the transformer architecture. Essentially, the transformer architecture has word embeddings at the start of it. And the word embeddings is the idea that text can effectively be captured into vectors, right? So you might be thinking, what do we do with these vectors and how is it related to LLM? So these are 26 vectors, and what I'm going to do is that I'm also going to convert my prompt into a vector. I'm going to convert my prompt into a 300 dimensional vector as well. And then what I'm going to do is that I'm going to see which one of these 26 vectors is actually closer to my prompt. And when I say closer, the notion of distance is going to be, in this case, we can either have Euclidean distance or we can have a cosine similarity. So two vectors are said to be similar to each other if the dot product is higher. Two vectors whose dot product is very low, or if it's negative, those are not similar to each other. So what I'm going to do is that I'm going to look at these 26 vectors. I'm going to take a dot product with this prompt vector, and let's say I'm going to retrieve the top three documents. So let's say if this is one, this is two, and let's say this is three. I'm going to retrieve the top three documents which have the highest similarity with the prompt. And then what I'm going to do, this is the interesting part. These three documents, these top three documents, which is document 1, document 2, and document 26, I'm going to pass these documents along with the prompt to the language model, and then I'm going to produce an answer. So along with the prompt, I now have passed very specific information in the context. I'm not passing all the documents randomly in the context. I'm only passing the retrieved documents. These three documents are called as retrieved documents. So if the earlier process of generation or earlier process of producing the text is just called generation, where everything is loaded in the context window, now this new process is called as retrieval augmented generation, because we are taking the retrieved documents and we are augmenting the prompt with these retrieved documents, and then we are generating the answer. That's why it's called RAG, or retrieval augmented generation. This is also sometimes called as grounded generation. And the reason it's called grounded generation is because now, since I'm passing the relevant documents, the answer will be more grounded in reality. And because of this grounded generation, hallucinations will be reduced. That's the entire idea of retrieval augmented generation. We we take the prompt, we convert it into a vector embedding, we take our document store, um, and we convert all the documents in that document store into vector embeddings. And then what we are going to do is we are going to look at which vector embeddings in the document store are more aligned with my prompt, and we are going to only pass those documents along with the prompt. That will lead to specific or grounded generation. It will prevent hallucinations as well. Um, and if you have some doubts, those will get clarified about as we go along with this lecture. We are going to see the vector embeddings in a lot of detail in the code. But for now, it's useful if you understand this simple schematic. And a beautiful schematic of this is created by Avi Chawla. And this is a wonderful schematic because it really explains the entire RAG process, which I just explained in a very simple manner. But if you get confused by the arrows, don't worry about it. I'll explain it step by step. So what happens is that, see, here is the LLM, right? And we have the prompt to the LLM. This much is fine. But along with the prompt, you can see that there are some additional documents. So along with the prompt, there are some additional documents which are being passed to our query. Then what are these documents? These documents are essentially, you take your original query and you are converting it into a vector embedding. You take your documents and you're converting it into a vector embedding. Then you're doing something called as similarity search, which means you are taking your documents and the vectors and looking for those vectors which are more aligned with the prompt vector. That similarity search will give you a list of similar documents which you augment with the query, and that gives you your modified prompt. This modified prompt is passed to the language model, and then it gives us the response. Now the question is that if you have these large number of vectors, let's say if you have 200 documents or 300 documents, and you have huge number of vectors, where do you store these vectors? The place where you store the vectors is called as vector database. And if the vector database is tens of thousands of vectors, it actually becomes difficult to do the similarity search by directly taking dot products. And that's why there are complex, not complex, I should say, but there are amazing libraries which have been developed to make this similarity search easy. How many of you have heard of Facebook AI similarity search? Facebook or Meta has actually contributed to some amazing research, and I have myself tried this in one industry project where we did not use FAISS in one case. We are directly finding the dot product for all the vectors, and that took, let's say, 2 seconds. But if we use FAISS, it took 2 milliseconds, which means that same similarity search is now done 1,000 times faster. So when I explained that you have to create these vectors, that's actually done in a very structured manner. We maintain a vector database. You can think of the vector database as collection of these individual vectors. And then when you want to do the similarity search, we can use algorithms like FAISS to very easily find the documents which are more similar. By the way, if anyone is interested how FAISS works, they use some amazing ML clustering techniques under the hood. You can go and search more about this if you're really interested in how FAIS speeds up the retrieval process or speeds up the process of finding similar vectors. So this is retrieval augmented generation. And if I were to explain the steps now to you, the first step is you load the documents. The second step is you split the documents into chunks. You split the documents into chunks. So what does it mean? Here we had 26 pages, right? Here I'm chunking by every page. That's not necessary. If you want granular information to be captured, you can even chunk by sentences. So one sentence is one vector, another sentence is another vector, etc. So for example, we can go here and say that, let's say this sentence is one vector, this sentence is another vector, this sentence is the third vector, etc. That way granular information will be processed. That's called a chunking strategy. There is a huge amount of theory in this point number 2 as well. You can use a hybrid chunking strategy, etc. But let's not get into that for now. Let's do a simple chunking at the moment, which is splitting page by page. The next step is you have to define the language model, and you also have to define the embedding model. Remember that there are two models now. There is a language model for sure, which will give us the final answer. But here, this place where you go from the document to the vector, you need something which is called as an embedding model. So you have to decide what language model to use and what embedding model to use. And then you have to create a vector index. So vector index, you can think of it as, let's say, you create the vector database, and a vector index will help you go through the database and then select the vectors which are most similar to the prompt. And then you create, or then you ask the query, we retrieve similar chunks from the data. So here we retrieved documents 1, 2, and 26, right? That's what's known as retrieving similar chunks from the data. We append the retrieved chunks to the LLM prompt, and then we generate the answer. These are the steps. And now what we are going to do is that, and okay, some questions are, does RAG work with images? So if you understood the notion of RAG, you will see that it actually works with anything as long as that thing can be parsed. So that's one important terminology here, right, which is called as parsing. Parsing is essentially taking whatever document you have and converting it into text and then subsequently into vectors. So if I have this document, how are you going to read this document and convert it into text? There are parsers which help you do that. Similarly, images can be parsed and converted into embeddings. By the way, if anyone is interested, the best parser which I have used recently and which we use for industrial projects is something called Dockling. I'm not sure if anyone is aware of this or not, but it's an incredible um, it's an incredible tool for parsing any kind of complex document. So here you can see that they provide parsing of PDF, docs, PPT, HTML, and even PNG file, JPEG files, etc. You can see that this repository is very popular because it actually does work quite well. Anyways, I hope all of you have now understood the basics of RAG. Some things which are still there are some doubts which are there. So for example, is it passing the entire document 1, 2, and 6 or specific vector embeddings? So we are only passing specific vector. It depends on the chunk actually. If you are chunking page wise, that entire chunk is passed. But if you are chunking sentence wise, those sentences will be passed. And when I say sentences will be passed or chunks would be passed, ultimately the LLM only cares about numerical values, right? So ultimately only embeddings will be passed really. Uh, so this is about RAG. We are going to now code this. I don't want to just explain this theoretically to all of you. We want to see the code in practice. So, okay, can you please explain the diagram once? Yeah. So let's do a quick recap here and then we'll go to code. So this diagram, right? If you see this at once, it might be a bit intimidating. So I'll take you through it step by step. What you do is that first you receive a query. That's a user query to the LLM. That's fine. And you have these documents, right? The first step is you have to use an embedding model and convert the document into vectors. Let's say you chunk each page into vectors and you convert the query also using a vector, right? That's embedding model. Then you store all of these vectors of the document into a vector database. You do a similarity search based on the query vector, and then you find the most similar documents to the given query. You append these similar documents to my query, and then that gives me my augmented prompt. So that's why it's called retrieval augmented generation. This augmented prompt is passed to the language model, and then I have my response. So essentially, load documents, split document into chunks, define the LLM embedding model, create vector index, ask the query, retrieve similar chunks, append retrieved chunks to the LLM prompt. So these two steps is where the terminology RAG comes from. This step is retrieval and this is augmented generation. And then finally we generate the answer. Okay, so good question is asked every time do we have to pass documents? Yes, and that's one of the drawback of RAG compared to fine tuning. If you have a fine, let's say you are a company and you want to create something like a corporate brain which answers questions based on your specific company data. There are two approaches to do this. The first approach is you do fine tuning, which means that you take an LLM and you augment the data set with your data and you tune the parameters of the LLM itself. That's fine tuning and that stays fixed. In the RAG, uh, what you have to do is that in RAG, every time, let's say, new data comes in, you have to add that new data to the vector database. You have to store that new data in the vector database, and each time a query is given, you have to uh, make you have to find the similar documents in the vector database. So every single time you have to do this querying to the vector database and retrieving the most similar documents from the vector database. If you have a fine-tuned LLM, this step is not needed because your parameters have been tuned according to the new data already. That's a trade-off between RAG and fine-tuning. Fine-tuning is an intensive process because parameters are changing, but you can just then use that one LLM as your company LLM. In RAG, however, it's a quick process. You just maintain a vector database, but each time you have to do that similarity search and that additional process, that additional computation is involved every single time. Um, Okay, I can see some other questions also in the chat, but now in the interest of time, I want to move to code. So what I'm going to do is that I'm going to share this Google Colab code file with all of you. And first we are going to code a RAG-based system ourselves using LlamaIndex. So take this Google Colab code file and you can open it right now. Already run the first part because that first step takes a bit of time to run. Meanwhile, you need to have some things which are already set up. So for example, here you need to have your OpenAI API key. That's the first thing. So you need to have this thing set up. The second thing which you need is Hugging Face credentials. This is not strictly needed, but it will be good if you have it. So what I'm going to do again is I'm going to run this first part, which is loading libraries. To do the RAG system, you only need to install LlamaIndex actually. All the other things which I have added, I'll explain it to you as we move through different sections of the code file. This second step is where we load the OpenAI API key. And again, the better practice is to load it as a secret key over here. You can add new secret and load the key over here. But I've just shown it here for simplicity. Third step is Hugging Face login. So what you have to do, and I've shown this again and again, you have to go to Hugging Face, you have to go to access tokens over here. You will probably need to enter your password to confirm your identity, create new token, right? And token name, let's say we are doing LlamaIndex, Agentic RAG, and create token. Copy this token and come and paste it over here. Okay, so I'll just wait for some time till everyone has reached this step. Can you mention if you have finished until here? Because package loading takes some time. So we need to go through the rest of the code together. So I'm going to wait here for some time. And if you have finished until this step, just let me know on the chat. Package is still loading, right? Um, okay, Gemini API key you won't be able to use in this code. Yeah, so while the packages are still loading, let me actually go ahead and explain what we are going to do. So just remember the steps involved in RAG. The first step is loading the documents and splitting the documents into chunks, right? First two steps. So let's see how this translates into code. What you have to do next is that on the left hand side, I have shared a PDF on chat. You will have to download this PDF and you have to upload it on the left hand side. So for all of you, this should show state.pdf over here. If you are unable to upload this file, the rest of the code will not run because we need this main file as a reference for running all the different code cells today. So just make sure this file is uploaded on the left hand side, and then I'll be able to explain the different steps. The first step is data loading. So what we are going to do is that we are going to use a simple directory reader, which is a parsing functionality directly provided by LlamaIndex. Again, a major advantage of LlamaIndex. Smolagents, I believe, does not provide a file parsing capability like this. So we can directly use a simple directory reader and the input file is state.pdf. And then what we are going to do, we are going to load the documents. After the documents are loaded, we are going to use a splitter, which is a sentence splitter, and the chunk size is going to be 1024. And then we are going to inspect the different nodes. So this is where we are breaking the document into chunks. And each chunk is essentially 1024 tokens. That will be each chunk size, which we have mentioned. And then what you have to do, as I mentioned, you have to define the LLM and you have to define the embedding model. So we are going to use, actually, if you want to use Gemini, you can maybe use Gemini, but you will need to change this thing over here. We are using OpenAI models here. So the LLM which we are going to use is GPT 3.5 Turbo. And the embedding model which we have to use is text embedding model. The next step is that we have to create a vector index because we need to search from, we have to search the vector database and find those vectors similar to the prompt. And then finally create a query engine. So the way you have to create RAG systems in LlamaIndex is through query engine. Query engine is actually quite simple. You can then use the query engine to ask questions essentially. So you can just do query engine.query after you finish the first step. All right, so let's see. You can use any embedding model really. And I see there is a question in the chat about how to determine the chunk size, right? So what I do these days is that in industrial level settings, I use the chunk size to be sentence level. And it actually depends because if you are working with an industry and they have given you code documents and each code is pretty small, then just one code can be one chunk, second code can be second chunk, etc. But if they have given you huge set of documents and every thing is important really, then one page cannot be one chunk. That will be a loss of granularity. So either a paragraph can be a chunk or a sentence can be a chunk. It depends on the data which you have received. There is also something called semantic chunking, by the way, which means that you can essentially organize chunks which have similar meaning into one bucket. And then there is also hybrid chunking. So there are multiple advanced strategies to do chunking, and that should depend on the data which your client has given you. Okay, so once this is done, you can click on run and you will see that loaded 26 documents. And so someone has asked a question in the chat that where do you load the state.pdf? So state.pdf is a document which I uploaded on the chat. Then what you can do is that you can take this document and upload on the left hand side. So can all of you confirm that you have indeed run this code cell and you are seeing this loaded 26 documents over here right now, how I am seeing this? Okay, good. Now we are not going to stop here. We are going to actually inspect the embedding of each of these 26 nodes. So essentially what this 26 document means is that we have converted our document into chunks. We have converted our document into 27 chunks, and each of them will have a vector embedding. So what we can do is that we can actually inspect the vector store. What I've done here is that I have first printed out the number of embeddings, and then I'm inspecting embedding 0, embedding 1, and embedding 2. So you can run this right now, and you can see that there are 27 embeddings. So what we saw on the screen here, right? We saw that these are 1, 2, 3, like this 26 chunks. In the code, we have 27 chunks, and each is a vector of, here I mentioned 300, right? But if you see now, each chunk is of dimension 1536, and I printed the first 10 values of this 1536 dimensional vector. So there are 27 different chunks, and every chunk is a 1536 dimensional vector. Where does this 1536 come from? It's essentially the embedding dimension of text embedding ADA 002. When you change text embedding models, the dimension will also change. For example, you can go to Hugging Face and you can even choose you can choose open source text embedding models on Hugging Face. And I think there is also a leaderboard. Yeah, this MTEB leaderboard is a leaderboard of text embedding models. And here you can see the embedding models which are performing the best. Yeah, see here, these are the embedding models which seem to be performing the best. Here's the accuracy also. All of these are open source models, or many of these are open source rather. You can use any one of these actually. And here you see the number of embedding dimensions: 3072, 4096, 2560, etc. Currently, we are using an embedding model which has the dimension of 1536. That's why the embedding dimension is 1536. So here it's actually, I will not say that the higher is better. If the service provider is such that, so for example, take a look at this one, right? This one, it's just a Quen 3, but 1024 dimensional vector, but it sits at the top of the table. That's usually the case with many Quen models. They are pretty small, but they have an amazing performance. So rather than looking at the number of dimensions, I would actually go to this leaderboard and see which models are performing the best and use those models. So don't blindly go with models which are big. For example, there are some models which have a huge number of tokens, like take Jasper, for example, it has 8960 embedding dimensions, etc. So my go-to is that I always start with either 1536 or this text multilingual embedding 002. I have also used this before. That's a 768 dimensional embedding vector, but it leads to good performance. Okay, so yeah, so I hope all of you are now able to understand what are we really doing until this stage. Until this stage, we have broken our document into chunks. We have converted each chunk into 1536 dimensional vector. And now we are actually ready to ask the question, right? So finally, we have to ask some question. And here we have created a query engine, and we will now query the query engine, which means we'll ask a question to the query engine. And here I am asking who is this person. And here you can see Larina E is senior partner and McKinsey Global Institute director. And you can see here that, yeah, senior partner and McKinsey Global Institute director. So it's retrieving the correct answer, but we also need to check whether the vectors which are retrieved are correct or not. So I mentioned here that the retrieved documents match the prompt, right? So let us see whether the retrieved documents actually make sense or not. What you can do is that you can actually, first of all, print response.source nodes. This means that there are two chunks which have been retrieved. And then we can inspect these chunks also. The first chunk is this, which seems to be on the first page. As you can see on the first page, that's the first reference of this person, right? This is the first reference on this of this person. And that's exactly what our first retrieved document indicates. And the second node is here, this. The second node is this, which our RAG system has now retrieved. And this is exactly what we see in the retrieved node text also. So see Larina E, senior partner and McKinsey Global Institute director. Although we remain in the early stages of Gen AI, we are beginning to get a glimpse into the ways. And here also we have the same thing. Although we remain in the early stages of Gen AI, we are beginning to get the glimpse into the ways, etc. So we did this demonstration right now in 15 minutes, right? But there are some incredible things which are happening. This demonstration will never have worked if the parsing was not done correctly. So loading the documents and parsing them into vectors, that's one first major thing. This demonstration will not have worked if our embedding models actually captured the meaning of text. Embedding models have become so much better that we can actually understand what the underlying text means. Because ultimately we are retrieving the documents most closer to the prompt, right? How do we know which documents are closest to the prompt if our embedding model vectors don't capture the meaning? So these vectors capture the semantics. This demo would not have worked if these vectors did not capture the semantics. This demo also would not have worked if the RAG system is actually working. So the retrieved documents are passed to the LLM prompt and then we generate an answer based on that. How many of you have finished reaching this point? Can you just mention yes in the chat if you have finished here? Okay, good. So until now, what we have seen is that the retrieval augmented generation system which we have developed seems to be working. The nodes which have been retrieved seems to be working as well. And we can even see a score. So there is a question on the chat about SQL, right? SQL, if you have SQL database, things get very different because then you don't even need to create embeddings. That can just be a structured RAG really. So the LLM can be used to transcribe your query into an SQL query, and then you just make the SQL request to the database. That's much more easier than unstructured RAG. So what we are dealing right now is unstructured RAG because the data set is completely unstructured, right? There is no structure to this. It's not in the format of a table. It's a completely unstructured document which you are taking and converting it into vector embeddings. So again, I believe we have this paper to thank for whatever we are doing today, because if this word to vec technique was not introduced in 2013, this notion that vectors can capture meaning in meaning of words, that's a very beautiful notion actually. And we should be grateful to these papers which have taken us to this stage. Many times we forget what are the innovations which have brought us to this stage, right? But there are some also cool images associated with this. There is a whole new, so we cover this in detail in our Build LLM from Scratch live course. But essentially, once you understand how vector embeddings work, it's very cool to know this technique that meanings can be captured in mathematical vectors. Okay, so now everything seems to be working in the RAG. So then why do we even have this thing of agentic RAG, right? Can someone, can you try to think? So why do we even look at agentic RAG? Everything seems to be working here. What are the main issues with retrieval augmented generation systems? Just try to think again from first principles. Not so it may not work. Why it may not work? What if the query has multiple questions? Even that can be handled. If the query has multiple questions, you can use a large enough embedding model to convert that into big vector. One time flow, not a loop. One pass might not get us to the goal to work autonomously. Actually, two responses are correct. So one type of response is that there is only one pass, and second type of response is that we don't have access to tools. Let's actually understand what people are saying when they are giving these answers. One of the major issues with RAG is that it only retrieves once and generate once. So RAG system are also called R1s and G1s, which is basically you retrieve the document once and you generate it once. Means that if the retrieved context is not enough, the LLM cannot dynamically search for more information. This is completely opposite to the thought action observation loop which we saw, right? What was the thought action observation loop? The agent thinks, the agent takes an action, observes. If the observation is such that I need to enter my loop again, we keep on going through this cycle until we get the correct answer. But this is not what is happening in the RAG systems. The RAG systems are simply you do the retrieval once and you generate once. But what if that answer is not really correct? Or what if we need to search more? Or what if the LLM needs to plan more? There is really very little provision for doing planning, reasoning. And also one major thing is that there is no interaction with the external world through tools. So during the RAG system, what if I need to search a list of archive papers? Archive is, by the way, this. What if I want to search a list of archive papers and I want to find the papers which have been written by some author? Maybe this same person whom we are seeing right now. I want to find any archive papers written by this. We are not giving any tools to the RAG system currently to be able to do this kind of a task. So that's another bottleneck which we have. So we only retrieve once and generate once, and we cannot use external tools. So overall, we cannot deal well with very complex queries that involve planning, that involve reasoning, that involve multiple retrieval steps. So let's motivate agentic RAG with our same example, right? The Spain trip example which we saw. In this trip, we have to make, let's say, we have to make flight booking, we have to make hotel booking, and we have to also make, let's say, itinerary. And for all of this, let's say we have documents. For all of these, let's say we have documents which someone has given to us for our help. Now, if someone has given these documents to us, we definitely want to use RAG systems, right? Because if these documents are large, we have to use RAG systems. But at the same time, we want to do planning also. We want to do reasoning also. And we do want to interact with external environments to be able to fetch itineraries. So for example, we'll use the RAG system to get relevant information. But if something has changed, so if this document is of 2020, if something has changed in 5 years, I want to be able to search the web also, which means I want to use RAG systems to retrieve relevant information in these documents, but I want to search the web for latest information. So let's say if this is a Spain tour guide which someone has given to me, but that's 2020. So I retrieve some important information about what are best places to visit during winter time, but I want to check whether this is true currently or not. So I need the retrieved information, but I also need access to web search. So I also need access to tools. Not just that, I don't want this to be a system which retrieves once and generate once. I want to also enter the thought action observation loop. So if I want to achieve all of these tasks, then that naturally leads me to something which is called as agentic RAG. So then people started thinking that, okay, if I forget about this RAG part, agents were already working. We did build a multi-agent framework in LangFlow, if you remember. So agents are already working and RAG is also already working. So why don't you combine these two together to lead to something which is called as agentic RAG? But how to actually do this? Because now when we look at agents, we now have a very concrete definition of agents, right? The agent has access. The agent is basically an LLM which has access to tools. It can reason, it can plan, and it can interact with the external environment. It also has memory. So how do I integrate a RAG system within this framework? Can you try to think regarding this question? How do you try to integrate a RAG system within this framework? Anudeep has already given an answer. What about others? And I think many of you are converging to the correct answer. So MCP, we have not yet studied about MCP. So that is not an answer, because we should think from first principles. MCP is something which is a technology in the which we have not studied. So our answer should not be related to that. Our answer should be first principle. So tools, memories. Yeah, so essentially all of you are converging to the correct answer. So the way people figured it out is through a very simple thing. Why don't we use our query engine as one of the tools? So think of it, right? If you don't want to use RAG, you will have the provision to not use the tool. That's up to you. But we give the agent the choice that we tell the agent that your entire framework will remain the same. You will still have tools, you can still reason, you can plan, you can enter the thought action observation loop. But now you have access to one more tool. If you want to use that tool, you can use it. If you don't want to use it, you don't, it's not a compulsion, but you can use the query engine as a tool. That's one major realization of how agentic systems can be augmented to include retrieval augmented generation within the system itself. So then we will have query engine as an added tool. So that's the main idea of RAG. And so that's the main idea of agentic RAG rather. And now the way agentic RAG actually proceeds is that take a look at this flow which I have prepared in detail and try to understand what's the difference between RAG and agentic RAG. I'm going to explain this now. I'm just trying to see the best color choice which I can use. Okay, maybe I'll use this color. So let's say a query is asked. First, the agent will try to think, do I need any more details? And then if the answer is yes, the agent will first look at its tools. Now take a look at these tools. The search engine is a tool, the API is a tool, and the query engine is also a tool over here. And then the agent, if it uses the query engine, it will retrieve the context in a very similar manner to RAG systems, and it will add to the LLM as the prompt. That's same as RAG. Then what happens is that this is a very important step. Please pay attention to this. The agent will try to answer, is the answer relevant to my query or not? And if it's not, it will again enter this loop. So see here a loop has been set up. Here a loop has been set up which was not set up in our RAG system. So this 1, 2, 5, 4, 6, this is a loop. And the agent will continue going through this loop until it is satisfied with the answer. So even if we retrieve the documents, even if we add the documents to the LLM and we get the answer, the agent is still not satisfied. And the agent will first think that is the answer relevant to the query. If it's not, it will go back and it will keep going back until it's satisfied with the retrieved information. At the moment when the LLM becomes satisfied, then it returns the response. So you can think of RAG as just going through this loop, that just one way loop, right? That's RAG. But agentic RAG is going through this. It's again a thought action observation loop. But the nice thing is that the framework stays the same. It's just this one place in the tools where we have added the query engine as a tool. Um, how will it identify if it needs more detail? So that's basically we have instructed. That's the prompting, right, which we do to an agent, which we have seen already. The prompt itself to the agent will be a huge prompt where we have told the agent that enter a thought action observation loop, use these tools which are available to you, and don't come out of the loop until you are satisfied with the answer. So execute the thought action observation framework as many times as you want, execute that. And we have seen that prompt. I've shown that prompt to you in small agents, and I've also shown that prompt to you when we inspected using Hugging Face, if you remember. That prompt will stay the same. The only difference is now in the tools we'll have a query engine. That's one important thing to realize. So now if you take a look at this diagram, so this diagram honestly I don't like too much because it's a bit confusing. So just remember that the change which is happening in agentic RAG is that there is this access to tools. That's the only major change. That's the first change. And the second change is that if the answer is not relevant, we go into this loop. We go into this loop. So two changes are there compared to the RAG. If you take a look at the RAG schematic, it's just one way, 1, 2, 3, 4, 5, 6, 7. There is no loop and there are no tools over here. But if you look at agentic RAG, it's actually two things which are changed, this access to tools. And you see the tools and APIs is one section and vector database is another section over here because that's a separate tool which now the agent has to its disposal. Uh, so how does agent choose between query engine or search tool? We can give that in the prompt. So essentially in the prompt, we can tell the agent when to use the query engine tool. We are going to see that in the code. When we code this agentic RAG system, we are going to see how we tell the agent to use the query engine. So this is much more robust than traditional RAG because it has multiple iterations and we also have access to tools, which is not present in traditional RAG. Please keep this in mind, this schematic, because I believe that as industries are moving towards agent, very few industries are implementing agentic RAG. So agentic RAG is simply a RAG system, or you can think of it as an agentic system, which has access to query engines. That way, thinking of agentic RAG becomes very simple. Just think of agents first. If you have understood agents, just add a query engine to your tools and then execute this same thought action observation loop. Okay, now what we are going to do is that we are going to implement agentic RAG in code. So the steps for implementing agentic RAG are similar to the steps we implemented for RAG, but there are a few changes. So let's see what are the changes. The initial steps actually remain the same. We are going to load the documents. The second step is we are going to split the documents into chunks. The third step is we are going to define the LLM and embedding models. Um, these three steps remain the same. The fourth step is where one slight difference is there. Instead of only creating a vector store index, we are also creating something which is called as summary store index. So if some question about summary is asked, we don't need to then query each and every document in the vector store. We can just take a look at the summary from this summary store index. The next thing is that we have to convert these into engines, right? So we have a vector query engine and we have a summarization query engine. We had a query engine last time also. These query engines will then be converted into tools. We'll see that in the code. Both of these query engines will be converted into tools. So this will be tool number 1 and this will be tool number 2. And both these tools will be added to the agent as the tool. And then we'll define a router query engine, which can essentially take the user query and decide whether it should use a summarization engine or whether it should actually use a vector engine. The difference between vector engine is that this is what we saw in the previous RAG. This I have just added one more thing because if the question is about summary, we don't need to retrieve individual documents. We can just take this route. So these two tools, so router query engine will also be ultimately converted into a tool. These tools which we have, these tools will be added in the toolkit of the agent. And then the rest of the pipeline will remain the same. We'll enter the thought action observation loop. And then the agent will exit that loop once it decides what answer is correct. So take a very closer look at this orchestration over here, right? We are kind of taking the query and we are orchestrating it between either the summary or the vector engine. So now let me take some questions in the chat before we move to code. Can you give an industrial use case example where agentic RAG is being used? So essentially, wherever RAG is used, you have to use agentic RAG. So let's say, for example, a company is building a RAG chatbot. Let's say a company is building a chatbot for customer queries. there are two ways to build this. You can build it as a simple RAG or you can build it as an agentic RAG. Why would you need an agentic RAG here? Because what if in some cases you need access to Stack Overflow API or some other API, like other APIs which are useful for your particular application, which are external, which are in the external environment. And some customer queries are actually difficult to solve. So those might require planning. So if the customer queries are such that they are difficult and they cannot be given in a single answer, you can, instead of doing a simple RAG chatbot, you can make an agentic RAG, which has access to Stack Overflow API and it has access to query engine also, which was the same query engine used in normal chatbot, but it enters the thought action observation loop so that it can provide you with better answers. Of course, the drawback of agentic RAG is that it takes more computational expense. So yeah, I do think that going forward, when people say RAG, it will be by default agentic RAG. Because if you think about it, RAG as a whole, its true value is captured only if it's integrated with external tools, right? So as we are anyways moving towards an agentic world, or rather than rather than thinking that agentic RAG will become default RAG, I think when we talk about agents will by default become agentic RAG. That is probably a better way to think about it because now we are moving into a world where we will have agents everywhere. So, and agents by default, if they come with query engines, then they will become agentic RAG by default. Does MCP help in this orchestration? So MCP is actually something completely different. MCP does help in orchestration. So MCP is like, so if you have tool 1, tool 2, tool 3, tool 4, tool 5, MCP is kind of like a unified interface between all these tools. So it can be thought of as an orchestration layer itself. We are going to learn about MCP, by the way, when we cover the lectures on n8n. But for now, don't be distracted by that. First, we should develop strong foundations. Then understanding MCP will become very easy. Has everyone understood what we are trying to do over here in this agentic RAG and what's the difference between RAG and agentic RAG? That was one of the main takeaways from today's lecture, that okay, conceptually you should understand what is the difference between RAG and agentic RAG. Now, if you have understood this, we are going to run agentic RAG in code. And before doing that, we need to do a couple of things. First, so if you go through the code now, the next thing is agentic RAG, and we can reach this step without using any API calls, but we are going to need access to some API calls. So today I am going to explain a new tool to all of you that is called as Arise. So we are going a bit above time, but it is impossible to actually cover this information within 1 hour. So if you have other commitments, you can feel free to leave the call. But there are some major things which are remaining, which I want to cover now. So I'm now going to share my screen to explain this tool, which is called as Arise. So first of all, let me ask, how many of you have heard about Arise AI? No, right? Okay, so I have told you about one evaluation engine. The evaluation engine which we have learned about currently is called as LangFuse. That's one. But I don't want to only use LangFuse throughout the duration of this bootcamp. I want to expose you to all other tools as well. One more tool which is increasingly becoming popular and which we are going to use for observation and evaluation is called Arise AI. So just click on this Arise AI and click on Get Started on the right hand side. Then what you will need to do is that I agree with Arise terms of service and you can sign up with Google. Uh, so here you can see that I'm signing up with Google right now. Yeah, my sign up is done. And then what we are going to do is that we are going to use Arise Phoenix. So you can then go to phoenix.arise.com. I'll share the link of this also. Once you have created an account on Arise, you can directly click on get started here. Yeah, this might take some time. So now my Phoenix workspace is ready. So I can click on continue. And then what you can do over here is that once you enter this kind of a web page, on the right hand side, you will see APIs. Just go to API over here. Actually, we have to go to API keys. So let me see where the API key is. I just downloaded it. Maybe go on settings on the left hand side. Yeah. These are not the, so there should be a API key section on the left hand side actually over here. Settings. Okay, so I can see that it's under profile, is it? Let me see this actually. Profile. Yeah, over here. So here you can create a new API key, or someone has also mentioned projects, setup telemetry. Okay, so here I cannot see setup telemetry right now, but I do see it in settings and profile. So if you go to settings, let me showcase it once more. Yeah. So in profile, actually, I just saw it right now, but I want to see if it sets some. I remember generating it from a different place actually before. Um, yeah, earlier I saw this API key on the left hand side. That's why I was confused. So here you see now I logged in through a different Gmail account and I see this API key. So I had actually generated my API key using this and I had copied it from here. But anyway, if you found it in your profile section, you can also take it from there. Anyway, just take this uh, take this API key and you will need to paste this API key. If you scroll below, you will need to paste this API key over here. So this, where there is a section of Phoenix API key, you will need to paste your API key over here. That's one thing you will need. Second thing which you will need, and that will come towards the end of this lecture, and this I'm only showing for industry professionals. I have also mentioned this on our Discord. What you will need to do is that you will need to actually create a Brave Search API. Brave Search is, how many of you have heard of Brave Search, by the way? It's pretty famous. It's a pretty famous web search API, but unfortunately it's paid. I'm showing this because this is used very frequently in industrial deployment. So what you can do is that you can just create an account over here and click on register. And when you, so I have already created my account, so uh, I can directly register over here. And when you do that, you will actually see an API key. That API key you will need to copy and you will need to paste that API key down below over here, where you use the Brave Search tool spec. Now, when you have to create the Brave Search API key, you will need to enter your credit card details, although it will be free. So it actually won't be charged, but you have to enter your card details. That's the trade-off over there. So even if you are a student, you can enter your details and then later cancel the subscription. That's also fine. But to subscribe to their free plan, you have to enter your card details and then you can get this API key, which you can add over here. Those are the only two things which you need. Now we can get started. But before that, can people tell me how many of you have got these two API keys? How many of you have actually got these API keys ready and working? Because then we can get started. Okay, it's good that at least 4 to 5 people have got this. Now we'll get started. Others who are unable to right now follow along or get these API keys, you can generate it very simply after the class. So as I mentioned in agentic RAG, several steps are going to stay the same. The first step is that we are going to again load the data. The second step is exactly same, break the data into chunks. That's step number 2. Step number 3 is define the LLM and the embedding model. This is also exactly same. Step number 4 is also exactly the same, but we are also creating this summary index. That's step number 4. Then we have to create the query engine. This is also same as before, but now we create two query engines, one for the summary and one for the vector. So until this point, we have reached a stage where we have created these two engines in the code. So let me just rub this right now. So until this point in the code, we have created the summarization query engine and we have created the vector query engine. Then as I mentioned, we have to convert these into tools. That's the most important step. So we can use this query engine tool function from LlamaIndex and we can convert our query engines into tools and we give the description of the tools. So this summary tool is useful for summarization questions. This vector tool is useful for retrieving specific context and then you run this. So 2.5 what I've shown here is what distinguishes agentic RAG from RAG, because here is where we actually convert this into a tool and we convert the summarization query engine also into a tool. Once you have converted these two into tools, we define a superset query engine. This superset query engine is this router query engine, which decides where to route that particular query to. So we create the router query engine and within this, it has the summary tool and the vector tool. And by the way, you can just test this router query engine by asking a query. So I'm asking the same query here, who is Larina E according to the document. And then you can see that selecting query engine 1 useful for retrieving specific context. So here it selects the vector, engine. And you can see Larina E is one of the authors listed in the document. Not a great response. We will modify this because the prompt has not yet been added. But now the query engine, the router query engine also needs to be converted into a tool. So this router query engine will need to be converted into a tool. And that's step number 2.8, where we convert this router query engine into a tool. And now we are ready to give the system prompt. So someone was asking in the chat, right? How do we know essentially what to use? Which tool to use. So here we have to mention this in the prompt. And this can be the time when I explain how I write agentic prompts. So agentic prompts need to be written as detailed as this, where you have to mention that you are a helpful assistant and you have the following tools. You have this summary tool and you have the vector tool. So see, we are using query engine as tool here. That's agentic RAG. And we mention when to use the summary queries and when to use the vector query engine. These are the two tools which are available to our agentic RAG system right now. And then you can set up the agent. You can give it the tools, which is only one tool, that's the query engine tool. The system prompt is the prompt which I've defined over here. And the LLM is OpenAI 3.5, which we have already defined earlier. And before running the agent, this is where we set up the agent observability using Arise Phoenix. So just click on this run over here. This installs the Arise Phoenix package. And then here is the place where you mention the open the Phoenix API key. And now once you reach this step, finally you can click on this. So I asked the same question. Who is Yarin Ali according to the document? Where is she mentioned in the document and in what context? So here you can see selecting query engine 1. So it selects the engine which gives the specific context. That's the tool. So actually our agentic RAG has two tools now, summary query engine and the vector query engine, and the router decides which tool to use. In this case, we use the vector query engine tool and we got the answer, right? But we should not stop at the answer. As I have already mentioned, we should observe the agent and how well it is doing. So now what I'm going to do is that all of you also who have set up the Phoenix um, Phoenix project, what you can do is that, so I will share my screen now. Yeah, if you have set up the Phoenix tool in the default section in the default project, you can click over here and this is where your workflow run should ideally appear. Um, so here you can see my workflow run has appeared over here and you can exactly see your trace where you can see that the text is Larina E is mentioned in the document in the context of this and this. But now you can actually explore so many things on the left hand side. Before doing that, can you tell me how many of you are able to see this trace in the Phoenix, in the Arise Phoenix? Is anyone able to see this right now? If you have set up the API key correctly, you should be able to see on Arise our entire workflow. So I can see that many of you are not able to see this. And where is the error which you are getting? Is it because the API key has not been entered correctly? If that is the case, you might need to restart the Google Colab interface once. So what till that time, what I will do is that I'll explain how to understand this. Um, so Phoenix is not opening, reloading. It will open. So Phoenix opens after 2 or 3 tries. Our API key looks different from yours. Yeah, so this is what I had also noticed earlier. Earlier, when I was generating the API key, I was generating it through my another Gmail account. So now when I created an account through here, the API key seems to be very long. In any case, let me just first explain what I'm seeing here right now so that the API key issue can be even figured out after the call. I don't think it's a big issue, but the important thing is for you to understand how to understand what's written on this Phoenix portal. So here, see in the Phoenix portal, if you click on the base retriever, here you can actually see the documents with the nodes which have been retrieved. So this node, this first page has been retrieved, which we already saw in the previous RAG implementation, and the second node has been. So this is the second node or the second chunk which have been retrieved, because this is where the name of that person actually appears. But here we can see it in a much better manner, the base retrievers, and then we can also see the tools which this agent has used. So this agent has used the query engine tool over here. If you see the tool which is marked in the yellow color, this is the query engine tool. And if you see on the right hand side, you can also explore. Yeah, so here you can see which tool has been used. State of the art report assistant. That's the query engine tool call. So our agent has used only one tool, it seems here, and we can see the documents which have been retrieved from the query engine tool. These retrieved documents are then passed to the language model, and then we generate the final answer, which I'm seeing on the screen here right now. Um, okay, so now this is regarding Phoenix, right? And many of you are not able to run this right now, probably because of the API key issue. But after this lecture, you can load the API key in the manner which I have showed you. So in the recording, if you go back to the recording, there was one place where that API key section actually appeared. So this is part one of Agentic RAG, but I don't want to stop here. There is one more thing which I want to show. It's that we can equip the agents with multiple tools. And that is where Llama Hub actually comes into the picture. So if you see, Llama Hub has a huge set of tools here. And today I want to integrate two tools from here. I want to integrate archive. I want to integrate archive tool spec. So this tool essentially connects to archive and allows an agent to search for recent papers and their summaries. Let's say I want to integrate this tool into my agentic RAG. And the second tool which I want to use Second tool which I want to use is essentially Brave Search. So if you go to tools here, agent tools. Second tool which I want to use is Brave Search Tool Spec. So this tool enables agent to search and retrieve results from the Brave search engine. That's the second tool I want to use. So this is not possible with normal RAG. Now you will see how easy it is to augment the agent with multiple tools. So what we are doing here is that we just install LlamaIndex tools archive, LlamaIndex tools Brave search. So this is a simple package installation based on the tool which you want to use. And then you create the tool. So I've created archive tool is archive tool spec. This does not require an API key, but to create the Brave search tool, you need this Brave search API key over here. And then you can define an enhanced agent. So you can first look at the tools here. So the first tool which this agent has is the query engine tool. This query engine tool essentially is this router query engine, which has access to two sub tools, the summarization query and the vector query. But now we are augmenting it with two more tools. We are adding an archive tool over here, and we are adding a Brave search tool also over here. So even if for you the Phoenix did not work, it's fine. This is independent of that run. So if you got this API key, this should work for all of you. So you define this enhanced tools and add the Brave search tools and the query tools. So now our agentic RAG has three tools essentially. And then you can, in the enhanced agent, you can mention the prompt that you are an AI research assistant with access to McKinsey 2025 State of the AI report, web search capabilities, and archive paper search. Use these tools to provide comprehensive, well-researched answers. When discussing AI trends, combine insights from the McKinsey report with recent search and web findings. So I'll run this right now. Our agent is now defined, and I have added some battle testing questions to the agent. I've added 4 questions. I'm going to run question number 4 now. Question number 4 is, who is Larina Yee in this document and what are her views on AI's workforce impact? Then I'm going to ask, search the web using Brave search for recent articles, interviews, or news about Larina Yee and her work on AI. Then I'm going to ask, search archive for any research papers she may have authored or co-authored. Then I'm going to ask, provide a comprehensive profile combining insights from all these three sources. Now see, the query or the prompt which I'm making is extremely comprehensive, right? This will not be possible with a simple RAG system. The only reason why it's possible is for this question, we can use the query engine tool. For this, we can use the Brave search tool. For this, we can use the archive tool, and then combine the result of all these tools into one answer. So if you run this right now, the agent will probably think for some time, and then we should ideally use many of these tools which I have just explained to you about. We should be using all of these tools actually. So if you scroll down below, you'll see the result. Web search insights. So Larina E profile, McKinsey report insights, um, archive research papers, etc. Now, what you can do is that you can explore this in Phoenix. So I'm again going to Phoenix right now, and I'm going to show you how we can see which tools are actually used over here. So you can refresh this and yeah, so see now, this is where you can inspect. So these are my trace details, and you can already see that it's much larger here, right? But don't get intimidated by this length. Go by the colors. So first look at the yellow color. The yellow color is only appearing once, twice, and thrice. It's only appearing 3 times. That's the tools which have been used by my agent. The first tool is the query engine tool, because our first question is, who is that person that uses the query engine tool? If you scroll down below, this is the second tool. And the second tool which has been used, if you see on the right hand side, if you scroll down, the second tool which has been used is the Brave search tool. And if you look at the third yellow tool on the left hand side, the third tool which has been used is the archive query tool. So you can see that in this one question, our agent has used all of these three tools which we had provided it access to. And in the workflow.run, you can see the full summary. So this is the response. On the right hand side, you can see the response text, and these are the tool calls. So just check the tool calls. The first tool call has been made to state of the AI report assistant. The second tool call has been made to archive query. And the third tool call has been made to Brave search. So there is a question, what's the difference between Arise and LangFuse? Yeah, Arise and LangFuse are very similar frameworks. What we did right now, we can do in LangFuse also. But it's just that both of these frameworks are equally popular at the moment. So as a researcher or an engineer or an industry professional in this field, you should know how both of these frameworks actually work. Secondly, Arise I have seen is more common in settings where people want to use agents, whereas LangFuse is used for all types of LLMs. Even if you don't use agents, LangFuse is used as a evaluation framework there. Now, if you actually see the answer, there are some errors in the answer because this person might not have written any archive document. It's just looking at the last name and looking at the archive documents from anyone who is surnamed Yi. So all of that we can actually provide in the prompt to reduce hallucinations. But what I just demonstrated to you right now is that, okay, if you have a RAG system, that's fine. But if you have an agentic RAG system, it can lead to two benefits. First benefit is that you can have access to multiple tools, and using Llama Hub, you can connect these tools very easily. So you can just augment, you can use the query engine as one tool, and you can augment this tool with the Brave search tool, archive tools, or any other tool which you want to add. The second advantage is that you can, if I instruct over here to enter a thought action observation loop, the agent will enter that loop and give me more detailed answers than I can get with a simple RAG. That's the second thing. And another most important thing which I really wanted to drive home today is Phoenix Arise. So there were some issues which I think many of you faced when using this framework, especially because of the API key. So the thing is, when I went to app.arise.com, on the left hand side, I got this thing as API key. But when I created a new Gmail account right now, this section is not coming. I will also check this once. But after this call, all of you can explore once more about how to get this API key. That API key, if it's added at the correct place, which is over here, um, then you can explore how your agent is functioning using Phoenix. And the way to do that is that you go into a trace and you sort by colors. So the yellow color is always the tool call which is being made. The blue, the light blue, this kind of cyan blue color, it's always the documents which have been retrieved. And there is also a score, the retrieval score, which is attached over here. So always go by the colors. Yellow is the tool call. This cyan is the documents which are retrieved. This purple color is the embedded text of our input prompt, which is converted into a vector. This orange color, this orange yellow color is the LLM call, which is actually made. So if you look at the colors, the blue is the main agent which is working. Yellow is the tool used by the agent. Orange is the LLM, the base LLM of the agent. Cyan green or cyan blue is the document which is retrieved. Then this purple is actually the input prompt and the part of it which is converted into vector embedding. Yeah, that's how you can actually visualize the trace in Arise Phoenix. And here you can also see the total number of tokens, the latency for every request, etc., which is useful for monitoring, especially if you're dealing with industry related projects. So how many of you were able to run this last part, which is testing with multiple agents, not the Arise Phoenix part, but this last part where we had multiple tools which are integrated with the agent itself. Okay, so without Arise, at least, okay, two people I can see in the chat are able to run without Arise. That should be your first step. After the session, first step should be to try without Arise. Without Arise, there should be no problem to run anything. Because if Arise, even if Arise framework is not integrated, you should be able to run the later part of the code. You just need Brave search API key. That's important. So after the class, I would suggest first get the Brave API key and forget about the Arise. And just run until this last part. I've added 4 questions over here to battle test. I only showed you 1 question, but I've added 4 questions. You can first run all the 4 questions and see the responses. And next, what you can do after that is then try to integrate the Arise API key. Okay. So now let me do a quick recap of what we covered today. Today was a very long lecture, but I think it is important because the first major takeaway from today's lecture is what is RAG itself? Why is it called retrieval augmented generation? We take an LLM, we take a prompt, then we choose which documents are most relevant to the given prompt using embedding models. We pass those retrieved documents along with the prompt to an LLM, we get the answer. This leads to grounded generation. It reduces hallucinations. That's quite good. But RAG is a retrieve once, generate once framework. This means if the retrieved context is not enough, the LLM cannot dynamically search for more information. So we are limited. Using RAG, planning cannot be done, reasoning cannot be done. We don't have access to tools. So how can we integrate agents with RAG? The simplest thing is essentially to start with an agentic framework and to add the query engine in the tool itself. That's exactly what is done in agentic RAG. So in agentic RAG, you have the query, then you look at the tools. If you have to use the query engine, only then you use it. You add the relevant context to the LLM as the prompt, and then you check whether the answer is good enough or not. If not, you go into this loop. That's again the thought action observation loop, which helps reasoning, planning, and decision making. If it's relevant, you exit out and return the response. Now to implement RAG, I showed you a slightly complex thing, which is this router query engine. We don't need this ideally, but I showed you this because we can first orchestrate where we want to go. So technically we have three tools over here. We have tool number one, which is summarization query engine, tool number two, which is vector query engine, and tool number three, which is router query engine. What tool number three decides is which of tool number one or two should be used. And then we added two more tools, the archive tool spec and the brave tool spec. This opens a door for all of you to explore whatever you want from the Llama Hub. Llama Hub has a huge repository of tools. So you can literally use any tool which you want over here. So if you want to make a knowledge RAG system, which is another KG RAG, which is knowledge graph based RAG, you can directly use a tool from here. So you can check the part where I've added these tools from Llama Hub, and you can add those tools which you want in a very similar way, but make sure that prompting is done in a correct manner. If your prompt is very small, your answers won't be good at all. So the first prompt which I've made, you can check how detailed that is. This prompt over here. The system response quality is heavily influenced by the prompt you write, because if you think about it, agents are nothing but LLMs whose prompt has been augmented with tools, and now whose prompt has been augmented with the retrieved documents. So it's in the prompt where the LLM actually knows what should I do, what do I use. That will not happen magically. Now many of these tools, right, which you see on the Llama Hub, as has been asked, there is a question in the chat. Many of these tools will not require you to have paid subscriptions, but some might, like Brave Search, for example, which we saw right now. That if you exceed a certain limit, you might go from the free plan to the paid plan, etc. Okay, so evaluation, right? So there is a question on evaluation, how important it is to have the evaluation data set. In industry projects, it's the most important thing, and that's why I'm stressing so much on evaluation frameworks. So right now I showed you observability, right? Before even going to evaluation, you should first know whether observability is good. Is my agent functioning as I want? Next step is setting up evaluation dashboards. So the dashboard which I've shown in this Substack is actually the kind of dashboards which we set up for industries. And then you have to have metrics, but make sure that the one thing which we do is that for evaluation, we get the testing data from the client itself. We don't touch that testing data during training, but we get some test data only during the evaluation phase. So in the evaluation dashboard, then we can have testing data and show the results on that data to the client. How to handle hallucinations in agentic RAG. So one good thing is that by default, there are many mechanisms in agentic RAG which prevent hallucinations. What's those mechanisms? This loop which happens, right, that goes a long way in preventing hallucinations. Then if we use a query engine, already that is reducing hallucinations, because retrieval augmented generation is also called grounded generation based on documents. That's reducing hallucinations anyways. This thought action observation loop It's also rechecking the answers many times. That again reduces the number of hallucinations, etc. All right, everyone. So this brings us to the end of today's lecture. It was pretty long, around, I think it took around 1 hour, 40 minutes. Um, Thanks everyone for staying till the very end. I can see that almost everyone is here till the end. Now, as we are getting into difficult concepts, it's, as I mentioned last time, the lectures are becoming longer because I could have condensed this by directly starting with Agentic RAG, but then most of the information would be lost. We need to start with RAG, then go to Agentic RAG, then go to code. For those of you who have not been able to run the code, please try it once after the class. So this is one of the most important topics today. So agentic RAG, all of you should know the difference between RAG and agentic RAG. And again, I'll stress this as I'm stressing after every class, evaluation observability of agents is extremely important. In the next class, we are going to cover a very important topic again, which is LangGraph. We are going to build projects using LangGraph in the next class. Tomorrow's session will again be 2 p.m. IST. And I look forward to seeing you then. After this session, we have CrewAI, we'll have n8n. I'll probably cover one. So there might be 11 sessions actually. If I'm not able to cover everything within the planned schedule, there might be an extra session. Thanks everyone, and I look forward to seeing you in the next class. Bye. All right, so let's get started with today's lecture. Today is day number 8 of the bootcamp, and we have an extremely important topic to cover today. And that topic is using an agent coding framework, which is, I would say, the most popular code-based agent framework at the moment, and that's LangGraph. So we are going to cover several important things today, such as what is LangGraph, how does it differ really from LangChain, why has it become so popular for agents, and then we are going to build projects using LangGraph in Google Colab. I'll try to finish this lecture within 60 to 70 minutes, but like the previous lectures, this is also a deeply involved topic. And if you are planning to implement agents in enterprise or industry, it's highly essential that you master LangGraph. So we are definitely going to code, but I also want to teach you the foundations of LangGraph in a very detailed manner today. So let's begin. Before we start, I just want to give you a quick recap of what we covered in the previous lecture. So in the previous lecture, we started building agentic RAG systems. We started looking at LlamaIndex, and we saw that what makes LlamaIndex really special is that it has this Llama hub, which has many ready-to-use components. It also has document parsing capabilities and an easy workflow system to understand. Then we saw RAG, what is retrieval augmented generation, and we also implemented retrieval augmented generation in LlamaIndex. We saw that traditional RAG is retrieve once and generate once, and it cannot even use external tools. So if we want to take complex decisions or if we want to plan, traditional RAG does not serve our purpose quite well. So then we discussed that how can we essentially integrate our agentic approach with RAG. And the simple way to do that is pass the query engine as a tool to the agent. And the second important change is that you enter this thought action observation loop, which means that if the answer is not relevant to the query, you go back again and you keep doing this until you're satisfied. This loop is not present in traditional RAG pipelines. That's what makes agentic RAG systems so much more robust. They are better at planning, reasoning. Hallucinations are also reduced because of this thought action observation loop which we have. And the agent has an option whether to use the query engine or not. It can decide that I don't need a query engine and then it doesn't need to use it. So this is agentic RAG, and we also implemented agentic RAG with LlamaIndex. So I've added all of the steps on this Substack article, creating multiple indexes, building query engines, wrapping query engines as tools, setting up a router query engine, defining the agent, and then finally running the agent. Yesterday, we also saw Phoenix Arise, which is another LLM tracing and evaluation framework. And we explored different colors in this framework and how we can use the colors to understand what's going on. We saw that this cyan blue color essentially is for the retrieved documents. The orange color is for the language model. The blue color outlines the high level steps which the agent is taking, etc. And that's where we ended the last lecture. Today we are going to uh, move ahead with the next agentic framework, and that's LangGraph. So first, I want to mention a quick, essentially distinction between LangChain and LangGraph, and that is where we are going to start today's lecture. And rather than going into definitions, which I already have on the whiteboard, I want to start with an example so that I can explain this difference to all of you in a simple manner. We are going to take the same example as our Spain trip, okay? And let's say I want the workflow as follows. First I want to use Google Flights. First I want to use Google Flights. And I want to find the best flight, which means that I want the price to be less than, let's say, $1,500. That's the first thing which I want. If the price is less than $1,500, what I'll do is I'll move towards booking my hotel. So then I'll move towards the hotel booking. And here also, let's say I want my price to be less than $1,500. If my hotel booking is also finalized, then I'll move to the third step, which is essentially the travel plan. And in this third step, one of my friends has given me this Spain tour guide. And I want to use this Spain tour guide as my reference to make my travel plan. And then that will be the final answer which I want. This travel plan essentially. Okay. These are the sequences of steps which we need to do. Now, if we want to do these sequences of steps using a popular framework which is known as LangChain, what will we do first? We'll first so can I get some responses from everyone in the call right now? You are to implement this framework using LangChain. Just think about what you have learned about agents so far. How will you implement this? Um, Browser agents. What about others? Can you try to answer this? I know this is a bit of an open-ended question. Tools, browser agent, I can chain multiple steps, etc. So let's say I have three agents. One is my Google Flights agent. One is my Google, or let's say I have only one agent, but I have multiple tools. So I have my agent and it uses the tool number one, which is the search engine for the flights. And remember, LangChain is extremely popular because you can chain different things together. Then after this, you will chain the second tool, which is hotel search. And then after this, you will chain your third tool. And your third tool is essentially the travel plan, the travel planner. And maybe you will also add one more tool here, which is the query engine. So then this directly becomes an agentic RAG because you do have this Spain tour guide over here, right? And we want to refer this document. So then I have a query engine tool over here. So in a way, it's also agentic RAG. But can anyone see the problem over here? So here I'm using LangChain. So I'm creating this sequence, right? I'm chaining one tool to another tool to another tool in a linear manner. What's the main issue with this approach? Remember, the reason LangChain became so popular is because we can chain different things together in a linear fashion, and that's how we can create very complex agentic and even language model systems. Let's see, a failure blocks everything. It's slow. If something fails, if one step fails, the whole trip fails. We want to parallelize, we cannot loop back. But Can you try to see what we have not integrated here? Like this flow does not capture some things which I had over here, right? What does it not capture? And I can see some statements in the chat. The thing which it does not capture is something which is called as conditional logic. What conditional logic means is that ideally I should go from my first tool result to the second tool result only if I am able to find a price which is less than $1,500, right? If if this is not satisfied, I will not go to the next step. If it is satisfied, I will go to the next step. Similarly, over here, I have another conditional loop. If the hotel price which I find is not less than $1,500, I I will not go to the next step. So essentially, there are conditional statements here which are very hard to integrate with the LangChain framework. The only way to do it in the LangChain framework is to wrap these tools in an if-else kind of a block. And that makes writing the code extremely inefficient. So here we have to maintain this linear flow of the tools. And if we were to execute conditional statements, if we are to follow conditional statements, the only way is to wrap every tool call in an if-else statement. So writing the code becomes extremely hard. But now that if-else statements are involved, don't you think there is another way to kind of do this? How do we do if-else statements? When you learn about if-else statements, don't you have something like a diamond? And then there is a question over here. And then if it goes into this path, you do something like this. If it goes into this path, you do something like this, right? So if there are conditional statements and if the logic which is to be followed is hard, then we should have structures like these. And what do I mean by structures like these? These structures can be known as graphs. You might think of decision trees. It can also be called as a type of graph, right? That's where actually LangGraph comes into picture. Now let me give you all another way to represent this same thing, and then you tell me what you think of this. Okay, the way I'm going to now, instead of doing this linear kind of approach, what I'll do is that first I'll have my flight booking node. I'll explain what nodes are. I'll have my flight booking node, and this will have a tool. This will have the search tool. Okay, I will keep on going in this loop. So I'll make a loop over here, and I'll keep on going in this loop until I have a flight which is less than $1,500. Okay, so if I get a flight which is less than $1,500, then I will move to the next step. If not, so for example, if I don't get a flight, I will end it over here. But if I go through these multiple steps over here and I do get a flight which is less than $1,500, I'll go to the next step. In the next step, what I have is I have my hotel booking. So even here, what I'll do is that I'll have a search tool and I'll go into this loop again. I'll go into this loop again over here. I'll go into this loop as many times as I can. If I find a hotel which is less than $1,500 is great, but if not, I'll end it over here. But if I do find it, I'll go forward to the next step. And here is where I have my travel plan. The tool which I have over here is my query engine tool. So this is where the Agentic RAG comes into picture. This is where I have my query engine tool. And I will keep on querying this until I get good results. If I get good results, I will return my results over here. If not, I am going to end it over here. So now take a look at the structure which is assembled over here. On the left hand side of the screen, we have this structure, right? And if you compare this structure with what was there on the right hand side of the screen, there is a fundamental difference. The structure on the left hand side is a graph based structure. So this is a graph based structure. and the structure on the right hand side is a linear structure. The advantages of graphs is that why people love dealing with graphs is because it allows you to deal with complex systems in a much better manner. You can you can incorporate as much amount of complexity as you want. You just increase the number of nodes, you increase the depth of the graph to make it more complex. Then you have multiple thought action observation loops over here. If you think about it, this is a thought action observation loop. This is a thought action observation loop. This is a thought action observation loop. So I have three thought action observation loops integrated within this graph-based interface right now. Whereas here in this kind of a linear approach, it really gets very difficult to deal with complex decision making. And when people started making agents, if and else statements are bound to come, right? Because that's how we plan. Think about how humans plan. If I have the money, I will do this. If I don't have the money, I will do that. So it's like if else statements govern our everyday decision making at every step of the way. So LangGraph actually came later than LangChain. Initially, people were building agents using LangChain. But even LangChain's founder now advocates using LangGraph for building agents. Because as you can see here, LangGraph enables us to design agents that can reliably handle complex tasks. And one major reason for this is that conditional, we can make it very easy to deal with conditioning using a graphical structure instead of a linear structure. You can have conditions even in a linear structure, but the code gets messy very quickly. And as a developer, it becomes very difficult to then visualize the code to debug errors, etc. But if you have a graph-based system, things actually become very easy. Then the another advantage of graph-based systems is something which is called as state persistence. What state persistence actually means is that the state which was X, and we'll learn about what state means in a formal manner. But for now, just think about it this way. What all information was accessible at the top of the graph, that's percolated down. Since it's a tree-based structure, the information of the top at the top is easily percolated right till the bottom. So the state which is available at the top of the graph is easily available at the bottom of the graph. That's called state persistence. So it's very easy to deal. Usually you don't want state variables to become lost when you define complex decision-making workflows. In chain-based structures, it's easy for the state variables to get lost. But in a graphical-based structure, it's easier to retain state variables, or rather it's easier to maintain state persistence. That's a deeper level advantage of graph or Lang graph rather compared to Lang chain. So now instead of diving into definitions, I wanted to first explain all of this to you with a practical example so that when all of us now look at the formal definitions, you have something in your mind to visualize, right? So I could have directly started with this, but this text does not make sense unless you have some kind of a example. So whenever I'm explaining this text to you right now, always think back to the example which we have just seen. So as I told you, LangGraph is a specialized library within the LangChain ecosystem. LangChain ecosystem developed first, it matured first, and LangGraph came a bit later. So LangChain is ideal for building LLM applications where things are kind of chained together. So you retrieve the data, then you split the text, then you summarize the text, then you generate the response, right? This is a linear operation. This is a simple linear operation, and LangChain is good to do these linear operations which are chained together. But LangGraph, the advantage of LangGraph is that it can handle non-linear processes quite easily. And what do I mean by non-linear processes? Non-linear processes look like this. You check something whether it's yes or no. Let's say if it's no, you complete the task. If it's yes, you add the task, and finally you summarize the task. So now see what I see on the left hand side is a complex workflow which involves decision making at several different points. It involves making a decision here, then going into one of these flows, then doing these tasks, and then merging the results of both of these tasks. This is a non-linear process. Nothing flows in a sequential manner over here. And not just that, after you summarize the tasks, you have to feed it back, let's say, to the input. if your process looks like this, then it's much more advantageous to build a Lang graph because you can easily visualize it like this. Another example is that let's say we want to um, have a document, right? And we want to decide whether we want to directly use a code agent for the document, or we want to just use LLM on text or OCR plus LLM. So what you can do is that if the user question and input document is the overall input, you check the document type. If the document type is an Excel sheet, you can simply use a code agent with pandas as the tool. But if it's PDF or text, you can check for images or tables. If images or tables exist, you can use OCR. If images or tables also do not exist, you can directly use LLMs on the text. If you are not familiar with some of these terminologies, don't get confused. But here I've just highlighted two use cases of what a complicated scenario might look like for decision making. And finally, this one schematic explains why you would want to use LangGraph over LangChain. So LangChain focuses on sequential LLM operations and LangGraph handles nonlinear workflows. That's one major reason. Second thing is LangChain includes memory, prompts, etc. But LangGraph has nodes, edges, and states. So I like to remember this as N, E, and S. We are going to learn about what nodes are, what edges are, what states are very shortly. But the entire framework itself is different. The whole agent is orchestrated using nodes, edges, and states. Then, as I mentioned to you before, LangChain has limited state persistence, if you see. But LangGraph offers robust, accessible state management. All right, so I hope now you have got an overall picture of, okay, what is LangGraph, what is LangChain. Although some things will still be unclear to you that, okay, what are nodes, what are edges, what are states. I have not explained this NES framework to you, but I'll do that shortly. Until this point in the lecture, if anyone asks you, why would you use LangChain or LangGraph, you should be able to answer at least qualitatively as of now. We'll make it quantitative as we go through the code in more detail. Now, let's come to how does LangGraph really work? And I'm going to first quickly explain to you the definition, and then we are directly going to go into an example which we are going to code out. Usually all LangGraph tutorials directly start with code, but I don't think that's the best practice because unless you understand these foundations, it will be difficult to understand the code. So to understand how LangGraph works, we need to first understand its building blocks, which is N for nodes, E for edges, and S for states. So we'll start with the state first. It's user defined and maintained and passed between the nodes. Nodes essentially are functions and edges connect different nodes to each other. I know this is a bit fast, but essentially, if I were to go to this same graph which I just showed you, these ones are nodes. So the flight booking, these ones are nodes. The nodes are connected together by these lines which you see over here, right? These lines are the edges. And the state is essentially what you're maintaining throughout. So for example, if we are tracking the price over here, price can be the one state variable. If we are ultimately tracking the destinations where we want to go to, that can be another state variable, etc. So state is user defined and maintained, such as price, travel locations, etc. Nodes are functions which call a tool. So if we are using if it's a travel node, it uses the query engine tool. That's a node. If it's a flight booking node, then it uses the search engine tool, etc. So nodes are essentially functions, and nodes are functions of the state variable. And edges essentially connect different nodes to each other. So if you see this right now, the framework can look something like this. You start, you have node number one, you have node number two, and you have node number three. Each node can have access to certain tools. And then you specify the connection between nodes as edges. So this is edge number one, this is edge number two, this is edge number three, and this is edge number four. This is a simple graph using the NES structure of LangGraph, which is nodes, edges, and states. Now, let us understand this in more detail by taking a simple example. What we are going to do is that today's first example is email sorter and sender. Email sorter and sender. So the example is as follows. We are going to uh, receive an input. We are going to receive an email as an input. Our task would be to first determine whether this email is spam or not a spam. That's why it's email sorter plus sender. If it's spam, then we don't do anything. We just end it over here. But if it's not a spam, we draft an email. We draft an email and we send it to the person. So you can think of this whole framework as an assistant screening emails for their manager, essentially. So you can think of this as assistant screening emails. So the assistant will get the input email. They'll determine if it's spam or not spam. If it's spam, they'll not do anything. So we'll just end. But if it's not a spam, they'll draft an email and share it to the manager saying that you have received such and such email from this person. So this assistant filters spam and not spam and directs the not a spam to um, the main person. Okay. So now what we have to do is that we have to make a LangGraph framework out of this. So this is an agent which does all of these things. We have to make an agent who does this entire workflow automatically, and we have to make this agent using LangGraph. So based on whatever you have understood so far, it's fine whether the answer is correct or not. What do you think the state of this agent should be? What should be the state? You know the problem statement which I've just mentioned, and you vaguely know the definition of the state, edges, and the nodes. Um, what do you think should be the state in this agent which I've just defined on the screen? Email content, sender, original email. Okay, great, right? So all of you are getting the basic idea of what the state should be, and I've just written it over here. So the state of this agent is essentially going to be the email. So this is a dictionary which contains several different things and which we are going to track throughout this building process. We have the email content, the input email content itself. Then we also have whether the email is spam or not a spam. Why do we have this as a state variable? Because that will be passed for our future decisions. Then what else do we have? We have email sending draft as well. So if the email is not a spam, we have to make a draft. So we have this draft over here, and we have the spam reason also in case uh, we want to send this information to someone that, okay, why is this email spam or why is it not a spam? We have the reason if we have classified it as spam. So these are the variables which will be propagated throughout our graph. When I say propagated, I mean that all the actions which we'll have to do later, such as we have to detect whether spam or not spam, right? That's why we need this state. We have to detect or we have to draft an email to the manager. That's why we need an email sending draft. And if the manager asks for a reason that why is this email classified as spam, if we maintain that in the state, it's good. And of course, we have the email content also in the state. So this is the state out of the N, E, and S framework. Now, can you tell me what should be the nodes? And remember, the simplest way to think about nodes is just functions. Nodes are just functions of the state variables. The fancy way of calling them is nodes, but they are essentially just functions. So in this problem statement which we have, what should be the nodes? And again, this is a bit open-ended question, but try to think to the best of your abilities. We can see some answers such as read the email, classifier, spam identification. Correct. All of you are getting into or going in the correct direction. The nodes, I'll have 5 nodes. My first node is I'm going to just read the email essentially, which means take in the content of the email, because the email can have several things, right? It can have the sender information, the sender email ID. I just need to take the body or the content of the email and read it first. That's the first function which I need to define. The second is classify the email. So I'll need to classify the email between spam and not spam. And I think all of you have mentioned this. Third is handle the spam. What does handle the spam mean? It means that if it's not a spam, we have to end. We don't have to do anything. Sorry, if it is a spam, then we have to end. We don't have to do anything. But if it is not a spam, then we have to use this node, which is draft an email. And then finally, we have to notify the person that, okay, this you have received this email, and we have to send that email to that person. These are the 5 nodes or the 5 functions. And so node, states, and edges. Edges will essentially connect the different nodes to each other. So if you see this right now, this is how we are going to assemble the states, and this is how we are going to assemble the nodes. So if you see, whatever is marked in purple color here right now, those are the nodes, right? So read email is one node, classify email is the second node. These are the 5 nodes which we see, 1, 2, 3, 4, 5. Those are marked in purple color. Read email, number 1, classify email, handle spam, drafting a response, and notify whatever the manager name is. Okay, these are the nodes. And now in this step, we have to determine the edges. This is an important step because it's crucial to understand what's the workflow we are following. The first, when we start, we are going to read the email, right? So that's going to be our edge number 1. After we read the email, we are going to classify the email, whether it's spam or whether it's not a spam. So that's the second. Remember, nodes are functions and edges are connecting the different nodes to each other. So this is my edge number 2. Now here is where I have an edge which is called as conditional edge. These edges which are over here, these are called as direct edge. This is called a direct edge because there is no conditioning which is happening here. Edge number 1 and edge number 2 are direct edges. But after we classify the email, we have a conditional edge because if it's a spam, we have to handle the spam, which essentially means we just end. So this one, edge number 3 is a conditional edge. Edge number 4 is also a conditional edge because if it is not a spam, then we have to draft a response. So then we have edge number 5, and then we have to notify the manager, and then we have to end. So that's edge number 7. So there are 7 edges in this graph. Edge number 1, 2, uh, 1, 2, 5, 6, and 7. These are direct edges, and edge number 3 and edge number 4 are conditional edges. This is the power of LangGraph, right? You can very easily define a direct edge, and with that same ease, you can define a conditional edge as well. In this one figure, now you should understand the difference between nodes, states, and edges. State is nowhere shown in this figure, right? Because states are our variables. They won't be shown in this figure. State is the body of your email, whether it's spam or not, your draft email itself. Those are the state variables. What will be shown in this figure is essentially nodes, which are functions. And you will understand it better when we define these nodes in Google Colab, but essentially these are functions, right? And functions are connected to each other through edges. That's why the framework is called nodes, edges, and states. And when nodes, edges, and states are assembled together, so if you zoom out and see now, this is state, these are nodes, and these are edges. When the nodes, edges, and states are assembled together, it leads to something which is called as a state graph. So this is the container which holds together the entire agentic workflow, something like this. In Python, you can visualize the state graph, and the important thing is you can invoke the state graph. Invoking a graph essentially means starting through this entire workflow and reaching till the end. That means invoking the graph. And it's very easy to define the invoke statement. You just have to do graph.invoke, and then we'll start the entire sequence from node 1 to node 2 to node 3, etc. So that is the whole idea. And more formally now, state is a central concept. It represents all the information which flows through our graph application. Nodes are essentially Python functions. They take state as an input, they perform some operation, and they return updates to the state. Edges connect nodes and define possible paths through your graph. and edges can be direct or edges can be conditional. Direct edge always goes from one node to another node. A conditional edge can choose the next node based on the current state. And then finally, we have the state graph, which is a container which holds the entire workflow, and we can invoke a state graph. So in the previous frameworks, you remember we did agent.run. An equivalent of this in LangGraph, or when we are assembling a graph, is essentially graph.invoke, which invokes the entire graph. Now here, if you see very closely, I have not told you where tools are used exactly. And we are going to look at that in our second demonstration of today. The first demonstration is building this email sorter and sender. In the second demonstration, I'm going to show you how you can augment such a graph with tools. But if I directly show you tools, then it becomes a bit more complex. So let's start executing this first example now on Google Colab. So what I'm going to do now is that I'm going to share this Google Colab code file with you. Let me start sharing my screen. First, I'll open the code file on my drive, and then I'll be able to start sharing the file. So I want to share two Google Colab code files with you today. But first, let's just start with one so that it will be easier. Yeah. So I've just shared the code file. All of you can take a look at it. Meanwhile, let me answer some questions in the chat. Where is the thought action observation loop here? That's a very good question. So in the first example, we don't have the thought action observation loop. We are going to see that in the second example when I'm going to show you how tools are used. In the first example, we are going to very simply assemble the functions, but we won't show the TAO loop. I'll show the TAO loop in the second example. You can call this as an email processing agent, a simple email processing agent. Does this not add a lot of time? So it actually, for complex workflows, it's much faster because in LangChain also you have to do if else statements if you want to do these workflows. It just flows much faster in complex workflows. For simple workflows, even LangChain can be used, but in complex decision making, LangGraph, it's actually shown to have better performance and also more efficient with respect to the code. So before now all of you start running the code, you should have the OpenAI API key. So just copy paste the OpenAI API key over here, os.environment OpenAI API key. And the second thing which all of you will need when you scroll down below is that you will need access, or you will need your API keys which we used in LangFuse. So LangFuse, if you remember, was the workflow which we covered in I think lecture 3 and lecture 4. Here is where we are going to observe our LangGraph agent. So if you have your public key and secret key from LangFuse, you just have to paste it over here. How many of you have these keys from LangFuse, which we had covered in one of the previous lectures? All of you should be having these keys because if you have these keys, you should very easily see the observability now. Setting this up for the first time, it takes time, but once you have the keys, you can directly use them here. So let's get started with the examples. In this notebook, we are going to set up this LangGraph workflow. I would call this a very simple agent with minimum agency. A full agentic workflow will be our second code, which we are going to cover today. But in this notebook, I want you to get familiar with states. I want you to get familiar with nodes, conditional branching, and essentially how to run the entire graph. Only then we will be equipped to understand agents, because LangGraph is slightly more complex because of this graph-based approach. But once you understand how to make this graph, it will be very easy for you to assemble agents. So first, what we have to do simply is that we have to install packages. So here I'm installing LangGraph, LangChain OpenAI, and LangChain Hugging Face. You can install 3 packages. And while this is being installed, let me explain to you what we are going to do step by step below. So someone is asking for the Google Colab link, right? Let me share it to you once more. Yeah, so this is the Google Colab link. So these packages install pretty fast because LangGraph is very lightweight. As you can see over here, it does not take up too much space. Then what we can do is that we can import the OpenAI API key. And as I mentioned, our step number 1 is always to define our state. So pay very careful attention to the steps which we are following right now. The first step is to always define our state variables. And before even going to the nodes, before even going to the edges, nothing will function forward if you don't define the state. And as we have seen, the state, so we are going to create a class called email state, and every instance of this class will essentially be a dictionary. And what will be the elements of this dictionary? We have already seen this. It will contain all of these. It will contain the email content, spam, not spam, email sending draft, spam reason, etc. So you'll see that this has now 5 things. The email content, whether it's a spam reason, email category, email draft, and messages. This message is very important because this is kind of like our conversation history, which is stored. So as you are going through the entire graph, it's generally a good idea for you to store messages. It's like caching memory because your answers might improve if you have memory. So this you can think of as caching or having the memory. So this is the state. That's it. We have defined the state, and then we have to define our nodes. Remember the definition of nodes. Nodes are essentially just functions. So don't need to be confused by nodes. These are just functions, right? So as you can see, each node here is a function. It's a Python function. So the first email is read email. And what we are going to do, we are going to access our state and we are going to access this key called email. That will give us our email body. And then we are going to print out an AI agent is processing an email from the sender with this subject. So just to give you a sense of what the email will look, the input will look something like this. It will have a sender, it will have a subject, and it will have the body. So this body part is what we are actually storing as the content of the email. Um, so an AI agent is processing an email from email sender with subject as email subject. That's the first step, which is read email. That's our first node, which we have defined. Moving forward, the second node is classifying the email. Can someone tell me how do you think we should classify this email? What will we write? How do we do this classification task? So I can see LLM, right? There are multiple ways to do this task. We can use a classification model. We can use a decision tree. We can use a language model. Um, anything is anything is fine actually, but for the sake of simplicity, what we are going to do here we are going to use a language model. And that's why we have defined the OpenAI API key. This is again why I always mention that the transformer architecture revolutionized everything because a language model can now see my email and understand whether it's spam or not. If these were not involved, I would probably need to use a classification model or a decision tree, etc., or any other traditional ML techniques. But as I've seen here, as a professional email reader, analyze this email and determine if it is spam or legitimate and should be brought to the person's attention. And then I actually give the email. So as I showed you, our email has a sender, it has a subject, and it has the body. So the LLM has access to our email. And we have mentioned first determine if this email is spam, answer with spam or ham if it's legitimate, and then only return the answer. And then what do we have is that it is if it is not a spam, then we update our messages with the prompt to the LLM and the output of our LLM. If it is a spam, then we just store the is spam state essentially. So here in this function, which is classifying the email, what we are doing is that we take the message which is received from the human or the input message. We are going to do model.invoke messages, which means our LLM will run on this on this input message, and then it will answer whether it's spam or whether it's not a spam. And then we'll print the response text. The LLM would respond something that it's not a spam because etc etc etc. If it is not a spam, we are going to update our history. If it is a spam, we won't update our history. And then we are also going to update this is spam state. So remember here we have this is spam, right? We are going to update this based on whatever is the result of the language model. And then we are going to update the history also with new messages. So this function is actually doing three things. This is not only classifying whether the email is spam or not, but it's also updating the is spam variable in the state, and it's updating the history. So if you now scroll back here to our figure, what we are doing is that first we are reading the email, and then we are classifying the email. And after classification, our state, now as you can see, our state gets modified. So state gets modified as we flow through the graph. State gets modified as we flow through the graph. So here, after this function, the state is modified. Several keys of the state are modified, whether it's spam or not a spam, the history gets modified, etc. And then we can do the further actions. So the next step is that this is the second node. The third node for us is handle spam. So if it's spam, we don't have to do anything. We just have to print that the email has been moved to the spam folder. But if it's not a spam, then we have to connect an edge to this drafting response, right? This drafting response. So what the drafting response node actually does is that it gets the email body, and then we say that as an AI agent, draft a polite preliminary response to this email, draft a brief professional response that the person can review and personalize before sending. So this is like the assistant is drafting an email to the manager saying that you have received this email from this person, and not just that, they're creating a first draft of the response, and then the manager can just quickly edit and submit. So here again the same thing, human message, the content will be the prompt, and then the response is added, and the response is added to the history. So again the messages of the state are updated, and one more variable of the state is now updated, which is the email draft. The email draft is updated and the messages is updated. So after this so messages are updated even here and here because the history is updated every single time. But after this drafting response, that particular variable is updated. So if you scroll up and see the state, this email draft variable is now updated with our draft response. So this is the drafting response function. And now I think we have written all the functions which are necessary except for this last function, which is notifying the manager. Here we have to say that, hello, I am your agent. You have received an email from this. I have prepared a draft for your review, and then the email draft. So this is the final email sent to the manager saying that I am your AI agent. You have received an email from the sender. I have already screened that. So we can write here, I have already screened that it's not a spam. And then I prepared a draft response for your review. That's it. And then one more thing which is there, it's the routing logic. So routing logic, essentially what it does is that we will need the routing logic at the place where the conditional edge is there. So we have conditional edge number 3 and edge number 4, right? So the routing logic is that you check the state and especially check the is spam. If it's spam, then you return spam. Otherwise, you return legitimate. So if it's legitimate, we'll actually call this drafting response. But if it's spam, then we'll actually do handle spam and end. So this is where we write the routing logic. This is how conditional statements are handled in graphs, right? And then you define a state graph and you add all the nodes. Here we have added 5 nodes: read email, classify email, handle spam, drafting response, and notify Mr. Wayne. So notify the manager. These 5 nodes have been added to the graph right now. But remember, we have not created edges until now. Until now, we have only created nodes, which are the functions. And if you see, every function is doing a couple of different things. So if you now just take a look at the functions or the nodes over here, it's not just simply doing this task. So for example, this read email is the simplest of all functions because it's actually just only reading the email. But classifying the email is it's updating the state and it's updating the history. Handle spam is also simple node, but draft email is not very simple. Draft email is updating the state and it's also updating the history. And notify person is also simple. It's just sending the email to the person that I have prepared this draft for you, etc. So state needs to be updated. If state is not updated, then this routing also will not take place because only when the state is updated, we know whether the email is spam or whether it's not a spam. Now, the final thing for us to do after defining the nodes is actually a very easy thing, and it's one of the main advantages of LangGraph, I think, because it's very easy for us to define our edges now. It's just very visual, right? Once you have created this visual workflow, you know there has to be an edge between the start and the read email. So that's what you write here. You create an edge, you add an edge between start and read email. Then you add an edge between read email and classify email, which is this edge, and then you create a conditional edge. So direct edges is just adding a add edge, but to add a conditional edge, the statement is add conditional edges. And then you add conditional edges, which is conditional edge from classify email. And it will first use the route email function. And remember, route email returns whether spam or legitimate. So if it's spam, then we actually go to handle spam. If it's legitimate, we go to drafting response. So it's these edges which are now created. And then finally, we add an edge between handle, spam, and end, which is this edge. We add an edge between drafting response and notify Mr. Wayne, that's this edge. And the last edge is adding the edge between notify Mr. Wayne and end. It's this edge. So that's how we have added every single edge over here. But you see how visually intuitive it was to add these edges. Otherwise, if we are using LangChain, we'll have to write if-else statements. We'll have to write if-else statements. It would have become very difficult for us to keep track of every single thing. But once you visualize the Lang graph, it's just, these look like just English statements, right? You just have to keep in mind add edge and you have to keep in mind add conditional edges. That's it. So you can run this now. Email graph is not defined. Okay, I don't think I ran the previous node. So you can run step number 2. Step number 3 is defining our routing logic. Actually, here we have defined the routing logic and add edges. And then finally in step number 4 is where we create the state graph. So in step number 4, what you do is that you have this email graph and you just do email graph.compile. And one cool thing about LangGraph is that you can actually visualize your graph here in code. So if you run this code cell, you will visualize this entire graph like how we are seeing it on the Miro board. So whatever you're seeing on the Miro board, Python has exactly parsed it into the same thing: start, read email, classify email, handle spam on one conditional side, drafting response, notify Mr. Wayne, and then end. That's it. Our graph is now compiled. As the last step, what we need to do is just take our input, is to give input emails for testing. So we create two types of emails. We create one legitimate email. So what I've done is that, let's say Cognizant AI potential partnership. We would like to explore a potential partnership collaboration with Visuara. Do let us know a good time to reach you. This is a good email, right? This is a legitimate email. But here it's crypto bro, the best investment of 2025. This is definitely looks like a spam. So I'm going to test these two emails. The way to test this is just, once we have done the compiled graph, right? We have compiled graph. We just do compiled graph dot invoke. So we invoke the graph for this legitimate email and we invoke the graph second time for the spam email. And when you invoke, you have to pass the state variables. So initially, when we define the state, it's only the email which we have, right? None of these other categories are filled. This will be filled when one particular node will be called. This will be filled when one particular node will be called, etc. Initially, when we pass the input, we have no information about these other state variables. So these are my inputs right now, and I have defined two emails and I've invoked the graphs. So let's see the result right now. So processing a legitimate email. An AI agent is processing an email from Cognizant AI with the subject potential partnership. The agent has decided this is ham, which means it's not a spam. And then, hello, I'm your AI agent. You have received an email from Cognizant AI. It's like I am receiving this email now from my agent. I have already screened that it's not a spam, and I've prepared a potential draft response for your review. Thank you for reaching out to us at Vijwara. We are excited about a possibility of collaborating with Cognizant AI. Could you please suggest a few convenient times? That's great, right? So now my time has been reduced. I can directly take this email. I can edit out a few things and I can send it. But the second email is this. For the second email, AI agent is processing an email from crypto bro with this subject. Alfred or has marked, or I should write here, AI agent has marked this email as spam. The email has been moved to the spam folder. So see, when the email is actually spam, we don't do anything with it, right? We just do handle spam, which is the text that the email has been moved to the spam folder. And then we return it. So when I teach you in the next code how to use tools, you can simply add the Gmail tool over here and put it in the spam folder of Gmail. So it's as simple as that. But I hope now all of you have understood the workflow of the NES, nodes, edges, and state. How many of you have reached until this part of the code? Can you let me know in chat whether this is working for you as intended? So for me, it gave the correct responses, but I want to see. Okay, I have. Okay, good. So for all of us, the responses seem to be correct. This is an example of all the LangGraph agents look like this. Whether you are assembling a simple agent or whether you are assembling a complex agent, at the heart of it, they have the node, edges, and state framework. You have to very carefully define though what every node does, how it has to update the state, and you have to carefully define the conditional edges, and so that it handles the conditional logic correctly. Now, as you can see here, we have not really added tools in this particular example, but I am going to show that in the next example. Before going to the next example, as always, we have to inspect using LangFuse. Now, I am doing this in every lecture because I want to drive home the point of evaluation, right? And I will keep on iterating this because I think this does not receive too much attention really. Because when you work on industrial projects, this is the most important thing a client really cares about. They don't care which framework you have used, etc. They want to care about whether the agent is performing well on their data, on the test data or not. And for that, if you don't understand evaluation observability, in fact, it will be very difficult. So for example, today we are going to again set up an observability framework through LangFuse. Now we have done it so many times that after this, all of you should have mastered this. So there is a question in the chat about Langsmith, right? Langsmith is also very popular. And once you understand LangFuse and LangFuse and Arise Phoenix, all other frameworks look exactly the same. So if you see yesterday, what we saw with Phoenix looks exactly same as this, right? These are all competing products at this point. As long as you know how to use one or two products very well, it's good. So here again, we are doing LangFuse so that you can practice more. So here you can install LangFuse, and as you scroll down below, you will see that here is the point where you have to enter your public key and your secret key. Now, I am not going to show how to get these keys again because I have already shown this before, but just for a very quick demo, you can go to LangFuse, and whatever project you have, you can go to project, and you can go to settings, then you can go to API key. And here what you can do is that you can generate a new API, create a new API key, and here you will get your secret key and you will get your private key. Then what you can do is that run this. This is the public key and this is the secret key. And here what we are doing is that we add a LangFuse callback handler. So once you have the callback handler, you call the same thing. So if you see legitimate result, we did compiled graph.invoke earlier also, right? So everything remains the same. The only difference is that we add this config. We add this config over here, which is a callback to the LangFuse handler. That's the only thing which changes. So here we indicate LangGraph that we are connecting this with LangFuse. So you can run this right now. Let me see on my dashboard whether I am able to actually see the traces on LangFuse or not. So I'm just going to go to my LangFuse portal right now. And I'm going to share my screen. Okay, so see here the time is 3 p.m. over here, 46 seconds, and I have seen and 3 p.m. and 43 seconds. Why do I see two traces over here? The reason I see two traces over here is because I'm running two input examples, right? So if you see the first input here, you can exactly see what framework our agent followed. We started read email, classify email, then it was not a spam. So it drafted a response, notify Mr. Wayne and end. That's the framework which we followed. And here you can see that it was classified as not a spam, and then the email was also drafted and sent to the manager for review. But if you see the second email now, let's see. If you see the second email now, that's the spam email. So if you see the graph for this is very different, right? And here you can actually move around this graph. So I'm moving this right now. Here you can see that start, read email, classify email, handle spam, and end. This graph is very different than the second graph which we saw, which was for not a spam. So here it was classified as not a spam. But this is the advantage of using an observation platform. Because now if I'm explaining it to a client, rather than showing it through a Google Colab notebook, it's much easier to show it over here. Because here if you see the response is aggregated in a much better manner. Um, okay, so this is LangFuse and now we have seen it multiple times before. So those of you who are not able to see this trace, you might just need, you must not have configured your API keys correctly. So just check that once after this lecture is over. Now what we have to do is that we have to move to the next part of today's lecture, where we are going to equip our agent with tools. Um, so let's see, there is a question, does order of adding nodes edges matter at all or just the correct edges? No, order matters a lot, because if the ordering of the nodes and edges is not correct, the agent can get completely confused. And it's upon the user to make sure that the order is correct. I'll show you that in the next example. We are now going to define the tools in a very smart manner. And there, if the order is not correct, then the agent, as you have mentioned, might go into a loop. And cyclic graphs are fine, right? We are going to design a cyclic graph right now. I'll show you how to design a cyclic graph. So if you are to enter a thought action observation framework, by default, you have to mention cyclicity somewhere. The only question was that how to integrate this thought action observation loop into our state edges and nodes right now. So currently I showed you these nodes, right? That's fine. But how do I integrate a thought action observation loop over here? That's what we are going to see in the next code. Why are we seeing the traces? What is the use judge as LLM? Okay, so this I explained in the previous lecture also, right? Evaluation has two components. Without observing something, it's impossible to evaluate something. So observation is one thing and evaluation is the second thing. And in one of the previous lectures, I've also showed you how to set up evaluation dashboards on LangFuse. So once we observe, what we can do is that we can go to LangFuse and we can go to evaluation. and we can set up an evaluation dashboard. I've shown you how to do this. You have to create an evaluator. You have to first set a default model. Here you will need an API key to set up the default model. But once you set up the default model, you can select the relevant evaluation metric which you want out of these. And then you can hook it up with your output, with your agent output. But there are two sides to this. Evaluation does not make any sense without observation. And typically observation is far more cheaper than evaluation. So you definitely need to have observation set up first. All right, now let me ask you this question that, let's say, so this is the first example, right? The second example which we are going to build is that we are going to build a vision assistant agent. We are going to build a vision assistant agent using LangGraph. So basically what the vision assistant agent will do is that it will look at an image and then it will print out what's present in that image. So the task itself is pretty simple, but the way we are going to set this up is using a slightly different mechanism. So first, let me ask you, what will be the state over here? In this example, in the second example, which we are going to see, now you have understood about state, node and edges, right? What will be the state in the second example? Image, correct. So all of you who have got this answer are correct. So the state is the image. What about the nodes? What will you need as functions? I can see some answers such as load image, classify image, scan image, image classification, etc. So um, for nodes, what we can do is that we can just simply have an LLM like what we did before. But that's not a good thing because in the code which we have seen right now, we did not have a thought, we did not have a loop. I want to now integrate my tool. So we are going to use an LLM itself. My question to you is that how can we integrate a loop? Which means I don't want to run the LLM once and stop. I want to run the LLM in a loop until I get to the right answer, like the thought action observation framework. How do we do this in a graph kind of a structure? Loop counter via edges prompt. So the way LangGraph actually does this is very, very smart. And I've seen this pattern enough times for anyone who is defining agents with LangGraph. The way they do it is that they actually define two nodes. They define a tools node and an assistant node. So the way this happens is that there is an assistant node. The assistant node essentially is connected with my tools node. And the other node is connected to the end. So the cool thing about this is that the assistant node and the tools node are connected in a loop. And this is where that thought action observation framework is executed, because what we can instruct is that the assistant node keeps on calling the tools node until a certain condition is satisfied. If it is satisfied, we can go to the end. So that's how we can exit it and we can prevent this from becoming an infinite loop. But if you see, if you just have a tools node, let's say you just have a tools and you have an end. There is no way to make this into a loop, right? So what people figured out is that you just have another node which is an assistant node. So if you think about it, the assistant node is nothing special, but the assistant node can make calls to the tools node if it thinks it's necessary. So the assistant node gets the output from the tools node, that's the observation. Based on the observation, if it realizes that it needs to call the tools again, it goes into this loop again and again and again until it's satisfied. And in this tools node, essentially, you can add all the tools which you want. The query engine tool can be added here itself. The archive tool, which we saw last time, can be added here itself. The web search tool can be added here itself. So all the tools can be added over here. And by defining this kind of a loop graph structure, we are simulating the thought action observation framework, which we learnt about in the React definition. And the assistant node is not really an LLM. The assistant node has access to an LLM. So it can make use of the LLM to decide whether the answer is correct or not, or whether it needs to enter into a loop or not. So you can think of the assistant node having access to an LLM. The assistant node is not just an LLM. It needs to have access to an LLM, and this is a conditional. So this is a conditional edge over here, which means we can decide where to go, either to go here or to go here. We don't know. That depends on what the assistant node decides. If the assistant node decides that we don't need the I don't need the tools anymore, then it can end it. So if the assistant node gets an answer, it can end it. But if the assistant node thinks that I need a query engine tool, that's good. Then it again thinks that I need the archive tool, then it goes back here. It again thinks that I need the web search tool. So we can keep on going in this loop until the assistant node is essentially satisfied. So that's how the agentic kind of a thought action observation loop is integrated within LangGraph. And here again, the graph-based structure helps a lot because the thought action observation is a loop, right? And through this kind of, you can simulate a similar loop over here by a bidirectional graph. So this is nothing but a bidirectional graph between two nodes, and that simulates the thought action observation loop. That's one link between LangGraph and the React uh, thought process which we have seen. And any kind of agent which you see using LangGraph, all types of complex agent, if you want that agent to have access to tools, the way you can do this is to set up the assistant node and make it go in a loop with the tools node. And now we are going to see a code for this. So let me share that with you. Okay, so before sharing the code, I just want to make sure if there are any API keys which have been exposed. So I'm just removing those and then I'll share the copy. Yeah, so now I'm sharing the code in the chat. This is the code file. You can try to open this right now. Actually, along with this code file, you will also need one more image, which I'm sharing now on the chat. So I've shared one image on the chat. It's essentially an image related to Batman. You can use any image which you want. You can download this image. We'll need it at a particular point in the code. I'll tell you when. So again, I'm sharing my screen right now. Okay, so I have actually divided this into part one and part two. I don't think we'll have time to go through part two today, but I'll share that code with you. I'll explain what part two is later. So first, let's do the same thing. We'll have to install LangGraph. We'll have to install LangFuse. Um, let me, and then you will need API keys. So for example, yeah, you will need OpenAI API key. You'll need LangFuse public key. You'll need LangFuse secret key if you are connected to LangFuse. And then you run this. And on the left hand side, you will need to upload the image which I've shared on the chat. After this lecture is over, you can replace the image with any image which you want. But here I have named it as Batman training and meals.png. So just add any image which you want over there. And again, these are the same LangFuse credentials which you are using. So you don't need to change this because for the entire duration of the bootcamp, it's fine if you see all the traces in one place. Later, it will be useful for you when you revise this entire content. So now I have installed all of this. The next step is again the same LangFuse handler. And this is where we are going to define the tools. So remember the first tool which we are going to use is the vision. We need to extract the extract text from the image, right? So that's going to be one tool. And I'm going to define the tool as extract text. And remember, this is just a simple language model which can understand what is present in the image. So I'm going to define a vision LLM, which is OpenAI GPT-4o, which can essentially take images as the input. And what I've written in this function is that it just extracts text from an image file. That's it. So I've given a prompt that extract all text from this image, return only the extracted text, no explanation. That's it. So this is the first tool which I have, which is extract text tool. And the second tool which I've randomly added is a divide tool, which divides two integers. So here the reason I've added this random tool is to show you how easy it is to keep on adding different tools to the set of existing tools which we have. So these are the two tools. And then what you can do is that you can bind the tools to your LLM. This means that now we have an LLM augmented with the tools. Um, and here you see there are multiple things which you can specify over here. This LLM.bind tools, it's a great function because you can mention if you want the tool calls to be done in parallel or not. I remember someone was asking in the chat one day that do we need to use these tools sequentially or can we use it in parallel also? So you can set this to true if you want to make the tool calls in parallel. And if you want to force the tool usage, you can even set that to true, which I have not done because I don't want to force any tool. I want to, I want the assistant to decide whether it needs the tools or not. And then as all of you mentioned, we are going to define the state. The state is just going to contain the input file. And then we are going to define the assistant. So when you just see this code for the first time, you might think, why is this assistant defined? There is a very good reason for why this assistant is defined, which I already explained to you over here. So the way the assistant node is now defined is that the assistant node is has access to all the tools. The assistant node has access to the extract text tools and it has access to the divide tool. And here we have mentioned you are a helpful agent that can analyze some images and run computations with the provided tools. That's it. So this is how we have defined the assistant agent. It's as simple as the fact that the assistant agent has access to tools. That's it. So if you see over here, here I've explained in English language why we need the assistant agent. The assistant node is just our model with tools. We will add a tools condition edge. So we connect the tools back to the assistant, forming a loop. This step is the most important step to really understand how tools work with LangGraph. So after the assistant node execute, tool condition checks if the model's output is a tool call. If it is a tool call, the flow is directed to the tools node. The tools node then connects back to the assistant. And this loop continues as long as the model decides to call tools. If the model response is not a tool call, the flow is directed to end, terminating the process. So as we have explained over here, the assistant node will essentially make tool calls till the point it realizes I don't need to make tool calls anymore, and then we end it. And the assembly of this graph is very interesting. So if you print this out, you'll see the way we have assembled. I don't think I ran this. If you print this out, you'll see the way we have assembled this graph. See, it's as simple as this. You start, then you have an assistant. So you have an edge between the start and the assistant. Then you have an edge between assistant and the tools. So these are nodes actually. I'm just adding nodes for now. The assistant node and the tools node. Here is where we are creating the edges. We create an edge between start and assistant. Then we add a conditional edge. We have a conditional edge between assistant and the tools condition. So if the latest message from assistant is a tool call, tools condition routes to tools. If the latest message from assistant is not a tool call, tools condition routes to end. So remember, this tools condition is a function defined in LangGraph itself. We don't need to define it otherwise. This I have not defined anywhere in the code. This is given by LangGraph itself, which automatically checks whether tools are called or not. So if tools are called, basically the tools condition is positive and then you keep on using the tools. If tools are not called, the tool condition is negative and then you don't use the tools. So this is how we have assembled our graph, and you can check this graph now versus what we had assembled in the first code. Um, in the first code, the graph we had assembled looks something like this, right? And although this looks more complex, I would argue that this is equally complex. The reason is because the tools are now being used in a loop. So it's a very powerful thought action observation framework which we have. And now you can just do graph.invoke like we did previously. We first compile the graph. So the same steps are now followed. You compile the graph and then you invoke the graph. So we compile the graph over here, which is this. And if I ask for some simple thing like divide 6790 by 5, here of course it will only use the division tool, right? So if you see the tool calls which are made is only the division tool right now. But now let me actually check whether this agent is working or not. So I'm going to give this image. This image is what I have attached in the Zoom call, and it essentially contains a eating regimen. So if I type here, according to the note provided in the images, what's the list of items which I should buy for the dinner menu? And here I actually give the input file as the image. So that's now the state of my graph. And remember here I have connected it with LangFuse. If you don't connect it with LangFuse, you don't need this callback function. So you can run this right now. And this will use the second tool which we have, which is essentially the multimodal language model. This does take some time to run because we are actually extracting the text from the image. But at the same time, if any one of you is connected to LangFuse, you can keep monitoring your response over there. And here, if you print out the messages now, here you can see that. See here, the tool call is the extract text, which is that particular tool which is being used, and we see the tool message, which is the training schedule. Then the diet also is given over here, which means that we are able to correctly extract what is mentioned in the image. Breakfast, lunch, etc. And now we can also actually go to LangFuse and see the traces again. So here I am going to LangFuse, as you can see, and I will refresh this. And I'm seeing the traces here. So see, this was the first thing, divide 7690 by 5. Uh, that's just a simple division which was used. But now the second is this, where we had um, the we were trying to understand what is present in the input image. There is a question in the chat about the tools condition, right? Can you explain how the tools condition is updated? Yeah, so let me explain that. That is probably one of the most important points in the lecture. So this tools condition over here actually makes all the difference because so if you scroll up here and see at one point there will be a tools condition. Yeah, this tools condition is the most important because the assistant actually decides whether a tool call is needed. So let's say if the assistant state is that I need a tool call, then the tools condition would be converted to true and automatically will route to that particular tool. So you can think of the tools condition as a gatekeeper to use the tools, and who decides whether the gate opens or not, that's decided by the assistant. The assistant can essentially take a call uh, related to whether you want to open the gate or whether you don't want to open the gate. And the way that is done, the gatekeeping is here. If you see builder.add nodes, here is also, as someone has pointed out in the chat correctly, you have tools, comma tool node, and then tools. So that is important. Okay, so this is related to how the tools condition is updated. Now what I want to do is that I want to make a slightly more complex request over here, which is according to the note provided, what's the list of items I should buy for dinner, count the number of items and then divide them by 50. Give me the resulting answer. Don't stop till you have integer answer. So here I have given this statement deliberately so that we can use multiple tool calls. I don't know whether the agent will use multiple tool calls or not, but I've deliberately given an input statement which is slightly more complex. So earlier we just had analysis of the input images, right? But here I have asked count the number of items and divide them by 50. Give me resulting answer. Don't stop until you have the integer answer. And here I'm hoping that the agent will make multiple tool calls. And instead of seeing it here now, what I want to do is I want to see this in my LangFuse. So I'm going to LangFuse again, and I want to see this. Yeah, so this is a more complicated question, right? And here, did you see this part? Did you see these multiple loops over here? There are two loops, right? As you see, there is one loop and then there is a second loop. This was not present in the previous LangFuse. In the previous example, there was only one tool call. But now there are two tool calls which you see here. And as the question gets more complex, it will be more and more and more. This is a very beautiful visualization to see. And this clearly, we can clearly see the thought action observation framework in action over here. Because in the previous case, if you see, there was only one tool call, right? There is no loop over here, but here is where we have multiple tool calls. And I believe that there were multiple tool calls because see, this is the tools condition is also tracked over here, tools condition. And as long as the tools condition returns some tool, we will be calling tool. So there are two tools here. If you see, extract text is one tool, and there is also the divide tool. We have given two tools, extract text and divide, and both of them are utilized over here. That's the reason why we see here two loops, because the agent figures out that I should not exit this loop until both my tool calls are covered. How many of you are able to see this on LangFuse? This is a very important visualization because if you see this, you will never forget it. Here we see no such thing, right? That's another advantage of observability frameworks. To all of those who have seen it, it's great. To all of those who are not able to see it currently, please try to make LangFuse work. It might be an API key issue if it's not working for you at the time. Okay, and the last thing which I've written is that what's the list of items I should buy for the dinner menu, then send an email to the recipient email with the list of items. So this I've just created randomly. And this is actually a good segue for the part two of this Google Colab notebook. So I won't have time to go completely in part two, but what I will be doing is that I'll be sharing this part two notebook with all of you. So what I did in part two is, oh, I need to sign in first probably. In part two, I have actually sent emails. So I'll tell you what I did in part number two. Again, I'm making the copy of this notebook so that I don't expose the API key. Okay, now the copy is made, so I can share it with. Yeah, I've shared the part two notebook with all of you now. Okay, so now let me share my screen once more. So what I figured out in part one is that, okay, this is fine, but when I added this last request, my last request was send an email to the recipient with the list of items. So I thought, what if we can actually send an email? So I wanted to get an actual email. So let me show you what the output of part two is. If you run part two, and I'll tell you how to run part two, you will actually get an email in your inbox. So yeah, if you run part two, you'll get an email like this. So this is an email which I actually got in my inbox, which is based on the part two code which has run. And that's pretty interesting, right? So I've made some changes in part number 2 essentially, which makes it a bit different than part number 1. I hope all of you can see the screen now, which is part number 2. So the thing is that, let's say, let me first ask you this question. If you get this recipe, which we have obtained in part 1, and if you want to email it to yourself, what will you change in the code? So this recipe which you have obtained now, if you want to email it to yourself, tool, right? So all of us agree that we need an email tool. So that is exactly what I've integrated. And the tool which I've used, which helps me to send an email, is this tool called SendGrid. So this I won't fully show you right now, but it's actually very simple. You just go to sendgrid.com. You create an account over here. And then when you create an account, what you'll see is that on the left-hand side, you'll see settings and you'll see API keys over here. So you create an API key. And this is the API key which I have mentioned over here. This is my SendGrid API key. But you don't have to stop here. What you have to do is that you have to go to sender authentication and you have to essentially add the email from which you want to send that email to. And you can also add receiver authentication over here. So the email where you want to get that email, that also needs to be verified. And once you do both of these steps, then you will need to add, that's it. Then you need to add the tool. Now let me ask you, where will you add this tool? Actually, over here. Yeah, where will you add this tool? Let's say you make that email tool. Yeah, correct. So as many of you are saying, there are two steps which are very important in the code which I just showed you. Not one step, but two step. The first step is this LLM tool binding. So if you see over here, this is the most important or one of the important steps in the code where you can bind a tool to an LLM. And then you can add this tool to the assistant node essentially. That's exactly what we are going to do. So if you see in the part 2 code, what I've done is that here is where I define the send HTML email and I mention the sender as this. This I've authorized. Actually, you don't need to authorize the receiver. You just need to authorize the sender, I think. So here my sender is verified. And this is the receiver which I've added. And the subject is dinner shopping list. So this is the second tool which I've added now. The only thing which you need to change is that this LLM with tools. So the tools which you bind to the LLM now, it has these tools which are, this has the divide, this has extract, and it has send HTML email. This has three functions, right? Earlier we just had two functions. So make sure that you have three over here. So whenever you want to add more functions, you just do comma and keep adding more functions over here. This is one place and then that's it, because now the assistant, in the assistant, you have to mention that you also have access to this tool. So earlier we only had this much, right? Then you have to mention that the assistant only has also has access to one more tool, which is send HTML email. And then finally you just build this, and the beauty of LangGraph is that this graph actually is the exact same, right? Nothing changes. It just that in the tools we have added one more tool now, which was not added previously. And then when you actually send an email, you will actually see the thing that the email has been sent. And that's really very great to see. I don't know if I have the tracing for it here right now. I think I had it. Um, Probably. Yeah, I had seen the trace for this and it actually has multiple loops because you also send an email, right? So it looks great on LangFuse. This is a simple code to run. All of you just need access to uh, these keys. You need access to SendGrid API key, OpenAI API key, LangFuse, secret key and LangFuse public key. That's all. Everything else is exactly the same as what we have seen in the previous part 1 code. So essentially what we covered in today's lecture is starting with a simple concept of nodes, edges, and states, we can slowly build up the complexity to make very difficult projects. So first we build this email sorter and sender. Second, we built a vision assistant agent. The part one is just a simple vision assistant agent, and part two is advanced vision assistant with email sending. Now, what I've done is that since LangGraph lecture is over, there are some advanced projects which I will add for pro plan registered people. There are three advanced projects. In fact, one is the resume checker agent. One is the end-to-end flight travel planning agent. This I've constructed through LangGraph. And the third is Agentic RAG event management. These projects I have finalized, and I'm making a private GitHub repository which will be accessible to people on the pro plan. Now the thing is, these projects you will now find it much more comfortable to understand and go through. These are industrial scale projects, and the code will look pretty long when you see it. But you will not be scared of it now, because ultimately it all boils down to the same thing. Here there will be more tools, here there will be more loops and more conditional edges, but the core of it remains exactly the same. The core of it does not change. There will be state, there will be nodes, there will be edges, and there will be loops. There will be loops like this. This is an important concept to understand, because unless you understand this, you won't understand the link between the thought action observation loop and how agents are used in LangGraph. So this I'll be sharing after the bootcamp is over with all the people in the pro plan. So you can execute these projects and you can even add it to the resume if you want. So let me do a quick revision of what all we have learned today, because again, today's lecture was quite long. First, when do you use LangGraph and when do you use LangChain? That's extremely important. And you may forget the technical details after 3 months or 4 months, but you will not forget examples. So if you are ever asked this question in an interview or anywhere, just think of the example which we have seen. What's the issue with the linear framework? It's difficult to handle conditional statements. That's why for non-linear frameworks, it's better to have a graph-based structure where it's easy to add conditional statements, and state persistence is also better in graph-based frameworks. Then LangGraph is built on three main pillars: nodes, edges, and states. So if you forget these three, just remember NES, nodes. So you can think of it as north, east, south, NES. So nodes, edges, and state. And nodes, so start thinking from the state. So in our email sending project, the state was the email. Edges were the functions such as reading email, drafting email, sending email. No, nodes were the function. Sorry, state was the email body, whether it's spam or not, etc. Nodes were the functions such as sending email, drafting email, etc. Edges are just the connections between the nodes. So edges connect different nodes together. Then what we can do is that after you understand the nodes edges state framework, then the door is open for building any sort of a simple agent, but still you don't know how to add tools to it and how to enter the thought action observation framework. One way around this is to just define assistants and make the assistants go into loops. If you want multiple agents, you can define multiple assistants working together. Whereas, so if one assistant has 8 tools, that's not very good utilization of this assistant, right? Because as we have seen before, it's better to split tool usage among different agents. So then you can have different assistant nodes connected in whatever your decision workflow is. That's also possible. And then finally, we saw that it's actually quite easy to keep on adding tools. The way to do that is that you just change the tools which are bound to the LLM. Here is where you change the tools which are bound to the LLM. You can keep on adding as many tools as you want. And then one more place where you have to change it actually is when you define the assistant. This you can think of like a manager agent. So you have to tell it which tools does it have access to. And then finally, for all the LangGraph based agents, you just have to do graph.invoke. So first you have to do builder.compile. So you have to compile it and then you have to do graph.invoke. That's it. And then you go through the entire workflow. So this is a bit similar to agent.run, which we have seen in Smolagents, which we have seen in LlamaIndex now also. So thanks everyone. This brings us to the end of today's lecture. The next lecture which we'll be having will be our ninth lecture that will be on CrewAI. Lecture number 9 again will be held tomorrow, and that will be held at 2 p.m. IST. And after that, we have one last lecture which is remaining. In that lecture, we'll cover n8n, we'll cover MCP, and we'll also build several workflows using n8n, etc. So this last lecture will be covered by Dr. Sridath, which I think many of you are aware of. He also completed his PhD from MIT. I'll introduce him before he joins the last lecture so that he can take so we can take this forward. Yeah, this LangGraph is extremely powerful. So the framework which I've introduced to you today can serve you for any type of project which you want to build in enterprises also. This is an actually enterprise level framework. This is not for building toy projects. You can build toy projects in small agents, but for industry level projects, LangGraph is the best framework to use. Tomorrow, we are also going to see another industrial-based multi-agent framework, which is CrewAI, which is also incredible. And there, the amount of coding involved will be way less. So LangGraph is a pure code-based agent, right? But pure code-based agentic framework. CrewAI is much simpler. So don't worry, tomorrow's lecture is not going to be as complex as today's one. But today it had to be a bit complex because otherwise uh, it's difficult to understand. And once you understand these things, it is simple to build the line graph. So tomorrow we'll build multiple agents through CrewAI. I look forward to seeing you in tomorrow's lecture. Thank you, everyone. See you. Bye. Okay, so let's get started with today's lecture. Today is day 9 of this bootcamp, and we have two more lectures now remaining. This lecture and one last lecture, which will be held tomorrow. So today we are going to learn about another AI agentic framework, and that framework is called as CrewAI. So first, let me ask how many of you have heard about CrewAI or have used it? I can see in the chat that many of you have heard it. Some of you may not have heard it, but this framework has become really very popular in the last couple of months. And I'll explain the reason for its popularity today, how it differs from the rest of the frameworks which we have learned in this bootcamp. And today we are going to code two projects using the CrewAI framework, which you can add to the list of projects you completed during this bootcamp. Today's lecture is also not going to be as complex as the last two lectures. So the last two lectures which we had, Agentic RAG and LangGraph, were quite intense. Both of these lectures were around 100 minutes long because both of these involve coding frameworks. Today we are going to deal with a low code framework, which is CrewAI, and I'll also explain why I call it low code. So this lecture is going to be easier compared to the previous two lectures. Before we get started with CrewAI, let me do a quick recap of what all we have covered in this bootcamp so far. And if you are on the pro plan, you should definitely go through all the Substack articles which have been published because those are directly related to the bootcamp content. So for example, this is the first Substack article that's about day number 1 of the bootcamp, where we studied about LLM agents, agency of agents, and main papers which have given rise to the field of agents. Then is the day 2 of the bootcamp, where we studied about large language models. So day number 1 and day number 2 were introductory lectures, understanding agents and language models. Day number 3 is when we learned about the thought, action, and observation framework. So this is one thing which should always remain in all of your minds after this bootcamp is over. Even if you forget many things, this thought, action, observation loop is at the heart of what makes agents really very different from language models. Due to this loop, agents can plan, they can make decisions, and they can also interact with the external environment. And again, in lecture number 1, we have covered the definition of an agent. So never forget this definition. Agents take you from point A to point B and they add value to your life. They can plan, take decisions, they have access to tools. They can also interact with the environment and have memory. And the underlying foundation of agents is language models. And in day number 4, we looked at an overview of the types of frameworks, the coding frameworks, the low code frameworks, and the no code platforms. And in coding frameworks, we have covered LangGraph, LlamaIndex, and Smolagents. We have had lectures on all of these three topics. In low code frameworks, today we are going to learn about CrewAI, and tomorrow you are going to learn about n8n. And then we actually had two lectures on small agents. In the first lecture, we covered tool calling agent versus code agent, vision agents. And in this lecture, we also looked at LangFuse actually. So just read through the Substack article of this lecture to see what we covered on day number 5. On day number 6, we built multi-agent systems using small agents. And this was our first time where we understood the difference between just having one agent and giving it all the tools versus having multiple agents, such as a manager agent managing a group of agents. And we saw that this leads to better memory division, it leads to better answers, and this also leads to efficient token usage. This was essentially day number 6. And in day number 7 and day number 8, we covered two major frameworks. We covered LlamaIndex in day number 7. And here we understood the Agentic RAG framework. So we first looked at what exactly is retrieval augmented generation, the steps for implementing RAG, and we ran a code for this. After this, we saw the limitations of RAG. Essentially, it's just one-shot retrieval and generation, limited to one knowledge source, no use of external tools, etc. And then we learned about agentic RAG, which goes into this loop. Through learning about RAG versus agentic RAG, we also learned about LlamaIndex, which was my purpose of this lecture, to get you familiar with LlamaIndex as well. And finally, at the end of this lecture, we also learned about Arise Phoenix, which is another framework apart from LangFuse, which can be used for tracing and evaluation. Last lecture was probably the most complex lecture of this bootcamp, where we learned about LangGraph. We first saw the limitations of LangChain, then when to use LangChain versus LangGraph. Then we saw the NES framework, nodes, edges, and states. And we learned about what exactly these foundational principles mean. And then based on that, we built an email sorting agent. That's the first thing we did in the previous lecture. And after that, we also built a vision assistant agent. This I showed you in two parts. First, we built a simple vision assistant agent where I showed you this loop between assistant and tools. That's essentially the thought action observation loop, which makes agent special. And then I also shared one more code with all of you at the end of the last lecture, through which you can add tools such as an email sending tool. I continue to use LangFuse throughout the duration of this bootcamp. Now we won't be using, for the last two lectures, we won't be using any evaluation framework. But in 3 lectures of this bootcamp, we have now used some sort of an evaluation framework, either it's LangFuse or Phoenix. And again, when I say evaluation, I mean observation plus evaluation. Both things are equally important. Observation is cheaper and can be done faster. Evaluation is intensive, and you can either do human evaluation or using LLM as a judge, that type of an evaluation. Both of these evaluations are possible to set up in LangFuse. I've also shown you how to set up an evaluation dashboard in LangFuse. So yesterday we saw this tools assistant thought action observation loop in action once more. And this is where we are right now. So the reason I covered this recap is just for you, all of you, to have a understanding of what all has been covered in this bootcamp so far. So it sets the context for the last 2 lectures. Now, in the remaining 2 lectures, I want to cover some modern frameworks, which are actually simpler than what all we have seen so far. But the previous lectures were important so that you can appreciate why these tools have become so popular. So let's start with the first tool, which is CrewAI. Now, in LangGraph, I had to show you so much theory, right, before we started jumping into code. One advantage of CrewAI is that it's actually an extremely simple framework. But still, there are some foundational building blocks of this framework which are important. So essentially, to define agents in CrewAI, you need to define 3 things. And the way I remember it is CAT, cat. So first is agent. You need to define agents. You need to define the task which the agents perform, and then you need to define a crew. So crew is essentially a group, right? So that's why it's called CrewAI. And just as the name suggests, this framework has become extremely popular um, for developing or for building multiple agents which run together. And I'll show you why. But the reason it's called CrewAI is because you can assemble a group of agents together in a very efficient manner using this framework. So today we are going to do two projects. First is we are going to create a multi-agent CrewAI framework to research and write an article. And the second project is we are going to build a customer outreach campaign agent using CrewAI. Now, as we are building these projects, just remember that we have already done a multi-agent code. If you remember, this was our multi-agent code where we had the manager agent and where we plotted the Harry Potter locations and the cricket stadium locations. You remember, this was the entire code which we assembled. So here is where we split the task between two agents. We defined the web agent over here and we defined the manager agent over here. And ultimately it looked something like this. So there were some steps involved to define this multi-agent framework, but we did define it successfully. So then you might be thinking that if I can do multi-agent frameworks using uh, previous coding libraries, then why do I need CrewAI in the first place? And I hope that when we go to the Google Colab code file, the answer will be self-explanatory. So let's start actually creating this first project, which is creating a multi-agent CrewAI framework to research and write an article. Now, as I mentioned, the first step to create a crew is this CAT framework, right? Crew, agent, and task. First, we have to define an agent. So let me mark this with a different color. First, we have to define an agent. Then we have to define the tasks which every agent will do. And then we have to assemble a crew out of all of these agents which we eventually define. Now, when you define an agent in CrewAI, you have to essentially define three things. And the way I remember this is R, G, and B. So you can think red, green, blue, but R stands for role, G stands for goal, and B stands for backstory. So when you define an agent in CrewAI, you have to mention the role of this agent, you have to mention the goal, and you have to mention a backstory. The way we are going to create this multi-agent CrewAI framework to research and write an article is that we are going to have three agents. We are going to have a planner agent, we are going to have a writer agent, and we are going to have an editor agent. These are the three agents. And when we jump into code, we'll write all of these three descriptions for the three agents. We'll write a role, goal, and a backstory for the planner agent. We'll write a role, a goal, and a backstory for the writer agent, and we'll write a role, goal, and a backstory for the editor agent. So the planner, as you can see, it's already quite intuitive, right? The planner will plan for what you want to write. The writer will write a first draft. The editor will edit that draft and give the final article to you. This framework, once we make it, you can already start using for making LinkedIn posts, for making Substack articles, anything, let's say, which you want to monetize later. This can entirely automate that workflow for you. Once we define these three agents, we don't have to stop here. We have to define the tasks which each of these agents will do. So when we define tasks for every agent which we have defined over here, we need to define the description of the task. We need to define the expected outcome. And of course, we have to define the agent name. So if it's a planner, we have to mention what's the description of the planner agent, what's the expected outcome. If it's a writer agent, we have to mention the description and expected outcome, and similarly for the editor agent. And finally, it all comes together when we assemble the crew. So when we assemble the crew, we have to mention the agents which we have to mention the tasks which we have, and the most important thing I believe which makes CrewAI very special is this workflow. But before I get to the workflow, all of you can see this and you can see that it's so intuitive, right? This is exactly how we think in English language, how we can do tasks using these agents. So you first assemble three agents, you mention the tasks which they want to do, and then you form a crew of these three agents. That's it. And once you have this kind of a framework of CrewAI in mind, writing the code actually is straightforward. Before we jump into code, I want to mention that thing which makes CrewAI very special. And that thing is that you can actually define various types of workflows using CrewAI. Essentially, there are 5 workflows which you can define, and I'm going to explain all of these. First is a sequential workflow. Second is a hierarchical workflow. Third is a hybrid workflow. Fourth is a parallel workflow. And fifth is an async workflow. So you can assemble all of these agents in any manner which you want. And already you can start visualizing, right, what might be the differences between these. Sequential agents are ones which we have seen before. The first agent does a task, it hands it over to the next agent. The next agent does a task and it hands it over to the next agent. Hierarchical agent is something different. So there is essentially a manager agent which manages 2 agents. So the task is received by this agent, and then this agent decides whom to give the task to. There is no pre-planned sequence like in sequential agent. That's hierarchical agent. Hybrid agent is where you have mix of hierarchical plus sequential. So this part is hierarchical and this part is sequential. That's hybrid. Parallel is when you want multiple agents to be working in parallel at the same time. So let's say if there are 1,000 research documents, you can spawn or you can start 5 agents together, each of which can handle 200 documents in parallel, and then you merge those results together. Async is when basically each task is executed independently. So every agent outputs something at frequent intervals of time without waiting for a completion from the previous agent. So this sequential is also synchronous task, because after the first agent finishes, then only the second agent can start. But async is an asynchronous task, which means every agent is essentially working independently. So this first you can think of like a relay race. After the first agent finishes, it hands over the baton to the next, which hands over the baton to the next, etc. So again, here I've mentioned the flow type, the explanation, and a simple example. So if you compare sequential versus hierarchical, in sequential, agent A writes content, agent B edits it. Whereas in hierarchical, a manager agent assigns tasks to 2 employees, and then 2 employees are agents which do those tasks. That's a hierarchy. Um, Hybrid is essentially a mix of sequential and hierarchical. So a leader assigns tasks to 2 agents, and then in each of those 2 agents, you have a sequential workflow, let's say. That can be called as a hybrid approach of a multi-agent framework. Parallel is, as I mentioned, 2 agents independently research topics at the same time. And async is asynchronous. So agents post updates periodically regardless of other tasks. So in asynchronous frameworks, tasks are executed independently without essentially waiting for completion. Now you don't have to write any different code if you want any of these workflows to happen. You just mention it over here. When you define the crew, you just mention the type of workflow which you want. Whether you want it to be hierarchical, whether you want it to be sequential, whether you want it to be hybrid, parallel, or asynchronous. It's that easy in CrewAI. You can easily define the type of multi-agent orchestration which you want. So putting different agents together is also called orchestrating agents. So this process of defining the way you want different agents to work is called orchestration, and you can think of it like an orchestra, right? Let's say there are different musicians playing instruments. The order in which the musicians play, that can change, and that needs to be defined. So it's similar here. You need to define which agents does its task at what time. Does it depend on previous agents? Does it not, etc. So that's to be decided by the user who writes the CrewAI framework. So until now, what I've mentioned is theory. Now let's dive into code. So I'm going to share a code file now with all of you. So let me share this now. So again, I'm making a copy of this. Yeah, so I've shared this code file with all of you in the chat now. I would request you all to open this and let's start running the code file together. So essentially now what I'm going to demonstrate is what I've written in English language over here on the whiteboard is exactly how we are going to write this code. To execute this, you will need one thing, which is the OpenAI API key. So just paste your OpenAI API key in this place where I have pasted mine over here. So here is where you need to paste your OpenAI API key. This place over here. And actually that's the only thing which you will need to be able to execute this code. So let's start running it together. So one thing is important is that to install CrewAI, you need to have Python greater than or equal to 3.10. Otherwise it will not be installed on your system. So here is the main command where you are installing CrewAI. So I'm doing pip install CrewAI over here. It will show that install is not defined, but still the package actually does install. So don't worry if it shows this red line over here. It will take some time to install the package, but again, it's not very heavy. So it should install relatively quickly for all of you. Can you just mention if anyone has finished installing this package, you can share yes in the chat. I'll just wait till that much amount of time for us to proceed. So I can see that many people have already finished installing the package. Okay, for me, it's taking some time over here, so I'm waiting over here. But others who have actually finished this, you can start sequentially executing the rest of the code. So for me also, it's done now. So I've installed CrewAI and I'm moving forward now. So the reason I have showed this Google Colab in black color today versus the light background is because the CrewAI output which is there, it does not look very good in a light background. So that's why I've opened this Google Colab in a dark theme today. Yeah, so as I mentioned, you have to define three things, right? That's the cat framework which we saw. Agent, task, and crew. This is exactly what we are doing over here. We have to do from CrewAI, we have to import the agent, task, and the crew. And you have to run this, run the OpenAI key. And as I mentioned on the whiteboard, for every agent, essentially, remember agent, task, and crew, right? So first we have to define agents as we saw over here. And for every agent, you have to define a role, a goal, and a backstory. So that's RGB. Similarly, here I have mentioned that for every agent, we have to define a role, which is the agent's function within the crew, goal, which is the objective of the agent, and backstory provides context to the agent's role and goal. So in this code file, I'll also show you the importance of writing prompts in as much detail as you can. So the way you define agents in CrewAI is as simple as this. First, you have to define a planner agent, right? So this exactly looks almost like English language, right? You don't have to assemble any complex piece of code. Here, what I'm doing is I'm defining a planner agent and I'm mentioning the role, goal, and the backstory. So I'm mentioning that the role of this agent over here is content planner. The goal is plan engaging and factually accurate content on the given topic. I'll tell you where this topic actually comes from. And the backstory is you're working on planning a blog article about this topic. You collect information that helps the audience learn something and make informed decisions. Your work is going to be the basis for the content writer to write an article on this topic. So it is basically the backstory for the planner agent. And here I have mentioned allow delegation equal to false. So this is again that thing of sequential workflow. So I want a sequential workflow over here. I'm not allowing this agent to delegate its task to anyone. So you run this and that's the planner agent which is defined. As we saw, we are going to define three agents, right? Planner, the writer, and the editor. So the next step is you have to define the writer agent. So here again, you write the role, the goal, and the backstory. The role is again content writer. Goal is to write an insightful and factually accurate opinion piece about a topic. And then backstory is this, you're working on writing a new opinion piece about this topic. You base your writing on the work of the content planner who provides an outline. So again, this is like a relay race, right? The baton is now passed from the content planner to the content writer. You follow the main objectives and direction of the outline. You also provide objective and impartial insights. You acknowledge in your opinion piece when your statements are opinions as opposed to objective statements. See, now some amount of time has been spent on writing these prompts. Technically, you can spend more time also writing these prompts, but already it's a bit detailed. So the reason I'm mentioning this to all of you is because the prompt is probably very important and not many people spend a lot of time thinking about the way you write these things. So this looks pretty simple, but you can be lazy and write it in a very short manner. You can use AI to write these prompts, but then you have to make sure that it actually it should not be blind use of an AI tool. You should actually write what you're feeling. So imagine you are writing this piece, right? If you care about writing the piece nicely, that will come in your prompt nicely. And longer prompt does not mean a better prompt. Not at all. In fact, it goes the reverse way. Sometimes if you make the prompt very elaborate, the LLM will not understand which parts of the prompt to pay attention to and which part to not pay attention to. So you have to don't just keep writing the prompt randomly. You have to make sure that the prompt is concise enough, but it should not be written lazily also. You have to strike that balance. Uh, Okay, so now next is the third agent is the writer agent, right? Actually, writer agent is done. The third agent is the editor agent. So content planner, writer, and editor. The editor agent is the final agent. So the editor agent edits a given blog post to align with the writing style of the organization. You are an editor who receives a blog post from the content writer. Your goal is to review the blog post and provide balanced viewpoints. We can also add some things like make sure that the grammar is correct and make sure that nothing is wrong over here, etc. So then you run this over here. So then there are three agents, the planner agent, the writer agent, and the editor agent, which have been defined. That's the first step of CrewAI, define the agent. The next step is task. So you might be thinking, didn't we already define the task over here? So it did not actually. If you see the way we have defined the agent, we have only mentioned the goal. We have not mentioned the tasks. The task is also usually where we can give access to tools. So in the second project, which we are going to run today, I'll show you how to give access to tools when you write the task. The tools are not passed in the agent description itself. The tools are passed when you define the task. So the next step is defining the task. And as I mentioned in the task, you have to define three things. You have to mention the description of the task. You have to mention the expected outcome. And you also have to mention the agent who is doing the work. So the first task is plan, right? And this is the agent which is doing the work is the planner agent. So I've mentioned agent equal to planner. Description is prioritize the latest trends, key players and noteworthy news on the topic, identify the target audience, develop a detailed content outline, include SEO keywords and relevant data. That's the description. Expected outcome is comprehensive content plan document with an outline, audience analysis, SEO keywords and resources. That's the planning task. Then we have the writing task. Here the agent is the writer agent. And here we mention use the content plan to craft a compelling blog post, mention sections, subtitles, make sure they are properly named, ensure the post is structured with an engaging introduction, insightful body, and a conclusion, proofread for grammatical errors. And then expected output. Here you also mention how long you want the blog to be, a well-written blog post in markdown format. So if any of you writes blogs over here, this agentic framework which we are building right now, it can be the first draft which you can just copy paste and then make minor edits. But here is where you have to write typically how long your blogs are. Is it 2 to 3 paragraphs? Is it more than that, etc. What is the expected outcome out of the writing agent? That's the second thing. The third task is editing, right? So in the third task, what you have to do is that you have to proofread the blog post for errors, for grammatical errors, right? So, and this we cannot write in the agent description itself. It's much better to write it in the task. And then the expected outcome is a well-written blog post. each section should have 2 to 3 paragraphs. So here again, we maintain the length which we want of the final blog post. And then now that we have defined the agent, we have defined the task. The last step which is left for us is to assemble the crew. So that's exactly what we are going to do right now. Let me actually run this. Let me run the planning task, the writing task, and the editing task. And now we have to form the crew. When you form the crew, you just have to mention the tasks, the agents, and the workflow. So here I'm forming the crew here, and if you don't mention any workflow, it will by default enter into a sequential workflow. So here what I've done is, see this process, you have to mention the tasks, you have to mention agents and the process. So by default, the process is a sequential process, but here you can mention the type of process which you want. So here finally, this is the place where you define the crew and tasks, agents. So the tasks are planning, writing, and editing, and the agents are planner, writer, and editor. That's it. So did you see now we have defined the crew, right? Did you see until now what we have written on Google Colab is not that different compared to what we have written on the Miro whiteboard. In fact, here it almost feels like we are writing in English language. It does not feel like we are coding at all. That's one of the biggest advantages of CrewAI, and that's the reason I call it a low code framework. Because compared to this, remember this was our coding based framework when we wrote about the multi agents. And here it actually felt as if we are writing code. And for those people, let's say for people who want quick prototypes and who don't want to get into coding frameworks, CrewAI seems like a much better and an intuitive approach for easily chaining multiple agents together. Because even to define the crew, it just assembling the tasks, agents, that's it. And now, once the crew is defined, the way to actually activate the crew is something called kickoff. The way to activate the crew is you do crew.kickoff. So remember, first of all, we are using this topic various at various places, right? In the planning, we use the topic. When we define the planning agent, also we use the topic. The topic is provided over here. So when you do crew.kickoff, you can actually provide the input topic. So I've put the topic as artificial intelligence. So we expect a blog around artificial intelligence in 3 stages: planning, writing, and editing. So now let's see this agent in action. So I've run this right now. And here you can see the agent is content planner. And these are the 4 tasks which this agent has started to do as we have run this code snippet. So the output of CrewAI is so good that it's actually very easy to parse. So right now you can see that the content planner has finished, and this is the final answer of the content planner. It has mentioned the latest trends in AI, key players in the AI space, target audience analysis, content outline. And it has aggregated its answer into this kind of paragraphs, right? So this is the first agent, which is the planner. And then you have the second agent, which is the content writer. And the content writer has the content plan, and it has to now write a post based on whatever the plan has been received. And this is the final output of the content writer. We instructed it to make it markdown. So that's why it's marked down over here. And this is what the content writer has written. But our multi-agent framework won't stop here. The third agent which we have in the sequential workflow is the editor. And the editor's task is to proofread the given blog post for grammatical errors and alignment with the brand's voice. And so this is the final editor answer now. The editor would have verified the grammatical errors and kept the paragraph length to whatever you wanted. And then you can just print the markdown. So see, now we have an entire blog post which we can directly copy and we can paste into any kind of blog or any kind of article which you are writing. And next time when you want to generate a new blog post, all you have to do is that you have to change the topic over here and a new blog post will be generated. This is how you can completely automate your post writing workflow. And you can make it as tailored as you want. You can even add images. The way you can add images is that you will need to pass in tools. And in the next project which we are going to do, I'm going to show you how to add tools to task descriptions. So if you want your blog post to have images, you just pass in a language model, which is a multimodal language model, which can generate images. So now instead of writing every single blog article from scratch, that's one way. The second way is blindly copying everything from ChatGPT. But CrewAI provides a framework in the middle, right, where you can personalize the content exactly as per you want. You can chain multiple agents together. You can make sure that every single task is done correctly before getting the final answer. And if you have a marketing, if you are in marketing or if you have a marketing agency or if you just want to build your brand online, this is just an amazing fast workflow for you to do that. This will not be your final blog, of course, but it will save you a huge amount of time because then you just have to probably edit this, make sure some sections are as you wanted it, etc. How many of you have finished this part? Can you type yes in the chat if you have finished running this workflow? And you can see right already that this is much simpler compared to LangGraph. This is also much simpler compared to Smolagents multi-agent framework. That's why CrewAI is very good for building simple prototypes. If you are in an enterprise setting and ultimately you want to deploy some agent, again, LangGraph is preferred because it gives you more control. But for developing initial prototypes, for showing it to clients, CrewAI can be actually a much faster alternative for all of you. So let me pause here for a moment and ask if there are any doubts or any questions over here. By generating AI content, are we not going to plateau quickly and also result in overfitting? So basically, generating AI content can be done in multiple ways, right? You can use agents and you can use, let's say, ChatGPT. If you are using ChatGPT, I agree, you're just recycling previous information. But these agentic systems actually allow you to add personalization on your own. So that way, it's not, I would say, it's not recycling that much. If prototyping with CrewAI, how to convert it into LangGraph for production? That's a good question. So directly you cannot convert this into LangGraph for production, but this will give you a sequence which actually works. So for example, now that this result is actually good, what you can do is that you know which agents, how many agents do you need, in which sequence do you need. Then you can take this and migrate it to LangGraph. There you'll have to write a separate code, but at least you know how many agents you need, what's the prompt every agent requires, etc. So then many things can be replicated. Now, if you want to do in LangGraph, yeah, as I can see in the chat, that would be an interesting exercise, how to do this in LangGraph. So let's all try to think about this, right? How would we do this exercise in LangGraph? First, we have to decide the state. The state is the article, the way it is written at any given point of time. That would be the state. The nodes, the nodes will be the different functions. The first node would be um, planning. The second node would be uh, writing. The third node will be editing. That's it. So it will be a simple sequential graph in this case. Is it possible to create agentic loops in this case? So the thing is, by default, the way these agents are written, they will go in a loop. So when I have mentioned three agents, right? The way CrewAI has internally defined these agents is that they will be based on the thought action observation framework. So the loops are by default integrated in this approach. If I want to make chatbot with the help of this, then how to make it? So remember that what is a chatbot? Think about it in terms of tools, right? If you want to make a chatbot using this approach, what tools will you give? You will need a language model, definitely. You will probably need a query engine. So those you have to mention it in the tools over here. If you want to give the query engine as a tool, just mention the tool over here which you want. Um, a language model definitely has to be a tool. So think about the different types of agents which you will need. Think about the different types of tasks and then just assemble the crew. Can we see how agents are internally communicated in CrewAI? That's a good question. So I will share this material with all of you on Discord. Right now, I won't cover it in today's class because that's a very extensive material. But for those of you who are interested, I will share so that you can see the internal workings. Probably I'll take one or two more questions and then we can go to the next project. Where are we defining the order in which the agents are running? So there are actually two things which we are doing, right? So if you see the order with which, no, not this code, the order in which we are running the agents is over here. So the tasks, right? Plan, comma, write, comma, edit. So by default, this is the order in which the agents are running. Also, it's a sequential workflow. So in the write, we have mentioned that you have to take input from plan. In the edit, we have mentioned that you have to take input from write. And one more place where we are mentioning this sequence is over here. Not explicitly, but since we have not mentioned any process, by default, it will follow the sequential workflow from planning to writing to editing. Okay, so now let's go to the next project. Next project which we are going to build is a slightly more complex project, which is customer outreach campaign. So here, what we are going to do is that imagine you are a company, right? And you have a certain product. One common task for all companies who are product-based companies or service-based companies, either of which, the common task is to reach to customer profiles. First, to identify customer profiles and to send email to them. This is also called outbound marketing, by the way, or outbound emails. So this every company has such kind of an outbound strategy, which is usually very useful in sales. And this is one project which we saw in our first lecture, how to automate um, outbound sales strategies. So let's see actually how to do this. And again, we'll use the same framework. We'll use the agent, task, and the crew. The agents which we are going to use are two agents. First is a sales representative agent, and second is a lead sales representative agent. The sales representative agent will do something which is called as lead profiling, which means the sales rep agent will gather more information about the lead and then pass this information to the lead sales representative agent. The lead sales representative agent will draft the personalized email and then we'll send it to that potential client. So this is the workflow which you are automating right now. And now in the tasks, we'll need tools, right? To find the people, or let's say when you have a lead, to find more information about their company, what's the mission of this company, you will need all that information to draft the email. The way you will get that information is using a tool called Serper, and we have already seen this before. We have used the Serper tool before. This is one more time where we are going to use it. Then we need the directory read, then we need a file read. Basically, we can go to any directory, open a file, read the file, etc. This will make sure that we get the details about a particular company so that we can draft a personalized email. And not just that, we are also going to build a customized tool in this project. So you will see that CrewAI offers its own array of tools by default. So we'll have simple functions to define these tools that's offered by CrewAI itself. But if you want to define your own tool, I'm also going to show you how you can define your tool. So then ultimately our toolkit will combine these three tools and our customized tool. That will be the four tools which are assembled in our toolkit. And then finally we'll form the crew. So again, this will be a sequential crew from the sales representative agent to the lead sales representative agent, and finally the email will be drafted. But we'll use these tools. Again, as I mentioned earlier, tools are not to be defined here. They are only to be defined in the task. So now I'm going to share another code file with all of you, which is our second project for today. Okay, so now my code file is ready. Let me share it with you. Yeah, this is the second code file. So let's take a look at this right now together. So this is the code file for the customer outreach campaign. And before running this file, actually, it's very similar to the previous code, but we'll need two things. We'll need the OpenAI API key and we'll need the Serper API key. So here is my original file where I have the OpenAI API key and I have the Serper API key as well. Again, to demonstrate how to get the Serper API, you just go to serper.dev and then you click on sign in. All of you should already have an account because we have used this before. If you already have your key, you can directly use this. How many of you still have your Serper key? Can you mention in the chat? If you don't have it, we'll need to create it once more. Okay, I can see that 3 to 4 people have mentioned that they do have your keys, right? We have created it before. So just copy that. But if you don't have it, you can sign up over here. You can create your account and you will directly get the key. You can use it for free. This does not require any charge or any payment at the moment. Okay, so once you have this, then we are ready for we are ready to assemble this entire crew. So now let's start running this together. The initial steps remain exactly the same, so they might take a bit of time. First, we have to install CrewAI, but in this code, we also have to install CrewAI tools because we are going to use some default tools which are provided through the CrewAI library itself, which were not, this we did not use in the previous Google Colab code because we did not use tools really. But now we have to use this pip install CrewAI tools. So these three commands will take some time. Then the same thing, from CrewAI, we have to import the agent, we have to import the task, and we have to import the crew. So you can run this, and then you have to write down the API keys. So this is the OpenAI API key. This is the Serper API key, and this is the OpenAI model name. You have to run this, and then now start forming patterns in your mind because now what I'm showing is exactly what we have done before, right? What are the steps? Agents, task, and crew, 3 steps. And in agents, we have to mention the role, goal, and backstory. So since we have 2 agents here, sales rep agent and lead sales representative agent, these are the 2 agents which we have. So let's define their role, their goal, and the backstory. So this is a sales rep agent now. Role is sales representative. Goal is identify high value leads that match our ideal customer profile. And backstory as part of the dynamic sales team at CrewAI. So you can assume any company which you want. Your mission is to scour the digital landscape for potential leads. Armed with cutting edge tools and a strategic mindset, you analyze data, trends, and interactions to get opportunities that others might overlook. Your work is crucial in paving the way for meaningful engagement and driving the company's growth. Okay, that's my first agent, sales representative agent, and my lead sales representative agent has a much higher or a much bigger responsibility. Their goal is to nurture leads with personalized, compelling communications. So within the vibrant ecosystem of CrewAI sales department, you stand out as the bridge between potential clients and the solutions they need. By creating engaging personalized messages, you not only inform leads about our offerings, but also make them feel seen and heard. Your role is pivotal in converting interest into action. So these prompts have been generated through ChatGPT, but not directly. A lot of customization has been done to get these prompts. So some keywords which have been used are make it compact, make it concise, but make sure it achieves the main objective of the lead sales representative. And the main objective is to nurture leads with personalized, compelling communication. There is also a question of how to choose the model name. So it depends. Here you can even go with 3.5 actually, because here we simply want to do writing tasks, right? But if you want to have multimodal functionalities, so if you want to even create and add images, then you can go ahead with 4.0 or some other a bit more advanced model. The latest one is GPT 4.1, which you can use if you are using or if you're deploying in industry setting. Can you please explain this example by relating to thought, action, observation, and agentic RAG? So first of all, agentic RAG is not even in the picture here because we don't have any documents to query from. And thought, action, observation loop is coming in the backend. So one disadvantage you can say about CrewAI is that everything looks very simple, right? So that's why people have all of these questions that where is the agent actually operating? But the way now when you write agent over here, that's the abstraction. The way they have coded it in the backend is such that when you write this agent here and when you invoke the agent, it will automatically go into the thought action observation framework, which is prescribed by React. But that depends on the way they have written this functionality. And actually, there is a question on how LLM is passed here, right? You can define the LLM here, but if you don't define any LLM, the code will automatically pick the language model which is in your environment. So in my environment, it's OpenAI right now. So by default, this language model and this key is picked. But if you want to use different LLMs for different agents, you can mention an LLM also when you define an agent. Now this step number four, pay careful attention here because in the previous in the previous code we directly jumped from agent to tasks. But now we are going from agents to tools and then from tools to tasks. So there is one more step which is added. So as I mentioned before, we are going to use these three tools, Serper tool, the directory read tool, and the file read tool. These three tools we are going to use from CrewAI tools itself. So here you can see from CrewAI tools, you can import these three tools, directory read tool, file read tool, and Serper dev tool. And if you go to CrewAI tools, you will see the list of tools which CrewAI actually provides. They provide huge number of tools really. Yeah, here you can see all the tools which CrewAI provides, which you can use out of the box, which means directly from, you don't have to define any function for it. But here I have very simply tried to define a custom tool. So let's say you want to add one more tool, which is a sentiment analysis tool. So essentially what you want to do is that when you draft the email, you want the sentiment to be always positive. So the way you can ensure these things is that you can define your own tool over here. So you do from CrewAI.tools import base tool, and then you define a class regarding the tool you want. So here I am defining sentiment analysis tool, and I've kept it very simple. So for everything, it will always return positive. But essentially what you can do is you can add an LLM here which classifies text into positive sentiment or negative sentiment. But it's very simple to define custom tools. You just have to define a new class and then you need to call an instance of that class to create a custom tool. Now, someone was asking in the previous code how to add images, right? The way you can add images is that you can create a custom tool. So maybe you can say a class image creator tool. So here you can say that, let's say if you want to add images along with your blog post in the previous, right? All you have to do is that you have to just say class image creation tool and you just mention the language model which you want over here to create that image. And then this particular tool will be created for you. For now, I've just created a sentiment analysis tool which is going to essentially return positive for many descriptions which are there. Now, so this is the custom tool which has been added. After tools have been defined, so let's say you have the agents, you have the tools, and then you have the tasks, right? Now we come to the next pipeline, which is defining the tasks. And this is where you have to make a distinction between agents and tasks. In agents, we cannot write tasks, but as you can see, I'm going to define two tasks over here. The first task is the lead profiling task, and that's the task of the first agent, which is the sales rep agent. And the second task which I'm going to define is personalized outreach task. So this is where the email will be crafted and sent. So let's see how this task is defined. So lead profiling here, right? Conduct an in-depth analysis of lead name, a company in the industry sector that recently showed interest in our solutions. Utilize all available data sources to compile a detailed profile. This task is crucial for tailoring our engagement strategy. Now see the expected output. We want a comprehensive report on that particular lead, including company background, key personal recent milestones and needs, highlight potential areas where our solutions can provide value. So this is the lead profiling task of the first agent, which is the sales representative agent. The second task is where the email will be drafted. So using the insights gathered from the lead profiling report on this particular lead, craft a personalized outreach campaign aimed at the key decision maker, the position of that particular lead. The campaign should address their recent milestone and how our solutions can support their goals. So see, that's what makes it personalized. Your communication must resonate with their company culture and values. And then the expected output is a series of personalized email drafts, which are tailored to the lead name, specifically targeting the key decision maker. Each draft should include a compelling narrative that connects our solutions with their recent achievements, ensure that the tone is engaging, professional, and aligned with the lead name's corporate identity. See here again, the prompt engineering plays a very crucial role, right? Because you can simply write a one-liner prompt over here, or you can simply mention two sentences, but that won't make a difference at all. The more detailed the prompt you write, the better it will work. And that's the general advice for defining agents across any framework which we have seen so far. So this is the second task which has been defined. And once the tasks have been defined, once the agents have been defined, we just create the crew. So you may be asking, where are the tools over here, right? So the tools are in the tasks. So if you see, the first task is lead profiling, and the tools have been defined over here. To do the lead profiling, I want to use the SERPer tool, which is a web search tool, directory read tool, and a file read tool. And to make the personalized outreach task, I want to use two tools. I want to use the SERPer dev tool, and I also want the sentiment analysis tool, so that I can make sure that the email sentiment is generally positive, the email which is drafted. This is the place where you essentially create the crew. And then, as I mentioned, the last step after the crew is created is kickoff. This step. So here is where the crew takes off essentially. The crew starts to do its work. So here you can do the kicking of crew, and you have to mention some input over here. And this input can come from an Excel sheet which your company maintains. So if in the Excel sheet you have deep learning AI, which of course is Andrew Ng's platform. And if my company is CrewAI and I want to form a partnership with deep learning AI, I want to draft a customized email to Andrew Ng. And now my agents will work together with each other to draft this email. So first agent is a sales representative agent, and you can see that it has understood its task. It also mentions the tools which it will use. So see, the thought action observation is happening over here. This is the thought which the agent thinks that to gather information about deep learning AI, it would be best to start by searching the internet. That's the thought. The action is the agent decides to use the tool. So search the internet with SERPer. And what is it searching on SERPer? It's searching deep learning AI company profile. So here's the deep learning company profile results which this agent has obtained. And here we can see that this looks correct because join over 7 million people learning how to use and build AI. It seems like something which might be written on this website, which is deeplearning.ai. Yeah, see, join over 7 million people learning how to use and build AI. And this is exactly what we see over here. So the SERPer tool is scraping the data from this website, and that's the tool output of the first agent. But see, again, now this agent entered one more loop. It does not stop here. So that's the thought action observation loop, right? The search results have provided some important web pages related to deep learning AI. which is their official website, LinkedIn profile, and additional business information on Crunchbase. These sources will be useful to extract specific data about the company's background. So then the tool which is used is read a file's content and read that particular directory. And then it will try to get directories at different locations. So here we can see the thought, action, and observation, and it's in a loop because still we are at the first agent. We have not yet moved to the second agent. So the first agent is having multiple thought, action, observation loops over here. And then finally, this is the answer by the first agent. So the first agent, which is the sales representative, collects an overall background about the lead, the client whom we want to target, and it passes on this information now, this detailed report. It passes on this detailed report to the second agent. And the second agent is the lead sales representative. And the lead sales representative task is again using the insights gathered from the lead profiling, craft a personalized outreach aimed at Andrew Ng, the CEO of Deep Learning AI. And here you can see that the lead sales representative thinks here. So the thought is to create an outstanding personalized outreach campaign. I need to ensure that the initial communication draft reflects accurate and up-to-date information, etc., etc. And then the tool is search the internet with SERPer, etc. And then the lead sales representative has the final email based on all of this information. And these are the multiple email drafts which it has made, but it's a bit difficult to read. So what I've done is converted it to markdown below. So here you see I have 3 email drafts which can be directly sent to essentially Andrew Ng. So if I'm a company who wants to target, let's say, potential clients, if such drafts are automatically ready for me, it will save a huge amount of time for me. And these drafts are not random drafts. They are completely personalized by agents scraping websites, agents trying to personalize the content according to the company's profile, etc. So what you see over here, dear Andrew, I hope this message finds you well. I greatly admire how deep learning AI has been pivotal. See, now this information is got because in the prompt we mentioned that write about what that company is doing and align our mission with their mission. I greatly admire how deep learning AI has been pivotal in democratizing AI education. With your recent initiatives, there is an apparent synergy between our missions. At CrewAI, our innovative AI platforms are tailored to supercharge engagement. Let's explore how we can collaborate. This is the first email. The second email is a bit more professional, I think, more concise. Your leadership is inspiring. At CrewAI, we believe in the power of collaboration. So this highlights collaboration more. So the first is new dimensions in AI learning. The second is enhancing deep learning collaborative tools. And the third email is a bit different. It's about drive data-informed decisions at deep learning with CrewAI's analytics. So here we are pitching our analytic framework to them. So each email has a different content, right? And then you can choose which email you want to go ahead with. So we can also add RAG where agents can, yeah, essentially what you can do here, you can take this a step further where if you have documents related to the client's company, like if there are leads in an Excel sheet and if you have documents explaining the company, what you can do is that in the tools which you have over here, you can also give the query engine as the tool. And you can make this into an agentic RAG problem. But if you actually want to do agentic RAG, I would suggest to use LlamaIndex. LlamaIndex is perfectly suited for agentic RAG because it was originally conceived as an indexing package. CrewAI is ideally suited for assembling multiple agents together in a very easy manner and for building quick demonstrations. That's where CrewAI is very highly suitable for. So now here you can already see, right? If I want to draft an email, I just copy this, I paste it into my inbox, and then I just edit it and send it. And this is completely automated, which means if I want to now do this for a new company, I can just mention a new inputs over here. And then I can even make this into a loop 500 times, 1000 times, etc. and collect all the drafts into a report. And then I can decide which drafts I can send, etc. This framework is what many companies are actually looking out for. So there are many companies who are looking for people who can draft automated customer outreach campaigns for them. and they are willing to pay for something like this. So if you are someone who can make this automated pipeline for the company, which sets this outreach campaign for them, it does add value to their uh, process a lot, because companies value two things, right? Anything which increases revenue or anything which cuts down costs. So this will cut down costs because it saves time. Uh, okay, so now how many of you actually got this result towards the end? Can you tell me? And how many emails did each of you get? I got 3 emails over here. One email, right? So actually, nowhere did I explicitly mention 3 emails, really. I had just mentioned, so if you see over here, what I have mentioned is a series of personalized email drafts. So this is a bit vague, right? I've mentioned the expected output is a series of personalized email draft. Now, series can mean 1, 2, 3, it can even be more. And that's why there is a bit variability in the responses which all of us have received. Uh, okay, so this, let me pause here if there are any doubts or questions. This has brought us to the end of today's lecture, but I'll take some questions in the chat. Can you please go over how to deploy agents? Yeah, that's a good question. So the agent deployment we are going to cover in tomorrow's lecture when we learn about n8n. There are two ways to deploy agents actually. You can deploy agents on the cloud, or you can deploy agents directly on that particular provider. So let's say if you are using a coding framework, let's say LangGraph, LlamaIndex, etc., you can deploy the application just like how you deploy any ML framework. You can upload the repository on GitHub. You can create a CI/CD pipeline. You can track the metrics on ML flow or weights and biases, etc. But if you are using platforms like n8n, it gives you two options of deployment. You can deploy on cloud on your own. You can deploy on your own server also. Both options are possible. But if you use Python-based frameworks like LangGraph, LangChain, etc., it's a .py file ultimately. So it's very similar to the way you deploy other ML AI frameworks. The reason I showed you CrewAI in Google Colab is ideally people run these frameworks in terminal. But I specifically wanted to show in Google Colab so that my teaching becomes easier. If you want to develop this in production level workflows, you have to work in VS Code. And not just that, one thing now I might suggest to all of you is how many of you have heard about this Gemini Cli? I think this is one of the biggest revolutions which has happened in coding in the last 1 or 2 weeks. I've used this and it's incredible. What it does is that if you are working on any code, right, or if you're working on any project, you can download this. This sits in your terminal, and it's as if you have a junior development engineer working along with you. It automatically has access to all the code files, and by the way, it's an agent. So anyone who has used Google Cloud now should try to relate some of the things which we have learned in this bootcamp. Because this Gemini Cloud, when it sits in your terminal, it automatically has access to all your files in your root folder, and it automatically searches through the files, etc. We don't have to specifically give it the context. Then Claude Code is also one more. And of course, Cursor has been there for a long time, but due to these new tools, they are much easier alternatives than Cursor. So many people are thinking Cursor's market share will now start to decrease. But let's see. When I tried Gemini Clay, I was amazed by it. Claude Code is also one option, but it's a bit expensive. Gemini Clay is like free um, until a certain point. Yeah, it's definitely better than GitHub Pilot because it feels like magic really. If you use it, Gemini Cloud or even Cloud Code. I have tried Cloud Code also. So now if you're working on agentic projects, right? If you're working on a Creo AI projects, you should do it on your terminal and have Gemini Cloud installed on your terminal itself. So it's as if you're working with a developer or a junior programmer. Okay, this is one thing. The second thing which I wanted to touch upon is NVIDIA actually released the paper recently. Did any one of you see that paper? So what they had actually mentioned was that agents become better with small language models. Yeah, I think it's this. Now, I really encourage all of you to read this paper because I think based on what all we have covered in this class, all of you will understand this paper. What these people are saying, and I think they make a very good point, is that when we create multiple agents, right? Like let's say right now we have created three agents. We have created three agents over here, right? Here we created a planner, a writer, and an editor, and each of these agents is doing a very specific task. So why is it that we equip each of our agent with a very large language model with billions and trillions of parameters? Why do we equip every agent with 100 billion to 1 trillion, let's say GPT 3.5 or whatever? Why can't it be possible that every agent is equipped with a small language model that has just 10 to 15 million parameters? Small language models are shown to be excellent at performing specific tasks. And agents exactly do that. Agents perform a very specific task. For example, this planning agent is not going to tell me anything about finance in this particular case. This planning agent is not going to tell me about sports news or other some random things. So why do I need an LLM which has all the knowledge in the world? It's like an overkill, right? It's like uh, expending unnecessary amount of compute. So this paper actually argues that when you have multiple agents assembled together and agents have access to tools, right? So every LLM which an agent has access to, that can be a small language model. So what they have mentioned is that um, the rise of agentic AI systems is ushering in a mass of applications in which language models perform a small number of specialized tasks. See, this line is important, small number of specialized tasks. So they have a proposition that SLMs are sufficiently powerful, more suitable, and necessarily more economical for many invocations in agentic systems and are therefore the future of agentic AI. And I actually completely agree with this. So SLM is more context specific and task specific, but aren't agents also exactly that? When someone builds an agent, it's usually for a specific task. It's not for doing all the things in the world. It's for a very specific task. So when companies want an agent, let's say they want an agent for um, customer query handling, that's a very specific task. And that can easily be done by a small language model who's trained at doing specific tasks. We don't need to invoke in giant models unnecessarily, especially for agentic systems. And they kind of prove their point. Um, they have their statements and they have some results also, I think. So if you can just read this paper. I'm going to post this as an assignment for the students who are on the pro plan. So this is going to be one of the final assignments which we have. And I actually have a video on building a small language model from scratch. So if any one of you is curious about how to build a small language model, um, I have recorded a 3-hour video, this video. This is that video which will actually teach you how to build a small language model from scratch. And I will share this on chat. If anyone is curious about what small language models are, this is something which you should definitely consider. Okay, now that we have come to the end of this lecture, I want to mention that for people who are on the pro plan, there are three additional projects which I will be sharing on the GitHub repository. The first is multi-agent financial analysis using CrewAI, job application booster using CrewAI, and I will also be sharing a repository which evaluates CrewAI agents. These two are longer projects and they are a bit more deeper, but I think now you'll understand how to do it exactly because the underlying framework is the same as what we have seen today. One thing I want to mention is this port key, right? So if you search about port key, there is one Google Colab notebook which actually lets you evaluate AI agents using or CrewAI agents using port key. So CrewAI can be connected with port key, and you can actually evaluate how your agent is performing. So all these three I will add to the GitHub repo. There is one GitHub repo which I'm making for pro registered participants, which has 5 to 6 industrial projects. There I will also add a compilation of all our Substack articles, etc. And finally, tomorrow is going to be the last lecture. And that, as I mentioned in the previous class, that is going to be covered by Dr. Shridath, who is one of our co-founders at Vijwara, and he also graduated from MIT with a PhD. He is going to cover n8n basically. He is going to cover n8n, he is going to cover MCP. So you will build multiple projects in n8n tomorrow. You will build also an MCP project and we'll deploy this. We'll also show the deployment using n8n. And in tomorrow's lecture, we'll also see a conclusion of what all we have seen so far. So I'll be present at the starting of tomorrow's lecture where I'll introduce Dr. Sridath, and I'll also conclude related to everything which we have seen so far and the resources which I'll be providing next. So thanks everyone, and I will look forward to seeing you in tomorrow's lecture. Tomorrow's lecture is where we'll again have AI automation projects as well. We'll build multiple AI automation projects, which then later you can add your which can add to your portfolio. Thanks everyone. I look forward to seeing you in tomorrow's lecture, which will be the last lecture of our bootcamp. See you. Take care. Bye. And the timings will be same as today, 2 p.m. IST. Bye. Okay, everyone. So let's get started with today's lecture. Today is day number 10 of the bootcamp, which is the last lecture. And we are going to learn about n8n today. We have with us today Dr. Shridath Panar, who is also a co-founder at Vijwara AI Labs. And we both graduated from MIT with a PhD at the same time. So he will be taking today's lecture and he will be introducing the n8n framework, and you will be doing hands-on projects together. But before that, I want to do a quick summary of the last lecture and the material which I'm going to share with the pro-registered candidates after this bootcamp. So here is the Substack article, as I always share, for the previous lecture. And we learned about CrewAI. We saw that in CrewAI, it's a low-code framework where you can very easily create agents, define tasks for agents, and then assemble a crew of agents. We started with a simple example of multi-agent content creation, where we had the content planner and we had the content writer and editor. These were serially connected to each other. This was a sequential workflow. But remember, I also told you that CrewAI allows you to do a wide range of workflows, not just a sequential workflow, but you can do a hierarchical workflow, hybrid workflow, parallel workflow also. So that was the first project. The second project which we saw was a bit more complex, where we actually created a series of agents which work together to make customer outreach campaigns. And if you remember, we had a sales representative agent and a lead sales representative agent. And one beauty of CrewAI is that defining agents in CrewAI is as simple as just writing English language. So to define agents, you have to mention the role, the goal, and the backstory. As I mentioned to you yesterday, you can think of this as RGB. So red, green, blue, so that you don't forget it. Role, goal, and backstory. Then you have to mention the tools, and tools are mentioned in tasks. So you can also define custom tools. Yesterday, I showed you how to use the tools which CrewAI gives, and also how to make your own custom tool. Once we define agents, we create tasks with their description and expected outcome. And then we assemble these agents together to form the crew. It's as simple as that. And then we can actually see the agents orchestrating and working together to get the desired output. Yesterday, I told you that if you make posts or if you plan to write blogs and if you plan to monetize it, this can automate your workflow to a huge extent. So you can get the first draft of emails if you are doing outbound sales, or if you can get the first draft of your post if you are making a blog article, etc. And then you can simply edit it. So that saves time and adds value to your workflow. Now, after this bootcamp is done, what I'll be doing is that first thing, for all the pro registered participants, we have assembled this Visuara AI Agents Bootcamp book. This has now become a 160-page book, and it covers all of our learnings which we have in these 10 days of this bootcamp. And as you can see, this is a very comprehensive book which I'll be sharing with all of you. Only those who have been registered in the pro plan. So here you can see we have started working on a GitHub repository called Agents 10-day Bootcamp. And we also have industrial projects, as I had mentioned to you. In all these other sections, we have the code files which we have seen throughout this bootcamp. And in the industrial project section, we have some end-to-end industrial projects, which I'll be sharing with people enrolled in the pro plan. So as I've mentioned on the Discord, please share your GitHub credentials on the Excel sheet which has been shared on the Discord. So that way, I can actually add you as a collaborator on this GitHub repository. This repository is going to remain private. I'm not going to make it public. So it is only accessible to people in the pro plan. As you can see, we have an industrial project section here, and the agents book, which I just showed you, that's also covered as a separate section over here. So after this bootcamp, all the code files, all the industrial projects will be accessible to you in one place, along with the dashboard which we have. We already have a dashboard where we have the videos and lecture notes, but this is the one place where you have all the code files. To those who want to enroll for the pro plan to get access, you can still enroll by clicking on this link. So click on this link and enroll in the pro plan, and then I will be sharing this GitHub repository with even you. Yeah, so if you have any doubts while doing these industrial projects, just create an issue on this GitHub repository and we'll clarify these doubts for you. So now let us get started with the main lecture for today, and I will hand it over to Dr. Sridat now, who will continue with the rest of the lecture.
All right, thanks, Raj. So I hope all of you have been getting fairly good exposure to the ideas of agents, and Raj has told me that in the last few lectures, you have built a few different agents together. We are pretty much going to do something very similar today using a no-code framework. So n8n is that framework. So what I want to do is we should all be doing this together, building one particular agentic or AI incorporated workflow. So let me just stop sharing and reshare. Can anyone confirm in the chat if you can see the Miro board right now or not? You don't see? Okay. Let me stop sharing and reshare. How about now? Awesome. Thank you. So this lecture is entirely about n8n, and don't worry if you have no idea what this is. If you know something about n8n, well and good. So n8n sort of is like a short form for the word node automation, which got later shortened into nodemation. And then later people started calling it as n8n. And now the website name is n8n.io. So what I have done is today's lecture, I have split into 3 parts. First, we will briefly discuss what exactly is this n8n thing, how does it work, and how can we use it to build something useful for any of us. And there are many different workflows which you can build using n8n for your own benefit. I myself have maybe built around 10 or 12 workflows so far for our internal workflow efficiency. So to automate many things that I'm routinely doing repeatedly that are boring tasks. So I have actually also started a lecture series on Visuara's YouTube on n8n. So feel free to follow that. But today's lecture will comprehensively cover end to end, starting from what is n8n all the way to building a very nice AI integrated workflow. So as I mentioned, nodemation was the previous short form of n8n, and the original idea was node automation. So here, what exactly is node? I will show you what is that. And oh, you want the YouTube URL? So go to youtube.com/@visuara. Just put in the chat. That's the YouTube link. All right. So to think of what exactly is a workflow, there are a few different things that you'll be doing on a daily basis. Maybe looking at emails first thing in the day, seeing whether there are important emails to respond to, seeing whether emails that you should forward to, or maybe if there are emails with attachments, you may want to download those attachments and save it somewhere. This could be one workflow. Another one which I painfully do these days is whenever we have to book a meeting room in this office building, I have to email the building manager to book the relevant meeting room for a particular slot. And then the building manager will let me know whether the room is available or not. If it is not available, I have to again email. And when the manager confirms the availability of the room, I ask him to block that slot, and in my Google Calendar, I add it. And this is an activity that I repeat multiple times a week. So it is clearly a workflow which can be intelligently automated. Or let's say you have a bunch of customers making some payment through your payment gateway, Razorpay or PayPal, and you want to update the details of that payment on your customer resource management platform, whatever the platform is. And then automatically you want to send an invoice to the customer either on email or on WhatsApp, Telegram, whatever the tool that they are using, right? So these are all examples of workflows which can be automated because there are specific set of tools that these workflows are using, and all those tools have API access. So whether it is Slack or whether it is Razorpay or Gmail or GitHub, all these tools allow API access for developers to access the tool not through their primary UI. So today what we are going to do is, first let us discuss about n8n. How many of you have heard of Zapier? It's also another workflow automation tool. Has anyone used Zapier ever for building? They allow you to build something called Zaps. Okay, so basically Zapier also does something very similar. They are a big company, huge revenue they have, and it allows you to create automated workflows. So I had built a Zap for once creating, whenever I receive a new email, our inbox was getting so cluttered that I could not manage the inbox. So I wanted proper labels which allowed me to quickly see, okay, these are the emails that are supposed to be looked at with high priority. So I created a Zap workflow for automatically creating labels. And there are many workflows which you can do. n8n can do something very similar. And there is huge similarity between what Zapier can do and what n8n can do. But even if you are not familiar with any of this, don't worry about that. So n8n is basically hosted. They have hosted version on cloud on the website, which is what we will be using. And they allow so many integrations. This 400 number is based on maybe 1 week ago. I'm sure this number will keep on increasing as n8n integration to many other tools will increase. So whenever I say integration, I mean, can n8n communicate through API to different tools? Can it communicate to Stripe? Can it communicate to your Gmail or Google Calendar? Or if you're using Jira or Slack or any other software, can it communicate to all those tools, make changes in those softwares, or fetch data from that software and feed it to another software? Can n8n do all of these? That is what I mean by integration. And currently it can already integrate with pretty much any software or any tool that you can imagine. But from my experience, I have seen Zapier can integrate with more, but I'll show you why I'm teaching you n8n today instead of Zapier, because this is one of the most modern frameworks at the moment. So the idea is that any workflow, right? If you are automating a particular workflow, it starts with something called as trigger node. Trigger node meaning what causes the start of an event. If you want to let's say fetch some details from a new email, and based on those details, if you want to classify whether this email is let's say high priority email or a low priority email, the trigger is arrival of a new email. And whenever a new email arrives, your workflow should get triggered. So this is like an automatic, like it's not a trigger that is under your control because you don't know when a new email is going to come. So these are based on certain events. There are also triggers which can happen based on time. So you may want to have a workflow that gets executed at 9 a.m. every day. Or maybe you want to manually execute it only when you require. So if you think about triggers and if you break it down, there are manual triggers where only when your intervention is there, the workflow gets triggered. There is automatic triggers where you don't have any control. It depends on when an event happens. And then there are time-based triggers, time-based or schedule-based. Out of this, of course, manual triggered ones are, you can have the biggest control over this because you decide when the workflow happens. Automatic triggers, you can't predict when it happens. And there are two terms which might help you in your future, not in today's lecture, but if you are not familiar with, those are webhooks and cron jobs. Cron job simply means that if you have a workflow as a cron job, you are executing is based on time, maybe at 9 a.m. every day. So I have a manual workflow where at 9 a.m. every day, I check my inbox. So now if I set up a system where my inbox is automatically checked by 8:30 by a AI workflow, and then it labels the priority emails, then by 9 a.m. I just need to check those priority emails. So I could set up a cron job for that. Similarly, I'm not sure if it's similar to webhook, Unix cron job. This is more like sort of like chronology, time-wise. I don't know what exactly is Unix cron job, Rajeshwar. So on the other hand, webhook is, let's say you have a website in which you would invite customers to make payment for something, and you are using Razorpay payment gateway. So in Razorpay, you can set up something called as webhook. So let's say your website name is called vishwara.in or .ai, and then you can create a URL, right? Something like Razorpay /webhooks / something, and then this URL, which is publicly accessible, you add in Razorpay, and then in Razorpay you can mention what all events you should be able to access when customer makes a payment, when a payment has failed, or when customer added something like reached the last level of payment but decided to not go ahead with the payment. So there are so many events associated with a payment, right? It's not just the success of payment. There are many things like, did customer use UPI or credit card or some other mode of payment? So there is so much data associated with one payment that is happening. So webhook is one way in which, for example, if you want those data from Razorpay, if you want to make it available for your website, so that if a customer upgrades from a free version of your software to paid version of the software, you can make appropriate change in your backend. So if you have hosted your backend on AWS or Firebase, you can make the change based on what data you get from the webhook. So these are two things which can allow you to know when events happen. Now, today what we are going to do is we will look at how to use n8n first. So there are mainly three ways. First is n8n cloud itself. So this is on the website n8n.io. And this is by far the easiest way to use n8n. The only thing being, it is not fully free. For 14 days, they have free trial. After that, you have to pay. So hosting is provided by n8n itself. The other option is you can access n8n through Docker. So if you install the software called Docker Desktop, you can access n8n. I will just show you quickly. So I have installed n8n using Docker, as well as I have installed the Node package manager. So that's the third way. But I don't want to spend too much time today on this and this, because that is not the important thing. Important thing is getting started with n8n itself. But I'll show you what I mean by hosting yourself. So if I go to my terminal, I have already installed n8n locally. And here, if I call n8n, it will or rather, let me open my Docker. Terminal is not visible. Okay, let me know. Yeah, I'll briefly touch upon the installation, but don't worry, you'll be able to run n8n today. Guys, can you confirm if you can see my Docker, or are you just seeing my Miro? Okay, let me stop sharing. How about now? Okay, awesome. So in Docker, what you can do is go to Google, search Docker desktop, and go to this link. This is just for future. If you don't want to pay n8n after the 14-day free trial, you can do this. And then here you can download Docker desktop. I'm using Mac Intel, whichever system you're using, you can download Docker for that. And then once Docker is installed, you can log into Docker using your Google account, or you can create an account yourself. And then what you can do is you will see a section called images here. In the images, you can do search, and in the search, just search n8n. Then it will show a bunch of things called n8n, but the top one, n8n.io/n8n with 100 million downloads, that is the correct one. Then what you can do is you click pull, then this image will be stored. You will be asked to create an image, and then you containerize it. So what you can do is, so I'm going fast here because this is not the primary mode of your n8n usage today. You will be using n8n today on the website only. So don't worry about the exact details here, but I just want to show you the local hosting, that's all. So here I'm going to run this. And maybe I'll have to do this once again. Let's see if it is not working. Yeah, my n8n local thing has crashed for some reason, but I'll fix this and I'll show you. But in any case, let's move on to the actual cloud-based hosting. That is the fastest and easiest thing to do. If you want to know how to install n8n, you have two options. I have already posted one lecture video in which I show both installing n8n using Docker for your local system. But the only thing is then you have to later figure out if you want to keep the workflow running in production, you have to host it somewhere yourself. You can't keep it on your local host. But you can also check their GitHub repo, which has, I think, 114,000 stars or something. It's very, very famous repository. Yeah, this one. So here at the bottom, they will give you the steps over here, how to deploy it with Docker or how to run it instantly with Node.js. So it's very easy thing to do, but let's not spend time on this. Now, what I want all of you to do is go to this website, n8n.io. We'll share the link in the chat. Just go to this website and create an account. So during account creation, it will ask for the company name, company email, etc. So you can give whatever details, but do create an account for free right now. And then we'll be using that account to run our build and run our first workflow. And meanwhile, let me say a couple more things. Zapier versus n8n. So the common consensus is that Zapier is easier to start as a beginner, and n8n is slightly more complex. This is what people are saying on the internet, on Reddit and everywhere. But from my experience, it has been kind of similar. I did not find Zapier any easier. Both are of similar ease. Local hosting part of n8n is a bit more involved. It's not as easy as running the n8n on cloud. And Zapier, I don't know if they provide that option to do things locally. But otherwise, in my experience, Zapier and n8n are pretty much similar. The only advantage that I have seen with Zapier is that because they are a much bigger company, they have more number of integrations. They have integrations with more softwares, which in n8n will take maybe a couple more months to happen. But in any case, let's now open n8n and start building our first workflow. So I'll tell you the workflow that I'm going to build with all of you today. Zapier, they have free version for limited period, but I don't believe they have a forever open source version. In n8n, if you are hosting it yourself, you can use it forever for free. I'll tell you the only downside of local hosting when you are connecting n8n with, let's say, Gmail. If you are using the cloud hosted version of n8n, you can make this connection between n8n and Gmail just by logging in. So in n8n, you can click a button. It will ask you to log in by typing your Google Gmail username and password. So it's that easy. However, if you are hosting it yourself, you have to copy paste the API key from your Google admin console or wherever the key is available, right? So that is the only minor disadvantage. I mean, it's not a disadvantage, it's just an inconvenience. Like, I don't like to copy paste API keys. So because I'm lazy to do that, I'm just running n8n on the cloud. But I think the moment my free trial ends, I might figure out how to, run n8n locally. Expose the port, mount the volume after executing. Yeah, Preetham. I think this npx package installation is even easier. It was just typing one line. So feel free to try whichever is convenient for you. Let me quickly see if I can show you the node base running. But meanwhile, can you guys confirm if you have created the n8n free account or not? Okay, awesome. So let this run in the background. I might show you sometime today how to run n8n locally. But meanwhile, the workflow that we are going to build today is something like this. Here is a pain point that I have. I use company credit card to buy some software subscriptions like pro versions of software. So I have a bunch of invoices that come into my email, okay? Now, the accountant, he will constantly ask me to send him all the invoices, give him the details of the invoices, like the name of the service provider, the pricing, and whatnot. So there are a bunch of details in an invoice, right? Now I have to painstakingly put all of this in an Excel sheet, plus also share the invoice PDF or invoice email with the person. Now this is a very irritating thing to do manually, and especially if you have subscribed to so many softwares, this will take you forever. So I am going to show you, and this you can also do because I'm sure all of you have subscribed to some softwares at some point of time, right? So in your inbox also, I'm pretty sure there'll be some invoices. So let's do that. So here, let's first imagine what the workflow may look like. We have to first fetch emails from our inbox. So let's look at a Gmail. And let's say we want to fetch multiple emails. And maybe I want to fetch this between two different dates. So let's say I am interested in getting all the invoices from May 1st till end of June. Okay, so May 1st to June 30th. But when I'm fetching the email, it will fetch all the emails. So maybe while fetching, I have to add some search term, like whenever the email content has words like invoice or paid or success, or let's say maybe thank you. If some of these words are present, maybe that email might be an invoice email, maybe it is not. But while fetching the emails automatically, we will create a search query, something like this, not exactly like this, something like this. Then we will get, let's say, 150 emails between May 1st to June 30th. But now, are we sure that these are all correct emails? Probably not. There are some other random emails. Maybe this is not just about invoices for which I have subscribed. Maybe it's about an invoice for a payment made by one of my customers. So this can be anything, right? So I have to now perform a classification where I do a 2-class classification. So if I have 150 emails, maybe 30 of them are not the correct ones, 120 ones are correct. So I have to perform some sort of text classification into 2 classes, binary classification. And here, for performing this classification, I can use, what can I use? What should I use to do this classification? I can use an LLM. So OpenAI, maybe I can use OpenAI, right? Now, after this classification is done, what should I do? I'll focus on these 120 emails because these 30 are not now the correct set of invoice-based emails. Maybe they are something else. So now from these 120 emails, after classification, the LLM has to extract some data, right? So maybe I have to ask LLM to extract data like service provider, maybe date of invoice, and let's say price. Only these 3 things for now. So I want these 3 things to be fetched from the that particular email for all the 120 emails. And then once I have fetched these things, I want to automatically write all of this into a Google Sheet. This info into a Google Sheet. So just let's look at the actual number of tools that we are using. First, we are using Gmail as a tool, right? Then second, we are using OpenAI. And then third, we are using Google Sheets. And there are more things that we can do. Like once this automatic updation of sheet is done, maybe if you want to send a message to your accountant or CA on Slack, maybe you can add Slack. So that it depends on your personal workflow. But in our case, let's stop the workflow here. Let's not go further. So basically the workflow that we will implement today is, and this will apply for all of you as well. We start with the fetching the emails, corresponding emails. We perform text classification, binary classification. We then fetch the data from those classified useful emails. And then that data we store in a Excel sheet. Now here there is one more thing. This data we need in some specific format. Otherwise, we won't be able to, it won't be in a structure. So here we specifically want this to be in a format called JSON. So JSON is a very popular format. If you have worked in web development, you will know. But basically, this is what JSON format will look like. There will be key value pairs. So JSON objects are, so here, this is an example of JSON format where this title, this is a key. Whatever is associated with it in the right-hand side is the value. So now in JSON, what we may need is, we want a JSON object where key is service provider and value will be depending on whatever is there in the email. Then another key will be date, value will be based in the email. Another key will be price, value will again be based on the email content. So this is what we want because this is a structured format. And then using the structured format, we are again sending this structured format into another structured document, which is Google Sheets. So we can't put unstructured data into Google Sheet. We need it in some tabular structure. So that is why we are saying we need JSON format. So now here are the things that we should get ready with. Do you have OpenAI API key from your past lectures? Okay, excellent. Then do one more thing. Create an empty Google Sheet and title it as, create an empty Google Sheet, which I'll show you again, but this you can keep open. Title it as invoice data. When I say Google Sheet, I mean in the cloud, not an Excel sheet, okay? Go to Google Sheets and then create this. Gmail, pretty sure you all have Gmail. Yeah, this OpenAI used to give $5 credits. I think until several months back. I don't know if they do it anymore. So if you have to use OpenAI, I think you will have to recharge. There is no other option. One more hack that I have seen recently on LinkedIn is this. I don't know if it works, but just go to GitHub and search OpenAI API. Some random keys will pop up, but obviously I won't recommend you to do that. But apparently there are famous GitHub repos which give you OpenAI keys. Obviously, It's yeah. Okay. Now let's start with the workflow. So log into n8n onto your account. So I'm going to log into my account, in which maybe 10 or 11 days are remaining in my free trial. All right. So now once you log in, this something like this is what you should see. So this is like your sort of like dashboard. Can you guys confirm whether you have reached here or not onto this dashboard, something like this? Okay. Then you can click here to create a workflow, because we are going to create an AI integrated workflow. So click create workflow, and then ideally it should open an empty editor that will look like this. Yeah. Now let's start step by step. And you will also now understand why n8n was formerly, I mean, the original root word is node automation. You will see why it is called so, because we are going to create this entire workflow by adding nodes. So right now, this is an empty thing. Now let's add nodes one by one. So what I want to do here is, I don't want this workflow to trigger automatically, right? So can you tell me what should be a trigger? What is an appropriate trigger here? So cron job is time-based, okay? Like it's like scheduling. Should I schedule it, or because if I schedule it, I can't show you right now. Manual is a better thing to do, right? Because we are looking at emails from the past. So no new email is going to come. We are not going to just look at the new invoice email invoices, but we are looking at past emails from maybe last 2 months. So we want to have a manual trigger. So what you can do is click this plus button, and then bunch of things will show up here on the right side. And here, select the option trigger manually. So this is just for now, but as many of you have mentioned in the chat, we can trigger it end of the month. We can trigger it on a daily basis, just to ensure that, from all the new emails that have come, if any invoice is there, add it into the Excel sheet. So this can be done in many different ways, but for today's demonstration purpose and for you guys to see for yourself, you should all add trigger manually. Okay, so this all of you added, right? The first node. So this is the initial node, which runs manually. Now you can execute this node, and on execution of this node, nothing will happen because nothing has been added, but you can execute either by clicking this execute workflow button, or if you hover your mouse on the node, you will see a play button, this small play button. So you can click either of that, then just run it. Can we have an Ollama hosted model as LLM for n8n? I am not sure, because n8n only provide connection with certain number of apps, right? So I think it depends on how the connection works. So they might have a custom option, but the only option that I have tried is different models of GPT. So I haven't tried Ollama hosted. I'm sure somehow it is possible. We can actually try, right? Cloud might be there, or yeah, Ollama. So here, if I go to Ollama, so probably it is possible if you log in using your Ollama credentials, Surya. So you should try this if you want to use this instead of GPT. But anyways, let me delete these. Yeah, and now if you want to delete these nodes, so these two nodes I created manually just now, right? So go to this delete button and just delete those things. So now if you execute the workflow, it will show in green color that the workflow has been executed with this green tick. But right now, nothing will happen because there is nothing to do. Now we have to add the next node. And what should be the next node? Here, there is a plus button. I can click this. What should I add next? Gmail, because we have to fetch things from Gmail. So here in the search nodes, search for Gmail and click Gmail. And from the Gmail, what action should I select from here? So these are the different actions. What should I select? So some of you have mentioned get a message. Some of you have mentioned get messages. Here we want to get many messages, not one message. We want to get all the emails which has that inbox thing in it, right? So here, ideally, it is get many messages, but while clicking here, even if you make a mistake, that is okay. You don't have to delete the node or something, but here click get many messages. So then what happened is this new node of Gmail is also added. So now the workflow is manual trigger will trigger getting of many messages, but this is not ready yet. So now to edit this node, this Gmail node, just double click it. So when you double click it, something like this opens. Now here, this is very important. There are three things that you can see here. The left-hand side input box, the middle email box, and right-hand side output box. So left-hand side input box is whatever outputs come from the previous node to this particular tool. So if Gmail is the tool, whatever inputs or outputs come from the previous node is the input to the current node. So that should ideally be visible on the left-hand side. On the right-hand side, we can visualize all the outputs that are coming out of the current node. So current node is Gmail. And in this middle table, we can set up the current node, which is Gmail with the particular credential. So here what you can do is click this table credential to connect with and press this create new credential button. And here you can simply sign in with Google. So I have already signed in with Google. So what I'm going to do is I'll simply select the corresponding account. So my account is this rajatdandekar@visuara.com. So this is my account. So similarly, you guys also select your corresponding account. All right. Now the resource is message because I want to fetch the details from messages, individual messages, meaning individual emails. And operation is get many. One thing we can do in the beginning is instead of returning all, we can limit the number of emails that we have to fetch. So let's say I only want to fetch 10 emails. Okay. So here you limit to just fetching 10 emails. Then I'll show you what this simplify means, but this is not enough. Is this enough or am I missing something? What might I be missing? Yeah, Anudeep has mentioned date filter. Exactly, that is one thing that I'm missing. So maybe I will say I want emails received before date. So received before is, let's say, July 1st and received after, let's say, end of or beginning of May or something, or June 1st. So this means all the emails that came after, I'm only looking at all the emails that came after June 1st and before July 1st. So that 1 month window. Is that enough? Is there any other filter? Email with some label invoice, correct, exactly. So some keyword, if we provide, that will be better. So that also we should add as a filter. So here in the filter, there is a search option. And here, what we can say is invoice. We can type invoice. Okay, so these are the filters that I'm providing. Now, even then, this will not be the correct set of emails, but that is fine. Let's at least do this as the first step. We can later increase the number. Now, can you all tell me if you have reached till this point of setting up the Gmail with filters? Okay, I can wait for a minute more. Yeah, go ahead and just once you reach this stage, just let me know. And now if you want to, so right now you are just seeing the Gmail node with the previous node's output and the current node's output, okay? Credential to connect with is your Gmail account. So you can simply connect with your Gmail account. How do we add multiple search criteria? I think this is how we can do that. Search for multiple terms in Gmail. And we can inbox or a receipt. Receipt is also like a good thing. Not inbox, invoice, receipt, etc. So then we can simply type invoice and receipt. So maybe not and, I want or. Invoice or receipt. So let's add that. So here I can say invoice or receipt. Okay. You can't see date filter. So date filter is basically you click the add filter. In that you will see received after or received before. So you can add that. If you have already added it, you won't see it. Right now, I don't see it because I have already added it. But before adding, you should see that. So all the filters are in this filter button. invoice or receipt or bill or Stripe. Yeah, that's also good, equally good, or bill or Stripe. So one, we can optimize this later, because this part is also a little bit important. Otherwise, it will fetch all the junk emails also, which anyway we'll classify later, but we'll see. You know what? I'm actually going to increase this to 25 instead of 10, just to show you. Now, one more thing in the settings here, do one thing, always output data and retry on fail, and let the default things be there so that you can see the output on the right hand side. So I have, these are my settings, okay? Connected with the Gmail, resource is message, operation is get many because I want to fetch many emails. Then limit is 25. I'm simplifying the email. We can try without also. And search criteria is this: invoice or receipt, received after some date, received before some date. In settings here, I just say always output data, retry on fail. And then what you can do is click execute step, this button, and then this particular node also will be executed. And the fetched data you will see here on the right hand side for those 25 emails. Now here the data can be displayed as a schema, which looks like this, or as a table, which looks like this, or as JSON, which will look like this. Okay, I find table the most convenient because this will definitely be easier to read. But there will be 25 items here because I have defined 25 as the limit. But I know that between the month, between 1st of June and 1st of July, I'm sure there are many more emails with these two terms, with either of these two terms. It's not 25. So ideally, we should not limit. But today, just for the demonstration purpose, I'm initially limiting. We can later remove the limit also. But here, there will be 25 items. Now, from this box that you see, if you want to go out to the editor, here on this blank space above, here, you can just click or double click. So now you will be back to the editor. So we have implemented two nodes and executed both, clicking for manual trigger and then fetching the Gmail. Output box is blank. Okay, then what you can do, Kanishka, is maybe this received after and before date, right? Increase the window, because maybe you don't have any receipts or invoices. So just increase the window. Maybe then some invoice will definitely be there. Now, what we are going to do is we have to add what? What should we do with these emails? Exactly, we have to classify it. We don't have to necessarily label it in the Gmail today. That we are not going to do. So labeling in the strict sense of terms, in the context of Gmail, labeling means inside the Gmail, it will have a label. That we don't have to necessarily do, but let's just classify. So for classification, we have a special node called classification text classifier. So click this plus button. Then there is an option you type here called text classifier, and you will see that text classifier option here. Okay, so it will look like this. This is the node. So just add the text classifier node here, which should look like this. Now in that, we have to attach a model. So this text classifier is just without intelligence. It's just saying which classes should I classify the email into. So you double click this node to open it. And here the text to classify. So please pay attention here. This is very important. So here, what is the text that I have to classify? What all things might be useful? So if I look at the table, there is a ID for the email, there is a snippet, there is payload, there are a bunch of other things. There is to address, there is from address, subject. There are a bunch of things. What might be useful for us to classify? Snippet is useful, as Anudeep and Moni said. So, and maybe, I don't know, maybe the subject also might be useful. So I'm just going to use that also. So here, in the text to classify option, you see two things. One is fixed and one is expression. Fixed means you can only use fixed text, like just copy paste some text here, which is not very good thing to do for us because we have different emails. But expression means it can be like a variable. So choose expression here and then do one thing. Click this subject and drag and drop it here. Similarly, go to the snippet, which is the main content of the email. Click that, drag and drop it here. So now you will have two things here. One is the title of the email. subject of the email and the content. Both will now be present in the text that we are supposed to classify. And how will this be done? If you have 25 items, this will iterate through each item. So 25 times this will be done automatically. Now we have two categories, right? It's a two-class classification. So here we can add category. So first category is invoice. I'm just naming it as invoice. Second category, I'm naming it as not invoice. Now here we have to provide the description, and this description is literally the prompt that we are going to give to the OpenAI. We have not connected OpenAI yet, which we will do in some time, but we have to give the Y categories, because sometimes the emails that we have fetched from the Gmail just using these search queries like invoice, receipt, bill, etc., they may not be invoices for my software subscriptions. Maybe they are invoices for some customers payment, or maybe they are invoices for unpaid invoices or reminders. So there are many things that can come in my inbox which has the keyword invoice, has the keyword bill, etc. So some of them will definitely be junk. So I have to use some intelligence, which we use the large language model to classify, hey, is this an actual invoice that I am looking for, or is this something else? So that is why I have two categories. So just add two categories here: invoice as the first category, not invoice as the second category. And obviously we'll be only using one of this. Now here in the description, we can type something like this. So here, if you want to expand this description box, you will see at the right-hand bottom corner, this small button. Just click that button to expand this. And here you can type something like, if the content of the text is corresponding to the payment I made for a software. Oh, by the way, one more thing, guys, I want to show you. This I am going to delete. How many of you have heard of this tool, Whisperflow? So I'm using it at the moment. I'll show you. So you see a small, at the bottom of my screen, you see this small little notch, this thing. It's basically, I'm using a voice to text tool, but if I activate it right now, I'm not sure if my audio will be captured by Zoom as well as with Whisperflow simultaneously. I'm not sure, but I'm going to try anyways. So what I'm going to do is I'll activate Whisperflow and I'll just explain, I'll just dictate my prompt here. So classify the text based on the content into invoice or not invoice category. So I just activated Whisperflow. Can anyone confirm if you were able to hear my voice right now? Okay, so it works both. Okay, fine. Then I'm going to use Whisperflow. This is very good tool, guys. I would say, the best AI tool that I have discovered in the last maybe 2 months. Because right now, my personal dilemma is this: I don't like using ChatGPT to, let's say, respond to emails or write some article. It's like I feel like my brain capacity will degrade after 10 years. So I want to use ChatGPT for some boring tasks, but for things that require intelligence, I'd rather use my brain. But yeah, it is installed locally in my system. Yes, correct. So this is the website. They have free tier also, Whisperflow. This sounds like an advertisement of Whisperflow, but I just love this tool. Like, it's very simple, and it's almost, in my mind, this is like a perfect AI tool. Like, I'm so jealous of the founders of this company. But in Whisperflow, basically what it does is, even if you make grammar mistake while dictating, it automatically corrects the mistake. And so these days, what I'm doing is, when I'm responding to emails, I just open my inbox and then I speak whatever my response is using Whisperflow, and then it will nicely convert into whatever email format. So it won't change my words, but if I make some grammar mistake, that part alone it will correct. So that way I can keep my brain engaged, and I don't have to manually sit down and type. So here, let's create the prompt using Whisperflow. And the way I am activating it is, so this is the Whisperflow app. So the app is open in the background, but here this notch is there. So on Mac, I just need to press the function button. So if I press function, then that notch will get activated. It will be listening to my sound. And then right now, whatever I'm saying is getting converted into text. Then if I release the button, that text will come into whichever box it was selected. So right now I did not select any box, but then you can go to Whisperflow and copy paste the text. See, this was the text that that I just created. So this is a very, very good tool. I think all of you are going to love this if you start using it. And now I can't live without this. It has reached that level. Anyways, let me describe my prompt. So the prompt that I was going to describe was prompt for classifying the text into the content into invoice or not. Classify the text into invoice if the text is corresponding to a software subscription that I have made, and if the content includes the pricing, date, and payment confirmation. So this is now my prompt. Classify the text into invoice. So this I'll just put in double quote just for highlighting. If the text is corresponding to a software subscription that I made, this is my prompt. Okay, so I copy this. I'm closing it. Now in the not invoice category, I can paste pretty much the same thing. Then I will say classify the text into not invoice if the text has nothing to do with software subscription. So I'm just using Whisperflow to dictate, and then yeah. So this is my binary classifier prompt. Then close this prompt box. So now my prompts are ready, and yeah, that's pretty much it. If I click execute, can anyone tell me what will happen? If I click this button, what will happen? If I click this, nothing will happen because we have not yet connected OpenAI. This is just the classifiers to classes. The intelligence part is not there yet, right? Similarly, in the settings, maybe I should output the data for visualizing and retry on fail. So now comes the OpenAI part, which is the AI intelligence, right? So here in text classifier, there is an option called model. So do you see these two nodes, not nodes, the branches got created. First branch is called invoice, second branch is called not invoice. It's because we created two classes. And here in the model, I can search OpenAI chat model. So now here I have already connected OpenAI account of mine, but what you can do is create a new credential. In that, it will ask you to copy paste the API key. You just paste the API key here. That's it. And if you want to find the API key of yours, just do this OpenAI API key, just Google it. This has been a pain. I think they should do something about it. Finding the website which has the API key, I hate it. So you can go here in the dashboard, you will see the bunch of API keys. Not bunch of API keys, your API keys, not mine. I think you can use Gemini also. Let me check. Good question. Yes, Gemini is also there. Cloud also might be there. I can check that. Yes, Cloud is there. Which one? Which other? Yeah, these are pretty much the popular. I use Cloud. Yeah, Perplexity. But Perplexity, at the end of the day, they don't have their own model, right? They use it's like almost like a router, right? Almost Llama, but where will you you will have to host it somewhere, right? So yes, you can use Llama model, but maybe it's hosted on Ollama or somewhere. Like it has to be hosted somewhere. I'm pretty sure this can connect to Hugging Face, and Ollama. It can already connect. Copilot. Copilot, I'm not seeing here actually. But other models, right? You have to have hosted it somewhere. Like for example, a DeepSeek and all. It has to be hosted somewhere accessible for you. So maybe if it can be put on Ollama, if it is possible, you can try that. I haven't done that myself. But I think many open source models anyway can be accessed from Ollama here if you have hosted it there. So that's pretty much it. But for today, just use anyone which you can get your hands on. I'll stick with OpenAI for the moment. So let me connect it here. And by the way, when you are adding a bunch of nodes, right, this can look completely ugly. Right now, there are only like four nodes, but it can look like this So after some point, you will get frustrated. So all you can do is like right click, tidy up workflow. So then automatically it will arrange the nodes in a nice, beautiful looking fashion. So in ChatGPT, what I'm going to do is the model that I'm selecting is not GPT 4.1 mini. I want GPT 4o. I'll just select this and yeah, that's it. Now what I'm going to do is I'll run this node, and what you should see is there are 25 emails that we fetch. Out of that, some of them will go to invoice branch, some of them will go to not invoice branch after we run this. So let's see. I'm going to run this and hopefully things will work. One thing I did not check in OpenAI is the retry option in the settings. So I'll open and check that as well. So in settings, okay, that is not there. So here you see out of the 25 things that are fetched, only 4 went to the invoice branch. You can see this, right? Remaining 21 were junk. Maybe we have to check it also manually a little bit to make sure that the way I have written this prompt, maybe this prompt is not good enough. I just wrote the random thing that first came into my mind. I did not follow any, any structure, but we may have to do that. But anyways, I'm happy to have 4 invoices here at the moment. Now I have, before we fine tune the prompt, now I have 4 invoices. Now what should I do? 4 invoices meaning I have 4 email content. Now what should I do? But Surya, can we update the sheet yet? How do we update? We don't have the information parsed into a format that we like, right? We have to extract the data. So what we can do, the simplest thing to do is add one more node here, search for OpenAI, and add a node here where it is just message a model. So what happens here is, let me close this and show you. Here, all the emails which are classified into the invoice category will be now sent to this particular node where we are messaging OpenAI. Are prompt generator good for adding? Actually, it is. There was an amazing website for generating prompts. I completely forgot the name of that website. I used to use it like 1 month back, where it will create prompts based on whether you want the AI's persona to be something or something else. So it's very, if I find it, I'll post it somewhere. Maybe in the GitHub, I can post it. But for now, let's stick with our human written bad prompt and let's see what kind of results we get. Prompt Genie, let me check. I don't remember actually. No, it was not this. It was some other promptly. Prompting guide, promptly. Let me check promptly. I remember the name, but I don't remember how the website looked. Yeah, I remember seeing the website. It was some other simple name, prompt perfect. Maybe it is that. No, there was one more website. I can't remember the name. I'm pretty sure it's somewhere there in my search history. But anyways, coming back to the workflow. Now what we are going to do is select a model. Here there is one thing, okay? We want some modern models because I don't think all the models can give you output in the form of JSON. So what I'm going to do is I'll say I pick, you don't see message a model. Okay, Satish, basically, let me delete this. So here, add and then search OpenAI and then just click OpenAI. And inside the OpenAI, in the text action, there will be message a model. You're finding it, right? This one. And here again, I already have connected with OpenAI account. Resource is text resource. The other ones are image, audio, files, etc. It's just text. Then message a model. Problem in node text classifier. Yeah. So don't worry about that. That problem part we can fix. For now, just add the new node. That problem sometimes happen if we have not run all the nodes. Sometimes there is a break in between, but that is fixable. But other than that, just add the node for now. So here from the model list, I am going to pick GPT-4o. And now here is where we have to put the prompt. So first of all, this prompt, should it be fixed or should it be expression? Because as I said, I don't think the some of the last time when I tried using, let's say, this GPT 3.5 or something, it was not allowing me to output the content as JSON. Maybe it was just a case of me not using it correctly. But ever since, and whenever I was using GPT 4.0, I had no problem getting proper JSON response. So that is the only reason why I personally stick with GPT 4.0. I haven't experimented with it with enough to tell you with 100% conviction whether GPT 3.5 will not work or not for JSON response, right? But anyway, so this should be expression. Why? Because we need the snippet and we need the title. So what I'm going to do is, title probably is not needed because, let's see, maybe I'll pick the title. So subject of the email and the snippet I'm going to drag and drop here. So that is one part of the prompt, but is that the whole prompt? No. Now I'm going to say a few more things. Extract the following data from this email content in a JSON format. Your only output should be the JSON objects and nothing else. And here are the JSON objects that I need. Service provider name, pricing, date. So I just used WhisperFlow to dictate this. Fairly good, right? Extract the following data from this email content in JSON format. JSON, nothing else. Here are the JSON objects that I need. Service underscore. So maybe I'll just make it explicit. Service underscore provider underscore name, pricing, and date. Yes, I'll show the last step once again. Don't worry. So let me go back one more step. This actually, let me copy the prompt so that I can come back. So this is what I did. I'll delete this. So text classifier, until the text classifier, everybody's still here, right? Till this step, everybody's done, no? Okay. So now we have to select the invoice branch, not the other branch. Not invoice branch is for the useless emails that we are not going to touch. In the invoice branch, we have to add a new node. The node will be OpenAI. So search OpenAI here. And a second. And then in OpenAI, if you scroll down, you should see this message a model option. This you guys are seeing, right? Like this should be there for everyone. Message a model. Then this screen will open, which is the output from the previous node, OpenAI configuration, and output from the current node. And here, keep everything else the same. In the credential, connect with the previous credential, previous API key, same thing. Message a model, all of this remains the same. But from the list of models, I prefer GPT-4o because it has not given me troubles so far with respect to JSON. And in the prompt, it should not be a fixed prompt. It should be a variable prompt because it depends on the email content. So here, I select this expression and then two things I drag and drop. First thing is this subject from the previous node. How do I differentiate between fixed or expression? May look like it is obvious. Yeah, so this is how I differentiate, right? From the previous node, I have 4 different inputs. I mean, 4 different outputs, which will go as 4 different inputs into the current nodes. What are those 4 things? 4 different emails, which means by the very nature, the content of those 4 emails will be different. I'm not going to classify the same message again and again and again. I want to extract a data based on the content of the email. And what should be the content of the email? Content of the email will be based on that particular email. So it is variable. So there will be 4 different subjects, which means subject is a variable. There are 4 different email content, which means email is also a variable. Why don't the table contain the actual mail body? Actually, you know what? The snippet itself is the main body. That is what I have seen. Snapify subscription. For some, actually, for some emails, content is completely missing. The proper content is missing. I don't know why, but we'll figure it out. But the main body is this snippet itself. Now, what we will do is, so we have the email subject and email snippet, which is the actual email. And one more thing, user role is user, simplify the output. Output I need as a JSON. And previously I had copied what I gave as a prompt. So I'm going to paste it here. Extract the following data from this email content in a JSON format. Your only output should be this thing. Maybe I'll share this prompt alone in the chat. Feel free to copy paste it. And your output should be JSON objects and nothing else. Here are the JSON objects that I need. That's it. And then in the settings, I need to see the output and I want to retry on fail. And yeah, that's pretty much it. Now I can execute this. And after executing this, I should see outputs with these three objects in each JSON. So let's see how it looks like. Okay, so now I have the output. So for some of the emails, actually, I have only the service provider name and date. Pricing is missing. But for some emails, actually like Snapify, pricing is given, date is given. So this is not the perfect data, but it's okay. For now, let's keep it as such. Now we have extracted some kind of useless data. I mean, it's not perfect yet. But anyways, now this data we have to write into an Excel sheet, Google Sheet. So let me open an empty Google Sheet, sheets.google.com, and start a new sheet and ensure that here somehow my account has been switched. So I was using a different account and here it's sridhat@gmail.com, but I was using Visuala's account. So here I will name this as invoice aggregator or something like that. And then I will share this with this you don't have to do. This is just because I'm logged into Google Sheets using a different account. And then I'll just switch the all right. Okay, so now I have the empty Google Sheet here. So here what I'll do is I will add 3 empty columns. First column is date. Second column is service provider name. And third column is price. Now what I will do is go back to the workflow, to the editor. And now obviously the node that we have to add is the Google Sheets node. Actual data is in PDFs attached to the email. Yeah, that's correct. So in my case, actually that Flutterflow email, it had data in the email also, but I think it's in some format which is making it difficult to extract. But anyways, can we add the criteria only to display? If not null? Yes, we will do that also. So here, let me add Google Sheets. Google Sheets. And what should I do? Should I create spreadsheet? No, just appending a row is enough because I have already created the spreadsheet. So click append a row in the sheet. And now here, let's sign into the corresponding Google account, Google Sheets account. So this Google Sheet is associated with rajatdandekar@visuara.com. So I just sign into that. And to know the account name, I will just rename it here. Otherwise, it will be confusing. So just rename it, save it. And now the resource is sheet within the document, appending the row. And the document, here I have to select the document. So if I click choose, automatically the top one will be the one which we created just now. So invoice aggregator, within that, the default sheet will be sheet 1. So if I choose this, sheet 1 will come. And then I would like to map the columns manually. So what I'm going to do is, so there are 3 columns that I created, which were empty: date, service provider, and price. So here, service provider, here I will drag and drop into service provider column. Date, I will drag and drop here. And one more thing, pricing. Now, if I run this and maybe I can here, I don't want to output the data because anyway, it will be visible in the Google Sheet. So no output, maybe retry on fail I can do. Yeah, that's it. Now, if I execute, so currently just check this Google Sheet is empty, execute. Automatically, this should hopefully get filled. Let's see, let's wait and see. See, it got filled. But these two things became empty because the content was missing. For razor payroll, price is missing. Now there are some minor issues. Overall, the workflow is working, but it's not perfect. Some tweaks need to be there to make it better. So let's do that. But before going into all of that, have all of you reached this stage, or just can you just mention in the chat? Okay. Anybody who is so all of you got some output in your Google Sheet yet? List is showing null. Okay. Like Google Sheet is showing null, is it? Unable to add message the model. Oh, that is a bit weird. So Jay, you are saying you are not able to find this thing, this message the model node. Only see. Okay, text classifier not returning any output, we can fix it. Okay, so there are, looks like there are a bunch of problems. So let's start from the beginning. Okay, at least have you guys added these nodes? Maybe ignore the last two nodes till these things, the ones that I'm showing in highlight, those things you all have, right? You all are facing problems. These many things you have. Now what you can do is just delete this connection, just delete this part so that that connection is gone, and just execute the workflow by pressing this. Just click execute the workflow. Then these three nodes will be executed. Then it will fetch 25 items. It will create a classification of whatever is invoice and whatever is not invoice. Do you see this effect? This is the hallucination. It's a classic thing that my prompt is not very good. See, previously there were 5 items, 4 items in invoice and 21 not in invoice. Here now it is 7 and 18. So some hallucination, maybe because I have to do the prompting better. But anyways, those things we can fine tune. But I want to ensure that when you guys are running your code until this point, you're getting some output in the invoice and some output in the not invoice. Is that happening or not yet? If that is not happening, what you can do is prompt is simple. Check sender is Amazon, but still no output. Ravi, do you have any things here from the Gmail? Do you have any items coming into the text classifier, or is this 0 items? Okay, Ravi also have 25 items. Okay, then in text classifier, is it looking something like this? Something like the text you are supposed to classify is expression, with basically variable, which with the thread ID and the thing, not thread ID, with the snippet and the subject. So those two you have dragged and dropped, right? And then you have two categories, invoice and category not invoice. In category invoice, you provide the description that check if the actually, if you want to just check if sender is Amazon, then all you need to do is like also just this drag and drop this thing from this from also you can drag and drop. Then I think that Amazon info will be there. Then and I think maybe rest of you can also do, because I'm sure you have an invoice which is about a purchase from Amazon. So just maybe for all of you, from might be a very important thing. For me, from is not important because I have many different invoices. So I don't want to stick with Amazon or any one vendor. But I think for you, if you have a lot of Amazon purchases, just drag and drop from. And one thing is in this Gmail, right? Just widen the number of, the number of days. So instead of received after from June 1st to end of June, maybe put this to May 1st till, let's say July 1st. How about that? 2 months. So I increase the width. And then here, one more thing I can do is return all, which means every single email with these things are there in this range will be returned. And I'll show you how crazy this will look, right? So let me run the text classifier, this whole thing once again. There might be some 300 emails or something. I'm pretty sure of that. So right now my Gmail is fetching every single emails with the word invoice or paid or something, receipt or something is there, and for a 2-month range. So I have not put any limit. So this will take few seconds to execute. But what I want to show you is the result after classification. And meanwhile, while this is running, I think somebody had mentioned we have to ignore the null. Whenever there is a null data, we can ignore it. So let's implement that. So in the messenger model, actually some output were null, right? So what we can do is, okay, let's first finish this execution. So see, there are 400 emails. This is so crazy. And in the invoice, maybe 100 might be there. And this perhaps I can connect. So are you guys all at this point where the text classifier is giving you some output? And how many of you did get some output in the Google Sheet? Any output, does not matter what it is, some output in the Google Sheet. Okay, good. Yeah, I will open the Gmail details once. This one, right? This Gmail node, right? So connect with the appropriate Gmail account. Resources messages, because each email has a message. Then here I selected return all because I want every single email with these two search queries between these two dates, between 1st of May and 1st of July. So June, July, 2 months. Now this gave me 400 email outputs, which is too much. And then now classification is happening as we speak. So ChatGPT, as you can see, 340 items have been finished, 50 more items to go. And then at the end, we'll see how many emails were total junk, how many were actually invoiced. And this is still not foolproof. Why? Because confused with parameter in append or update row. It should be append row. Keep it as append row for now, instead of update row. Okay, so I have 76 items that are kind of legit. Can yes, it is possible to extract data from attachment, but then here things should change. Here you see, I am currently not here. Here in the messenger model, I am currently using text as the resource, but here things should change. File should be there. And then after extracting the email attachment, we have to figure out where are we storing it somewhere, or are we somehow figuring out directly sending it to the model as a message. What should be given inside update message? Update message meaning in the in which one? In the sheets or in this, right? Update message. Where do you see the update message? Because I don't see that. Okay. All right. So now I have 76 emails. Now let's do one thing. Okay, extract the following data from this email content. This is okay. In text classifier, maybe I should have added classify the text into invoice if it is corresponding to software subscription. That okay, all of this is fine. So now I'll tell you the main problem. The main problem is this sheet looks very ugly because there are a lot of empty data points which we need to remove. So what I'm going to do is, in the messenger model, from the messenger model, we are getting some output, right? So now some conditions we can check before writing into the Google Sheet. So let's do this. What is a condition? If condition. So here search if, and then it will bring up an if node. In the if node, and before that, let me run this node so that now it is extracting the data from these 76 items. So I have 76 emails from which I am fetching the data, and ChatGPT is fetching it. And here I'm going to create two branches, true or false branch. In the true or false branch, what I'm going to say is, if the output of something is null, I will send it to the false branch. If it is not null, I will send it to the true branch. And Google Sheet, I will only connect with the true branch. I will not connect it with the false branch. That way, the emails with no useful info, I can just discard. Messenger model is simply like just like how you use ChatGPT in the message mode. The other operations are this custom API called classify for text violations. So this is basically just like in normal ChatGPT, when you are sending a message, you are sending a text-based prompt, right? Same thing. You have a model, you are just sending a message to it. Okay, so that execution is done. And here, what I want to do is if if service provider is empty, you know what? Instead of this if node, there is another node called filter node. Maybe I should use that. Remove items matching a condition. So in the filter, if service provider name, so I'm dragging and dropping this, if service provider name, instead of is equal to, I can say if is empty, or if it does not exist perhaps, and date. I definitely need pricing. So if pricing is empty, then I don't want it. So, okay, let's start from scratch. So add a condition. Let me delete this. If pricing is empty, then I'm filtering it out. Then, or I don't want and. If service provider name is empty, then I'm filtering it out. So these two are, I don't mind the date being not there. So if either of these are empty, I'm filtering it out. So now if I execute the step, only those with these details available should be in the output. So here, always output, retry on fail. Let's see how many out of 76 emails will pass the filter. Not specified as a string, but was expecting an output. Okay, pricing not specified. Okay. Yeah, is empty. Yeah, you are right. We should select it as a string, not as an object. Similarly, service provider is also a string. So string empty, I guess, is empty. Let's see if this works. Sometimes this will cause issue because some pricing is in number, some pricing is as a string. Okay, wrong type object is an object, but was expecting a string. Then I'll go back and ask ChatGPT to do one thing. So in my prompt, I will say, here are the JSON objects, your output should be in the value of all objects should be strings. So I'm just giving that as part of the prompt. Okay, so now hopefully all objects should be strings, and let me execute this once again in the hope that the key value pairs, the value will always be a string. Price is numeric, I understand, but sometimes the thing is some price is in dollars, some are in rupees. So first we can extract the price thing, including the symbol, the currency symbol, and later we can maybe figure out a way to split it into the symbol plus number, and the number part originally will be a string, and later we can convert it into a number. So for now, let's keep it as a string because it could be in different currencies. Yes, we can country specify in the prompt, select price later. Yes, we can do that. So ideally, where I should have done this, I should have done this in the text classifier. In the text classifier, I should have said, if pricing is not mentioned, then classify it as not invoice. But I'm not doing it right now, right? So that is the reason why even the ones with price missing, or maybe pricing is mentioned just in the attachment, even those ones are coming. But meanwhile, what's the update, guys? Did you get proper output yet? Like, are you in the process? Just let me know if you are stuck somewhere. We'll be happy to help. Today we are not covering MCP. MCP will put as a separate item in the GitHub. Okay, in progress. Very good. Okay, so I have the output here now. Then let me filter once again. So hopefully now everything should be string. Date should be string. Service provider should be string. Okay, and if I execute this, I hope there won't be any error. Okay, excellent. Now kept 27, discarded 49. So it kept all the items with empty. So I should say not empty, because it seems like it is letting only this condition and this conditions pass. So not empty. So see, this creates two branches. So kept, 70 items are kept, 6 items are discarded. Okay, I don't know what is their language. Discarded means, yeah, kept, 70 items have passed. Now I'll connect this with Excel sheet, Google Sheet, and I have pretty much everything. And what I can do is delete the current data so that it starts completely fresh. And let's execute the Google Sheet. Now, hopefully, whatever is coming into the Google Sheet will be such that for the 70 items, even if date is missing, rest of the things will be there. Okay, much better. Still, there are some issues. Our condition should be better, but much better than what we had before. Price is not specified, but just look at the number of rows here. This has already filled like 71 rows. Very good, right? I'm really impressed with this. Now there are some issues here. Okay, there are obvious issues like date should be in one uniform format. So we should specify that to ChatGPT rather than just extracting the date and randomly putting it. It should follow one like day /mm/yy some format like that. Service provider name, at least it has gotten correct. Price also we should say if it is in US dollars, convert it into rupee based on that particular day's conversion. And then maybe you can assume some conversion rate and then say all the pricing should be in INR and convert the price into a number instead of a string. So that can be done to make this better. And you can imagine many other things to make this into a fully usable sheet, but I hope you understand the flow. Now let me pause a moment and just check with all of you. Can you guys tell me what is the status with you? Did you manage to run and get some invoices, maybe your Amazon purchases data in your Google Sheet? Okay, like it's proper, right? You have the service provider, like whatever is the name of the thing which you purchased. Can you show the JSON from the message model output? Yes. So in the message model, this is the JSON. So here I have asked the model to just give me JSON output, right? So no, I did not. Did I say that here? Yes, I did. So see, this is the main content. The rest of the things are the details of the model, like index, message, role, but service provider name, pricing, date, service provider name, pricing, date. Here you can display it as JSON or you can display it as table. I like to see it as table because it's easier to read, but you know what, both are equally useful. Then the other thing is you can save this workflow. Okay, and there is one more option called active. So if you activate this, if you make this active, no trigger, no, oh, sorry, this is manual trigger. So what I will do is I will convert this into an automatic trigger. So this is how it works. So now if you want to host this workflow so that it automatically works, you don't even have to be here as a human. All you need to do is change the trigger, delete this, and here instead of get many messages, the trigger should be get one message, get whenever a new message comes. So let's actually try this, right? Let's see how to do this. So here instead of get many messages, I am going to say get one message or whenever a new message happened. Plus trigger, no, not manually. plus Gmail on event in Gmail on message received. Okay, so my trigger is now on receiving an email. Now what I'm going to do is I have a personal email. Maybe I'll connect with this email or this email, and every minute it is going to check message received. Okay, if it will check if message has been received. If it has received the message, then I will connect it here, and this I'm going to delete. Oh, sorry. This I'm going to set up such that now let's do one thing. Yeah, correct. Here the reason why I completely made manual intervention is because in some workflows, you can automate everything using agents, right? Like for example, if the way in which the LLM has created JSON is not in the right format, you provide a feedback loop there using an agent where you are ensuring without the presence of a human that the workflow happens. But here, if you look at the n8n, right, there is literally something called as add human in the loop. So here the way it works is, let's say, I'll give you an example. So one of the workflows that I built was sending an email to our building manager for creating the schedule meaning for meeting. So if I want to automatically send the manager a message for 2 p.m. on July 8th for 1 hour, can you book the meeting room? So only 3 details I have to mention somewhere. So let's say I say 2 p.m., 1 hour, July 7th. Only these 3 things I say somewhere in the chat or in Slack. And then automatically it triggers LLM response to draft a proper email to the building manager. And then it will send, and then human in the loop is still needed because I want to ensure that the email that is going from my personal email is something that is not erroneous. So then all I need to do is like in the Slack, it will send me a message. All I need to do is like press an approve button, and then it will send the email to the building manager. Then building manager can also with a click of button approve whether the meeting is scheduled for that time or the room is not available. Then if building manager approves, automatically my Google Calendar is filled. So here again, this can be fully automated or partially automated. So I prefer this human in the loop option to be utilized almost always because I don't fully trust the workflow, agentic workflow yet. And especially for sensitive tasks. But if it is something like this invoice, it's okay if 1 or 2 invoices are missed, I can deal with it later manually. But if for things that involves my personal email, I won't be implementing a fully automated agent. So that is the reason why this is not fully aligning with the agent's philosophy. Values to send append in the row. Yes, I'll show that. But one more thing, I thought we'll do an interesting exercise, right? Can you guys all send me an email with the following details? So this is the email. Let's play with this. This is the email. Just send an email mentioning the service provider, some random service provider name, mentioning a random service provider. Then let's say a random pricing and some random date. Just send an email with these 3 details with the subject. There is a question, when we design this workflow, let's say cold emailing, if we are connecting source for the email list and then prepare the content of the cold email, does this evolve into a spam bot? So, I mean, whether it evolves into a spam bot or not, anyways, lot of emails, if you send too many emails without any previous history of sending large number of emails from your domain, it will anyway go into the spam folder of the receiver. But yes, if you set up a cold calling or cold emailing workflow, and let's say from your domain consistently 500 700 emails are going, then you can ensure that at least the email hits the other person's inbox. Now, whether the content of that email will be complete spam or not, or complete useless content or not, I think the checks needs to be made there. So in general, yeah, what about the data security for sensitive data? Does enterprise allow this in business use case? Yeah, in general, if you are classifying inbox emails like this, yeah, it's not a good practice to send the data to open source. Right now, this is just for educational purposes, but for production purposes, you would rather host an LLM yourself and then use that. So in our case, for example, when we worked with a company previously, we privately hosted an LLM on AWS, and we were calling that for building a RAG-based chatbot, so that all the data is either on, I mean, at the end of the day, it will also go to AWS, but it's not like overly sensitive data is exposed without having any control. So it's a good question. I mean, yes, ideally, we should not be implementing this workflow by exposing the whole data. What about multiple agents? What about the results instead of LLMs? Yes, you mean multiple agents for making sure that workflow performs as intended, correct? Is that what you mean by multiple work agents? Okay, any easier way to simply tell a prompt what I want to do and n8n just ask for authentication and does everything on its own? Actually, you know what? There was such an option do exist in Zapier. In Zapier, I have seen that. In n8n, actually, I have not seen that. Maybe it does exist somewhere as an option, but in Zapier, you can just by words you describe what you want, and it will suggest the nodes. Okay, so assuming that have you sent this sample email to this email rajatdandekar@visuara.com? Because I want to show you some interesting thing, and here I'm going to fetch test event services. Yeah, I received some email. Then what I'm going to do is ask the text classifier to classify the text into invoice. If this is this, okay. Message model filter, and I think rest of the things are fine appending the row. So I'm going to delete all of this data so that I can show fresh that how your information can automatically come here. Your information as in the dummy email that you guys are sending. So right now I'm going to execute my workflow, but just notice how the trigger works, okay? Execute the workflow. Now the trigger will keep on listening once in a minute. And now the workflow is being executed. And whenever, just do send me an email like this. Let's see where all this is getting. Yeah, somebody must have sent this, right? October 5, ABC hosting, $20. So I think this thing can only do at a maximum frequency of 1 minute, once in a minute. So the emails that came in that time frame should hopefully reflect here. So can you once more send the email, because the previous one you sent is now in the past, so it won't help with the trigger. So can you just resend the same email, just copy paste and send it once more? I just want to see this sheet getting populated automatically, because now the workflow is deployed. So just wanted to show you how it technically works. So let's see if in the next minute, if we can get some more entries in the sheet. And Gmail trigger mode every minute, event message received. Okay, so yeah. I thought it was already 1 minute. Not sure why it is not getting executed. I'm just asking to fetch a test event, just to see if something new. Refresh sheet. Sheet, I'm not sure if we need to refresh, because I think it adds it here. The main thing is if the workflow is getting executed, we should be able to see that here. So that was my issue. Like I couldn't see the workflow getting executed after 1 minute. Just we'll have to figure out. But date Flipkart, $120, very good. So it is working, just that the trigger, I am not 100% sure if this is custom. Today, hour 14 minutes. Fetch a single mock event. It will show up once you are happy. Activate it. Okay, so probably I have to activate it. So let me do that. I have to not just execute, I have to activate it. So this is the last thing that I want to show you, activating the workflow. Okay, so here also next thing came. So now let's keep it activated. So hopefully now regularly check for emails. This. Don't show again. Got it. Okay, right. So now this workflow is active. Can you guys, I'm sorry, could you send this once again, the emails? Just copy paste the same email. I just want to feel the happiness of getting this thing filled all at once after 1 minute. And I just want to wait for 1 minute to make sure that this workflow is actually getting executed, because now this is fully automated. For new emails, the info is getting filled in my sheet. And the logic is very cool, right? I mean, prompt is not good. We have to modify it. We have to fine tune it, but it's still something that does things on its own. Okay, so I hope after 1 minute, this should get executed without me having to do anything. Yeah, it is getting executed. So two more email data just reached. So you just saw these two came just now. So after one, if in between, in this 1 minute gap, if something else came, that also will come here. And also one more thing, in the last 2 minutes, I would have received other emails also, not just the emails that you guys send me. I'm sure I received 5 other emails, but it did not come here. So to a great extent, it is working. But I have to make the prompt much better to fetch the data properly. Is it possible that some emails are going to spam? Oh, actually, that is true. Since all of you guys are sending similar emails, yeah, it's likely. I have to check that. But I hope the idea is clear. It's pretty automated now. Now this is active. This workflow is active. I can close it. I can go, and it will be working. And active workflows you can see over here. See, these two workflows are active, rest of them are inactive. So don't keep workflows unnecessarily active, because you will incur cost. So generally, for playing with this, just play with it, and oh, more emails came just in the last 1 minute automatically. So amazing. Do you have recommendation for good image to text converter similar to voice to text? You mean reading the data from an image and converting it into a textual description, right? Have you tried Copilot? I think Copilot is pretty good. I haven't had the need for converting image to text ever, as in the reverse is true. Text to image is much more needed. Image to text. Oh yeah, you mean if you have a screenshot with the tabular data and converting that into actual tables, right? For that, I use GPT. So like yesterday, like one of the like the accountant, he wanted the credit card statement details in an Excel sheet format, but the bank was giving me the credit card statement in PDF. And that PDF it had so many rows, and fetching the info from that was a pain. So I just divided it into smaller screenshots, uploaded it into GPT, and then got it back. And Satya, regarding MCP, I do plan to create a lecture on MCP, but regarding whether it will be a class in the course or not, I have to talk with Dr. Raj. But MCP, I do plan to share a MCP based lecture with you. It's in the making. And I think, if I'm not wrong, Raj may want to conduct one last lecture tomorrow, but I'll confirm with him, and I'll ask him to get back to you guys. But thank you so much. I will let's stay in touch. I'll share my email in case you want to reach out to me afterwards. This is my email. You can just send your email here, questions here. I'll be happy to get back to you. And I know that the session went much longer than expected, but I hope you enjoyed learning, and I really enjoyed the seeing the Excel sheet getting filled automatically. But thank you so much. We will meet again. And by the way, n8n's lecture series, I'm going to post many more lectures on that. So whenever I build an interesting agent for my own personal use case, I do plan to put out a lecture video so that all of you guys can use it. But thank you so much, folks. Have a good one. Hope you enjoyed the course. And I'll ask Dr. Raj to confirm with all of you regarding the status of tomorrow's lecture. Share updated with AI advancements. Yes, Sumit, this is what I do to stay advanced in latest AI advancement. I follow certain people on LinkedIn. I follow certain newsletters like Alpha Signal, and I follow certain journals. Some websites like Papers with Code, which tracks many archive papers. And then there are some GitHub repositories. So if you search in Google something like trending GitHub repos, just something like this, if you search in Google, you will get a link which leads to a page where you can find the latest trending GitHub repos based on topic. So many repos are related to software engineering, but many topics are related to AI itself. So just follow those repos, and trending meaning the rate at which they are getting the stars, right? And it's a very good index of what is happening latest and what people are going to talk about recently. So when MCP became so famous meaning people were all over LinkedIn were talking about MCP 2 months ago, although it came much before that. And that was also the time when MCP was, Anthropic MCP repo was the most trending one on GitHub during that 1 week or 1 month or something. So following trending repo is one of the best ways to keep track of. You can even predict, okay, if you start seeing some repos trending, it's very likely that in the next few weeks, people on LinkedIn will start talking, or on Twitter, X will start talking about that particular topic. So it's a good way to stay ahead of times a little bit. But anyways, nice talking to all of you. Will please email me after this. I'll be getting back to you as an email response. Thank you so much. Take care. Bye.